It doesn't matter where you go. The
What do you
sun
mean by
never goes.
light? Can you be more
Lumens,
specific?
lumens, light.
No, not the
Constellation.
definition,
We
not
saw
the definition of what light is. I'm saying like, okay, we know what a star is. We know what the moon is. When you tell me lights, can you be more specific? What do you mean by
Okay.
lights?
When I say star, I do not
Yeah.
say a big burning ball of gas in a vacuum. I don't say that. When I
Okay.
say star, I mean you step outside your house, you look up, and you see the white dots in the sky. Those are lights. Those are the stars.
So real
That's what
quick,
I'm referring to.
Emperor, you just said we know what stars are. You gotta kind of realize this though, that
Yes.
there is a separation between what we observe, stars. You and I can observe them. Everybody in here can look and see, observe the stars, the observable phenomena. We label stars, right? And then there is the belief of what they are that
Go
cannot
on.
be verified. Like they are big suns, bigger than our sun, trillions of miles away, kind of stuff.
Depending, yeah. There are red dwarfs as well.
That cannot be then. That is part of the religion. That is part of the globe, like you were saying, the solar system and the globe Earth. That is part of the belief side of things.
Built-in assumptions.
I used a telescope before. I saw Jupiter.
too.
I saw the so I
Me
saw
too.
it. Is it just a glass? Like a
No,
glass
it's an observable
ceiling
phenomenon. It's an observable
What?
phenomenon. Observable phenomenon.
phenomena?
Yeah.
Okay.
Now.
What do you? No,
now,
wait. What do you mean?
People
by
are gonna tell you. Listen, some people are gonna tell you. They know what is the distance, the makeup, the size, the medium that thing is in, or they believe it. But you think they really know?
They've never been there
I trust
to
them to know.
circle around the object, to take a measurement of the shape of the object, to measure the size of the object, take a sample to
do
find out what
I-
material it's made of, what it smells like, what it tastes like.
Okay.
How
How
could they
do I
ever know
believe?
to claim? How
Yeah.
could they ever claim to know what that is if they've never
I
done
get it.
that?
I get it. I'll answer you. Basically, when it comes to claims that fall within the bracket of scientific claims, I believe that certain people dedicate their time and efforts into understanding phenomena, and they use the scientific method to verify certain claims, theories. And when they give a theory and they provide their research and they provide their experiments that can be,
Those people do
reused
exist,
again.
but not on this topic. Not on the topic of the stars. There's no science done about the stars.
Yeah,
and
I've
the planets.
got a news flash for you, Emperor's Child. They don't
Yes.
utilize the scientific method. We can give you quotes from them. From like, have you heard of Nishio Kaku?
Yeah, the Japanese guy. I've seen some videos.
Right.
Yeah, he's the prime priest of this topic that you're talking about.
Whoa,
Yeah, he specifically says that nobody that I know of in my field uses the so-called scientific method.
When it comes to what?
He says it's astronomy, cosmology. He says it's all leaps of logic and seat of your pants and guesswork.
I'll give you an
And then
example,
he
Emperor.
also-
Emperor, I'll give you an example. Real quick, guys. I'm in a second. You and I could be next to each other or different locations. Could both be looking at the sky. You can make your own ideas of what those things are. I can make my own ideas about it. Who's right?
What? Can you repeat your question? We are both on different places on the Earth,
Yeah.
looking at the same constellations. That means we have to be on the same sphere. I mean,
No, you're adding too much to what he said. That's not what he said at all. Say it again.
okay. That's what I understood.
if
I
you and
understood
I-
that we're both looking at the same constellations and we both make up explanations of them, right? That's what you
Yeah,
said.
if we're both outside, standing elbow to elbow, and we look up and we see the lights in the sky, you make up a story.
You keep
I
calling
make
them
up a
lights in the
story.
sky, and you didn't explain to me what you mean by that.
The things that twinkle at night.
Dude,
Yeah.
please don't be literal.
Yeah, just to explain it a little bit. Okay, so we've all been taught growing up. Okay, the same thing, that they're burning balls of gas millions of light years away in a vacuum. Okay, that would go against natural law, right? That's not something that's been scientifically validated. It goes against gas laws, right? It goes against what's testable and repeatable in a vacuum, right? In the most similar environment that we can create here on the Earth, right?
But don't they do that with those nuclear? What's it called?
No, that wouldn't be a ball of plasma gas inside a vacuum being contained or held together.
No,
by
but
gravity.
they do the same.
That would be in a chamber.
Now you're just asserting. You're saying they're doing this thing. That must be the thing that's happening in the sky. You have no clue. No one's ever been there to verify.
Wait, just a second. What's it called?
Finish it.
Dude, English is not my first language. Help me here.
Nuclear reaction?
No,
not the nuclear reactors. Those,
no, it's not. It's not our first language. Yeah, we don't use that language anymore either, so it's hard for us to remember your globe slang for things.
Globe slang.
What globe slang?
Yeah, so look, that's not taking a vacuum
when you
chamber and
say
making a ball of plasma
nuclear
gases.
fusion, and that's what you're trying to say, a nuclear fusion reaction that's happening with hydrogen in the sun.
Yeah, it's not analogous, basically. Right, and claiming that you can have a ball of gas and water, right, inside a giant vacuum, inside a space vacuum. Okay, that's also something that goes against natural law, goes against entropy, goes against gas laws, goes against every testable. Yeah, it's textbook definition pseudoscience, literally. Even admitted by people like Michio Kaku said nobody in his field uses the so-called scientific method. Right, he says we're off by an average of 10 to the some ridiculous amount of zeros.
120 zeros.
Yeah, 10 to 120. Okay, so let's bring it back down to Earth a little bit. Okay, this is how we know for sure that the Earth is not a globe, right? Because they tell us the exact size of the Earth. Okay, and 70% of the Earth is covered in water, approximately. Okay, of the globe. That's what they tell us. Now, that water would have to be curving at a certain rate. Okay, and we can go out and test the surface of the water consistently over and over and over again using all sorts of different methods. We can calculate exactly how much curvature there would have to be over a certain distance, and then we can test for the byproducts of that curvature. Okay, like things being obstructed by the curvature in the distance, and a horizon being at a certain distance based off the height of the observer, that kind of thing. Okay, that's been done
that goes
hundreds.
To visibility is affected by what's it called? The density, not the density of air. It has a term.
Yeah, visibility is affected, but we also have nice clear days as well. Okay, where we have really nice clear conditions, right? Quite often.
Of course.
Okay, so we could get a distance of say 20 miles, for example, and over 20 miles there should be about 293 foot of curvature. 266 foot of curvature over that distance. Okay, we can test for things, becoming obstructed in the distance. That's been done hundreds, if not thousands of times now, and no curvature is ever detected. Okay, we've got teams of engineers going out with high-powered lasers, that kind of thing, shooting the laser over the surface of huge distances, right, over the water, over frozen lakes, over salt lakes, and they're hitting the targets at the same height, right? So say they set up the laser at 1.5 meters height. They'll shoot it over, say, a 40-kilometer distance.
Oh, yeah, okay. I knew the experiment you're talking about. Didn't it, actually register that there was a curvature?
No. You're probably thinking of a different one. Okay, this one was done by a team of engineers in Europe called Field Engineers Corps, and they shot the laser from 1.5 meters height, and they shot it they did 5 different tests, but on the longest test it was over 40 kilometers distance. Okay, and
did they make sure that
they had weather stations. They had weather stations measuring the density, the pressure, accounting for refraction, that kind of thing, and they repeated. Right, they also repeated the tests as well 5 different times, different weather conditions, and every single time they're hitting their target. Right, they're not the only ones that have done it as well. Okay, so they have an hour-long documentary and a 180-page PDF document, 100-and-something page PDF document.
Can you send it to me?
Yeah, I can pop it in the side chat for you.
Thanks.
No problem.
You know they're lying, DJ. You know that, boy.
No,
what is this? Like, if you say it's a lie, what does it change?
Nothing. You already experienced the Earth is flat and stationary, right? You already live on the flat Earth. So the only thing that's going to change is your knowledge and the way that that would change people's situations depending on how they take the information, what they want to do with that.
I mean, yeah, but like me personally, like I will look into what you're going to send me, and I read these what that person you sent them, you actually sent them, but I kind of I don't know. It doesn't feel like it's logical, sort of. But at the same time,
like an appeal to incredulity.
What?
You're saying I don't think it could happen. I don't. What the information that you're giving me. I haven't seen it yet, but I'm appeal to my incredulity. How do you say that word? Okay.
Incredulity.
Incredulity.
Incredulity, yeah. Just one sec. DJ, was that Ski that came in?
Incredulity.
Gunslinger?
Yeah.
It was Ski.
Yeah, that was Gunslinger, yeah. I don't know who it was.
I just don't want to get rid of the wrong person, that's all.
Skepticism. Could have just said skepticism, man. Didn't have to send me on. Okay. No. What I meant to say was that I have to actually read this because this is kind of interesting. But at the same time, now I'm thinking I had to rely on certain navigation methods. I had to use them. I was up there, sort of in the sky, and I saw the Earth. It looked curved to me. But at the same time, that doesn't change anything for me. The way I used to live and the way I would live, it doesn't take from the importance of this, by the way.
I was military also. I've lived in 10 different countries on 3 different continents. I've been on flights and I've been on ships. It's experienced the same way, no matter if you're at, 200 feet off the water or 40,000 feet off the water, right? You're referencing a horizontal plane, especially if you're going to use a sextant on the, I don't know, say on a C-130. Inside the crew station, they've got the little sextant that hangs from the ceiling. They've replaced it, but you'd have to have your horizontal reference, and then you would take your elevation angle to the star, right? And so now your angle to that star is going to be from that horizontal reference frame, which that horizontal reference frame is parallel with the horizon, which is all the way around you 360 degrees. If you lived on a sphere, you'd still have to make the horizontal reference frame. We're just saying that sphere doesn't exist because we're not measuring the curvature, so the method is just as you experience it, an angle from a horizontal reference frame.
Is there a map for flat earthers?
I stated earlier, all maps are flat.
Yeah, what kind of map do they use?
Well, the maps again would be referenced to the sky. So
can you give me one that I can read or study?
Pick one.
Pick one. I don't know what I'm picking. How can I pick from what I don't know?
What are you asking for?
A map, just a map that can be used as a reference with coordinates and everything that is used by flat earthers.
I can be a flat earther and I can use a map, a globe map, and I don't have any problem with it.
Do you know why? Oh, okay, fair enough.
Yeah, do you know why I have no problem with it?
Yes, explain to me, please.
The reason why is because coordinate reference systems are completely arbitrary. As long as you pick one kind of system, whether it's spherical or flat or dinosaur shaped, and you use it consistently, you're not going to have any issues. Right? Because the coordinate reference system itself is internally consistent.
That's nice.
Now, where the issues come in is if you're going to compare those distances to reality. And I'm here to tell you that the spherical maps that we have that are laid flat do not comport with reality based off of our measurements.
How does this work with gravity?
I drop a pencil, it falls to the ground. What's so bad about that?
I drop the pencil, it falls to the ground, of course.
Yeah, what's the issue?
I once saw this documentary that said that if gravity functions as we understand it to function, whenever you go to the edges of the Earth, what I said again.
Of a globe?
You guys, no. If the Earth was flat.
Yeah, I don't think there's an edge. Earth isn't like a disk in outer space, dude.
What is it?
I stated this earlier.
Yeah, it's the floor of the universe.
You said it's everything.
Yeah, the Earth is your reality. Listen, nobody knows how far you can walk.
Wait, oh, okay. I mean, that's not a point of reference with historical figures who actually.
No, I mean, if you use a spherical coordinate reference system, you're going to walk in circles.
Yeah.
But it doesn't mean that Earth is a globe.
How does that work then? If I keep going east, I will end up coming to the same point in a line. Yeah, right?
East and west are circular.
Yeah.
Yes. So it's going to work the same on either, right? So you have a compass and it's pointing north, right? Yeah. If you have it on a sphere or you have it on a flat surface and you want to go due east or due west, you're just going to go around in a circle. You're just going to go in a circle around the north and come back to where you started. Okay, what you wouldn't be able to do on a flat Earth is go south, right? Keep going south and then do a great circle, come back around to where you started. Okay, east to west, no problem on either. Okay, north to south, only on a globe. Okay, just so happens that tons of people have done east to west to east. No one's ever done north to south. No one's ever done a great circumnavigated around a globe, right, and come back to where they started.
Because it's geographically not feasible.
Okay, so whatever the reason, no one's ever done that.
When you look at the map,
that's just a fact.
It's geographically not feasible, sort of.
When you look at the coordinates, right? But in reality, we know that east and west are circular as far as coordinates go. As far as staying on a line of latitude. But if you go 90 degrees from north, you're not going to be heading west or east for long. Flat or globe.
Yeah, but because when you're at the utmost north, everything is south. There is no east and west anymore.
Right.
Correct, yep.
And when you're at the utmost south, everything is north. Magnetically speaking.
For the coordinate, yep.
Yeah. So what I'm asking is, okay, if you tell me that Earth is a reality, an encompassing reality, the way I'm sort of thinking right now, okay, I haven't read the data he just provided because I'm talking to you. I cannot read and talk at the same time. I'm just winging it with my thoughts and logic. It might be flawed, so I'm just winging. If I'm on a plane of reality, and I look up to the sky and I see these lights, the way you just mentioned them. There is no way for me and scientists to determine what these lights are. There are some theories that say that these lights are gases in a vacuum, doing the whole shebang. If there is that is up where these lights are, they are somewhere, and I am here somewhere as well. And on certain places on Earth, like if I am in France and I look up, I will see certain constellations. And if I am in Australia and I look up, I will see other constellations.
Not different times. Different times and places,
and of course,
right?
there's the time zones. There are the time zones. And
I'm not talking about time zones. I got you, man. So here's the problem. How do you know how much distance takes place between these locations? And how do you know whether or not these locations are oriented the same way as you think they are?
I use the sun and moon and constellations. The only thing that is permanent. Yeah.
Me too.
Yeah. And using them, I realize that I am in different places. Like that's how sailing works.
It absolutely is. Yeah.
So what I'm asking is, since on different places on Earth, doesn't matter, sphere or a flat circle or a realm, an encompassing realm that is reality itself, if there is something outside of it and I can look at it, doesn't that mean that Earth in itself is not a realm and that there is something beyond it, sort of, because I can see it?
If you can go outside and look back in like a God's eye view, then you will have achieved something that is impossible.
Impossible? Explain.
Yeah, where do you think you have to go to see the Earth like this?
Outside of it.
Yeah, like...
by outside, I mean towards the constellations that I am using as points of reference.
Right, nobody's been there.
You mean like nobody has ever left the Earth?
Nobody's been to the constellations and looked back down, no.
But we already see space stations.
Yeah, do you know how high up in elevation space stations are? They're about 250 miles.
Of course, they're always orbiting the Earth.
They're 250. Yeah, I know. The claim is they're in 250 miles in elevation above an 8,000 mile diameter ball. What percent is that?
Can you repeat the question, please?
Yeah, so they are 250 miles in elevation above an 8,000 mile diameter ball. What's that in terms of percent? We can bust out a calculator and figure out like what difference that is.
Just a second, I'm turning miles into kilometers so I can have an idea.
No, I got you. Yeah, go ahead. I'm doing it too right now, but in miles.
So a mile is basically okay.
Right. So 8,250 divided by 8,000 is about 3%.
Mm-hmm.
It just so happens that if you want to do some more exact mathematics, you are seeing 3% of the Earth's surface from the ISS.
Yeah, but you can actually see the surface on like, I guess your observation view, what's the word I'm looking for? Your perspective from that distance. What did you give me the percentage right now? 3%.
Yeah, 3%. You're seeing 3% of total surface. This isn't the way to do it exactly, but coincidentally, it gets close.
Do you think those YouTube lives from the ISS, like circling the Earth, do you think that's actually some made up bullshit, or like is it real?
I do, but for the sake of the argument, I would accept it. And I would say, well, if they're showing you Earth's surface, they can only show you at most about 3% of it. So why do they show you so much curvature?
Yeah. I mean, it shows.
It should look flat.
Why should it look flat?
Because you're seeing less than 3% of Earth's surface of a ball. So if let's say that the ball is like 8,000 inches tall, and you are 250 inches above it. Let's say the ball is 8 feet tall, and you're 250 segments of a foot above it. Like that is a fraction. That is, I think it works out to like 2 centimeters above an 8-foot ball or something crazy like that. Might even be less. The point is you're seeing such a tiny slice of the ball that you would not be able to discern any curvature whatsoever. It'd be ridiculous to assume so from 250 miles.
I understand. Yeah. You make a point, but at the same time, when we actually assume that there is no ball, if I go back, I'm sorry if it seems like I'm jumping, but
no, it's okay. Go back.
It's parts of my brain. Like this is assuming that we have a ball, right? Like the fella who said that it's not a ball at all. It's literally just everything.
That's sort of the sea that you would sail on or fly over. That's the floor of all of existence. That's the floor of everything that you would experience.
Bingo.
Right?
Yeah, go on.
If you wanted to go into the ocean, you'd have to create an environment so that you could survive. If you want to go into the sky, you got to create an environment in which you could survive. You're not going to go any deeper. You're not going to go underneath the floor, right? You're only going to experience what's on the surface.
Right. And so to me, like this world we live in is a realm. The Earth includes the dirt, the ocean, the sky, and everything. That is our world.
Yeah.
You know, and I can't create an object out of that.
What do you mean by that? I can't create an object out of that.
I can't conceive of it as an object.
Okay.
Yeah, like
okay.
I can't conceive of my reality as an object without coming up with some kind of fantasy imagination for what it should look like. So,
what about the pictures that were sent by the what's it called again? The Voyager 1 and 2 of Earth from different perspectives.
Not sure what you're talking about.
The Voyager 1 and 2, the one with the golden disc and all
the not real. The vacuum of outer space is not real. It violates entropy. You are in a contained environment.
How does it violate entropy?
Yeah, what do you think is containing the oceans from off-gassing into the outer space vacuum that's expanding and infinite? Gravity
spinning around itself. Yeah, Earth spinning around itself, and it's gravity, I guess.
So when I put a Coke can inside of a vacuum chamber with gravity supposedly pulling on the vacuum chamber itself and everything, and I start pulling vacuum, the can of Coke is going to explode, and all the gas is going to fill the vacuum chamber equally against gravity.
Mm-hmm. But it doesn't have a center of gravity, the Coke. Okay, wait. Before we delve into this,
but it's going against the Earth itself.
Just a second before we delve into this. I am a psychology major. I am not a physicist or someone who knows these things. So
just you can appreciate us even more because we are direct realists.
No, I'm just saying this. So like the scientific information that we're about to delve into, like it's not something that I am completely, like aware of.
Well, from a psychological standpoint, we are rational empiricists. From a philosophy of psychology standpoint, so we understand that reality exists apart from the self. There's objective reality that exists apart from your subjective experience, and you can understand the world through your experiences directly, and this forms the basis of your worldview. As a psychologist, you might appreciate too that children develop a flat Earth interpretation of the world until they're told otherwise, without experiencing it. So when you see that picture from Voyager of the Earth from outer space, how do you know Earth is supposed to look like that?
Because it's a picture?
Yeah, but how do you know that Earth is supposed to look like what the picture shows you?
Because I trust it.
Exactly.
I emphasize on trusted that the people who sent that rocket into space and detached that had like the whole thing, the Voyager, and it flowed into space. I trust their qualifications, and I trust that they have no reason to lie to me about Earth being flat or not.
Yeah.
Because for me to actually doubt this, there has to be. That's why at the beginning of the conversation I asked, what does this change? Because I have to understand what's the catch. If someone is telling me Earth is round or if it's flat or a realm, I don't instantly tell them get the fuck out of here. Okay, tell me at least why you think that way. And with humans, the way I approach these things, I have to understand what's the catch for this human to give me this, sell me this idea. So far, there is no reason for them to lie about such a thing, about their qualifications, about whether they actually sent the Voyager. I'm not talking about the moon landings or about getting people on the moon. Because
what if I told you I don't think they're lying? I don't think this is a conspiracy.
What do you think it is then?
It is interpreting data with a bias.
Bias. Oh, okay. I see where you come from.
This point of view I have right now makes me much different than probably 90% of people you'll talk to in this community.
Oh, no one is attacking you, so I guess
that's a good sign, at least. I mean, but but the community that we're from is also probably the genesis of this movement within the last 10 years. And when you go to TikTok, Facebook, X, and you Google this topic, you're going to find a lot of science fiction BS. You're going to find a lot of crazy people hawking conspiracy theories. That's not us.
Are you skeptical of the moon landings?
Good question.
Me personally, I take it with a grain of salt.
Same skepticism can be applied to the picture of Earth from Voyager by the same people who gave you the moon landings.
Dude, listen, if I'm being real with you, I am so skeptical of my own existence and my interpretation of reality that if I follow this, I would probably kill myself because reality doesn't really make sense.
Let me stop you right there. This is something that you can be as sure of as the fact that you're breathing right now. The fact that you can measure the Earth flat is something as sure as the fact that you had breakfast this morning. It's one of the fewest things. Listen, in this world of deception, it's one of the fewest things that I know for sure, 100%.
What do you mean 100%?
I measured it. I measured the Earth to be this way just as much as I measured my couch to fit my living room.
Have you okay, this might seem off topic, but it's like sort of did anyone here ever read the Critique of Pure Reason by Kant? Anyone?
A long time ago, yes. I used to study that what you did.
I don't claim that I fully understand it. I bet no one actually can claim to understand it fully, because like only Kant knows what the fuck he wrote. But like, I guess what I'm trying to say here is, when you take everything with a grain of salt, you are falling into your own bias. When you fall into skepticism, when like, for example, when you tell me about the Voyager 1 and 2, the images that were sent and were presented to the public.
Yeah, well, how did they prove it to you?
By the picture itself. And
yeah,
the
so
people who saw the rocket flying.
I would say,
space.
listen, this is a process that precedes skepticism itself.
Go on.
Before I can be skeptical, I need to be given enough information, and I haven't been given enough information in order to even be skeptical.
Like from the
space agencies. In fact, it's even worse. Yeah, the information they've given me is contradictory to the known laws of physics, which is what Tactical Droid was bringing up with you earlier.
Yeah. But like, when you tell me about the laws of physics...
Listen, they're giving me a contradiction. It's not that I have to be skeptical. I can outright dismiss their claim based off of what they're presenting as a contradiction of natural law.
But aren't the laws of physics based
I really don't.
Okay, so then let's ignore laws, right? And let's just go off of your experience, okay?
Yeah.
What I mean by it being a violation of what you experience is you recognize when you have high pressure or high temperature, that high pressure and temperature will flow into low to try and equalize, right? So you have your lungs. Right. You have your lungs. You expand your chest to breathe in. That makes a low pressure environment inside your chest. Your esophagus is open. The air from outside your body is higher pressure than inside your chest, so the air flows into your body. To breathe out, you compress your chest. That creates a high pressure environment because you've reduced the volume, and now the air takes the same process out. High pressure flows to low pressure to try and equalize pressure. You have an open system for your lungs, but you can open and close it whenever you want, so you can hold your breath and go underwater.
That's a variable, though. It functions differently depending on where I am. Basically, when I go diving, I do what's it called, compressed diving, and that's a whole different process when I am, like, let's say 10 bars deep.
How? You've kept your body closed. You've isolated your lungs from the outside environment by keeping your mouth closed.
It's not isolated. It's heavily affected by the outside environment, and it's so heavily
the outside
affected.
environment is compressing your chest, right?
Mm-hmm.
What I'm saying is the air is not allowed to leave the system because you've left your mouth, your throat closed, so that the air inside your lungs stays inside your lungs. You see what I'm saying?
No, not really. I don't.
So then, while you're diving, you let the air out and you breathe in the water.
No, I let the air out, and then I breathe the mix of air, the mix of gases that I concocted for that certain depth.
So your dive tank.
Mm-hmm.
Okay, I'm talking about the outer environment, which would be the water, the body of water that you're diving in. Okay, and your lungs. Right? You've decided to now create an expansion pack to this closed system that you're going to have. And you're going to breathe in from the tank, and you're going to breathe out, and it's going to push it out
outside into the water.
Into the water, right? But you're not allowing the water into your body, so you have a closed system.
Of course.
Okay. This, in comparison to the Earth, right, having water and gas inside of that massive vacuum, is not comparable.
It has an atmosphere.
That is the gas that gives it.
Yeah.
The air inside your lungs, the air that's on the Earth, that's your lungs.
Keeps it a closed system.
It is not a closed system on the Earth. It is an open system.
How?
It is an open system.
How?
We can launch Voyager off into outer space. We can get meteors to come and kill the dinosaurs, according to the stories. It's an open system, but the air is not releasing off into that low pressure environment.
Yeah, it's not.
There's no barrier preventing it from happening.
Super basic demonstration in the side chat there. Right, you can use the top chamber is a vacuum, right? That could represent outer space. The bottom chamber is a gas pressure system. Could represent what we're breathing right now. Okay, a space is above the low pressure system, and we have a valve, right? We have a separation of the two systems. And what do you think is going to happen as soon as he releases that valve?
Of course, the vacuum will be compensated by its pressure, and it will take from the gases from the other one.
Yeah,
other
and
side.
relate that on a grand scale to what we have here, right?
Earth, on Earth, the thing, what's it called? The thing that she twisted, or it twisted to
The valve.
compensate. Yeah, the valve. The valve on Earth is the the layers of atmosphere that we have.
That's gas.
Each
That's
layer, exactly. Each layer is composed. Each layer is composed of a
gas. Doesn't
kind
contain
of
gas. Gas doesn't contain gas. This is evidenced by the air we're breathing. It's a homogeneous mixture.
It's contained by multiple factors, like gravity, like temperature. Like oxygen, when it's hot, oxygen becomes lighter. When it's cold, it becomes heavier. And the higher you go, the gases will change. We will have other gases. So gravity is the one responsible. The gravity and the magnetic fields are the ones responsible for creating this barrier. The very fact that Earth rotates. Just a second. The very fact that Earth. I'm not going to say fact. The saying that Earth rotates on itself and its center creates a magnetic field that prevents those gases from escaping and prevents radiation from the outside, from like the sun, to affect us. Blah blah blah. All these things.
Okay, so the Earth is spinning, and you experience centrifugal forces causing different densities of fluids to have the denser material.
Don't experience
at the outer edge of the cycle, at the outer edge of the centrifugal force, while the least dense is at the center of the centrifugal motion, right? Which is opposite of what you just claimed the Earth is doing. The Earth underneath your feet is spinning, but the denser materials are at the bottom, and the least dense materials are at the top. Opposite of what you just claimed.
Can you please go back to what you just said?
Okay.
Re-say
in that. Your reading of whatever it was that you read, it stated that the Earth is spinning. Okay.
I wasn't reading. I was saying from the top of my head.
All right. When you take different densities of fluids and you put them on like a centrifuge, okay, it spins the fluids, right? You can make a merry-go-round, give you your... Anyway, you have the centrifugal force applied to the fluids, right? Now the denser material is at the outer edge of that centrifugal motion. So if you take the flask of different densities of fluids and set them on its side and then spun the merry-go-round, the denser fluid is going to be at the edge of the merry-go-round. The least dense fluids are going to be at the inside of the merry-go-round. Can you picture that?
I'm trying to. All
right, here. Let me see if I can get one.
I was going to ask about something I forgot.
So the fact that you're breathing air means it's pressurized. The pressurization of gas does not depend on gravity, according to natural law. One of these laws is called Avogadro's law. We can demonstrate this law in a laboratory, and we can find evidence for this in the natural world. And I can tell you more about this if you're interested.
We didn't exist breathing air. We developed into breathing oxygen.
Yeah, the fact that you're breathing means that there's no vacuum adjacent to the pressurization that we are experiencing with our breaths.
A lot of factors fall into that, like the effect of the moon, heat.
Yeah, the moon, okay.
Not heat, the temperature, and the movement of the oceans that create.
Yeah, that may be true.
The winds and all that. Yeah.
The fact that you're breathing is not reliant on gravity whatsoever. There's an entire body of physics called kinetic molecular theory of gas behavior. Does not use gravity. Ideal gas laws have no gravity in the entire in the equation. Excuse me, in the equation.
Okay, repeat that, please.
Gravity is not a factor in any of the gas laws. The laws that govern the behavior of gases do not have gravity in them. There's no gravity in the molecular behavior of gas. No kinetic theory of gravitation for molecules.
Okay. How does that affect? What was the punchline?
Your assertion that gravity causes the pressurization of gas is unfounded.
I was saying the moon. I was saying the moon causes the tides, the change of tides, and
the moon is why you're breathing right now, dude. Hold on. We're talking about the fact that you're breathing gas.
Breathing gas? I mean, I was evolved to breathe gas. I'm not saying it's because of gravity that I breathe gas.
On the
Yeah,
globe,
so what's
yes,
the atmosphere?
The atmosphere is, like I said, a bunch of gases that choose altitude depending on temperature, and
Yes, not gravity.
gravity affects the magnetic fields. It doesn't affect the gases.
No.
Right?
Gravity does not affect magnetic fields.
Wait. Isn't like our magnetic field is affected by our by the Earth spinning around itself? Hey, come on!
You think
don't
Earth can
me. I'm
suspend a
actually
magnetic
thinking
field by rotating?
yeah, that's my understanding of it.
But so
Second.
the rotation overcomes the Curie point.
Bingo.
And what's the evidence of rotation?
I don't
QTO.
know how to tell you.
Yeah, nobody.
What do you mean?
Scientists told me, trust me, and I trusted them.
Well, Emperor, tell him if you want to see the Earth rotating, you look away from the Earth. You look to the sky, and the sky is rotating. That means the Earth is right.
I follow the constellations, of course.
There you go. So
Those things move, not the Earth.
Yeah, Emperor, right? Ignore the thing in question and look at something else. And if that something else is doing something, you can attribute that something to the Earth.
Hey, Gemsy, I actually think he might be ready for the sporadic meteor complex conversation.
Oh no.
Me personally, I have to rely on my knowledge of constellations to determine my location and all those things, and actually navigate using maps and all that. So, like I said, what you're telling me right now,
that it happened on a sphere. You're only currently asserting that it's a sphere because it's what you were told.
Wait. What I'm saying is, Earth being flat or realm or a sphere does not change my knowledge or my way of dealing with that.
No, because what your knowledge comes from your experience, which comes from the world around you, which comes from others having the same experience and writing it down so that you can learn the method to do it as well.
Yeah, it's a method that can be used.
Sure. It not being a sphere allows you to be able to do everything you do, even breathing air that they explain to you very, even with the Gauss law. So for you to be experiencing what you're doing, vacation and everything, don't you need to breathe air first?
It sure does.
The conditions in place to be able to do everything you're saying you're doing, yeah. And what you're doing, you're measuring angles to the constellations, constante constellations, that they're always moving in cycles like clockwork, that they're repeating cycles. That's why you can use them as references to determine your position on your GP on the ground.
Oh, it gets even worse, Gemsy. So he's a psychologist, right? So when he looks at the sunset at night, psychologically, he's watching the sun move down, but psychologically, he believes, because he was told this, that he's rotating backwards on a ball. Even though he's watching the sun move, but he thinks he's on a ball that's rotating backwards. Isn't that crazy?
Listen, this one can be thrown right back at you, because when I see the constellations, sun, star, moon, all of that, when I see them moving,
you think it's the Earth rotating.
What a laugh. Okay, listen, when I see them moving, and throughout the seasons, throughout the years, I can accurately deduce the location of every star.
Yeah, me too, and I'm a flat earther.
Yeah, that's what I said earlier. I said that earlier. I said that does not change anything. What I'm trying to say now is it the constellations above me that are moving, or am I moving, which is a conversation that a man got burned for and killed.
The constellations are moving, dude, 100%. Yeah, I'm totally serious.
That would be the starting point, right? That would be the base axiom. Okay, the Earth doesn't appear to have any curvature. It doesn't appear, right? We don't sense any movement, and we see the celestial bodies moving in cycles in the sky. Okay, you've been told a story that everything's the opposite of what you experience.
Okay, just a second. What is this? The Curie point temperature? Oh, okay.
It's the point at which magnetic fields become incoherent. So what you have is a bunch of electrons that are vibrating and moving around, and they no longer point their north-south in the same direction. They're vibrating so rapidly because of the heat that the magnetic field that requires all the electrons to move in the same and rotate and point in the same direction, the heat causes them to lose coherence. They start pinging off each other, moving left and right, up and down, 6 degrees of freedom, total chaos and bedlam. And so the magnetic field that was once strong starts to weaken and weaken and weaken until there's nothing left. Okay, so that's what heat does.
You know what? Only one way to tell if this is true or not. I'm gonna go.
Yeah, we measured the Earth with lasers, dude.
Oh, okay. I was just gonna go on my rocket
40-kilometer laser tests over frozen lakes.
Uh-huh. Frozen lakes.
Yeah, no curvature.
Yeah, but you're doing it on the same lake compared to Earth. It's back to that thing where you told me, like, from the space station,
Yeah.
you can only see 3%.
No,
If you
no,
do
no,
it
no.
on the
We
lake,
have,
you're actually...
if I set up a laser on one side of a 40-kilometer lake,
I don't believe you.
listen, I'm
when
going
you
to tell
actually
you
do it from... Just a
Oh
second.
my
I'll
gosh.
believe you. Just a second. Come on, I'm not being aggressive. I'm just saying, like, if you actually do it from, let's say, from America to Australia, is that feasible?
Australia. What about from England to Australia?
Doesn't matter.
We've got something to
Any
show him.
point.
Like I can show you 720 miles of Earth in infrared, where a mountain range on the horizon should be 180,000 feet below the curvature of the Earth, but you can see it.
Repeat that, please.
So from an airplane at 35,000 feet, call that 10,000 meters. I can show you infrared footage through the air of a distant horizon in a mountain range. The mountain range is a known geological feature that is 720 miles from the airplane's location. The curvature of the Earth should begin at about 260 miles from the airplane's height. The mountain range should be 180,000 feet down. But you can see it. You can see it from 260 miles away from the plane all the way out to the mountain range and beyond. 760 miles of flatness. And we have dozens and dozens of these. We've got hundreds and hundreds of long distance observations. We've got dozens and dozens and dozens of laser tests all over the world in frozen conditions and hot conditions over land, over sea, across the air. We have not only our own tests, but we have the tests done by the US government and by other organizations around the world. We have flat earthers with weather balloons taking infrared cameras to 120,000 feet. You can see well beyond the curvature of the Earth. This is why we're here, okay? The world has not heard about us yet.
I mean, okay. I mean, they heard about Epstein. I'm sure they're going to hear about you.
I hope so. Yeah, like, I mean, you've heard how bad the Epstein freaking deception is. Wait till you hear about the globe deception. Holy cow, dude.
I mean, wait, so the Epstein thing, I get that it's a deception because there was, like I said earlier, there is something to gain from it. No one here told me what's there to gain from saying that the Earth is round.
Yeah, well, I mean, listen, I mean, this is a self-delusion. This is a self-deception.
Okay.
Human civilization
so
for hundreds of years, have accepted the globe as an explanation for the stars.
Wait, so, no, wait.
It's broken.
Ever since, like, ancient civilizations used to think that the Earth is flat.
That's true too. It depends which civilizations, I guess. If you look at the ancient Greeks, from I don't know, Pythagoras.
Certain Greeks.
Right. So in Vedic cosmology, they were flat earthers. Chinese cosmology, they were flat earthers until about the 1600s.
Arabs were
Protestants in Europe were flat earthers through Martin Luther and beyond.
Yeah, but they killed Catholics too. Aren't they the ones who killed Galileo for saying that the Earth is...
They were, but they flipped.
No, they didn't kill him.
What happened?
Nobody was ever killed due to their belief in heliocentrism. Not once.
Wait, I'm pretty sure they killed him, right?
No. They flipped.
What happened to him?
He was on house arrest. The Roman Catholics actually became the biggest purveyors of the Big Bang Theory. The Big Bang was invented by a Jesuit priest.
Wait, he was sentenced to life imprisonment. Spent the rest of his life under house arrest in Florence. Come on, that's...
Yeah, I can believe that. Listen, the Roman Catholic Church invented the Big Bang Theory.
Yeah. Wasn't it the Big Bang Theory? I mean, there are multiple theories to it.
Georges Lemaitre invented the Big Bang Theory. He was a Roman Catholic Jesuit priest.
It falls under the presumption that the universe is expanding, therefore it must have been compressed into a single point, right?
Which is fundamentally Kabbalistic.
What does that mean?
This comes from Kabbalah, from the idea of emanations, which preceded a lot of Gnostic influences regarding the...
By the way, I am a Gnostic.
Okay. All right, so the uncreated light of the universe is responsible for the Big Bang because it basically withdrew itself from itself, and by withdrawing itself, it created a vacuum, which created a positive explosion of the universe. That's basically what the Big Bang is.
Yes. To my understanding, of course. My humble understanding.
Yeah, it's a bunch of baloney.
I am eating some bolognas now.
If it's pork derived, I love you, man.
It's beef. We don't have pork here, so. Are you like what?
Try some pork, man. Bacon is the best.
I did try bacon. I loved it.
Okay.
When I traveled outside of these Muslim countries. But okay, do you think this is derived from the whole creation myths? I used to study anthropology at a certain point.
Oh, cool.
At
Okay.
my bachelor year. First bachelor year, I used to study anthropology. I was like interested in it, and I used to read about like the creation myths.
Yeah, I mean, many creation myths are Kabbalistic. I would say even the Vedic texts come from Babylon, which is the root of Kabbalah itself.
Yes. Most of them approach the celestial bodies as levels, sort of.
Right.
Like if you take the Greek, let's go beyond. I mean, before the monotheistic religion started to show, like when we go to pantheons, and before that as well, to myths. Most beliefs rotated around the idea of multiple dimensions that exist within one realm. And in order to ascend from one realm, you need to shed every connection you have to the realm you're in. Like if we take, for example, Norse mythology, the tree of the realms. In order for you to travel between those realms, you need to be a certain kind of, like humans, for example, in Midgard, they cannot travel to Niflheim without severing every connection they have to Midgard, right?
Yeah, I got to shed the dead weight. I gotcha.
I am sort of falling into, like I said, I've been reading a lot about Gnosticism. Specifically, I bought a copy of the Gospel of Judas and Judas, the Gospel of Mary, and the ones that they found, and blah blah blah. And I'm reading a lot into them, and I'm reading a lot into the whole mythos of how the universe came into being, and it falls under the same idea of layers and dimensions. Except with Gnosticism, it's not the same realm. It's actually a different one, the material realm. And I remembered it because when someone here, what's his name? Jimmy Neutron, that's all I remember. He told me that it's a realm, the material realm. That kind of makes sense when you look at it from a Gnostic point of view. But at the same time, it's flawed, so meh.
Yeah, but within this paradigm, right, within materialism itself, we use matter to measure itself, matter, and we discover that there's no curvature. The curvature that exists, the globe, is not material. This is in your mind.
Okay, I believe you.
People who call themselves surveyors and geodesists, so geodesy is the so-called measurement of the globe. They begin with measurements of the Earth using triangles, point to point to point to point. They actually measure the Earth flat in reality. And you know what they do? They say, I distrust what I actually measured in reality because reality is illusion. It's Maya, right? It is in a higher realm, and I am being deceived. So what I must do to make these measurements conform to what I think is real is to select a mathematical model of the Earth called a datum, D-A-T-U-M. And I'm going to take these measurements and I'm going to bend them. I'm going to take these flat triangles, these horizontal triangles, these vertical triangles. I'm going to bend the math to fit this curved datum. And then I know it's got to be true. And how do I know that the curved datum is true? Because it's how I interpret the stars to behave as I move. This has been going on for hundreds and hundreds and hundreds of years. They measure the Earth flat. And then, because they're conforming to an ideal in their mind, they take their perfectly good flat Earth measurements and they break them. This has been the human condition. Yeah, we can prove it. I can prove it by showing you their own textbooks, their own lectures. I can show you their own mathematical processes, their philosophical thinking, everything. There's a book, a famous 2-volume set written in the late 1800s by F.R. Helmert. He was a German mathematician and scientist. He fancied himself a surveyor, a measurer of the Earth. And he wrote a book called Higher Geodesy in German, and it's been translated in English. This 2-volume set serves as a foundation for modern geodetic measurements. Within these 2 volumes, he outlines a 10-step process in mathematics and measurements. The first part involves these measurements of the Earth. You go out, you take what's called the theodolite. You basically measure the azimuthal angles between 2 points of interest. You measure their vertical height and elevation. You do this a bunch of times over a bunch of points of interest. You're going to get a flat Earth. And he says, aha, but we know the Earth is not flat. And therein lies the philosophical presumption of a globe. Aha, we know the Earth is not flat. We have to contort and move this stuff. Why? Because when we look at the stars, we imagine a globe. Right? I mean, this goes back to the Greeks. So because we imagine the sky to be a globe, we're going to imagine that Earth is a globe. And if the Earth is going to be a globe that conforms to how we imagine the sky to be, the Earth is going to be this big. And it's going to be of this dimension. So we're going to take those azimuthal angles and elevation angles, and we're going to select one of these models of the globe. And by his day, in the late 1800s, there were many different models of a globe, mathematical models. There's the Airy ellipsoid of the 1820s, the Clark ellipsoid of the 1860s, the Bessel ellipsoid of the 1840s. There are so many different models. They were not all in agreement. He said, basically pick one. And if you want, use an average of them, right? And you're going to take your flat measurements. And as he walks you through the 10 steps, you're going to build a globe out of your flat Earth measurements. You're going to use the globe model. You're going to use globe refraction ideas. You're going to use astrogeodetic surveys of the stars, and you're going to take your flat Earth measurements, and you're going to use all these things, and you're going to break them. You're going to break them in such a way that conforms to an ideal that doesn't exist in reality. And that is what geodesy is. This is what NASA used to launch satellites. They never measured the Earth. So what's funny is we can actually look back in time throughout human history and show you all the flat Earth measurements before they were perverted with these globe models. We can do the same thing today. We can go out and measure it. We've got field engineers, credentialed experts with lasers that cost 30 grand on custom-built gimbals that have sub-millirad accuracy. And they've gone all over the Earth, at least from Western to Eastern Europe, from the Netherlands to Hungary. And they've measured the Earth. They can't find curvature anywhere. We can point to you measurements taken from the military. We've got a great example from, I think it was from the Big Island in Hawaii to Maui, or Maui to Hawaii. There was a 149-kilometer tri-band laser propagation that was done by the U.S. government on top of one of these volcanoes. Might have been Mauna Kea. They've got this observatory, they've got this laser set, and they shot lasers 149 kilometers, 3 of them to make a precise target grouping on a telescope on the receiver side. The point of this test was to determine whether or not there was terrestrial refraction. That is are there conditions that bend these lasers around the globe? Well, let me backtrack a bit. When they shot these lasers, they actually had no test in mind, but they shot the lasers to a target, and a bunch of nerds came by and said, let's come up with tests and explanations and experiments for this. So there are a few guys that came along. They studied the propagation path, 149 kilometers, and they tried as they may to retrofit terrestrial, that is globe curvature refraction formulas, to explain how it is possible that these 3 different lasers at 3 different frequencies are able to hit a target of such a tight grouping that is beyond the order of diffraction limits of the laser itself. And they couldn't come up with an explanation. They had to develop a custom model involving a combination of terrestrial refraction, because they believed in the globe, plus turbulence to explain the propagation path. In other words, they shot a perfectly clear line of sight, 149 kilometers, without any globe curvature present, and they had to backfit globe curvature into the explanation in order to explain what happened without any real-world measurements. So you got that going on. Then around the same time, coincidentally, you had military surveyors in the Chesapeake Bay region. The Chesapeake Bay is outside Washington, D.C. It's a nice part of the Earth where you can pull up some delicious blue crab. If you tie some spent chicken wings to kite string, you can lob it into the water. The crab's going to lob onto it, and you're going to pull them up, and you can net them, put them in your cooler, bring them home, and boil them with Old Bay. Yes, I've done that. So they were shooting lights across the Chesapeake Bay, right? They purposefully positioned a ladder of lights such that the bottom light would be below the curvature of the Earth from an infrared telescope on the other side of the Chesapeake. What they found was they could see that bottom light across the Chesapeake. And what frustrated them is this was their control variable. This was the light that they were supposed to use to control for the curvature of the Earth. And their point was to study the marine layer, the sub and super refraction effects from the diurnal cycle, the day and night cycle of the sun, and the seasons to see how much distortion, optical distortion there would be from the point of observation to the point of interest across the Chesapeake Bay. So the bottom light served as a control variable for the freaking globe. And you know what? They saw the bottom light in conditions that didn't make sense whatsoever. They called the situation cursed. This was two teams of military surveyors working under a NATO contract funded by the Naval Research Lab of the US military. The project was called NATO Sapphire. You can Google this, you can pull up their papers, and you can check it out for yourself. They called the situation cursed. They were trying to control for the curvature of the Earth, and they couldn't freaking do it. And so they decided to go with the curvature of the Earth anyway. And you know what they did? They backfitted their data as if the curvature of the Earth existed, which required them to modify the temperature gradient by 2 orders of magnitude in order to explain the amount of curvature that they thought was present that really wasn't in real life.
Just a second. What was was it NATO Sapphire?
Yeah, SAPPHIRE.
Yeah, I had a watch. I mean, the results came in with a watch, a hand watch, a wristwatch. Can you specify?
It was with the watch.
I typed in NATO Sapphire, and the results were a wristwatch. So can you give me another
maybe a PDF. Put PDF next to it. You might get maybe a PDF.
I'll post the PDFs in the chat.
Okay, Sapphire optical smallsat AIT. Is that it? No. Refraction measurements and modeling over during Sapphire Trail, however, we're able to arrange a zodiac order level.
All right, I posted the PDFs.
How can I know it's not furry porn?
Don't be stupid, dude. Come on.
Swear to God, if it's furry porn, I swear to God. God damn it, it's not furry porn.
I'll post the other papers I referenced earlier to the 149-kilometer tri-band laser propagation. So the so what for that is listen. So they use 3 different bands of frequencies. Refraction is frequency dependent. So lower frequencies are going to bend less through the medium than higher frequencies. What they were looking for specifically was the target grouping of 3 different frequencies, one in deep infrared, one near infrared, and one in visual spectrum. They wanted to see how much these 3 different lasers had diverged as a consequence of globe curvature refraction. They were surprised to find that 3 lasers actually hit the target and hit them much more closely together than they thought they would, which means terrestrial refraction as an explanation for seeing things too far is a whole load of crap. You want those papers? I'll post those too.
Emperor's Child's going to have 6 months worth of research to do by the time he leaves this conversation.
Yeah, you guys gave me a lot of sources that I need to actually read, and I have to prepare my bachelor. I'm making a study on addicted people and their cognitive capacities, and you guys give me this, and now I have to read this and do my research at the same time. So, God damn it.
Just one thing I wanted to add as well. You were saying earlier, extremely long observations would be better, but if gravity, right, the way it's claimed to exist on a globe, okay, if everything's being pulled towards the center of mass, okay, that would mean that any body of water, okay, of substantial distance would be able to be calculated. We would be able to tell exactly how much it would have to be curving. Okay, if the globe was to be real, if gravity were to be doing as it should in that claim, right, just 10 miles, right, 10 miles, 20 miles, that's plenty, right? There's a huge amount of curvature over these distances, and it would have to be there. If it's not there,
yeah,
okay, then it's a big problem for the globe.
Hey, when was that? Did you guys read about that paper when they said the Earth was not a sphere, it was a potato? The shape-wise, of course.
Yeah, it's like the gravitational model. They're not saying it's literally that shape.
Yeah, it's like a rough-shaped potato.
Right.
You guys are not debunking gravity, right?
Well, flat water debunks the claim of gravity, essentially.
But even if it's flat,
the
like
claim of the
it's
cause.
laying on, like for something
Right.
to like, even if the Earth was flat, it needs something to pull everything down, unless
Not everything.
it floats.
The claim of gravity is a philosophical claim. Nobody's ever used a scientific experiment to identify the cause of gravity.
Wait, they
Gravity
did.
doesn't
not the
pull gas
cause,
down.
of course,
Okay.
but effects. We know the effects of
No,
gravity.
gravity does not pull gas down. Period.
I'm not talking about gas. I'm talking about
Yeah,
like
but you
water.
said
Like you told me
everything.
water.
Gravity
Okay,
does not push you
take
pull
everything
anything
with
at
a grain
all.
of salt.
It
What do
doesn't
you
push
mean
you
it
pull
doesn't
anything.
pull anything at all?
It doesn't
It
hold
doesn't.
the gas against the vacuum of space.
What is keeping, like, if the Earth is flat and
There's
like
no
he was
vacuum
talking
of
about?
space, dude.
Hey, don't yell at me. I'm sensitive.
I just did.
Try
I'm
and-
sorry.
Try and pay attention then. He won't have to raise his voice if you'll pay attention the first time.
Oh my God! I hope you don't become
Well,
a father, man.
Deal with it.
Let's do
You
this a
are
different way.
presenting fatherless behavior.
Let's do this a different way. Can someone tell us what gravity is and what it does?
Oof, 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 oof. Why did this suddenly turn very violent?
No, it's all good. Let's just carry on. It's fine.
It's not violent.
Why did this turn so violent?
What is gravity and what does it do?
This says who? We've been on with this guy for like an hour and 20 minutes.
I've been in and out listening to it. I mean, he's got some staying power. It's just, after a while,
Hell,
if you believe that gravity is a thing, what is it and what does it do?
ever
Yeah,
see
you believe it's a
Kindergarten
thing,
Cop?
yeah, I think-
Like Kindergarten Cop with Arnold Schwarzenegger. Who is your daddy and what does he do?
Yeah, exactly. There seems to be a lot of disagreement among people who believe in the globe about what gravity is and what it does, and the current rhetoric around what it is. And sometimes they'll combine the current rhetoric with an older rhetoric and try to shoehorn one into the other. And I'm just curious, what is it and what does it do?
It's basically an attraction that pulls masses together, basically.
It is an attraction that pulls masses together.
Yeah.
I don't ever see this
Yeah,
occurring
where does that-
anywhere in nature. Yeah, where does that
Right.
happen?
Your feet are on the ground. You're a
Welcome
mass.
to circular
You're
logic,
attracted
Mr.
to-
Psychology Man.
Yeah, that's circular, bro.
What do you mean
Don't
circular?
tell me. Well,
I
at this
jump-
point, we have a baseless assertion. So you're saying your feet are on the ground because of gravity. Okay, well, what
Yeah,
is
because
gravity
if
and
you
what does it
jump-
do?
It's the thing that pulls me back to the ground when I jump. Basically.
Okay, is it made of
But that's
something?
true, dude. So,
Well-
like, I'm going to ask you, like, what is your evidence that gravity's responsible for the thing that pulls you to the ground?
It's not.
You're going to
I'm
answer the
explaining
thing is
what
pulling
my-
me to the ground. I'm going to say that's circular reasoning, dude. And you're going to be like,
Okay,
What?
tell me what it is. Okay, let me ask you this. What is pulling me to the ground when I jump?
nothing's pulling you to the ground.
Why am I not flying then?
Hold on, bro. That's
Look at
for
the
you to
side,
answer.
Dad.
You're asked. This is a burden of proof reversal. It's a fallacy.
No, I'm asking.
You're saying that something is pulling us to the ground. I don't experience anything pulling me to the ground, nor does anybody else.
Oh, you're floating?
Yeah, and says who? It's even worse than that. He thinks you're going to fly.
Right.
He thinks
So now
you're
I'm
going to
gonna
fly
float?
somehow.
Why would I float?
Check the side chat. You do not understand your own worldview.
I do not understand my own.
Why
world.
Yeah.
is flying an alternative, dude? Why would you think you would fly?
Because on a globe.
Yeah, because on a
You're
globe,
right.
you think without gravity, you're going to fly. It's circular reasoning.
Exactly. So it goes like this, right? Gravity because I'm on the ground. I'm on the ground because gravity.
It's my explanation. It's not gravity. It's a thing that I used, an arbitrary word that explains why I am on the ground. And why when I jump off a cliff, I fall and my speed accelerates to the point where my bones crash.
Holy cow, dude. Do you hear yourself right now talking out loud? Like, you should go on the YouTube and play this back.
Am
That's
I
silliness.
hearing-
Funny, like he doesn't need gravity to explain that. Like
Am I
relative
hearing
density
myself?
does.
Just a second. Am I hearing myself when I say that if I jump off a cliff, something will pull me down, a force will pull me down to the
That's an
ground?
assumption. Yeah, it's an assumption.
What if you
that you've
jumped into a pool of water?
Yeah? What about it?
It would stop you from hitting the
down.
ground, right?
If I jump into a pool of water, I will fall into the water.
Yeah, and you
Yeah.
will float on the water, right? Like you won't be falling with gravity.
Depending on the height. If it's too high, then the surface tension will function as a solid.
If you jumped off a cliff and you were holding onto a bunch of helium balloons, you'd float up.
Yeah, you're still
talking
giving us
about right
the
now?
observation, right? The observation is in air, I go down. Okay, I'm going to ask you why. You're going to say gravity. I'm going to say, what is that? You're going to say it's the thing that makes me go down, and we'll just be in this circular loop.
What is your explanation to it then?
Explanation for what? I-
Or what makes
don't
me fall
have one.
down when I jump?
Nothing makes you fall. You just do.
You are more dense than the
What you're
medium.
saying. So what
You're
you're
more
saying? What?
You
Look,
are
this
more
is the
dense
two-
than the medium you're in, dude.
Exactly. Look, you guys on the globe side, right? You need to have some type of force or pseudo force, right, pulling you back down to the earth in some way, right? Because you think that you live in a big space vacuum and you would just fly off into space, right? All the gas, everyone would die, all the water would boil, blah, blah, blah. Okay, so you need to be able to explain all of these things, like all of the ocean sticking to the outside of a ball, people sticking to the outside of a ball, and all of that kind of thing, and not flying off into space. We don't have that issue in reality. Okay, so you need to have gravity to have a globe, okay, and you need to have a globe to have gravity. Okay, whereas on a flat stationary system, things will rise or sink due to their density in relationship with the density of the surrounding medium. Okay, so that will basically dictate which direction an object will go. Okay, if you drop a tennis ball in the air, it's going to sink through the air because it's more dense in the air. If you change the medium from air to water, the tennis ball is going to go upward. Okay, and also, right, there's also a displacing force as well. Okay, there's going to have to be some energy exchange to pick something up for it to move in the first place. Otherwise, it will just sit in equilibrium forever. Like a rock sitting on the ground, it's never going to move. If you come along and you exchange some of your energy, you pick up the rock, and then you release the rock, it's going to sink back down to where it was. Right? The only reason it moves is because you picked it up and you dropped it. You input energy into that object.
Okay, now I see.
Yeah. And we can vary and manipulate this, right? Let's say we have a glass of fresh water and we grab an egg, okay? And we put the egg in the glass of fresh water. It's going to sink down to the bottom because the egg's more dense than the fresh water. Now, we could vary and manipulate the medium, okay? Not touching the egg, just add some salt into the water, and now you're going to watch that egg change direction. It's going to go from sitting at the bottom and it's going to go upward, and it's going to rise up to the top. The only thing that was changed was the density of the liquid medium in that case. Okay, so that's why anything that you can think of in nature goes up or down.
Kind of makes sense when you consider that for avians, they need to have hollow bones in order to minimize their density so that they can fly.
Precisely. There's no need for gravity. It's not a real thing.
Hey, you could have explained it like DJ did right now instead of just going on loops. Come on.
No, well, look, sometimes I think we have to get people to think critically for themselves. That's why we ask questions. What is gravity and what does it do?
Explanations to it, and you kept making fun of me. Like, that's not how it works.
Different people have different ways to present it. Look, if you talk to me, I would say gravity is a statistical distribution.
Rara. That's so sexy.
I know, I am.
Statistical distribution.
Statistical distribution, right. Right, you're gonna find mass where it's more prevalent. Just so happens that the ground you're walking on is one of the walls of the container that is encasing the air that we breathe. And it just so happens the ground you're walking on is the production source of the gases that you breathe. So statistically, you're going to find a higher prevalence of the gases that you breathe near the surface where it's produced that you're walking on. Yeah, the gas you breathe does not come from outer space, dude.
Has anybody clarified that we do not claim that it's some kind of pizza planet space frisbee with this guy
That'd
yet?
be a good point of clarification. Thank you, Ethergrass. Yeah, flat earthers, no pizza disk in outer space. If you think that flat earthers think that flat earth is a floating space pizza, nope, not us.
Oh, flat earth is not flat, dude.
Well, it's also, a topographical plane.
Okay. A topographical plane with no borders.
Not that we know of. I mean, there is an upper limit defined by the gas pressure.
So there is an altitude, but there is no, like I said, there are some altitudes, but there is no border to where it ends, where it starts.
No.
Well, no.
Okay.
Right. We live within a limited volume.
Limited volume.
Right. So basic gas laws. So if you were to take all the gas laws you learned in physics in high school and shake them up and plop them out on a table, you would end up with PV equals nRT. Pressure times volume equals number of moles times the gas constant times temperature. The V, pressure times volume in the beginning, the V is absolutely limited. If the V were infinity, we could not be breathing stable pressurized gas whatsoever. The V is limited. So it causes us to ask ourselves, if V cannot be infinity because we're breathing gas, does that mean that our existence has a limitation to it? The answer is yes. There is a limit. There's a defined volume. This is the law of gas. This is the law of nature. This is thermodynamics. And if you're going to argue against the laws of thermodynamics, you're going to have a bad time, let me tell you.
Question the words of the mighty Jimmy.
Yeah, man. If you're going to argue against the laws of thermodynamics, in the words of Heisenberg from Breaking Bad, you're going to have a bad time. I mean, it's true. Like everything. I mean, this is all about energy transfer at the core of it. Energy and matter cannot be created nor destroyed. Guess what? We have a stable gradient of gas pressure. That means our volume is fixed. That means we are in a giant container. Is it a fish tank? I don't freaking know.
So at the core
could be really freaking big though.
Right?
Yeah.
So at the core of this belief, you guys don't know. No one knows.
Yeah, it's so full of academic humility. It's going to make your heart warm. You're going to be like, oh my gosh, these flat earthers, they have so much academic humility. They're not arrogant. I want to be a flat earther. I want to be part of them because I experienced humility and humbleness in my own life, and I want more of that for myself.
Man, all right. The way you're selling it. I'm in.
Totally true.
Credit card. Okay.
Dude, I don't have a PhD. I got 2 master's degrees. I hope that counts for something.
Just remember, everyone here has already demonstrated that we're capable of changing our minds, and we interact with bigots who do not change their mind every single day. We've already shown that we can.
What do you mean? Is that a threat?
I'm saying that we speak with people who never have never changed their minds in their entire life, and they act like we're the ones who are closed-minded. Meanwhile, they treat us. They act like bigots towards us. They're highly offensive, and they go out of their way to do so. Meanwhile, we try and be respectful like this, how we are with you, every day.
Yeah. Well, that's nice.
Right. And this topic may raise more unanswered questions, right? Than would be hoped for, right? Because at the core of the entire heliocentric model, right, the current mainstream cosmological view of reality is a globe Earth, right? And that requires its surface to have curvature. And if we come along and demonstrate that it doesn't have that requirement, then that entire model, that entire ideology falls apart. Everything about it, everything. And if that raises more questions for you, that's fine. It doesn't mean that someone's going to be able to answer them and replace every question that you had an answer for previously.
I have questions. I get it. It doesn't bother me that I have questions or that I have more questions now because, I don't care. I have been swallowed by academia and I have a lot of questions all the time. So, but you guys have,
and that's great.
You guys helped me with certain ideas now. That's pretty fucking nice.
Good. I mean, so if anything, we want this topic to open people's minds so that they can get out of the rut that they were brought up in and think about new possibilities. At the end of the day, Flat Earth is about critical thinking, if nothing else.
Okay.
This doesn't mean we're not Flat Earthers. This means we are absolutely 100%. And if we can leave you with a little nugget of information, we hope that you consider what we're saying seriously.
You guys, apparently you're not Flat Earthers. You're simply non-round Earthers.
That's a good insight, yeah. I mean, listen, I think the Earth is much more complicated than just being round in a globe or just flat.
You guys should change the name of the channel to non-globalers, non-globulars.
Yeah,
well, it's still flat, right? So you got to think of the context. Flat's not a shape, right? It's the description of a surface, and we're talking about, in this context, the surface of the water being flat. So most of the surface is made up of water.
No, I get it. I get this one. I'm talking about the taboo that was built around the sentence itself. The phrase itself, Flat Earthers. So basically,
go ahead.
Like when someone, when Jimmy Neutron told me, hey, Fulgrim, why did you leave? It's because, to me, when I see someone saying Flat Earther, I get tinfoil hats, a bunch of, maniacs. But then, I mean, I don't judge people, and I always listen. I love listening to people and their theories, so that's why I listen. But if I bring a friend and tell him, okay, listen to these Flat Earthers, I'm pretty sure he's going to have a bad connotation based on his preconceived notions from the internet, from the culture around him.
Yeah.
That's why I said, if you change the name to non-globalists, okay, wait, people will start thinking you're far right.
Oh, we're definitely anti-globalists.
What do you mean anti? Yeah, but globalist as in...
Listen, I got you. It's so when you go to court, right? When you go to court, you're not ruled innocent or guilty. You're ruled not guilty or guilty.
Yeah, it's
right. It goes back to the hypothesis. It goes back to the philosophy of science and reason and evidence. Can you actually prove that somebody is not guilty, or can you actually prove that somebody's innocent? Proving innocence is a lot harder than proving somebody's not guilty, and those are extremely distinct from one another.
Everything we do everything we do will never be faced with understanding. It will either be faced with disapproval or approval. That's a sentence.
Yeah, everybody wants to rule the world.
Yep. Yeah. So what I submit to you, like, listen, our community has been around for more than 10 years. We've got tons of content. We are not like the TikTok, Twitter, Facebook flat earthers that you find when you do the typical, Google search or whatever. We're fundamentally different than all of those. And I think our community actually spawned a lot of sub-communities that gone out and have done crazy things. If you have a friend, a professor, somebody that you want to introduce to flat earth, bring them here, have them listen to our YouTubes. If you look at the top, we have 2 YouTube streams, 2 bots. And these are going out to Rumble and X. So we're broadcast to the world.
Hey, wait. I have to read what you guys provided me with first. So I'll have to spare some time to read those things you sent, especially the PDFs. Especially the PDFs. And those, what's his name again?
Visit our home server, dude. We got terabytes.
Hey, you don't want me to... Come on, man. Don't send me down a rabbit hole yet.
We got home server. We got 30,000 members. We've got multiple terabytes of info. Discord.gg/flat earth.
Okay, let me first finish my work with addicted people, and then I'm going to go back to this.
Yeah, you're going to be one of those addicted people because you're going to be coming back again and again. You're going to have sleepless nights, just like an addicted person who's trying to get off of the globe. In this case, you'll be like, dude, what do these flat earthers got going on? I want to be part of them.
I mean, fair enough. Okay, that's a claim. That's a claim. That's a claim. Is anyone here schizophrenic by any chance?
Nope, totally mentally competent and sane. I used to work in the aerospace industry for the U.S. government.
No, that's not what I mean.
Okay, before you reiterate your question again, do you know what psychological projection is?
I work with schizophrenics. It's not because related to this topic. It's because
one could say it takes one to know one.
Certain addictive substances cause schizophrenia, so I wanted someone at least to talk to gather some data. So
no, dude, I like wine and beer. That's about it. And I got a professional life. I'm also about 50 years old and have kids and a family, so you're totally stable, not crazy.
Okay, I get it. It's a joke. Fair enough.
It's not a joke.
Hey man, the entire world's schizophrenic, just about. I mean, like, everybody's going about their daily lives operating as if the Earth is flat and motionless, observing it to be flat and motionless, right? And then coming into places like this and declaring that it's the exact opposite of what they experience.
Case in point. So listen, dude, I'm like, you watch a sunset and you think the world is turning backwards.
Exactly. Okay. You observe a horizontal horizon and you think it's curved.
What's it like? Cross my heart and swear to God, I only ask about schizophrenia because I need to work with the schizophrenic to deduce whether addiction had any effect on it.
Turns out they're right about flat Earth, right? Oh my God. They're wrong about everything else, but they're right about flat Earth.
Man, schizoid.
To act like the government is trustworthy at all is the most gaslighting shit you could do, especially knowing full well that things like the Tuskegee experiment happened. Come on now, dude. Come on.
The government did.
Don't be gaslighting people.
What the hell? Do not attribute me to those sons of bitches. Come on. Anyways, I have a lot of work to get to. So thanks for your time.
You sound tired, so.
Yeah.
Feel free to come back, man.
Yeah, and subscribe to our YouTube and Rumble and X accounts.
I'll be sure to take a lot of notes next time I come back about what you guys provided.
Yeah, wait till you hear some of our heavy hitters come in. I'm just like a porch dragon. I'm like the monkey class.
Monkey class.
Monkey class. Yeah, we got folks that have like brains that weigh 10 times as mine do come in. And they're flat earthers. So yeah, you just basically talk to the court jester.
Don't sell yourself short.
Dude, I am. I'm the freaking court jester, dude. I'm wiping my ass with my bare hands and wiping it on the wall right now, compared to the kinds of people that come in after me.
Are you trying to sway me with hyperbole?
Yeah.
It worked. Congratulations.
But it's been a good conversation. I've enjoyed listening to it. So thank you, Emperor's Child, for coming in and being so polite. It's been great to listen to, man. And hopefully you come back again sometime.
Of course, I'll try. When I feel competent enough, I'll come back with the knowledge you guys provided. And thanks for your time as well.
Okay. So here's the list of claimed full Great Circle circumnavigation pole over both poles to date. All right. 1. The Pioneer Polecat, 1965. The route: Honolulu, North Pole, London, Lisbon, Buenos Aires, South Pole, Christchurch, Honolulu. 2. The Speed Demon Pan Am Flight 50, 1977. To celebrate Pan Am's 50th anniversary, they chartered a long-range special performance jet. The aircraft was a Boeing 747 SP. The route: San Francisco, North Pole, London, Cape Town, South Pole, Auckland, San Francisco. 3. The Heavy Lifter Aeroflot Antonov, 1990. The aircraft was an Antonov AN-124 Ruslan. The route: Melbourne, South Pole, North Pole, Melbourne. That was the previously held record. This flight covered 50,005 kilometers, which is significantly longer than the Earth's polar circumference.
Why would they use that aircraft?
Sure.
That's the worst aircraft to choose for that flight.
Right. And ensuring it met the strict Great Circle requirements. The current record: one more orbit, 2019. This mission was launched to celebrate the 50th anniversary of the Apollo 11 moon landing and holds the current FAI world record, which is the Fédération Aéronautique Internationale. Sounds French. Aircraft Qatar Executive Gulfstream G650ER. The route: Kennedy Space Center, Florida, North Pole, Nur-Sultan, Kazakhstan, Mauritius. Is that how you pronounce it? Then the South Pole, Punta Arenas in Chile, and then back to the Kennedy Space Center. Record of 46 hours and 40 minutes. This flight was specifically designed to pass as close to the precise 90 degrees north and 90 degrees south coordinates as possible. Those are, to date, the closest, well, they claim full north-south circumnavigation. And then it says here, like, because I originally asked for suborbital claims, it says you mentioned suborbital in your initial query. To date, no suborbital vehicle like the Virgin Galactic spaceship 2 or Blue Origin's New Shepard has performed a polar circumnavigation. True suborbital point-to-point travel over the poles remains a theoretical goal for companies like SpaceX with Starship, which could technically fly a ballistic trajectory from one hemisphere to another via a pole in under 45 minutes, but this has not yet been attempted.
Okay, that's interesting. Ask it. What about Fram 2?
Fran 2?
Fram, F-R-A-M?
It says, excuse me, the Fram 2 mission was launched on March 31st, 2025, represents a historic shift from aircraft-based circumnavigations to the first ever crewed orbital polar mission. It is not suborbital. It is a full orbital mission that specifically targeted a 90-degree inclination to pass directly over both poles. Spacecraft and launched via a SpaceX Falcon 9 rocket and Crew Dragon Resilience capsule from Kennedy Space Center, Florida. The trajectory: this was the first human flight to achieve a true 90 degrees or 90.01 degree polar orbit. Previous crewed records were significantly lower, such as the Soviet Vostok 6, which was 65 degrees, or the Space Shuttle, 62 degrees. Orbit speed, and at an altitude of 430 kilometers, the crew traveled from the North Pole to the South Pole in just 46 minutes. This is roughly 30 times faster than the one more orbit aircraft record set in 2019. The flight lasted approximately 4 days, concluding with a splashdown in the Pacific Ocean off the coast of California on April 4th, 2025. It goes into the crew specifics. Scientific and historic goals, atmospheric research, health studies, legacy. That's about it.
Yeah, that Gulfstream one was trying to like beat the record or something for fastest circumnavigation. They did it in 46 hours, 40 minutes, and 22 seconds. Their refueling stops were optimized for quick turns, about 30 minutes each.
So this is what it claims, right? It claims it did pole to pole to pole, right? Like 55 passes directly over the poles within its 3.5 to 5 day duration. Why can't they be clear on the days? But that's weird. Okay. The spacecraft completed one full pole to pole to pole loop every 93 minutes. It traveled from the North Pole to the South Pole, one half orbit in roughly 46 minutes. From that footage, does that look like it's doing that? Doesn't. It looks like it's going really slow. Like to the point where they zoom in and it doesn't look like they're moving at all.
Yeah, it's kind of weird. And if they're that height above the Earth, why are we seeing this much curvature?
Right. Yeah, I was looking at that. I was looking at the tiny little bubble window he looks through too. I was wondering if that has something to do with it. Wherever they are, you know. All right, get this, right? I don't get this. I don't understand this, right? This is weird. The mission's 90-degree inclination meant it was flying perfectly perpendicular to the equator, allowing the crew to witness 24 hours of daylight at the North Pole and 24 hours of darkness at the South Pole during their orbits. What? But they witnessed 24 hours of sun and darkness? I thought they were orbiting it like doing pole to pole in like 46 minutes.
Exactly. They wouldn't be loitering over the poles for very long.
I don't get that statement. It's really weird. Actually, I messed up there. So the previous record was the 1965. So 1965 Boeing 707 held that record until 2019. It claimed to have done it in 62 hours and 27 minutes. And the 2019 attempt was 46 hours and 40 minutes.
Yeah, there was
sorry, 1977 Boeing 747, 54 hours and 7 minutes. Okay, so 77. It wasn't broken. The 1977 flight wasn't broken until 2019.
There was another attempt back in 1988 by a Saudi businessman. He did it in 52 hours, 31 minutes, and 48 seconds.
Hello. How's everyone?
How's it going? Oh, hello.
Buddy.
Welcome.
Thank
Hello,
you.
everyone. How are you doing?
Chilling. That's crazy. My phone's about to die.
Why are you silent? They are crazy, maybe.
Everybody's just hanging out, man. These people are impatient.
Oh, DJ. All right.
What you found?
Listen to this. So I'm pressing it even more. I said, now let's get this absolutely straight. All these attempts, excluding Fram 2, were complete great circles, meaning they reached 90 degrees south and continued as a forward path as possible not backtracking like other polar circumnavigation claims were discovered to be. And it said, to get this absolutely straight, no, many of them were not. When you apply the strict requirement of a forward-moving great circle, meaning the craft crosses the pole and continues out the other side without a 180-degree turn, most famous polar circumnavigations actually fail the test. Here is the breakdown of who actually straight-lined it versus who performed a U-turn or backtrack. So, the failed Great Circle test, right? Many historic claims, especially surface and ship-based ones, reached the pole and then turned around. Fiennes, the Transglobe Expedition. Michael Palin, 1992, reached the South Pole via plane for the finale of his show and then flew back out the same way he came. The true Great Circle flyers, the 180-degree rule. Okay, Pan Am, Flight 50, 1977, Antonov, 1990, One More Orbit, 2019. They claim to have passed the test.
Yeah, but they didn't do that. One More Orbit didn't do that.
Yeah, it's saying this is saying it reckons it did.
Also, there's the footage. They don't have footage of them doing that. Like they have footage, but they don't show any footage of them flying over Antarctica. And if you actually have a look at their claimed path that they did, which I call bullshit on, even if we look at their claimed path and assume they did do that, they, you know, I'll post it in the side chat. 1 second. So, 1 second. Here it is. So, which other ones does it say? It says One More Orbit and the Pan Am one. Is that the only ones it's saying?
It's saying there's 3. So the 1977 Pan Am Flight 50, the Antonov An 124 1990, and the One More Orbit 2019.
Okay. All right. Well, let's investigate those then. All right. So here's the flight path for One More Orbit. So clearly that one didn't do it. All right. So this is from their website. And there isn't footage of them doing this. There's some footage. Most of the footage shows just footage inside the plane, not even looking out the windows. Shows some footage of them landing at some airports. It doesn't show them footage of flying over Antarctica. Right, and look at the flight path. They didn't do a great circle. They didn't do that at all.
Ouch.
So, all right. So, what's the next one? The Pan Am. Flight 50 or something?
Yep, Pan Am Flight 50, 1977. Says they flew into the South Pole from Africa and exited toward New Zealand.
All right. Well, we would need some footage of that, right?
Yeah. I doubt they're going to have that.
Oh, well, what, they didn't have video cameras back then?
Well, I guess they did in 77. Don't know that they really, they didn't. Did they have camcorders even then?
Yeah, of course they did.
Yeah, I suppose they had. I thought they were not as compact and manageable as today, but maybe they did have little versions. With the bigger, TV crew style ones. Well, you'd think they'd even take a TV crew, TV crew equipment with them. I don't know, maybe.
If there's no footage of anyone actually doing it, then why should we believe it? All right, I found a video about that one.
Yeah, is just a story, isn't it?
Yeah. Here we go. Here's a documentary about it. All right, here's the path they're claiming in the documentary.
What the heck, bro? It just skims over the edge of the South Pole. All right. So they're saying that the way that is on a globe, that's a great circle, is it?
They're trying to say.
That means it's not perpendicular to the equator, then. Like Fram 2 was claimed to be. It's off by a few degrees.
Oh, hold on. Check this out, T-Dub. This is out of the documentary.
Yeah, see, they could say that, like, they could project that onto the globe and say, yeah, it's technically a great circle, right? A little wonky, right? But it just wasn't perpendicular to the equator. They're going to say. I mean, yeah.
So panning through the whole video, there's one tiny little shot of them looking out the window and it looks like ice.
So verdict works on flat.
I mean, it kind of looks like they just kind of crossed over a little bit of Antarctica. I don't know. Hold on a second, because it's kind of hard to tell when you've got this Mercator projection.
Yeah, that's what their graphics are showing. I mean, you know, like Dave Weiss had put this in the works on flat basket. He put it in there, you know, because it skims over that little peninsula. If you were comparing it to, you know, the AE map, right, you'd want it to not do that, right?
Right, so this is what they're claiming was the path on a globe.
Well, that's a lie. That's not what their Mercator map shows at all.
Yeah, that doesn't seem to align with what they're showing us, right?
No, that's too perpendicular to the equator. That's not what they're claiming. They were off by a lot. They didn't. Right. They didn't reach the South Pole. No, that's not what it'd look like on their Mercator projection. Their Mercator projection, and that doesn't match.
All right, here's someone's put it on an AE map apparently.
Okay. Right. Yeah. I see. But no, their projection onto a globe, that's dishonest. That doesn't do what it shows on the Mercator. They were off. It says specifically says they flew into the South Pole from Africa at approximately 20 degrees east and exited toward New Zealand at approximately 170 degrees east. So the Mercator projection, the Mercator map flight path is not showing. That's not the South Pole, is it? Really? That's their South Pole on the Mercator projection? That's what they call the South Pole, that tiny little portion?
Yeah, that's what they call it.
Yeah. Okay, whatever.
Is that even a Mercator projection? Looks kind of weird.
I'm not sure.
How is that a Mercator projection? Because in the Mercator projection, Antarctica doesn't look like that in the Mercator projection.
No. Yeah, I'm not sure what that is actually.
Here, just to make it even more confusing, here's someone else putting it onto an AE map. Check this one out.
What the heck?
Yeah. Yeah, how is that what they're showing on this globe? Hold on a second. Take a side by side. Like the features on Antarctica aren't the same in both of these pictures.
Okay. All right. This got even more interesting because I asked it. All right. So all those that passed, right, as in they passed the test, held as close as possible to the same longitudinal path. And said, actually, no. In the world of aviation, as close as possible to the same longitudinal path is almost never done, even on record-breaking runs. While these missions pass over 90 degrees north and 90 degrees south, they almost always shift longitudes significantly between the two poles. If you stayed on one longitude, say the 0 and 180 line, you would be flying over empty ocean for the vast majority of the trip. Here's the intellectually honesty breakdown of how they actually fly. The S-curve. Aviators don't fly a single great circle. They fly a series of connected great circle segments. To keep the forward motion you asked about, they enter the pole from one side and exit the other, but the longitude they use to reach the North Pole is usually different from the one they use to reach the South Pole. Pan Am 50 crossed the North Pole moving from the UK toward Alaska, 0 to 150 degrees west, but crossed the South Pole moving from South Africa toward New Zealand, 20 degrees east to 170 degrees east. The goal, they aren't trying to say stay on one line of longitude, they are trying to minimize total time. To do that, they have to zigzag to hit specific airports for fuel. The true longitudinal path surface, the Trans-Global Expedition FIENS is the only one that attempted to stay on a single longitudinal path. Because they were on the ground, they couldn't just jump to a different continent. They followed the Greenwich Meridian as their track. Even then, geography forced them to deviate. You can't walk in a straight line. Through the middle of the ocean, they had to follow coastlines and ice shelf edges. Bam. The only perfect path, Fram 2. That's Fram 2's yeah, that's it.
All right, so I looked up just a like a general picture of Antarctica on the globe, and now I'm gonna put this little section of Antarctica that they flew over next to it in Canva. Check this out, Tito. Something doesn't add up here. So, you there?
Yeah. Go on.
Yeah. So the one on the left, I reckon this one's been made by some anti-flat earther for sure. Right. So that's the path that they're claiming that this flight took. Okay. Then the one in the middle is from the documentary about the flight, saying that this is the path they took. And then if you have a look at the one on the far right, that's just a random map of Antarctica on the globe from Google. Right, so it looks like they just took, like, they didn't go over Antarctica. Right, most of Antarctica, like if you cut out that little section that you can see there, right, most of it's missing. Most of Antarctica, they didn't go anywhere near the core, like the center of Antarctica at all.
Exactly, yeah. Yeah, that's what I'm saying. That's right.
So when we see these pictures where it shows the red line, like, kind of going over Antarctica like that, that's bullshit. That's absolute bullshit. That's some anti-flat earther that's lied, plotted it out like that. It's not even the path they claim to have taken.
Right, yeah. I mean, it looks like they're just settling for, like, we're just going to say that we reached, like, they're just, South Pole is just really, they're just saying Antarctica. We got to Antarctica. Like, there's not even any grid lines on that map.
Yeah, it's like they did, like, just a little flyby over the, like, you can just take those commercial flights. It's like you can go from Australia and it'll fly you over, or from New Zealand, and it'll fly you over a tiny little section of the edge of Antarctica. It's kind of like what they did.
Yep. Yet the Google AI is, like, being somewhat honest, right, when I ask more questions. But it's still trying to claim that the Pan Am went to 90 degrees south.
All right, so far it's given us 3. It's given us one more orbit. That one's pretty easy to debunk. That's been debunked a million times, right? Because clearly they did a U-turn, basically, when they hit Antarctica, and they only just flew over a tiny little section of it, even according to their own map, which they don't have footage of them doing either. Right, next one was the Pan Am one. You know, that they just flew over a tiny little edge bit of Antarctica with that one.
Yep.
And then what was the
other
next
one? Was the Antonov. Yeah. 1990, I think it was. Yeah, also called AN-124. Or AN-124.
Okay, anybody got any globe evidence? Go ahead. Anybody?
Not at the moment. DJ and I are just taking a dive into some of these claimed to be north to south polar navigation attempts.
Cool. Found anything interesting? Besides, they actually didn't do it.
Inconsistencies with stories, inconsistencies with them plotting the path out on different map projections. No footage of what they claim to have done.
They basically go down and hit Antarctica, then come right back up.
Yeah,
they just fly
over
across the North Pole. That makes sense. But I'm sorry. Go ahead, DJ.
Yeah, no, you're right. That's exactly what happens. They seem to they do they cut over a little bit of Antarctica and kind of turn around and and there's not even footage of them doing that, really. It's just a claim.
Yeah, if more people knew just that one fact that they've never done that north-south thing, we'd be in a lot better position, but that's what makes it so obvious that we're not involved. I mean, that was one of the main things for me, but 10 years ago. Like, why has nobody ever done that? Billions of people have done east-west. Nobody's done north-south, you know.
So we kind of debunked the first two that were on P-Dub's list. Now we're trying to do this last one, which was 1990, some Russian airline or something like that. So
you already did the most recent one, the One More Orbit one, because I know somebody debunked that one anyway. But
yeah, One More Orbits. Yep, that one's debunked. That's easy. Well, I mean, just
down and we can bounce right back up anyway.
Yeah, yep. And then the other one's the Pan Am Flight 50 or something like that. And then, can you see the side chat, Dave?
I can look at it. Go ahead.
Yeah, so at 48 minutes after the hour. Okay, so when you look it up, you find images like the one on the left, and it kind of looks like this is the path they took over Antarctica. Well, that's bullshit, right? Because if you have a look at the second one on the right, I looked up the documentary from the 70s when they did this, and this is the path that they're claiming that they took in the middle image, right? Just dipping over that little peninsula, basically, right? And then the image on the right is just a random picture of Antarctica on a globe, right? So if you have a look at that little bit that they flew over, it's missing most of Antarctica, and it's absolutely nothing like the image on the left that has clearly been made by someone like a anti-flat earther or something like that.
Yeah, and doing it that way, they can sort of claim that they actually did travel across Antarctica, if that makes a difference. You know what I mean?
Yeah. But this is one of the ones where they're claiming that they kept going south and they flew all the way around the globe, kind of thing. But it's bullshit.
Yep.
Where the hell did you talk to P-Dub at?
Who, me?
Oh, DJ, where did you run into P-Dub?
P-Dub? I'm talking to T-Dub.
P-Dub.
I thought you said P-Dub.
Who's P-Dub? Sounds like a rapper.
He's an anti-flat earther on Twitter that hangs around McZoon and Slice Parkane.
I try to forget anti-flat earthers, but go ahead.
Well, I mean, it's important to know who they are, right? Like, even with Ozian, like, I don't know if you know the story with Ozian, but even he turned out to ring true with the more degenerate they are, the more anti-flat earth they are.
It's a mental condition for a lot of these guys. I'm not saying anybody personally, I'm not pointing anybody out, but it's a mental problem that they're having. They won't let go of this globe and space and all that shit. I kind of feel sorry for them in a way, but you know, they don't need to behave like they do on the internet. People that come on here and are clowns and are dishonest, I got no time for them, you know. I hear DJ say that to them all the time.
No, I like how DJ calls them out. They're just being dishonest, man. He sounds like Simon Cowell.
So this whole panel of people, nobody wants to take up the banner for the globe right now?
I will. The fact that you're talking to us is proof that satellites are in orbit.
Oh, okay. Who wants to do satellites? Go ahead.
And then when we can't hear you, it's because the satellite went away. We're waiting for the next satellite to pick you up.
So did you say you already debunked all 5? Was there 5 of them, DJ? Or how many were y'all doing?
There was a bunch, right? So first AI, like it tries to get you. It gave T-Dub this giant list of north to south circumnavigations, and then T-Dub pressed it a bit further as he's like, oh, like, did they actually like cross over? How many of these actually crossed over Antarctica and kept going around? And it's like, oh, well, most of them actually just got to the South Pole and just turned around and left the same way that they came in.
That's wild. Why would you turn around?
Yeah, and then
it would have to be a documented flight over 90 degrees south and keep going that way. You know, don't change your direction. Go directly over 90 degrees south and keep going. Pop up on the other side.
And film it. They got to film it, right? They can't just tell us they did it.
Here's the wild thing, right?
The whole list that T-Dub got at first is all people that went to Antarctica and came right back up. But they claim they crossed it. You know.
Here's the wild thing, right? If you were swimming across the river and that river was a mile wide, and you knew you were halfway across the river, but you felt like you couldn't, that you weren't going to make it, which way would you swim?
I'd turn around and come back, man, just like they do in the airplane, right?
Like, why would you, if you made it halfway, you felt like you're going to drown, and you had to pick a direction to go, would you go back or would you continue forward at halfway?
I would say 99.9% of all logical humans would continue swimming the direction they're going. If you knew the other beach is only another half mile away, right? Why would you ever turn around?
That's it, man.
Whatever's beyond the point that they actually flew to is what they're hiding, is part of what they're hiding. I'm speculating, but it ain't like it. They did all this discovering of lands, and then they told everybody about all these lands. There's a lot of shit we don't know about. Total speculation.
Well, they say like the lady that went all the way around Antarctica, I think, circumnavigated Antarctica, was an actress, and she did it in 90 days.
I don't remember that one. What was her name?
I don't remember. I just like.
What year was it? You don't know, do you? Seems
Once I
like
hear
generally
actress,
speaking, people are getting less. Sorry, I was just going to say real quick. Seems like people are getting less enthusiastic about defending this globe idea, but that could just be a speculation impression I've got. Anyway.
Yeah, there you go. Over the fences. Shows it. But yeah, no, every time I hear actress or Freemason, I can automatically dismiss that, what they did. Like, I can just dismiss them as being untruthful, and they're going to have to give me all the evidence, not just a story.
Yeah, they have to document the physical reality of what they're doing. You know, it's obvious they can go down there and come right back up. We know that. Just like they know the general gullible public will just believe oh yeah, we got these hundreds. Like whatever T-Dub got in his first search, everybody just they might look that up and it's like, these flat earthers are crazy. All these people have done this north to south thing. And that's the last time they think about it, right? For what it's worth, I just noticed that the date is 2626, if that matters to anybody. And it's still not a globe. Somebody prove me wrong.
Do 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 do. Who else in here?
What song is that, India?
Hey, India, what's up, man?
Right, now I've got that.
What song was that? I didn't hear it. He was.
I don't fucking know, dude.
Hey, have you been listening to the stream?
I listened for a second. I heard you guys going over the one more orbit or something.
Yeah. So, we're going over all of the different claimed north to south circumnavigations one by one. Super inconsistent, man. It's crazy. And it's like anti-flat earthers are lying about when they plot the path out that they said they took. right? So the best one that they seem to have is the Pan Am 1977 one, and just
that's the best.
Yeah, that's the best one.
When they're $4 billion in debt and about to go into bankruptcy, and they needed something to revive their company, and yeah, that's the best they got.
So check this out. So it seems like the anti-flat earthers or someone like that, because if you look it up and you look at the flight path they took, there's these images that make it kind of look like, see what I posted in the side chat? The left one.
Oh, yeah.
The left image, that's what you get when you look it up on and hit images on Google. And it kind of looks like that's what they did. All right, but then I looked up the documentary and took a screenshot of the path that they claim to have taken in the documentary. And it looks like they just kind of cut over that little peninsula there of Antarctica. And then the image on the right is just a Google image of Antarctica. So it looks like most of Antarctica was completely skipped. And it doesn't look anything like the left image that they're telling us this is what they did. It's another one that's just bullshit. And there's no footage of them.
Oh yeah, they just have them like taking off with like, it was a bunch of celebrities, right? Celebrities, business people, and I don't know, they paid some ridiculous. Well, some people were paid to be on it, like the celebrities, but then there's other people that obviously paid, and they paid to be on the flight, and it was just like they filmed them partying or whatever, drinking, and it's just it's a advertising.
Exactly, that's what it seems like.
All it is.
Yep.
Pan Am was also the company that was selling the first moon flight club. So
Andy, didn't they go bankrupt pretty quick after that? What year was that? Didn't they go bankrupt pretty quick after that, Pan Am?
No, they were about to go bankrupt. They were like at the verge of bankruptcy. There was something like $4 billion in debt, and then that kind of like revived them for a little while. And then they went bankrupt. Didn't Pan Am go bankrupt during the Reagan era or something?
I'm trying to remember. I can look it up here in a second.
Yeah, look, I'm going through it. Let me see real quick. God damn, it's a long ass wiki article. Yeah, no fucking way. You can't make this shit up. Financial, operational, and reputational setbacks. This is from Wikipedia. This can't be the same guy. Ugh, it is the same fucking guy. Unfucking believable. In 1987, Towers Financial Corporation, led by its CEO Stephen Hoffenberg and his consultant Jeffrey Epstein. Can't make this shit up.
No, it could be a different Jeffrey Epstein.
Take over Pan Am in a corporate raid with Towers Financial as their raiding vessel. Their bid failed. That was in 1987. Bro. And it's...
It's gotta be a different Epstein, Martin. Come on, man.
Dude, you can't make this crap up, man. It's a cartoon, I swear to God. We're living in a cartoon. What are the odds? Like, we're going to debunk Pan Am as scammers, and then Jeffrey Epstein comes up. Well, that seals it. That was easy.
All the world's a stage, isn't it?
My goodness. What year did they do the circumnavigation?
Which one?
DJ? The Pan Am one.
77.
Well, from their revenue passengers per mile, so between 75 and 79, so it has like the revenue passengers per mile flown, and it goes from 16,000 And then at 75, it went down to 14,000. So they're going in the wrong direction. Then boom, back up to 22,000. Yeah, it's a marketing gimmick they did. That's how I figured it. Just, who can confirm it? You see the plane take off. Yeah, we'll be back. We're going to fly around the world. They just come back 3 days later. Yeah, we flew around the world. They declared bankruptcy in 1991. I knew they were around for a while. But man, Jeffrey Epstein, this guy is everywhere.
Yeah, so basically with all of the north to south circumnavigations, right, none of them are even claimed to have kept going like along a line of longitude or anything like that. The only one that they are saying did do that is the Fram 2.
I'm not familiar with the Fram 2.
Yeah, it's in the side chat here. All right, so you want to check out how much curvature that they had from that height?
Fram 2, the movie.
Yeah. So it's like an orbit. So they reckon that they did like 12 orbits or something like that around the globe, 90 minutes or something like that per full orbit, and the curvature's all like warped out, right? Kind of like egg shaped.
Is this Fram 2? Is it an aircraft or is it something like the International Space Station?
It's like the International Space Station, and like it's meant to be doing an orbit. It's like a capsule.
Okay.
Yeah. Well, just
that's what I was going to ask you guys. Remind me, what is their official excuse that the ISS doesn't do this all the time? They have some official excuse. I can't remember what it is. But
I was just listening to the footage. Sorry, Dave.
I was just saying, if the ISS is up there, they could do it north to south all the time if they wanted to. But they've got some reason they don't, right?
I was just listening to the footage in the thing and the girl in it, right? So this is the scene that she's looking out the window. Right, it's kind of weird. We could see this much curvature, but anyway, she's like, "Oh, I can see the launch pad. I can see the launch pad."
Did she fuck? Is she the bionic woman?
Yeah. It's at like 43 minutes 30 in the film.
Okay.
Nice bionic woman reference. I like that.
Fram 2. I've never even heard of that.
No, neither have I.
It's claimed to be the only pole-to-pole, like full circumnavigation that went perfectly around doing a great circle. Yeah.
Who did it? NASA?
SpaceX.
Oh.
So it's really kind of recent then.
2025.
Wow.
Boy, Elon, he nailed it, boys. Way to go, Elon. Way to go.
Yeah, hi Elon. Thanks for listening.
I'm just like skimming through, looking through the proportionality. That's like, okay, is that Florida? That's like Okeechobee or whatever it is. It's way too curvy for that to be Earth ball. Unless Florida is like absolutely gigantic.
Josh was in here the other day, and he's saying, "Well, it fits just right. That's how big it would look, because when you're really close to the globe, things look bigger."
What? Yeah, but it wouldn't be that curvy because you're too close to the globe. Like what? He's ill.
Yeah. That guy's a mess. You know, the other day, what was he saying? Oh, he was saying some of the dumbest shit, and then you just look it up, and he says it confidently. Something about X-rays from the sun. He said they I forget what he said, but I just looked it straight up. I'm like, that's not right at all. He's like, oh, okay, yeah, I concede on that point, right? And then the other day he was waffling on about Velcro, and he was so proud about how amazing it was that NASA invented Velcro. Looked it up. It's like, they didn't invent Velcro. He's like, oh, okay, yeah, I concede on that one. Yeah, I was wrong about that. The guy is a freaking
liar. Cool. No, he's a liar. Yeah. He spent a lot of time in the beginning getting anytime someone can especially because he first started coming over on the politics, and he spent a lot of time trying to he would get indignant if anyone questioned his honesty, and which is what I expect actually honest people to do, but it's so many times now that he's just been caught straight up making shit up that I can't. That's just an act. No way. I mean, I don't know how many times he's been caught now. Like it's like 20, 30 times now.
I told him the other day I can't say Josh Ingersoll.
Josh in making
him. Oh yeah, no, yeah, I get it. Yeah.
I gave him the benefit of the doubt, which I usually don't give Globers. I gave it to him for a long time because he insisted. That's the one thing. He said this when he first came around. The one thing I don't do is I'm not dishonest and I don't lie. Well, I mean, usually that's a red flag when someone goes out of their way to say that.
Yeah.
But I go, okay, I'll take people, especially if they say, listen, man, I'm dishonest, I don't lie. But as soon as I catch you, that's it. That's a wrap, man. Like, you just literally lie twice because you said you're dishonest and you don't lie, then you lied, so that's 2 lies.
You filled yourself up to that standard, right?
Yeah, exactly.
Wow.
And he didn't qualify and say, well, sometimes they exaggerate, sometimes I,
That's what I was going to say, India. Guys like they don't count making shit up about space and satellites. That's not really lying because they know it's a globe and there's satellites going around and stuff. So he's just kind of embellishing it a little bit, right, in his mind.
He's definitely has instant expert syndrome. For I called him out last time I was in here because he was like saying stuff so matter of factly, stuff that we had asked him earlier that he said he didn't know because that wasn't his specialty. Now he was talking about the same things as if he does know now personally that he has primary information. Where no, he just read it somewhere in a he's like, I went and researched it. Yeah, well, you still don't actually know. You just like, hey, they have questions. I'll go find the standard bullshit answer, and then I'll say it as if I have personal knowledge of it. Oh, that Las Vegas sphere. I got a picture of that thing. I didn't take it, but it's pretty cool. No, I just posted. This is actually to scale. This is actually correct. I took this image, loaded up in GeoGebra, overlaid a circle on it, and then changed the scale to 3,959 mile radius and did all that. So, yeah, that's. I just can't even believe Jeffrey Epstein was involved in Pan Am now. We didn't have any idea who he was. We're doing corporate takeovers of a freaking national airline and nobody knows who the guy was. Give me a break.
Well, we needed an airline to get to and from his island, right?
Oh, yeah, that's right. I was going to mention the thing about the one more orbit. I mean, I don't know if it was on his own channel or his current channel. Antonio Subarats watched the live stream, and they never went over Antarctica. According to their own path that they were showing, their own GPS projection on the Mercator map, they never went over Antarctica. They changed, the thing that they had on the website was their projected flight path. But they had a flight path that they were showing during the live stream of what was supposed to be their GPS position, and it never went over Antarctica at all. I don't know. I'd have to look and see. When was the one more orbit?
Kind of recently, within the last
2019.
Yeah.
Let me see if his channel. I mean, he went through a few channels because you know how the fucking Globers are. They'll just strike that shit.
That'd be interesting to see though, because all I see is what I presume would be the projected kind of route, because that kind of goes over Antarctica and does I think at least 2 dog legs. So yeah, I don't know. Well, I'd like to see it for sure.
What month? What month you guys say? The date of 2019?
I'm not sure.
His first video on that channel is January 19th, 2019, so it might still be on there.
Okay, if we're flying from pole to pole and we're doing it, won't one be in darkness? No pole is illuminated at the same time, right? 6 months here, 6 months there. If you're going to go pole to pole, one of them's going to be in darkness, right?
Yeah, it said that's what they experienced.
Okay,
right.
Just making sure.
They would get from one pole to another pole in 45 minutes.
Really? Wow.
That's the claim. Yeah.
45 minutes?
Yeah. Yeah, July 2019, India.
Okay, then it's on here. Let me see.
July 9th to 11th.
Man, Yoder already had it. Word, Yoder. You on it. So I timestamped, so what he basically shows is what they advertised the route, and then the route that they were showing, you only got to watch about 30 seconds. Then he goes to the website and shows the route that they were showing that they actually took, and it's nowhere even near where Antarctica should be. Holy shit, yo, did you index his whole channel and summarize it?
Yep. He did.
You mother.
That's brilliant, eh?
Damn, you're quite industrious.
I've also got copies of them. The ones that are indexed that can't be downloaded, yes, they can be. So if anyone wants them, just give us a yell.
Oh yeah, you can. If you use Jade Downloader, you can download entire channels, no problem. It's called Jade Downloader 2. You just you hit add link and just add the channel link. It'll download all of them. Though Jade Downloader's organizational part is kind of shitty. It'll give you a bunch of folders. Did you do that with Notebook LM? Is that the one we were talking about? I didn't think it ever worked. Nice work, Yoder. Yeah, I see it. I did it with the API. Yeah, nice. Awesome. See, these large language models are good for stuff. Not giving dating advice is not. Don't use it for that. But it's good. I think the AIs or the large language, they're good for automating like arduous tasks that are repetitive.
Yeah, they're good at doing menial things that we don't want to do.
Exactly. You know, I was talking to Dandelion about this, like whether the AI is gonna do one or two things. I figure either it's going to automate the menial tasks that you could do, right? So, for instance, if I have a lawnmower and I want to know how to change the lawnmower blade, I can look at the lawnmower, flip it over, look at the model, check out the blade, start Googling around for the freaking model, then for the instruction manual, then find out how to replace the lawnmower blade. Or I can take a photograph, upload it to the AI, and the AI does all that search and shit for me. And I don't have to do any of it. And in 3 minutes, it tells me exactly what I have to do. So I can go do more productive things. Now, that's one solution, one possible utility of these AIs. Or the other one, where the AI does the thinking. You know what I mean? Where like it isn't doing, like, it either makes everybody go like revert to the mean, where that's like where everybody starts believing the AI is holy fucking writ, and no matter what comes out of its keyboard or whatever it is typeset, people think that's the gospel truth. Then that will be a problem.
It might just take the whole human interaction out of it, where you don't even have to replace the lawnmower because it's AI, because it's robot. You leave it alone, a replacement will be with you in 24 hours. So the whole idea of you being even involved with maintenance of something, they probably even take that away. So that removes cognitive function, right? If you're not getting down to repair it, right, you can ask AI how to do it, and you can go and you can do it. You can get your tools out and whatnot, or you don't. It just replaces itself, doesn't it? No need for maintenance. Not from you, anyway, the consumer. It's got to be simple and easy, right? See, I don't think the AI would give you the instructions of how to do it. I think the AI would just replace itself.
I think it's either going to augment human expression, or it's going to replace human expression, and we're going to revert to the laziest mean. I don't want to do it. Let the AI do it, like you said. Or we're going to let it do the menial tasks that we could do that we don't want to do, and then with that extra time, actually do something exceptional. I mean, I'm sure some people will do that.
Yeah. I was talking to my cab driver the other day, and he was talking about the automation of taxis and so on within large cities before, I think, 2035 or something. So within the next 10 years, the majority of taxis will be automated, driverless. I mean, some people really enjoy driving, some people don't, but that's kind of being taken away as well.
I mean, the car thing is tough because as far as like predicting what's going to happen, because there's always the legal part of it. Who's responsible for the accident?
Yeah, that's what my driver was thinking about as well.
The car manufacturer, the dude that's in the car, the people that made the road. Who's responsible for the accidents now? And now what are they going to use for an excuse to pull you over? They won't have one.
Yeah.
Hey everyone. Hey India.
What's up, security?
Hey, I don't have a lot of time. I just wanted to say what's up, guys. Hope you're doing well.
I am. How about you?
Good. You blew my mind the other day. Thanks a lot.
All right.
I appreciate your outlook on the metaphysical was a topic I wasn't expecting, and since then I had been thinking on it.
I was actually thinking about it again myself yesterday, just like, why is it got to be either or? Why can't it just be both at the same fucking time?
Exactly.
Which is the way it actually is, right? It's like, that is the way it is.
Mm-hmm.
You know,
nothing is as it seems.
You see what you look for, though. So if you're just like in a materialist atheist, that's all you'll see. You won't see the other stuff. And if you're a woo-woo head in the sky, all you'll see is magical mysticism, and keep stubbing your toe on that, thing over there in the corner, you know, because you don't think the real world is real.
Yeah. Got to find a good middle ground. Hey, did I interrupt a topic you guys were having, or?
No, not really. We're just shooting the shit about.
Well, earlier I did come in and I was discussing. I was discussing the stars, and I used the wrong word. I asked for an explanation, but what I mean is, what's the story behind XYZ? I'm trying to reframe my questioning. You know.
Well, what are the explanation thing? Like anybody, like I can explain why Spider-Man exists, right? Peter Parker got bit by a radioactive spider, turned into Spider-Man with superpowers. So that's an explanation. Not a word of it's true, right? We can explain anything. They used to explain the sun by being Apollo's chariot. You know? No. Now, explanations are one thing, but is there evidence for the explanation? Is that explanation the only possible explanation? That's where we get into like weird. That's where it gets a little crazy. People have been explaining stars and the planets since the beginning of time immemorial. But who's right? Us now? They, them? They then? Way back in the past? Somewhere in the middle? Who's right? Which culture's right? Which group of people were right? Because none of that can be verified. If I want to know the composition of a star, how can I actually ever really know that? Now, I could believe a bunch of things. Well, observation? You think you can tell the composition of something just by staring at it?
No, I'm not a scientist, so.
Well, nobody can do it. You can't get that. Look, you can make what's called an inductive inference about what the composition could be, but you can't ever actually know for certain unless you go take a sample.
Hey, can I ask you a question?
I wanted to comment on that question you had before.
Sure.
For another question, I just wanted to say that you were asking about the luminaries, and India's points are on point, but the observation that you're doing on the luminaries does tell you something, not the material, what it's made of, but it does shows you, in my opinion, since the luminaries moving cycle, kind of like clockwork, it shows you some type of design, and it also shows you that observed phenomena that it can be described as a beautiful phenomena, and it gives you kind of like a design beauty in a sense. So it gives you kind of like a sense of the creator or the designer has a sense of beauty. Then when you look across the earth, you also see the sense of beauty of the creator, including with the luminaries, the order in place, and the whole creation with it. So yeah, the luminaries kind of like give you a sense of, we'll say, some type of design, but you cannot go there and check what is that design made of. Not like down here that you can actually check stuff. Go ahead. Also give you a sense of wonder. That's why
security bounced.
Oh, security does that.
Yeah.
She does that often.
I think she thought that was some sort of gotcha, and I'm not sold on her veracity.
No, she came in and asked a similar sort of question earlier when I was around, speaking about the stars and kind of, how do we explain them? I kind of told her, like you did, that we don't.
We can. But we can make some shit up right now on the fly.
Yeah, but I was kind of leading her to the idea that whatever the sky is kind of, as Gemsy pointed out, it's wondrous, it's potentially got a lot of intent behind its design and so on. So I don't think she was coming in with some kind of gotcha. I think she was just looking for more clarity on the question she asked earlier.
She has a question because she's wondering about it, and that's one of the biggest wonders for most people. most people, even from both sides, they wonder about the luminaries. And
most
she's
of
an
humanity.
example of it.
Yeah, most of humanity since the beginning of humanity. Yeah.
Yeah.
It's like they're inaccessible, right? You can see them. It looks like you can touch them, but you can't. You know what I mean? They're just like that's the curse of humanity. You're gonna look up, you're gonna see those things. You're never gonna know. And even if space was real and they made the craziest fucking spaceship imaginable, they still can't get there and know. So.
Yeah, it's all too far away.
And what is pseudoscience? Unfalsifiable claims.
Yep.
Prove they're not made out of hydrogen gas. Okay, how would I do that?
What if there's hydrogen gas up there? Then what?
I don't know. There could be. I don't know.
Yeah, but they say if we do an analysis and we can look up and we can somehow tell the colors and we tell this color is hydrogen and then we look up and see the color and we say that's hydrogen, we have evidence that you're denying it. But I don't know. That's the kind of like the position they say.
But it's not that simple. They try to portray it. Yeah, they try to portray it as that simple that they're just like looking up in the sky at hydrogen, and hydrogen creates a certain spectrum, and it's like a fingerprint. No, it's not a fingerprint. A lot of times these spectrographs are smeared. They're not like, what would you call it? Straightforward. You kind of have to interpret them a little bit. And then you have the problem of redshift and all that. So now you have your spectral lines and they're shifted in one direction or not. So you have to make the assumption that, well, this spectrum looks like this because all the freaking shit's shifted because it's this far away and it's moving this fast. And you know what I mean? But you're already starting from the assumption that it's hydrogen in the first place. And you're doing... Man, they actually do a bunch of crap, which I actually found out recently. There's way more nonsense in it than even I imagined.
They have to add a lot of stuff. I mean, because you have a lab setting. So you have a lab setting where you can demonstrate light doing certain things to certain mediums, different gases, different mediums, and the light will give you. You can do those experiments, but how can you actually say it's the same thing as when you're looking up there? That's what I'm trying to mentally say. How can they go and get to that conclusion that it's the same thing?
Yeah, they don't know. I mean, they could if even if they had one confirmation, they'd have a little more solid footing. But they don't even have a single confirmation, right?
Yeah.
Because they say that the stars is just another sun because of these spectral lines. So they're all the same or close to each other. But you don't even have the first confirmation to even justify the rest of the theory that all stars are suns and that suns do this and stars do this, that and the other thing. Yeah, you looked up, you saw the lights of the stars and they all look the same in similar spectrum to the sun. Similar. I'm not saying exactly the same because there's differences between the suns and the stars. But you don't have the grounding in the first place. It starts with an assumption. Like the whole globe, like we all know, no matter what part of it, or the heliocentric model, or cosmology, or astrophysics, no matter what part of it you bring up, when you dig down, it's founded on some assumption that they can't prove. Foundation is always wishful thinking.
Great guy once said, it's the best explanation.
Yes. Based upon the best explanation, based upon the variable evidence. But that all falls apart when you start asking them, well, how do you know it's the best one? How did you determine that? What's the metric for best that you're using? And then it just becomes subjective. Wow, I like this one. It explains the most phenomenon. What explains the most phenomenon? This mathematics. Mathematics don't explain, it describes. It describes the most phenomenon. Well, just because you put little freaking stupid names for the variables and say this causes X causes Y, you don't know X causes Y. Actually, this freaking Neil deGrasse Tyson said, science is true whether you believe it or not. Crazy. I love what it says. A hypothetical gaseous chemical element proposed to explain certain spectral lines in the green glow found in the polar auroras. That was later to be explained by singly ionized oxygen. Now think about what that just said. It was found, and this goes right to what she just said, that was found to be explained, was later found to be explained by singly ionized oxygen. Why wasn't it discovered to be caused by singly ionized oxygen?
It is all very interesting. Like, one of the first things I noticed when I started looking up their spectrography shit, right, was that ground-based, there's actually, well, I don't know if any exists, but I couldn't find any analysis of, like, Jupiter, right, which in the spectral graph shows helium or hydrogen. There's like ammonia, methane, and some other gas. And I was like, okay, then why are we getting told that that's made of helium and hydrogen? Like, there's a lot of it there, apparently. And you also find out that certain emission lines can mimic, like one substance can mimic the absorption lines of another substance, right? Like, there's all you're right, India. There's a whole heap of shit
overlap. Yeah, there's a lot of overlap, and there's these things called Doppler line broadening and like all sorts of crap. So like, and then like complex molecules can totally screw. If there's any complex molecules intervening gas, then you know, it's complicated. And I never understood this part. Is that if the sun is a plasma, that means none of the electrons are bound to the nucleus of the atom. They're free, zipping around. So it's just protons and electrons zipping around. None of the electrons are actually connected to the protons, right? These are ionized protons. There's nothing there. Just like a soup. Plasma. Electrons disassociated from the protons. Well, according to the freaking quantum theory of light is created, well, with the wavelengths of light, like hydrogen, when the electron is bound to the nucleus, goes into the excited second orbital, and then relaxes into the stable orbital, and then it emits a photon of a certain wavelength. Well, if the electron's not bound in the first place, how can that even happen? Right? What you should have is, and what we do, like what we see the sun at least just a little bit, is that it should just be noise. Be complete noise, because some electrons are being accelerated, because if you accelerate an electron, it'll emit radiation. If you decelerate an electron, it'll emit radiation. It's the same with any charged particle gets accelerated or decelerated, it emits radiation. It's like a wake field in an electric field. It's like a wake that creates a wake that flies out. And because the electric field is changing, it creates a magnetic field, and that's basically photons. So that goes off in the freaking into the solar wind or wherever the hell it goes. But the point is that they say the proof that the sun is, a nuclear furnace or whatever, is because like the hydrogen hyperfine lines, which is a certain emission spectrum for bound hydrogen, but there's no electrons bound to the hydrogen, so I don't get it. It doesn't make sense to me. It never did. And they invoke all these fucking weird processes that no one's ever actually observed, like the triple freaking alpha reaction, all sorts.
Right. Yeah. Yeah.
It's literally a special fleeting fallacy.
Yeah, and they're so far from actually replicating stable hydrogen fusion.
Fusion. I think fusion is nonsense, quite honestly.
Yeah, but don't they claim that the sun has an atmosphere of helium and hydrogen? Like it's not plasma, it's gas?
I mean,
and that's how they can actually, even though it's a near perfect black body, that they can actually bounce like radar off it and shit.
Well, I mean, plasma, gaseous plasma, freaking, it gets a little weaselly. They get a little weaselly and kind of like, they try to straddle both the properties of both states of matter at the same time so they can get the advantages of one, right? So they can make an argument, well, hydrogen gas emits this spectrum, but it's too hot. So, it's a hydrogen plasma. It's just... They can't reflect the fucking radar off the sun, dude. I had a Glober freaking say that in comments, dude, in one of the comments in a YouTube video. He's like, you're just saying nuh-uh. No, dude, I'm not saying nuh-uh. I'm saying, how did they measure the signal through the noise? Think about it. You bounce a signal off the sun with any type of radar array on Earth. 93 million miles, inverse square law. The absorption of the sun, whatever that is, right? How much it would absorb the freaking radar radiation. What the fuck is left? And how is that going to be more powerful than the emission of the sun itself? So that you'll even see it against that noise, right? That's like trying to light a match in front of a floodlight and thinking you're going to see the light from the match flame.
Yeah.
Yeah, you're not. You're not, and this isn't even the frickin' match, dude. This is the reflected light from the match after it went 93 million miles.
It's probably that same sort of power trick that they try to pull with the whole fucking bouncing shit off reflectors on the moon.
Indio, it's actually probably even worse than that. As the gentleman that you were speaking to, maybe in the last week or so, said it's the refracted, reflected, dispersed. Something.
Talon X, yes. It's dispersion, reflection, refraction.
No, it wasn't Talon. It was some other kid. Talon's, was it? I don't think so. I thought it was some dopey kid that, was really trying. Yeah.
Talon was the one that was doing the Geodesy thing. Or no, you said you would you said you'd talked to him a bunch of times. So who was that?
That was Talon. But the individual who said this, I don't think it was him, man.
I thought it was. I mean, maybe it wasn't.
Talon's probably equally as dumb, if not worse, because of his arrogance. But this kid, that was funny, man.
Refraction. I thought Talon was the one who freaking the dispersion in the rainbow and all that crap. Wasn't that him?
He might have. But the guy that... No, I think this was Brown Recluse who said this.
Yeah, that's right. You're right.
Yeah,
we're close. Yeah, yeah.
I think so. Yeah, because you guys were talking about the FE core tests, and he was arguing that the lasers, that were able to be seen from that far, it was because the light was doing all this shit, and he was just throwing all these turds at the wall, and
Like, why? What satisfaction they get out of that? Where, like, first, they can't form a coherent argument for the thing they're proposing in the first place, where it makes any sense. And then, even if you took that phenomenon and applied it to that situation, like, you can't do what they say it's doing, right? That would be like a very rare one. I mean, hypothetically, at the limits of freaking the physics, they could probably do it in some like extreme physical, in some extreme meteorological condition. But like,
not sure. But I think the tactic is more along the lines of, throwing shit at the wall, seeing what sticks, and maybe throughout the conversation, a door opens that it gives you a glimpse at the sheer possibility that whatever they threw at the wall could stick, right? And that little bit of doubt, depending on how they word it or how the conversation goes, that ever little bit of doubt that emerges, that you might be wrong because you didn't consider this one shiny little possibility, no matter how improbable, right? It gives them a cheap win. You know what I mean? Something like that.
Yeah, I know. I understand. You don't know 100%. There's a 1 in 1 gazillion chance that there was a rare weather. That's why the FE core one's so awesome. Like, because they have to say, yeah, it happened again 3 weeks later. So, when I first started talking about that, for like 2-3 years, I didn't even notice that they did it twice, like 3 weeks apart. So it's like now they have to justify it not once but twice. How are they going to do that? When you have, especially when they have the meteorological conditions of the day recorded, right? Like, how are you going to? But I mean, then again, they don't really care about justifying. They're just doing FUD, the regular FUD tactics, the fear, uncertainty, and doubt. You can't be freaking 100% sure what you're saying.
It's the same. I get the same kind of response with the Black Swan, right? Like when that comes up and I'm around and I have a moment, I try to press them on giving all the details of all the necessary components that are involved in bending the light. Right? Like I did the same thing with Talon. Okay. Because they need to have all these constituent parts worked out to justify that they know that it's doing this thing. Right? So what I've done with the Black Swan thing is I modeled it out using the Walter Bislin calculator. Right? Did you ever see this? Hold on. Well, I think so. I think. Well, I know you've seen the Black Swan and all that shit, but the work or the modeling of it using Walter Bislin, I'm not sure if you ever saw. Hold on, let me just post it quickly there. Basically, the calculator shows that in order to get the view that we get, it would require some enormously high K factor, right? So I press people. I'm like, okay, what's the necessary, all those fine details throughout the line of sight. Sample that, even sample at 1 mile apart. To start with, right? Something, some of these details that would warrant this observation, and they don't do it. Right, because
But that's when the conversation turns into, oh, well, you know, maybe there could be, you know, all these, you know, just on the right day, you know, the right humidity, temperature, and air pressure, and, you know, temperature differential between the water and the air that could do this. Yeah, they just say that. And apparently, you know, that breaks a hole in the argument. It seems to be like that's what they think. You know what I mean?
You don't think they actually believe that shit, though, do you?
I don't think so. I really, really don't.
And why are they doing it? They doing it just to frustrate us? They doing it like to like just have a plausible excuse for the audience on YouTube, like
something like that.
Well, actually, it's an implausible excuse for the audience on YouTube.
No, but it's enough. It's enough because here we are. You know, we're talking our book, right? We're standing here all sure about what we're saying, and justifiably so. You know, but for them to get that one little kind of jab in there, it's enough.
Well, it's just like, you know, I that's why I try to flip it to them, dude. Like, if they say anything about you did this wrong, I say, okay, I agree. Tell me how we do it right then. Tell me how it's supposed to be done right. And they can never say how to actually do it.
I know.
They'll just mumble some generalities or look it up on Google or this, that, and the other thing. Well, then how do you know it's wrong if you don't know it's right?
Yeah, I think that's a good move, to be fair there. Because, you know, they're adopting the burden of proof when they call you out in whatever you say. Like, implicitly. You know?
Well, you know, the other thing is when they say, well, you know, could be refraction. Okay. They have to justify the refraction effect that they say is happening is even possible. No, because they need to show it's actually possible to do it, which they've never done.
That's the thing, right? So check this out, right? Post it in the chat. You've probably seen this before. Well, that's what I mean, right? Check this out. In the chat, Abe has passed the hour. Okay. This is that. You must have seen this, man. But this is the Black Swan image from the 1 foot observer height. Right? And we see the oil rigs in full. Both of them. But the last one is the most important one, right? The 9.41 miles away. We see it in full. So according to this thing, you need a K factor of fucking 0.989182. It's like, is that possible to achieve? According to them, apparently. No matter how improbable, well, how did you know you didn't just go out there on the right day at the right time to see it, you know, with that type of effect? That's what they do. And then somehow they win. Which is why I think what you were kind of hinting at before about repetition, repeating the thing multiple times, right? That's what whittles down that kind of argument. Because the likelihood, you know, it shouldn't be that high where you see things consecutively like that. You know what I mean? Like the odds of you seeing it once is already very low. But then think, you know, if you want to throw in like a little twist on it, you know, apply Bayesian reasoning to it. What's the likelihood of you seeing it consecutively as close, you know, as you do one day apart from each other or several days apart from each other, et cetera, et cetera? The odds go very, very low. Shit like that, you know what I mean?
Yeah, and they also can't say the mechanism only in a very general way. They just say, "Oh, refraction can do it." Yeah, how?
I know.
Well, how? You got to say how it can do it. You can't just say it could. Yeah. Well, you don't believe in refraction? That's just shit you hear all the time. Oh, you don't believe refraction's a thing. Yeah, of course refraction's a thing. We're talking about it's just, to me, like, I'm even getting pissed off even talking to you about it, because it's just bullshit, smoke and mirrors. It's someone literally trying to obscure the truth, dude. Actively doing it. Trying to obscure, and they know they are. You tell me why someone intentionally would come on here and try to obscure the truth. Why? I mean, and I don't believe in the agent bullshit that fucking everybody flips out. Oh, they're agents in fucking the Discord or something. I don't even believe in that shit. But some of these people, their behavior, it like can only be like rationalized why it's even happening. Is if they're fucking like being paid to do it. Why would you come in here? Listen, if Earth is not a globe, if you think Earth is a globe, and somebody thinks the Earth is flat, why would you want to convince them based upon a lie or information that isn't truthful? Does just the ends justify the means? Is that it? Just keep believing the globe. Even we got to scare everything and bullshit. We don't care. Just as long as you just stay on the globe.
But they think it's true, though, right?
I know.
Even don't possibly true, right?
Do the ends justify the means, bro?
If you're insane, if these people are either paid, like you're suggesting, they might be, or they're just really like there's something wrong in the head, man. Like Talon, for example, he's the one that blows me up, man. I'm telling you, I've had too many conversations in too short of a period of time where every time I lose my temper, and I don't like doing it. Okay, and it's hard to get me to lose my temper.
I know that. Look, dude, we'll just lay down the law with him. Next time he comes in here, he's going up on the witness stand, and we're gonna take him through step by step. In each step, nothing's gonna happen until that little step of rationally walking through the problem is resolved. We're gonna walk through it step by step. Okay?
I've been trying, man. Matrix and I worked on him a few weeks back. You know, you've seen my.
There's no taking no for an answer. As soon as he gets off, like, listen, bro, you get one fucking chance. The moment you walk off the fucking track onto somewhere else, you're banned. And just keep doing it every single time. Okay, where were we? Oh, yeah, we were on step 5. We're gonna start there.
Yeah. I've attempted to do that last few times, right? I always like hint at, the India thing. Oh yeah, the refraction thing. Oh yeah, the you didn't give us the data of all these constituent parts thing. Yeah. Like I try to bring it back, because of exactly that. It's too insane, man. Like, check this out. I don't know. Did you get a message from him anytime recently? I think DJ and I. We're talking. He mentioned he got one. Were you there? Did you happen to get a text from Talon in the last 3 days? 3-4 days? Check this out. Do I have it? Hold on. He sent me a text. Wrote literally. Okay. He sent a screenshot of some textbook, an older book. It looks like a screenshot of a page from it. He wrote, I didn't post the whole page. They literally say they take temp measurements. LMAO, y'all are so cooked, lol. The Great Trig survey keeps getting stronger and stronger. Okay?
Yeah, I got that same thing.
Oh, you got the same fucking...
Yeah,
did you read the page?
Yeah, I mean, let me see. I'll pull it back up.
I'll post it in the chat.
So I told him, this is what I told him. I said, shut up, noob. And then I posted about 1, 2, 3, 13 citations saying that terrestrial refraction is not quantifiable from, academic literature. And this is what this is. I wasn't going to get into it with them, but this page, they're telling you how they made the tables, not what they did during the surveying. You understand? Because it says straight up, refraction is had from the tables of mean refraction, and no notice is taken of the barometer and thermometer or the heights of stations above the level of the sea. Considers doubtful, blah, blah, blah. With corrections for the micrometers were determined by taking runs between every dot, right? So this, from what I can tell, is how they came up with the mean refraction in the first place.
Sure.
Right? The tables. How are you going to make the tables? You got to make the tables out of something, right?
Wait, the mean refraction? Or because when Talon and I were talking, he only talked about them basically averaging out the angles that they take, right? So you get an average angle from point A to point B, an average angle from point B to point C, or maybe even a reciprocal one back to point A, whatever, right? Then you all those averages, then you sum them, and then you're supposed to get a 180 degrees, right? But if you get over that,
that'd take days.
Huh?
That would take days to get a decent data set.
Well, that's another good point, right? Things change over a few days, right? But he claims because they take enough samples over the course of a few days from all points that it averages out enough, I guess, so far. Like, he's never ever posted any of the data, to justify this. But let's say, let's say, watch this.
Actually read any of this or understood it?
Probably not. But all he has been doing so far has been relaying our inquiries to him through ChatGPT.
AI,
open about it too. That's all he does, right? So according to ChatGPT, this is how they did it, right? So even if we take it at face value that maybe, let's say, okay, between 3 points, you got a group of guys over there taking the sample on the same day as the other guys, and then they average it out. Even if that were the case, there's still problems. You know what I mean? Because you get an average excess. So maybe on average you get 181 degrees, 182, 180.5, I should say. Whatever the case may be, that 0.5 extra, that 1 extra, that 2 extra, degrees, the problem still comes in. How much of that is caused by what? The curve versus the light bending. And then how do you determine that? Proportionally speaking, right? And according to him, they can do some shit, but he's never been able to show. And that's where the frustration arises, man. It's like we've circled on that so many fucking times.
Yeah,
and he just doesn't want to
There's no light bending. No? That's the thing. There's no evidence of any light bending. Just because you expect to sight in on a certain freaking dot on your rod and you sight in either higher or lower does not mean there's light bending. Okay, that's just a jump to conclusions. Because there's other reasons you could be sighting in at that location. Deflection of the vertical. The curved plumb line and all that shit. That's one reason. Expansion of the fucking rod. These rods, it even says it in here, unequal heating cause them to expand on one side than the other. This is known. Okay, this is known. I've seen this in contemporary geodetic surveying stuff. Is that they should store their rods in their case, and then when they take them out of their case, they should warm them up. Right? They shouldn't They should only use them when the temperature is equalized, and then they should equalize the temperature to the rods because the rods themselves expand and contract. So
their leveling mechanism varies, basically.
Yeah, everything varies. It's not. This is an easy thing to do. those things there's a lot of variables, needless to say.
Yeah. That's another one, man. So how do they account for that potential?
Light's just bending. That's just stupid. It's just dumb, dude.
Well, I mean, light bending. I mean, you look at what Radwin posted. Like that phenomena of shit going up and down, waving, and all that. If I were trying to sight the beach from that same position where the camera is, I would have to be angling it up and down. You know what I mean? So I get that, but it's just the way.
But the funny thing is, light's not rays. Light, there's no such thing as a ray of light. That's a concept.
I know. It's an abstraction. I know.
So when you say light bending, you're talking about bending rays of light. There's no bending of rays of light. What's actually happening is the wave front of the phase of the wave is getting tilted. It's getting tilted either forward or backwards. And okay, think about it like this, right? So it's really simple. I mean, so say you had a fucking 12 by 12 tile, right? And it's coming right at you. It's freaking perpendicular to its direction, smacks you right in the face. So you got the entire 12 inches of the tile. Well, if the tile's tipped back or tipped forward, it's going to look like it's a different size, right? It's going to appear compressed or because it's tilted, right? And this is the same thing that's happening when I say wavefront. The wavefront is like the tile, right? It has a front, like a front surface. And I mean, that's the way you can think of it. But it's like, that's actually the way it excites the fucking molecules in your eye. So, there'll be more excited freaking photoelectric fucking cells in your eye if it's straight up and if it's perpendicular to your eye, the direction coming toward your eye, versus if it's tilted. And that's what happens with this turbulence, is that the wave front is changing its orientation. It's not bending or anything. It's just changing its orientation, kind of like wobbling. So it's like these words are kind of like
misleading.
They're being misused. In this context, I'd say they're being misleading, but the idiots that are using the words don't know what they mean in the first place. So they're not misleading anybody because they don't know what they're talking about. But they can be used misleadingly, I guess.
Sure.
Well, I got a good illustration of this. Anyway, my point was, Mick, is that, right, they do surveying. They got to survey India. They got to account for refraction. But somehow, when they go down the Himalayas and they go to the Bay of Bengal and frickin' look across the ocean and they see some frickin' Chinese junk halfway cut off, then refraction don't apply no more.
Yeah, I hear you. I remember asking or posing the scenario, or the how you put it, mental exercise in the past. How can one tell between these two scenarios without the finer details? So say scenario one, you're on a flat plane, you look out, it looks flat, but then something changes and it looks curved. Okay? The light bends, wavefront tilts, whatever the fuck, right? Versus the contrary, or the other scenario, you're on a curved surface, you look out, it's clear, you see, the curved part because it's bending and, some shit's blocking some shit out, whatever. But then one day it looks flat. Unless you have the known, unless you know all the details of what contribute to the light bending, right? And how,
Nick,
under what circumstances.
Nick, I know how to tell the difference.
If you have the detail.
I've talked about it. No. Listen.
Yeah.
Chromatic aberration, man. I've talked about this 100 times. Chromatic aberration.
Yeah.
We don't
So
see
if it
this.
was actually,
But if
if
you
it
were to
was
make
actually,
a camera, right? If you were to make a camera, say you decide, hey, I'm gonna make a camera, I'm gonna grind my own lens. Okay, let's take a picture. Hey, why is it all fucking rainbow looking? Oh.
Yeah.
Well, because your refractive medium is too thick, you got heavy refraction going on. The blue takes a different path than the red, which takes a different path from the green, so you get 3 images. Okay, so correct your lens, grind it differently, and then you can merge these images. And okay, how can you do that to the atmosphere?
You can't.
How come that? How come the atmosphere is chromatically corrected all the time? See, it doesn't make any sense. So we should at least some of the time on these high refractive, extreme refraction days, especially over long optical paths, right? Especially the longer the optical path, the greater this effect is going to be, right? Because the more air it has to go through, the more distance it has to separate, right? So we have red going in one direction, green going in one direction, and blue going in another direction, and they're all getting spread out like a prism. Now obviously, the bigger the prism, the further apart the rainbow is going to be, right? The greater the rainbow. But we never see this. It's never been seen, never been reported. No one's ever seen, damn, dude, I went out and I saw a freaking refraction rainbow. I went out and I saw the freaking the Willis Tower across the Chicago skyline looked like a rainbow. No one's ever said that.
Yeah, that's a good point. I guess what I was just highlighting was on like the naive, simpleton way of explaining.
No, Nick, the reason I say the reason I even brought it up is because they want it, like, because you brought up a good point. How can I tell the difference between, hey, a flat Earth that sometimes will look like a globe or a globe Earth that sometimes look flat? How can I tell which one it is? No, they just wanted to make it the whole thing unfalsifiable. They want to go, oh, you can't tell. The only way you can tell is you got to go on a rocket to space. That's the only way. You can't tell from the Earth, remember? That's what they want. They want you never to be able to tell what the Earth is from the Earth. They hate that idea. You have to go to heaven. Or, I mean, space. You have to go to space. Sorry. I misspoke. Or did I? No, you got to go to heaven. No, you got to go to heaven. That's the only way you can tell what the Earth really is. When you're in heaven, you can look down on the Earth and see the freaking little people.
So if given it's planar, right? The days where it looks like it's being cropped from the bottom up more intensely than it looks when shit just gets really far, right? We don't see chromatic aberration either, though. So is it kind of like
I don't think that's caused by refraction. I have never thought that. Because what do we see? We see like in a little inferior mirage, which is a reflection. That's not refraction. What they try to say is that inferior mirage, and this is what they've always said, inferior mirages are caused by like the light dipping down into colder air, then coming back up and making a double image. So you see directly the thing and then the refracted light popping back up. When it makes like just more just common sense that it's just an actual reflection. They didn't know when they came up with the refraction thing about inferior mirages. They didn't know about things like total internal reflection. That wasn't even a thing yet.
Yeah. Okay. But I mean, are all images of the kind that I was kind of talking about or hinting at, do they have mirror images? Because I thought I could swear that I remember seeing like one instance of the oil rigs, for example, where they look a little stooped, right? I don't think I remember seeing a.
Well, that's one, but what I've noticed is sometimes they look magnified way in the background, right? So it'll like up to the horizon, there'll be like one like I don't want to call it a color tone, but it's something like that. Look, hold on, let me get the Black Swan. The other one, the frickin' the halfway cut off one.
Because DJ brings up and talks about a lot about the phenomena they've dubbed stooping, looming, et cetera, right? I think they're forms of what you were talking about. Inferior mirages or superior. I always get fucking confused between them all. I don't fucking know.
Inferior, look, bro. Inferior means under, and superior means over.
Yeah.
So inferior is when the bottoms, right? So you have the city, and then you have the reflection of an upside down city underneath. The superior mirage is where the upside down city's on top. So underneath inferior, on top superior, right?
Okay.
So their tops would be touching, but the city would be above the real city. And if it's under the real city, then it's an inferior mirage. Both of those are like. Does it make more sense that they're just reflections to me? That's actually what they are? Because they're saying that there's a layer, right? A hot, cold layer, in that the light's dipping down into that layer and creating a double image. Well, that's also how reflection works. You have two different refracting mediums, and if the angle is small, it reflects off the boundary and creates total internal reflection, which makes more sense to me than saying the light is going into it and coming back out and making a perfect fucking mirror image. That doesn't even make sense to me.
And you're not the only one. I mean, people within academia are challenging the previously held mainstream idea of what's going on. There's publications out there about it, exactly what you're saying. Exactly. They are, at the moment, it is... The books are getting changed.
Yeah, the textbook's trash, bro. Like, they probably didn't know about it at the time they, came up with the idea for mirages, and it's just like something that just like keeps just going on and on and on until someone like gets the nuts to change it.
Right. Okay. So in these instances, we would see a double image. One reflected of the original. But what about we still haven't?
I know you're talking. I can't find. Yeah, I need the black. Oh, there it is. Matrix posted it.
Here's one we prepared earlier.
Yeah, you see how the back, the oil rig in the back. You see how like the color scheme looks different. It looks like faded or blown up. It looks like the oil rig in the back is like. How many? Isn't it like 3 miles farther?
No, I think that 3.
Yeah, it's like 6 and 9, right?
Oh, I heard.
Right. 6 and 9.
Sorry, I thought you said
6 and 9. Now,
I thought you said 30.
Why does it look the same size?
And not only that, but it doesn't look like it's tilting back either.
Yeah,
right.
Well, I mean, there's that. I mean, that's a big problem.
Like that, I always wondered about that one. Like at that low of a fucking sink, man, like that's steep of a curve in 3 miles.
That's a tiny Earth, bro.
Well, that shit, I should be seeing that thing at a fucking like 20-degree angle or something from the looks of it.
Well, hang on. So the horizon's at 6 miles, and then there's curve, right? Like so.
Right.
So you've got an Earth with a radius value which is equivalent to whatever would produce a 6 mile horizon, right, from whatever altitude the camera is, and then you've got that the hidden target, right?
Yeah, but I guess the point though is
what's hidden?
It is a little bit faded. And it almost looks like around like the. I don't know if this is an artifact of the camera.
The size isn't right. Like the side, there's no way if it's that much further. I'm assuming these two rigs are like nearly the same size. Like,
I think so. I remember looking up one, like to do that modeling there in the Walter Bisling calculator. One of them is 94 feet, I think. I didn't check the other one though. But I was going to say, like, if you look at the arms on this thing, the little, like the sides there on the cranes or some shit, right? The one on the left if you zoom in a little bit, it almost looks like a little bit. There's like a pinkish, reddish cloud around it, like a smudge kind of thing. Like zoom in a little bit. I don't think it's a camera. I don't know if it's a camera thing. It looks like a little bit of a smear or a smudge compared to the other one there. You don't see that as pronounced. Yeah, not as bad, not as much. See what I mean?
Yeah. I mean, I think there's even an inferior mirage on this one that Matrix posted. Because there's a discoloration right at the horizon. Here, let me see if I can pick it up with this.
Normally, chromatic aberration is more pronounced when you've got very specific lenses in your camera. Normally, the high-end lenses will have multiple group sets of glass, all moving in different spaces and different timings to zoom in and zoom out. This minimizes chromatic aberration, whereas some of the cheaper lenses have one thick, chunky lens at the front. You twist your lens, it moves further out, and you focus with it. Those ones with only one big, thick piece of glass will notice it more so. So if you're looking at images, you probably want to be looking at older stuff or stuff that's being used with shit lenses.
But is the chromatic aberration an artifact of the camera lens? Or is it an artifact of...
It can be created... No, hold on. It can be created at the camera lens. But it should also be because camera lens is a refracting medium, right?
Yeah.
But so is the air supposed to be. So according to these guys, that the air is a refracting medium. But none of the effects that we associate with refraction, chromatic aberration, vignetting, that's where it's dark around the edges and like bright in the top, like magnification, shrinking, right? We don't see any of this in nature. But why not? If the air is acting like a lens that's bending light here and there and everywhere, right, and flattening the curve, right? So if it's flattening the Earth to make it look flat, right, if it's like, if it was 7.6R, right, is what? A larger ball. Well, a larger ball is a magnified ball, right? So not only should it be, 7.6, the Earth should appear 7.6 bigger. Not just the fucking curve part, the waves, the shit that's out there, the boats, the fucking goddamn windmills. It can't just happen to just the curve and nothing else.
Right. Never has the air ever temporarily just so happened to correct my short-sightedness.
I know, right? That'd be great, though. Oh.
Yeah.
It's 2020 Vision Day today. All you short-sighted people, get out there and go surfing. Good day to shoot baskets, target shoot, anything that involves shooting you'll be good at today because now you can see the target.
Yeah.
I'm wondering now. So, checking out the photo from Jaeger Bruno. Well, the second, the last one, right, where it kind of shows that graphic of the colder air, warmer air, the vanishing line, and what happens when it kind of lowers or whatever. Yeah, you see the reflected image, right? But might there be scenarios where that reflected image doesn't reach your eye, but the phenomena kind of creating the kind of elevated horizon line or whatever still manifests, but between that part of the water in this scenario and your eye, it has another effect on that reflected image so it doesn't reach you, so it just looks like it's one giant body of water?
What I think happens is that whatever you're looking at, like when you look out, especially over the ocean like this, is that it's not as continuous as you think. When I say continuous, I mean like vertically continuous. meaning like, say the air right above the horizon, it could be opaque, right? There could be sea salt, frickin' sea spray, all sorts of shit. So light can't, that's beyond. So say you're looking out and the horizon's 5 miles away, say. But the light beyond that 5 miles, and say you have like sea spray right on the surface, if it can't penetrate that sea spray to where you are, it's going to effectively act as a wall, right? With a light beyond that, you wouldn't be able to see. It would just be a wall. But stuff like higher up, that might be transparent, more transparent. Or it could be freaking turbulent, or refracting, or reflecting, or any number of things, right? And then stuff before that, like on the ocean itself, because you're looking at it more at an angle and you're looking into it, you know, that could be freaking just look normal. So it's like a combination, like, because, I mean, I don't think a lot of people understand that at the distances we're talking about, the way light behaves at these shallow angles is way different than where it just behaves at just the regular, because we're like glancing across the surface, you know what I mean? And the light the light that you'd see is like coming in at like a super shallow angle. And that's where, but the thing is, super shallow angles are the reflecting angles.
Right.
Yeah, I can remember that dive.
I guess they would interfere. They can interfere too, right? If there's a phenomena that kind of like, you know, redirect, you know, some part of the wavefront, it can kind of like cancel out the other part or whatever.
Yeah, and then there's destructive interference. So you could have like, it's called multi-path interference, right? So say you have the light coming in, right? But some of that light gets reflected off the surface. And well, that can constructively interfere on some boundary layer. When I say boundary layer, I'm talking about right at the surface. It's like, this is like the fallacy of the single cause. It's way more complex. That's why I start, like, I want to do this year of observation. Like, if you guys have been following Pavel's dog, like, he's got these weird ass observations because he's been just going out there for like a couple of years. And like, in the mainstream narrative of what they say is going on, nothing that he sees makes any sense, dude. It doesn't make sense within their narrative. There's no possible. But I don't think anybody's ever gone out and consistently made observations of this fucking sea horizon that this guy has made.
Right. You remember that Dive guy, Beethoven dude? The strange Aussie flat earther dude. You remember him with the pendulum in his kitchen and all that elaborate? You remember him?
What's his name?
Is Dive, DEIF or something, like Dive something or other, and then he was Beethoven. Anyway, like yeah. So he posted this footage. I think it was amateur footage of someone had filmed the debris of a exploded fucking SpaceX rocket or something, right? So this thing's way up there and way out, right? And they're following the debris in the frame and watching it go down towards the horizon. And this shit's on fire, right? And it fizzles out before it hits the horizon, right? And like, so you've got some options there of what happened, right? It fizzled out before it hit the surface, and you saw it fizzle out midair, or it's actually hit the water, right, just above the horizon. Like, so you've got that internal reflection thing going on.
Yeah.
So you're actually seeing more of the surface, and it's fizzled out in the water, or it's hit some sort of like you were saying, some haze, so it's gone behind the haze, and you just don't see it get to fizzle out because it's just the light's just not reaching you. But it was just interesting that, like, this is just amateur footage. They weren't even trying to capture that, right? Like that was just following the debris, right? Because it was a cool event, you know. This thing exploded. I caught it on film, you know. So yeah, it was like that. I'd say, like, my guess would be is that it hit the water, right?
Yeah, I think I know what you're talking about too. It was
Yeah,
like
I'd
a
never
rock.
say-
It was like, this is way back, man. Didn't Reg Rhetoric do a thing on it or something?
I'm not sure.
About
Not
it
sure,
was
but
like a rocket launch that like freaking crashed, and they were like saying, or, I don't know, it was one of Elon Musk's reusable rockets.
Yeah, I asked him to post it again, and he never got around to it, and I never got to save it. In politics, where the chat gets wiped.
Hey, here, Mick, look in the chat.
Yeah.
Have you ever seen this one?
No.
It's a clip. Just watch it real quick.
Okay.
Yeah, it reminded me of the dolphins one that AG posts a lot.
Oh,
with the
yeah.
dolphins.
There's some seagull ones that are like that too. The seagulls just appear out of nowhere. They like dive down to like catch fish, and like one seagull appears like it's floating in the air on the water, but it's not on water, right? It's in the air, but it's like on the air because it's an inferior mirage. So there's like a seagull's like floating there in the air. Another one just like flies up out of nothing, right? It just appears in the air, like half a degree above the water, like. Yeah, man, but just like ships go over the horizon, man. That's it, man. There's a geometric curve, man. That's it.
Okay, so explain to me what I'm looking at here. It's a little bit vague. What's going on?
Dude, there's a boat there. They're dropping cargo into the boat.
Yeah.
So there's an invisible boat on the left-hand side of the oil
It's
rig.
an invisible boat, bro. Do you think they're dropping the cargo into the ocean? Don't you see like it come up, like the reflection of it come up and meet it and then disappear?
Oh, yeah. Okay. Yeah, okay, it's got the cargo, and then it hits a certain height, and then it kind of just, there's a mirror, and they just, okay. Okay, yeah.
So, I mean, like, refraction? I don't fucking think so, dude. That's not refraction. That is definitely caused by reflection. And because this angle, you got to think, if I calculated the angle from the crate, right? So you got two images, right? You got the crate and the reflection of the crate. Now the refracting, the boundary is going to be the halfway point between the two crates. If I calculated the angle between that point, right, that line, to the camera, that angle would be small, like super small, in the thousandth of a degree and 100th of a degree, or in the 10,000th of a degree. Well, that's total internal reflection. That has like, even if you have a difference of, say, in refractive index of 1 in 20,000, right? Which is kind of where air hangs out. Like when you change a degree, the refractive index changes by about a 20,000th. And you just calculate what the angle would, the total internal reflection angle. It's freaking just like 2 100ths of a, or 2 1,000ths of a degree. So it's like, or 200ths of a degree. Is that right? 0.02? Yeah, 2 100ths of a degree. So the part of the problem is like people don't understand that, like at these very shallow angles that you're looking at long distance stuff with, their expectation of what light should be doing is wrong, because it's different, because it's far away and you have these very shallow angles of the light traveling. It's just totally different. just the way it behaves.
I see.
So what I would bet, right, is that if you were out there in the ocean and you measured like to 6 feet above sea level, it would probably be like 3 degrees warmer, 3 degrees colder than like the 3 feet of like a meter. Let's say a meter above sea level would be like 1 degree warmer than, higher than it. Well, the light that is above that will reflect off that boundary. Not refract, it'll reflect. There's a little app. I mean, you could just type it in. You like, it's called, it's a little physics simulation. Yeah. It says
physics simulation.
Yeah, it's just for reflection and refraction. Like you can just play around with it. You just change the angle incidence, and it'll show you the intensity of the reflected beam versus the refracted beam. When you start getting to what's called the critical angle, all the light's reflected. None is transmitted.
Well, it's like those floating ships, right? Or flying ships. Now, they'd have to be claiming, right, that there is a total internal reflection thing going on, right? But that whole scene is actually behind the Earth curve and being refracted up, so that the incidence of total internal reflection is being refracted into a position that you can witness it occurring. Because right, they can't just claim that that's refraction, that's light lifting the boat above the horizon, above the Earth curvature, and making it appear to be hovering in the air. Because otherwise, if it's going to show the part of the boat which would be sitting in the water, then it's going to show you the water that it's sitting in as well. It's not going to look like it's in the sky, right?
Right, exactly right. But, I mean, when it comes down to it, Goldberthers, well, at least the worst ones, are going to come in here, and they're going to try and obfuscate all this stuff. They want you to go, oh, in the textbook, it says frickin' it's caused by colder air on top and warmer air on bottom, and what, you think you're smarter than all the scientists?
Yeah, they can explain why refraction decided to just eliminate the water and just focus on the boat.
Yeah, it's pretty crazy. Did you guys were you guys in? I don't know if I was in. Yeah, I was probably in here. Maybe the home server. The frickin' what do you call it? Let me see. Naval Surface Warfare Center. Horizon Infrared Surveillance Sensor. Detection Range Performance. You guys heard of this yet?
No.
No? What's this?
Oh, shit. Okay. So, the United States government, on behalf of the U.S. Navy, decided that they were going to make something called the Horizon Infrared Surveillance Sensor, where they would try to detect, at the longest range possible, missiles, incoming threats, boats, you name it, right? They're going to use infrared sensors to pick up these things. So this report is detection range performance. So they're testing how far away they could detect. They first got a detection of their targets. Now their targets were TLX towed targets were typically conducted in a sequence of 4 inbound burn runs per day. The first run was usually around 200 feet altitude, and the next 3 reached lower altitudes, approaching the intended altitude of 30 feet. This figure shows the effects of a target's altitude as compared to the effects of atmospheric transmission in band over a 200-kilometer path on first detection range. In the top chart, and this is the important part, there is no apparent correlation between altitude and detection range. But if the Earth is a globe, how's that fucking possible? Altitude and detection range should be directly correlated.
Oh yeah, because there's supposed to be a massive hump of Earth curve in the way.
Okay, well, it gets worse. Because this goes along with what we say. The longest detection range was at high altitude in the bottom figure. However, there does appear to be a correlation between atmospheric transmission on detection range. The longest detection ranges occur during the time of the highest infrared transmission. The shortest detection ranges occur during the time of the lowest infrared transmission. In the previous figure, it was apparent that on a single day, you could see the effect of altitude on reducing detection range, but if you look at all the runs, it appears that the TLX altitude was not the most significant factor on reducing detection range. Rather, the overwhelming factor is the change in atmospheric transmission from day to day.
Shocking.
Shocking. This game went going on in here. I'm shocked, I tell you. I'll post that in chat. Link to that.
Yeah, during World War II, the Japanese didn't think the Americans could hit them from far distances. And they were shocked to learn that they were putting shells on target for 20 miles.
So you had to take over Japan and stop them being flat earthers that could shoot artillery shells. What if that crap's a psyop, dude? That freaking flat earth globe, they tell the rest of the world the earth's a globe so that they'll believe them and then make military equipment for that. And then when they actually go into war, they lose because the earth's not a globe. They're accounting for Coriolis and can't hit nothing. Accounting for curvature, can't hit nothing. Think they can only shoot it so far because the curve of the earth's in the way.
Yeah, the Brits thought the same thing about radio signals, right?
Yeah, the Kinnickabine. How'd that work out?
Yeah, then all of a sudden the Brits had to come up with all sorts of countermeasures for these radio waves that were going over the curve of the Earth.
Oh, Dark Matter lore update.
Oh man, we're going to get a new gravity theory. Yes, we can add that to the pile.
When does a pile become so large it collapses in on itself and forms a black hole?
No, when it falls over, we blame gravity.
Okay, let me ask you a question. Can my friend come?
Okay.
Do you believe in aliens?
Aliens? Jamesy?
Yeah, aliens.
Take this.
You mean
You don't
Mexicans?
believe in aliens?
Oh, I do.
Only.
I know many. I myself, I'm an alien in the United States. I'm an immigrant, and I immigrated from another country to the United States. So yeah, I'm a legalized alien. Someone from another land.
Okay. Now you know the truth.
Do you
Now
live in
know
the country?
everything.
Do you live in the country that you were born at? Do you live there?
The country what?
Do you live right now? Are you standing on on your mother country, the country that you were born at? Is that where you're at right now?
Yeah.
Is there foreigners in your country, like people like Chinese people in your
No,
country?
no Chinese people. No.
No foreigners.
No.
So, yeah, aliens. In the fictional sense, it will be beings from other planets, but in the actual meaning of the word, it will be a legal term, alien for foreigners, people from other lands. The fictional sense, when you're speaking about the globe and being from other planets, like the Earth is a planet, fantasy, fiction, science fiction, then you use the word alien to talk about beings that come from the other globes or the other cartoons' imagination from the vacuum of space. It's fantasy. Like in the movies, when you see Star Wars and you see the aliens in Star Wars, that's the globe. That's the globe is the same. They're in the same universe. Fantasy.
What's the argument for that?
That the globe
I haven't
is
seen one
not
before.
the ground that you're standing on. The ground that you're standing on is not curving. It's not a globe. So when you see Earth as a globe, that's a misrepresentation of the Earth. And it will, if you see it in a movie, it's a cartoon. When you see it in the TV, it's not what the Earth is. When you see
I know
it
that's your
as a
claim.
globe.
Yeah, I know that's your claim. I'm just asking what the argument is for that.
That wouldn't be my claim. That would be the acknowledgement of the physical or natural world out there. I'm acknowledging the surface of the
I'm
Earth.
just saying, what's the argument
you're
that those
saying
depictions are inaccurate?
Because the surface of the Earth is not doing what the depictions are showing you. Like the water
That's not
doesn't
an
behave
argument. That's
that
just
way.
a repeat of the. That's just a repeat of the claim in different words.
Okay, the surface of the Earth.
Like, imagine if I said, "Oh, the Earth is not round," right?
So the surface of the Earth is lacks the drop over distance to a specific rate that will conform to the claim of the sphere in the TV screen. So the sphere in the TV screen says that the Earth has specific variables, specific dimensions. So when you go turn off the TV and go outside on the Earth and you check that, you check the Earth, you measure the Earth, use lasers, long distance observations, you do all of those things and you check and triple check and 100 triple check the surface of the Earth and it's not curving, then the thing on the TV is not real.
But have you actually checked, or?
Yes.
Okay, so you must have come to the same answer that all professional surveyors have, right?
Oh yeah, the surveyors definitely tell you that the surface
Oh
is
yeah, so the
measured as
professional
a plane.
surveyors say that we do indeed observe a curve. So.
No, you don't. You're all out.
We do observe a curve, right?
No, we don't.
I'm glad that you're a fellow Glober. Welcome to the Globe.
Is this idiot even listening, or is he just going to come here and just bark out bullshit?
Have you got Matrix muted?
No, I heard what he said. He said that the movies would be wrong if they don't conform to the measurements we take. And I said, yeah, have you taken the measurements? He said, yeah. And I said, did you come to the same conclusion that
Yeah,
all
but you didn't
professional
listen to what he
surveyors
said.
do?
You kept
And he
fucking
said,
talking,
yeah.
you rude little shit.
And he said, yes, I did come to the same conclusion.
No,
that
you
professional
chose not
surveyors
to
do.
listen to him. And that conclusion was what?
Yeah,
That he
tell me
came
what was
to
the
the same
conclusion.
conclusion.
That's right, you spoke over the top of him because you're a rude little shit.
Yeah, but what is the
How
conclusion?
about Unity, instead of speaking over him, sorry, Jamesy, don't. You're a fuckwit debate child. We don't need your caliber of shit stain in here.
He spoke about conclusion, maybe.
What he did, Jamesy, and you missed it because he spoke clean over the top of you, was when he said you've come to the conclusion, he didn't even give a fuck what you said, mate. He just ploughed right through. Oh, so the conclusion of all the other surveyors is that it's a globe. And he just ploughed straight through you.
Yeah, I got it. I just wanted, yeah. No, you're right. You're right on point. I get it. That's a tactic. It's pretty obvious. But he's presuming that the conclusion. He's presuming that the conclusion. He doesn't want to talk about the conclusion. He said the conclusion is that it's a globe, and you agree with that. But he's misrepresenting the conclusion of the measurements because it doesn't represent the globe. That the globe
if
will
it's
be
been measured as a globe,
misrepresentation.
Jamesy, he'd have the measurements. If he knows that it's come to the same conclusion, he'd have these measurements where it shows as a globe.
Yeah.
Unity, have you got these measurements to put forward to everyone? Or are you going to go quiet on us?
Cool, I'm unmuted. I could share such measurements. I could share such measurements if you're referring to the claim I made, which is that professional surveyors do indeed observe a curve. You want me to post a link for that?
You know, Jesse, Path of Light's not a professional surveyor.
Do you want me to post a link showing that professional surveyors observe a curve?
No, we want to post you to post the data that you've got that proves this curve.
Well, my
it's been
claim
measured
was
as drop over distance.
My claim was
blah blah blah. Post it in the side chat. Listen, this is not a debate. Post your data up.
Yeah, my claim was just that
the
professional
debate project. Just post your data. Yeah, you've got to reiterate your claim so no one plows through you. It's a bastard, isn't it? Post your data in the side chat.
Are you okay? Calm down, sweetheart.
Are you okay? You post your data in the side chat, boy. Yeah, we don't care about your original claim because you have to reiterate it again. Let's just put you on there. You're going to post your shit in the side chat and then I'm going to unlock you. See, if you haven't learnt yet, kid, I don't go for the debate bro tactics. You come in here, be an adult, not a complete fuckwit, post your data in the side chat. And no one's holding you in here either. No, a lol is not data. You can do better than that. So step up, Sunshine. It's your call.
What did he say? What did he say? Did he say surveyors measure curve or something?
Yep.
Okay.
His claim was professional surveyors. We've got to make sure we get that right.
And observe it. And observe it.
Oh, and observe it.
I'd like the data posted up in the side chat. Unless anyone else wants to talk to him and listen to his shit. I thought it was piss weak, him just plowing through Jamesy.
I didn't hear. I just got back.
I'll get him for you.
For a second. I'll
get
get
him. It's all good.
Okay. Unity. Yeah. If they measure curvature, can you tell me what the reference ellipsoid's for then?
I don't know, but I just know that the land surveyors say that they've measured curvature, so that's good enough.
What?
I just know that the professional land surveyors have said that they do account for curvature when structures get large enough and there's project planning, so that's good enough.
Yeah, but they don't say that. You just made that up.
No, they say that.
No, you made that up, dude.
You want me to just give you a quick Google search or something?
I want a quotation from somebody saying what you just said they say.
Yeah, look. So I just quickly Google it. Professional land surveyors do account for the Earth's curvature.
That's not a quotation. That's a general bullshit.
The approach depends on the scale and purpose of the project. For large scale or precise projects,
still not a quotation.
Such as national mapping. I don't know why you need
a human being, dude.
Yeah, I don't know why you're Account looking for for it. I thought you some said sort they of-
Measure it, not account for it.
You said professional
You're just
surveyors.
moving the goalposts.
No,
You're
no,
moving the
no.
You
That's
said
just a,
he
no.
said measure. Indio. He also said measure, not account for. Slightly different.
Yeah, yeah. So Unity, you said professional surveyors. That would be a human being, not Google. So show us the professional surveyors saying that.
Yeah. Professional surveyors.
Yeah,
account
an
for
actual
curvature.
one, not
And
the
indeed,
abstract concept. No, an actual one. An actual
you
one
guys seem
saying it.
really,
An actual one,
out of
Unity.
control
Why
here.
are you
Can you guys
deflecting?
just like
Why
calm
are you
down?
deflecting? Why are you deflecting from you not being able to?
There's no deflecting. You're just like getting a little rowdy. Just calm down. I don't know why you're so like hurt.
Well, you didn't answer my first question. What's the reference ellipsoid for if they measure curvature?
I did answer. What was my answer?
You said you're an idiot and you don't know anything about this subject.
What? I didn't say those words. I said I don't know because I'm not sure how those terms are used.
You know what a reference ellipsoid is?
And then you said, all I know is I've heard surveyors say.
Hello. What did I literally just tell you?
Surveyors also say that they use. Hold on. Surveyors also say they use a reference ellipsoid.
What did I literally just tell you?
Yeah, but that's what they also say. They also say that they use a reference ellipsoid.
What did I literally just tell you?
Who cares?
You're reading shit off Wikipedia or something. We don't give a fuck. We want an actual quotation from. Yeah, we're just going to talk for a minute. No, you're not. Unity. I don't know if you can get this through your thick little skull, but the debate bro tactics don't work in here. If you're going to put data forward, put it forward. And he thinks he's funny. You're a child.
No.
If you want to go do the debate bro thing, fuck off to politics and do it. No one's going to stop you, mate.
So,
seriously.
Unity, let me get this straight. We're supposed to have a conversation with you when you don't know anything about it. Say somebody says such a thing, you don't know who said it and can't quote a particular person.
Yeah, I don't think needing to quote a particular person is some sort of reasonable standard because there are a multitude of things.
You said you've heard them say it.
Calm down. I just started speaking. Why are you cutting me off? Calm down. Calm down.
Because I'm correcting you because that's not what you said. Now you're changing the story. The story was that you've personally heard them say it.
When did I say it was personal? You're just putting words in my mouth.
Yeah, you did.
That's the best you've got.
Right at the start.
You know you can rewind the live stream and just hear yourself say it.
Do you have that on recording? I'll give you $200
do.
if you have a recording of me saying that. You want to make a bet?
Yeah.
You want to make a bet?
Let me just find the recording.
So that is that I said I've personally heard surveyors say that. And if you're wrong, you owe me $200. If you're a man, take that bet. If you're a little bitch, dodge it. Go ahead.
I'm just going to go.
Yeah, you're a little bitch. I knew you were a little bitch. You're submissive and weak. You have no testosterone. You're not a real man.
Oh, I know who this is. Just get rid of him. I know.
Which clown shoes is it?
Yeah. Are you the faggot that's always in my DMs? Unity? Are you that little faggot that's always in my DMs?
Are you dodging the bet?
India?
Are you dodging the bet? Oh, he's
no,
dodging
let me find
the bet.
out what your name.
Even your
I want to find out what your name is.
That's so weak, bro.
Dodging
Holy
what
shit.
bet?
The bet that I said that I personally heard a surveyor say that.
I said, so you get to make the terms of the bet that I bet? I don't think so.
No, you made a claim, and I said, "Are you willing to put your money where your mouth is, retard?"
First of all,
no, you didn't use those words.
Micro penis haver.
First of all,
you're so weak and
wrong.
submissive.
First of all, you're wrong. I didn't say it. T-Dub said it. So you want to correct yourself?
Whichever one of you said it.
That was just whoever. You want to bet on it?
Well,
you bet on it?
So you think that your friend is wrong when he says that?
Wait,
so your friend is wrong? So is your friend wrong, yes or no?
No, bet me $200. I didn't say that. You're a little testosterone-less bitch. Yeah, see how that works, you stupid fuck?
Is your friend wrong, yes or no? Is your friend wrong?
Yeah, I just played the same game you did on you because you're so weak.
Now, Unity, just so you know, if you can read the side chat, we know you can write in it, so obviously you can read it too. Just above what you just posted by Yaga Bruno. heard them say it implies you've personally heard that. So you failed. Not anyone else. Please try harder.
Yeah, when you say you hear, that means you heard with your fucking ears. You didn't say I read. You didn't say someone told me. You said I heard them say it, right? Correct? Did you hear him say it or not, Unity? Yes or no? Yes or no?
Yeah, Princess, that's you.
Yeah, back to the drawing board, Unity. You in your DMs? Circle jerking your girlfriend?
Finally uncucked. Yeah, so if you're thinking that what was meant is that I heard a surveyor say that in person, how would I even share a quote with you about that?
How else would you have heard it?
You know that if I hear something, that's audible sounds going into my ears. Do you understand that that's distinct from writing that you could extract from the internet from me? How did you get a quote from me?
Yeah,
how do you get a quote from me?
Who did you hear it from?
That's irrelevant. I probably heard it on some YouTube videos, heard people talk about it in like documentaries.
Shut up, dude. Get the fuck out of here.
Could have been in my fucking.
Get the fuck out of here, bitch. Yeah, keep coming back. I'll just keep doing it.
All right, so I'll admit he didn't actually say he's heard them say it. What he said was, I don't know. All I know is that surveyors say they measure the curvature. I can clip it if you want, but that's what he said. So he didn't actually say he's heard them say it. He says, all I know is that surveyors say that they measure curvature.
He doesn't know what they say. He doesn't know anything. He's a bullshit artist. And your bullshit
He's probably
doesn't
heard
come
one
out a good
YouTube
picture.
video. He's probably heard one YouTube video with McToon and Jesse Path of Lies.
And you know who
Jesse
doesn't
Pat-
account for curvature?
Yeah, Jesse Pat the Light is not a surveyor, by the way. Unity, Jesse Pat the Light's not a surveyor, but that's who you got it from. Neither is McToon.
Why do you keep talking about this Jesse Light person? What the fuck? Anyways.
Because most of you little cockstrokers coming here talking about it.
What that is. Anyways, so now that we're
Nobody
clear
claims
on
they
how you
measure
don't know how
curvature.
quotes work, right? If you want me to find a quote, I'm happy to do that. But I want you to think
Well,
of
you
this
should already
analogy.
have it.
Suppose that
Well, you
someone
should already
says-
have it.
Suppose that someone says, but Christians say that sex before marriage is bad.
Great analogy.
Now,
Get back to your curvature.
ask them
don't
for
give a shit.
If you ask them,
Dude, I'm gonna just fucking ban you, bro. Why the fuck can't you stay on topic?
What's going on?
Not much. What are you up to?
What I'm up to?
Yeah, what are you up to? Yeah. What are you doing? What brings you here? Eating. What we having tonight? Anything good?
I'm eating cheese.
Cheese pizza? Or just cheese, dude? You poor? You just eating down on a block of cheese?
Not just cheese.
Just cheese. Goat cheese?
No, it's like do you know like Turkish cheese?
String cheese.
Turkish cheese? No. That shit's good though. Is it good?
If we said Earth is cheese.
The moon is cheese. Turkish cheese, man. I want to check that out.
Yeah.
So are you from Turkey? Is that why you're eating Turkish cheese?
No, I'm not from Turkey. But Turkish cheese is the one with too many holes, like you.
I thought that was Swiss cheese. Oh, there's more holes or something? Huh. Why are you eating only cheese, man?
Is that funny?
So you're eating only cheese? Oh,
That has more holes than you.
There's more holes? Wow. So if the earth is a ball, how can there be cheese? Can't be no ball, no cheese on a baller.
Yo, what's up, Shadow?
My friend just came.
Oh, he's here?
Yeah, you can talk to him. His name is 3BT ULRA7MAN.
Yep, 3B dollar. 7 man.
$3 Yeah. Now talk to him. He said to me that Earth is flat, and he saw it. He has the proof.
He saw it? You saw it too. Everybody's seen it. What are you talking about? Everybody has seen a flat Earth. Everybody.
I saw nothing. Don't say
so you're
everybody.
blind? So you're blind? How did you find your cheese if you're blind?
What? I didn't say anything about Earth being flat. He just told me.
That doesn't matter whether you think it is or not. You did see a flat Earth. There's no doubt about that.
No, he just told me that Earth is flat, but I didn't say anything about that. What I can see is Earth being flat, but my eyes can't see is what Earth is being flat, not because my eyes is limited vision.
Chad, what are you trying to say?
He doesn't know.
I don't know.
He doesn't like the idea that he saw a flat Earth. He wants to just imagine that he saw a ball, but that's all he can do is imagine.
Just you need to tell me if Earth is flat or not flat. I don't know. Most of you gonna have a conversation. Okay, it's your opinion, but my friend think it's not flat. Now you can have a conversation to tell me.
Okay,
and
it's not. But you're wrong. It's not an opinion. An opinion is red's my favorite color. That's an opinion. The Earth is flat. Okay. That's objectively true. It's not an opinion.
Okay. Give us your proof.
The ocean.
The ocean. What is about the ocean?
Okay.
What is about the ocean?
Hold on. You asked me a question. Is most of the surface of the Earth ocean water? The surface of the Earth. Ocean. Okay. So whatever the ocean does, that's what the Earth does, right? So hold on. Why you interrupt me? Whatever the ocean does, that's what the Earth does, right? So if the ocean curves, then the Earth's a ball. If the ocean's flat, then the Earth is not a ball.
Okay, let me.
Okay, so the ocean's flat, bro. We know. We measured it. It looks flat. It measures flat. We use it as flat.
Okay, ocean is flat in human perspective. What your eye can see is ocean being flat, but the whole ocean, what your eye can see, is curved.
How?
Because Earth is so massive. Ocean is so massive.
Yeah, it can be so massive, but it can be massive and flat. So why do you think it's curving?
Why do I think it's curved?
Yeah. Why do you think the ocean water curves? Why do you think it curves into a ball?
Because you saw it on the TV.
Yeah, because I saw it in the TV. TV told me.
Okay, there we go. Yeah. So you went outside, you looked out, you saw the ocean, it looked flat, and you're like, nope, go back inside, watch TV.
Bro, let me tell you.
Yeah, that's the situation. You can't get out of it. That's the way it is. You can believe in the TV. I don't care.
I'm not about the TV. I was making fun of you, idiot.
No, you look. You have never listen. You've never seen curving water. You've never seen a curving ocean. You haven't. That's true. That's why I said you saw a flat Earth. Everybody's seen a flat Earth since the time began.
Look at the moon and the sun. They are totally.
Are they there? So notice how you had to say, "Oh, look at the Earth over here." You said, "Look at something that's not the Earth." The sun and the moon. Why should we look at the sun? Why would we look at the sun and the moon to tell what the Earth is?
Because I'm gonna relate everything together. Because
why you didn't answer my question?
Objectives.
Why would we look at the sun and the moon to know what the Earth is?
Because Earth make gravity with moon because they are objects.
Okay.
Bro,
there's no reason to think that the Earth is like the sun and the moon. Okay?
It is like them.
How do you know they're the same?
Because it is among them. So it should be like them.
What do you mean among them?
It follows the rule. It follows the rules. So it should be like them. The gravity rules, the physics rules.
What about other planets?
That's what he just said. Other planets. Other than what? Other than Earth?
Yes.
Okay.
I want to know if Earth is flat, then how the satellites and space station and everything are there in outer space?
Okay, one question at a time. Okay. For the second guy, I mean, Earth isn't a planet. Okay. So there are no other planets. There are planets, but not planets other than Earth because Earth isn't a planet. Now the other guy, what did you say? TV station?
Yeah. So what I said is that the space station and the satellites, those are roaming around the Earth. So how they are doing it if the Earth is flat?
Okay. How do you know there's satellites and ISS roaming around the Earth?
If you use telescope and at particular time at the night at the sky, so you can see good enough with clarity that something in the sky is rotating, and which is some shape. And
fine. Yeah, but you don't know how high they are. You don't know how big they are. You don't know what they are, right? So let me tell you a story. So about 6 months ago, some astronomers published in a journal, they went back and looked at photographs, telescope photographs from 1947 to 1957, okay? Before satellites. Right? You understand before satellites were ever launched?
Okay.
Yeah, they found satellites before satellites. I'm not making this up. This was published in an astronomical journal. Professional astronomers went back and looked at old photographic plates from telescopes and found objects that looked like they were orbiting the Earth, even though that's impossible because there was no such thing as rockets. There's no such thing as satellites. The point is, from the Earth, you can see all sorts of stuff in the sky, and somebody can tell you any story about them. You have no way to confirm it.
So the thing is, why Earth is round? So if you want to put some mass or put let's say area, the circle has the least area, sphere has the least volume. So everything which is attracting, like why Earth is a sphere shape, because the gravitational force pulls everything to make it the volume of that subject or that matter, whatever it is, in the shape of a sphere, so that its volume is very less as compared to square, rectangle, polygon, or whatever may say.
I understand. So ninth grade. Yeah, I understand. But that right there, what you just said, that's a hypothesis. Right?
It's not hypothesis. If you calculate the area, if you calculate the area, how times measure?
I understand that part. Hold on. You said two parts. The mathematical part you said and geometric part you said was correct. The part about there being gravity that pulls it into that is a hypothesis. So you mix two things. You mix math with physics. Now, the physics part, if your theory is, hey, there's a force, it's going to pull everything into a ball. Okay, that's your hypothesis. Well, you're going to have to go out into the natural world and actually measure that the Earth is a ball, right? To prove your hypothesis?
Okay, and so what about the videos that we see from this
you better stay past that one. So has anybody actually measured the Earth as a ball to prove that hypothesis, buddy? That gravity forms things into balls.
Yeah, so that is everyone proved. Like in laboratory they can easily prove that they can.
Really? They can do gravity. They can do gravity in the laboratory and form balls.
They won't take the gravity part because gravity is like we are not supposed to develop anything.
That's the hypothesis.
But they try to oscillate the object in a high speed so that its gravity is going to get less, then how the density of the matter is going to change. So that kind of indirect study you can do. Directly gravity you can't study it, but indirectly you can replicate some of these things to study those behaviors. That's
a lot of nothing. You just told me a lot of nothing, dude. Science is empirical, right? It's based upon empirical evidence. So if you have a theory or hypothesis, you have to go out into the natural world and demonstrate it. So if your hypothesis is gravity forms everything into a ball, you need A, an observation of that happening, or B, something or doing it in a lab. Which one do you have? Neither.
Okay, so
you have to confirm your hypothesis. Right?
So if I can't prove the hypothesis, then the other thing is correct. Is it the way to say? Like if I can't prove A, then the B is correct? If I can't prove A, then B is correct? Or B is also not correct?
We know B is correct because, we know B. The way to prove what you're saying is correct, or at least indicate it's correct, or give evidence that it's correct, is to actually measure the surface of the Earth and show that it's curving, right? If the surface of the Earth was curving, then you could say it's a ball, but it's not curving, so it's not a ball. It can't be a ball. And how do we know the surface of the Earth isn't curving? Because we can measure, right? You can shine a laser, and if the Earth is a ball, then the laser will get higher and higher and higher, right? With distance.
So that is the thing people are doing. So what is
we've done this, and it doesn't get higher and higher and higher. We've done this.
So how far you went, like to measure that? Because if you measure this, so 40 kilometers may not be the curvature of the Earth, because Earth is a diameter is around how much?
Yeah, that's great.
But 12,000 kilometers. So in order to get a curvature, you need to go like quite a far enough distance. Obviously I need to do the math, but obviously 40 kilometers is not good enough.
And that's why I'm telling you 40 kilometers is enough, because the drop in 40 kilometers is supposed to be 127 meters. So if I start at a laser, right, on one side I'm 2 meters, I shine the laser across water, 40 kilometers. At the other side, 40 kilometers away, the laser should be 127 meters off the water. But we've done this, and it was the same height. From 2
So you are
meters,
measuring
40 kilometers, 1.5 meters at the other side. Not 127 meters, 1.5.
So you are doing it in the water, in the ocean.
In the air, dude. Well, no, this was done at a lake.
So you know the Earth has different elevation. If you go to, let's say, California, it is a different elevation.
On a lake. A lake.
So
water.
So a lake is because but the lake has also how lake flows. It's because of the Earth elevation. It's coming from top to down. That's why the water flows. If that is not there, the water won't going to flow. It will be a pond.
Hold on. This lake is an inland lake. It was created when it's called Lake IJsselmeer. It's in the Netherlands. It was created. It's man-made. They cut it off from the sea. It doesn't have a water source. There's no water flow into it. So that don't work.
So it's a pond. So it's a pond.
No, it's
so
a
it's not a
giant lake that they cut. It was like a what they call a fjord, and then they dammed it up, right? So they just cut it off from the ocean.
So water stay there, or it flows, or there's no way.
Flow.
It's like.
There's nowhere for it to flow to.
And how big? The lake is 40 kilometers? That big lake?
Well, it's bigger than that. It's freaking probably like the full size of it's probably like 100 kilometers. But they did their beam was they did 19 kilometers, 12 kilometers, 47 kilometers, or 40 kilometers, 41 kilometers, and I think 12 kilometers. They did 5 different trials.
Yeah, so the thing is, you need to have some sufficient horizontal distance in order to get the Earth curvature, because diameter of the Earth is
I just told you what it was.
That makes sense.
Do you think I can know the difference between 1.5 meters and 127 meters?
Yeah, that's true. And the second thing is the elevation of the water or the ground. That also varies when you move from 1 meter. That is from. If you travel like 1 meter, also your ground is going to elevate.
Don't you think accounted for all this, dude? You're being a dunce, okay? The laser was 1.5 meters off the water. At the other side, the laser was detected 1.5 meters off the water.
Okay, maybe you have done the experiment. So I need to believe.
Water. Water doesn't have different elevations unless it's a freaking waterfall. It wasn't a waterfall. It was a lake. This isn't the only one. There's Salt Lake. There's Great Salt Lake. That's 21-mile laser shot there. You don't understand. Like, you think the Earth is supposed to curve, so you guys all say this. Earth is so big, you can't measure the curve. But if you do the math, it should be easily measurable. So I'll give you for instance.
I'm just difficult to find a 40 kilometer.
In 15 kilometers, bro, in 15 kilometers, the drop because of curvature should be 20 meters.
Yeah, but I'm just thinking 40 kilometer is like a lake,
an exponential
and the water is not flowing. Water is not flowing anywhere. Just 40 kilometer, water is staying somewhere.
Yeah, it's a man-made lake.
Okay, so can you say like what the name of the lake? I can Google it. Like 40 kilometer lake. I also want.
Lake. It's bigger than 40 kilometers. It's Lake IJsselmeer. I'll post the name in the chat. It's a freaking because it's Dutch. They got weird names.
Yeah, definitely. Because if you guys have done the experiment, so yeah, maybe it makes sense something because you might have observed something that we don't know.
I love how you guys always default to we fucked up. We didn't fuck up. This is like the 7th time it was done.
Okay,
you guys have you pretend you're not biased. You're extremely biased, extremely, and you don't realize it. You're extremely biased. I'm giving you information, and you're just popping up every possible reason you can think of on why it's wrong. You have never, ever in your entire life looked at the globe Earth that way and said, holy shit, dude. If the Earth was a globe, how does this work? Or if the Earth was a globe, how does that work? No, it's only, if the Earth was flat, how does that work? You only question flat Earth. You never question the globe.
Actually, physics makes sense when it is globe.
It just makes
when
sense.
it is flat.
No, you just like it. Has nothing to do with
it
making
makes sense.
You just like it.
Yeah. No, it makes sense. That's why. How satellites
I'm sure that's what
get
Plato
orbit.
wrote down.
Yeah.
I'm sure that's what the famous philosophers, Plato, he wrote down, it's a globe, just makes sense.
Yeah, in the sense, physics, science, math, and logic, everything match when Earth is
The globe has no logic. There is no logic to the globe. None.
But yeah, but the experiment, if you have proved something, then obviously that need to be seen because experiment has more weightage than, let's say, logic, philosophy, and other stuff.
Okay.
Yeah.
Experiments determine cause and effect relationships. If you want to know the geometry of something, you just measure it. That's the only way to get that. So if the Earth is flat, or the Earth is a globe, you have to measure the Earth. That's the only way to know one way or the other. And because only one thing separates a sphere from flat, that's whether the surface is curving or not. That's the way we can know if it's curving, could be a ball. If it's flat, can't be curving. It's called a true dichotomy.
Yeah. But okay, it's fine. But one of my cousin is a pilot, and he also says me the same thing. The way he used to fly the aeroplane. Obviously, you can say that no one has proved, no one has seen that something and all. But yeah, so basically the thing is.
Are you gonna tell me he sees a curve from his airplane, dude? Is that what you're gonna tell me?
No. The way he told me that he has to take this path, like. He can't go directly so that it doesn't make sense because Earth is curve. We have curvature in the Earth, so we need to follow this path. That's why we are going to this space. So yeah, because you can see down there. So let's say you are traveling from Europe to, let's say, Washington, or means like Seattle. So you need to go to the because the Earth is curved. That's why flight usually say they used to go from the northern part. Then you come to the Seattle, let's say from France to Seattle. So up there you obviously won't able to see down. But if the pilots, like they used to say, if they come down, they can see that the thing that they are crossing the northern pole when they are going from France to, let's say, Washington, that is Seattle. So they are not going straight from the France to Seattle by crossing, let's say, New York or Minnesota or any other
that
United
they're looking down from their plane at the North Pole.
No, I'm not saying the pilots and all, but the fighter jets and other things.
Freaking workshop too.
Okay, it's fine. So the pilot won't able to see that, but the fighter jet, another one, if want to travel, like which aeroplane can travel in a low altitude, and they can easily see around from if we are moving from one location to the next location. How they're which path they are following and what down there.
Look.
So if Earth is a flat, like
I was on an airplane last week. Okay, you can see maybe from an airplane, even though the globe says 140 miles, I think you can see about 150 based upon my estimation. Okay, now 150 miles is nothing. Nothing. You can't tell which way you're going. Planes fly in what's called international and domestic flight corridors. They have transponders, they have waypoints, they have a route which they're supposed to fly. If you're talking about the way the route is projected on, say, a Mercator map, that is just an artifact of taking one coordinate system and projecting it into another. So if you have a polar coordinate system, which uses angles, and then you project it into a Mercator map, which uses, rectangles, which is actually a cylinder, you're going to get distortions because you're doing a different projection. but that's not the way the plane is actually flying. I can post right now, I can post a polar projection from pilots inside the cockpit talking about their map, and it shows they're flying in a straight line. But that's just an artifact of the projection. It has nothing to do with which way they're actually flying.
Okay, it's fine. So one is your experiment. Then second one is obviously they are, let's say, going straight flying. And the third one, if I ask,
they don't fly. They don't.
The satellites.
Hold on. Let me clear this up. Planes don't actually fly in what they call great circle routes. That's a myth. Air traffic is highly controlled. Like, say you fly from the Atlantic. Say you fly from New York City to France. You have to fly in a flight corridor. That means there's a narrow corridor that all the planes fly in. So if you're in New York, that corridor is in like Nova Scotia. So you have to fly north to get into it to fly across the Atlantic, even though it's out of your way. If it was a globe, you would just fly across the Atlantic and you wouldn't take that route. But they fly wherever the goddamn government tells them to fly.
Fine, because obviously you didn't see that, I didn't see that, so yeah, so there's no proof for us. But those who are dealing with those coordinates or those who are flying, let's say at low level, if those guys have see those things, so they might have.
What are they going to see? What do you think they're seeing?
I mean, yeah, they can see like the route they are following, and in the if the art is flat, so they are the route supposed to follow.
Airplane. You really need to get an airplane. You can't see what route you're following, bro.
No. What I'm saying is commercial flight is obviously is difficult. Like they are going, if I remember, 30,000 feet or something. So you can't see the city that you are crossing on. But the thing is, if you are going for, let's say, the fighter plane or other thing, those who can fly in very low altitude and they can see even the earth or the surface, what are the location they are flying on. So I'm saying in that regard, but obviously I didn't talk to any, let's say, Air Force guy which is using a flight like the fighter planes, and he's observing the path and the ground. So obviously I'm not saying that because I don't have a proof as of now. But yeah, no one has said the same thing that the fighter guys, that yeah, if we are moving from one location to the next location, we are following the straight path, not the curved path, and or something like that. So it's the fact that we know is that the aeroplane or the flight generally follow the curved path because of the curvature of the earth. So yeah, so that is what I'm trying to say. But obviously I don't have the proof
I understand what you're trying to say, but it's not a curved path. It only looks that way in a certain projection. So if you show the flight path like on a Mercator map, that path will look curved because it's because the plane is flying in the latitude longitude coordinate system, but the Mercator map is not. It has latitude and longitude coordinates, but they're distorted. So when you take one mapping and you mash it onto another, the line will look curved. But if like you paste it on a physical globe, it would look like a straight line, right? So why does it look like a curved line? Because it's a projection. It's a map projection, but it's a map projection onto a different map projection. So it just looks like that. That's not the way the plane's actually flying.
And that makes sense. And one more thing,
brother, the map is not the territory. Okay, the map is just the map. It's not the territory. That's
yes. But if the flat is a flat, let's say we are staying at the upper part of it, then what about the down? Is there anything else? No. A flat surface is two surface. A flat surface has two.
There's no outer space.
Okay, there is no outer space. And one more thing, why the sun goes down somewhere and it goes up for somewhere? Like sun is like, let's say if you are in US, your sun goes down, but obviously in some country there will be sun is going to go up.
Doesn't go down.
Why it is happening?
It doesn't go down. It just appears that way because things that go off into the distance converge with the horizon. It's called perspective. You ever seen perspective drawing? Everything converges to the vanishing point.
And why it is coming back from the back of side again? Like if it is going east, it is coming from west.
Yeah, because east and west are circles.
If east and west are circles, then
right.
Yeah, then something is moving from east to west.
Circumnavigate and you go east and circumnavigate, you go in a circle and come back to the same spot.
Then all the space program, all the satellite that is happening. So no, just I'm asking. So those are also develop one.
Your mind escapes right back to Fantasyland. That shit's fake, bro. That's it.
Okay.
That's a TV show. Do you understand?
It's fine. It's fine. Yeah. I think I remember. I think there's one movie. I think it's some Third Man or something.
No, the things that they say are not the TV show are still a TV show.
Okay, it's fine. So satellites are not there. Gravity force is also not there. Okay, so what else?
No.
Argument.
So the gravity thing, you have no evidence for the claim that gravity forms things into balls. There's no evidence for that. It's just a claim, right? I said, hey, dude, where's the experiment? We don't have the experiment. It's just bullshit. Till you got the experiment, I can't take it seriously. No one's ever observed that happening, gravity forming. Nobody in the history of all humanity has
observed the thing is, gravity is, you see, yeah, no. I think you are getting it wrong there. Gravity is a force.
Oh,
so,
God.
So people have observed that if you can use magnetic force and any force,
you can the apply story. Bro, I understand the story. There's no evidence for the story. Do you understand?
It's fine. So if the argument is that way,
or not?
No, evidence is what? Like everything is working on that principle. So that is the evidence and all.
Oh my God, that's circular logic. That's circular logic.
And a pragmatic fallacy.
Nobody ever calculated anything on Earth to do anything on Earth ever using the universal law of gravitation, ever. Little g, the rate of acceleration of a falling object, that's known empirically. You don't even need a theory of gravity to use that. You don't need a theory of gravity to shoot a cannonball. No, you don't need it. It's because you have little g, 9.8 meters per second squared. Little g. We know that empirically because we can measure that.
Yeah.
You don't need a theory. Mass attracts mass is a theory. Do you understand? That's a hypothesis.
A hypothesis long since abandoned.
Yeah, no doubt.
So, then how the nuclear bomb that has been created? It is also based on that physics and all. Energy is equal to mc squared.
Based upon gravity. Jesus Christ.
So energy. It's not. It's based on energy. It's energy. It's based on energy. Mass. When mass is going to dissolve off, then your energy is going to come equal to mc squared. So.
Oh my.
So obviously it's not about the gravity part, but what I'm saying is every physics is working well. When it comes to gravity and when it comes to, let's say, flat slab, then that is not working well.
We have all or nothing fallacy. That if one part of physics is wrong or right, then all of physics is right. No, there's parts of physics that are incorrect and there's parts that are correct. The universal theory of gravitation is bullshit. They don't even believe it nowadays. They abandoned that for general relativity. That's also bullshit, but it's stacked higher, I guess.
No, in the bullshit you can find it in a natural and physical and natural world.
I mean, I guarantee, but I know this is hard for you to hear, but if I ask you what the definition of mass is, you're not even going to know what it is. But you think it's like you'll say it's a quantity of matter. No, it's not a quantity of matter, not in physics. Mass is a unit of measure. It's the measure of resistance to acceleration. That's a unit of measure. So how can a unit of measure attract a unit of measure? It doesn't even make sense. Gravity's horse shit, bro. Sorry, it's just a bunch of nonsense. And I'm talking about the universal theory of gravitation. We all agree things fall. But whether things fall, how you get to things fall, therefore Earth's a ball, that is not logical. You need to fill in the logical gaps to make that statement. And if you want to say gravity forms things into a ball, you need to measure that ball. You don't just get to say, well, we have a theory. No, you got to go out and measure it. You got to go out and test it in nature. That's how you confirm it. Is that unreasonable? To expect confirmation through experiment?
I need to ask maybe ChatGPT, like if they have done any sort of gravity experiment.
Yeah,
but I have no idea.
But that's not what you need. You need, is there any observation, experiment, nature that showed gravity forming an object into a ball? It's never been observed in nature. The claim is after the fact, right? We look in the sky, we see balls. Now, we don't know how they formed. We have no fucking clue how they got there, how they formed, what they're made of, what they're doing, how fast they're going. We don't observe orbits, actually. If you think about it, has anybody actually seen an orbit? No. From the point of view of Earth, you just see the planets go across the sky and then whip around and go back the other way, and then whip around again and go forward again. That's all we see. We don't see them go around the sun. We don't have that viewpoint.
Then, if we don't see that those
things around the sun.
No. Yeah, that's true. We are not seeing those things. Then we are also not able to see the frequency. Now we are talking to each other from the internet, from the web, and everything. We don't see that. We don't see electricity.
That's great.
Yeah, we don't see air. So everything is now questionable.
Well, we can measure the electricity. We can measure all these things.
So, but these measures are again
based because we're generating it somewhere, someplace. They freaking built magnets and wires and freaking substations and towers, and they freaking flipped the switch and turned them all on. That's how we know the electricity's there. We put it there.
Okay, it's fine then. Do I have anything else to say?
How come you're not doing this to the globe? Why don't you go on ChatGPT and ask all the reasons why it's not a globe?
It's fine. Yeah, it's quite interesting talking to you, and yeah, you have good arguments and good points. But obviously, it's difficult for us to believe. But yeah, you have good points.
I don't know why, because the flat Earth is not about believing something, it's about abandoning a belief. You'd be leaving belief behind. And you guys just don't seem to comprehend this for some reason. I know, I think that's harder to believe that the globe is a belief than actually believing the globe. It's like you guys can't comprehend that you're stuck in a belief system. Okay, we observe the Earth is flat. Nobody has to believe that. The Earth looks flat. Even the scientists say, well, locally, yeah, the Earth is giant and it looks flat. You said it. You said the Earth looks flat. We don't have to believe any of that. We see that. Now, saying it looks flat, but that's because it's a giant ball, that's a belief. Okay? Because you actually don't have the evidence for that to support that. Not from observation. Now, you can conceptually in your mind think, yeah, if I can think of a ball that's so large it would look flat. Well, I can think of a shark that's so large it would look flat. And I can think of a freaking, Roger Rabbit is so large he looks flat, or any other thing. Any large enough thing, if the other thing's small enough that it'll look flat. Great. But that doesn't mean it is that thing. You want to know what looks flat too? Things that are flat look flat. Yeah, things that are flat look flat. Now, I don't have to believe that. That's just true. And, we don't have the belief. The belief is stuck on you guys.
Anyways, Jedi, are you away from your mic?
Is this a chat? What is this channel about?
This channel is about the flat Earth that we all live on. And today we're talking about geometry and science as it pertains to the Earth.
So are all the planets flat?
Well, I don't know. When I get my telescope out and look at the planets, they seem to be circular at very least. So I would say, they are circular in nature. They could also be flat because round and flat are not mutually exclusive. Like you could have a coin or a CD, or a pizza. They're kind of round and flat. So those two things are not mutually exclusive. Do you mean spherical?
Well, you know what I mean. I'm not going into the terms because I don't know the terms, but yeah, like round, like everyone else believes, and flat. That's
like a ball.
Yeah.
Yeah, like a ball. Yeah, no, I have no idea whether or not the planets, that being the wandering stars above our heads, I cannot determine one way or another if they are spheres. The Earth, though, is objectively flat and stationary.
And why they say that it is otherwise?
I don't know. I could make some speculations, but I ultimately don't know their motives. I don't like to try and read people's minds.
What would be those speculations?
Well, like I said, I don't like to speculate, especially in this channel. We're only trying to talk about what is objectively true, what we can measure, what we can test, especially empirically, dealing with the physical realm around us. So in this case, we measure the Earth, and when we measure it, it measures to be horizontal, flat along the surface, no curvature consistent with the globe told to us while we were, still in diapers in some cases and through our schooling as children. That entire concept has been debunked by the measurements of the surface.
All right, and does gravity allows you for a flat Earth?
Well, we've also checked the claim about gravity, right? Because then we would supposedly be jumping into physics, right? And that would fall under the category of science in here. So physics, there is no physical mechanism that we can detect or determine that would be anything like what is described as gravity. There is no gravity as far as physics is concerned.
And what keeps us in this flat Earth?
Nothing, as far as I know.
So why I am attached to the ground and not floating?
Why would you be floating?
Why would I not be floating?
Well, that's a burden of proof reversal. That's, I don't want you to ask me a question. If you say we would be floating, I would want to know why we would float.
But then I ask you a question and you ask me a question as an answer. And then I just did what you did to me.
No, you asked me, why are we being held to the surface of the Earth?
Well,
and I said, as far as I can tell, excuse me, sir. You asked me, why are we being, dude, you asked me why we were being held to the surface of the Earth. I said, as far as I know, we're not being held here by any physical force. And you said, well, then why are we not floating? That tells me that you think we should be floating for some reason. Why should we be floating?
Why we should not be floating? I mean, what keeps us attached to the ground? Why does a table doesn't, why I'm not connected to a table the same way?
Let me ask you a question. I can tell you that there are certain times on the Earth when I do float. You want to know when that is?
Yeah.
When I go into a different medium, let's say water. I float when I'm in water.
You float when you're in water?
Yeah. Don't you float when you're in water? You ever been swimming?
Yeah, but what do you mean by that?
I mean that I can float in water and I am not being pulled to the surface of Earth. That would be the ground beneath me. I float at the surface.
Well, the density of your body is not that strong to pull you to the ground, so the water just push you out.
I don't know that the water pushes me at all. I just know that I do float in water.
Well, if you didn't have air in your lungs, you would just sink in the bottom of the sea.
Right. And as you described earlier, depending on my density compared to the density of the medium that I'm in, I may go up or I may go down. And yet everything that you and I have both described right now, gravity is no part of it.
How is not? You haven't explained why I just don't fly and I'm just attached to the ground.
Whoa. Why would you fly?
Well, why would I not fly? What does it keeps me to the ground? Well, this is what I'm saying. What
Nothing's keeping you to the ground. As far as a physical force or anything like that, there is nothing keeping us to the ground. There is no sentient being or force that we can detect called gravity that is holding us to the surface of Earth.
But you have to explain when I jump why I get back to the ground.
Oh, well, then you've instantly created potential energy. See, when you're standing on the surface of Earth, you're at rest. So there is essentially no transfer of energy. Now, when you jump, right now there's energy input into the system. Your muscles contract, you burn a few calories. Now you move from your state of rest and go up into the air. Now you have potential energy. And since you're in the medium of air, you're going to return to the Earth. But if you jump into a pool, why? Because the air cannot support you.
How to explain why?
Brother, I'm telling you, can you let me explain? The air cannot support you, but the water can.
The water, I told you, the water can't support you if you don't have air in your lungs.
Right. Well, how about a piece of wood?
The piece of wood probably have air inside. It should be solid.
Exactly. So it is a relative density relationship, isn't it? If the object is less dense than the medium that it's in, it will have an upward vector. If the object is more dense than the medium it's in, like you and I or a piece of wood in air, it will go downward. So you have two different vectors, and the only thing that we can describe is that there is a relationship between the density of the object and the density of the medium, and that basically determines whether or not something will go up or down. And no gravity is involved whatsoever.
If you remove the air, I will still go down. I mean, we have vacuums in the air.
Yes, I know.
Let's use a rubber ball. How about a rubber ball? A solid rubber ball.
What?
A solid rubber ball. It's not going to go down, is it? It's got no air in it.
What is a solid rubber ball? I don't know.
Like a bouncy ball? Like the bouncy balls you get when you're a kid out of the little machines?
Right? Yeah, so what? Yeah.
Yeah, so it doesn't have any air in it. So you can't use that as your excuse now.
I don't understand what you're saying.
Seizu's explained it to you perfectly, right? And you're just using the remove the air. You're saying remove the air, and it will go down.
Well,
but no, it's not.
I'm saying remove the air because it's not the air, guys. It's not the air the point.
We are not saying that the air is anything. We're saying that the air is a medium, right? And so the medium determines what happens with the object within it. So if you go, let's say, in air, the wood block goes down. If we take most of the air out of, let's say, a vacuum chamber, the wood block goes down. If we change the medium again and fill the chamber with water, the block goes up. So it's always dependent on the relative density between the medium and the object. There is no gravity. There is no force of gravity. No one has ever proven a force of gravity. It is just a concept. And currently, it is only a mathematical concept, meaning it's not even a physical proposition.
Well, I understand what you mean, but then there is something that pulls object, like even me as a body has some sort of attraction to the other entities, but it's so small that I can't really attract them. And then that we call gravity. I understand that we haven't like defined it, but then there is something that's called gravity. This is what I mean.
I don't want you to ramble and make many claims. I want you to, friend, don't make claims. In this case, we're talking about science and physics, right? So what I would like for you to do, instead of making the claim over and over again, is to prove to me the mechanism by which you go downwards. How are you going to prove that?
Well, I told you, like everybody, like when it is has a high mass and has some sort of attraction, like this attraction, I think we call it gravity. I'm not a physicist, but this is what I've learned.
Yes.
So even a small body, if I were very, very, very tiny small, then I would attract something else. And this
That's
is
not
what
true. I'll tell you why we know that. That's not true because gas, right? The molecules of gas, the small particles that we call gas, the stuff that we breathe, moves freely and randomly in all directions. It is not attracted to anything.
Well, this is quite different because when you have tiny masses, I guess a gas will have a tiny mass. Then I don't know what happens there. Like, I mean, I'm not a physicist. Maybe this is something that, like, probably is not. The force is so small that it can't really get, pulled or attracted to anything.
Right. Now you're saying probably. So actually, you're telling me that you don't even know if this has been proven. Believe me, we've checked. There is no evidence or proof of any kind of force that is determining someone's vector up or down in the realm that we live in. And the reason that we know that is because gas is omnidirectional as far as its vectors are concerned. It moves freely and randomly in all directions. It is not attracted to the ground. It is not forced to the ground. Gas debunks the idea of gravity completely.
I ask something. Why is Earth attached, or like why it is like I don't know what flat Earth people believe, but like, is the Earth or the Sun the center of the system of the how's it called, the system? Yeah.
Oh, I have no idea. To say the center means that it'd be the focal point, or that's kind of a weird question. When you say center, what do you mean?
I mean, does the Earth moves around the Sun or the Sun around the Earth?
Well, what we observe is that the Sun moves across the sky along with all the other celestial bodies from east to west. So it seems that the celestial bodies move, although I'm not sure that I could consider the Earth to be a center point.
It's not the center point. So, but is the one like is Sun moving around the Earth or the Earth moving around the Sun, or you haven't defined that?
Well, the observations show us that the Sun transits the sky in a east to west direction. And of course, in the extreme north and the extreme south, it seems that you can see the Sun do circles. But that still wouldn't necessarily tell us that the Earth is the center of anything.
Who did these observations?
Many people over the last, since, the beginning of mankind. The sun has come up in the east and set in the west for everybody. And in the extreme north, and apparently now the extreme south, the sun does circles in the sky.
Are they scientists or are just experimental?
Well, what would it matter? That's what we observe. The scientist is going to observe the same thing that I observe. They just have a PhD attached to their name.
Well, isn't that important? I mean, I'm not...
Not really.
How is not? I mean, I can easily make wrong assumptions or like wrong calculations if I'm not expert to the field.
No.
I'm not saying...
No, you can't make assumptions and you can't make calculations. You can only make observations. The scientists and I both have eyes. We both see the same thing. And if we're going to be empirical about what we observe, then we will attempt to prove the cause for what we see. But him and I both have the same problem. We don't have access to the sun, moon, or stars. So we don't really have a great way to prove one way or another how or why they're doing what they're doing.
The bodies. And what do you think about the rest of the world, the rest of the people that believe that, this is why they move, this is why the Earth is round, and all the occasions that, like, they can prove that a comet after 30 years will come back at some point in the future.
What do I think about them? I think they're well, number one, if they're observing the same thing that I'm observing, but they have a different conclusion, I want to know why they're getting to the conclusion that they have. So far, all I can figure out is that they are under a delusion that they live on a ball, and then they make all of their assumptions and calculations like you just described to me based on that assumption that they live on a ball. And so they've created a mathematical realm where Earth is a ball and the sun, moon, and stars are all planets, and we orbit, and yada, yada, yada. You know the solar system story, along with the rest of the universe. Hold on, bro, I'm not done. So all of their assumptions are based on their delusion, when in reality the Earth is measurably flat. So their assumptions are false from the beginning.
But then the language of the universe is mathematics, and there should be only one truth. And if they
I agree. So if we measure the Earth, hold on, bro. I agree with you completely. So if we measure the Earth and it is flat and there is no curvature, then math, being the language of the universe that you discussed, is telling us that we live on a flat Earth, right?
I think they have already done that. We have already.
Okay, so
we have sent.
Oh, great. So that's fine. So can you go ahead and get me the Earth curve measurements on the surface to prove that we have roughly 8 inches per mile squared of drop over distance everywhere across the surface of Earth? Can you get me those measurements?
I told you. Well, see, I need a team of scientists. I can't do it myself.
Why? No. I'm saying somebody at some point has measured the surface of the Earth, right? So you don't have to do it yourself. You can find out how somebody measured it, and if they did something that is easily replicatable, we can all go do it and check. But so far, we have not seen any measurements of the surface of Earth showing that it curves.
Well, what about all the photos? I don't agree with what you said just now, but I'm just saying.
Oh, you don't agree that somebody has measured the Earth curve? I agree. Nobody has measured the Earth curve. Now, the photos and the videos that you're appealing to, if they're showing an Earth that is curving, then we should be able to measure the surface and see that it's curving, right?
Do you want to Google that? What you just said? Just ask Google or ask an AI agent. And
why would I do that? Why would I not measure the surface of the Earth? Why would I ask Google to tell me what's true when I have the Earth underneath my feet and I can go measure it?
When you buy stuff from a supermarket, do you ask why there is a milk or who? Like, do you just buy the milk, right? You just
That's non sequitur. That's a complete red herring, and it's not even analogous to what we're discussing. You stand on the surface of the Earth, do you not?
Do you step on giant salters? So this is how science works, doesn't it?
No, it's not how science works. That's how someone told you that science works and you believe them. But in reality, you have access to the Earth and you also have access to the technology. Excuse me. You have access to the technology to measure the surface of the Earth. You do. Why haven't you done it?
I'm telling you right now that if you Google that, if the curvature of the Earth is measured, there is 100% chance.
Okay.
100%.
100% chance. Okay. I'm gonna give this challenge to you. You say there is 100% chance, meaning there is an absolute certainty that if you Google who has measured the surface of the Earth to be curving, that you will find that somebody has done that. I'm going to challenge you to do that. Not calculate, not assume, but measure. So I want you to get me the measurements of the surface of the Earth, who did it, how they did it, and how can we replicate it to check and see if it's accurate. I want you to do that.
No, I'm the challenger. You have to do that.
No, brother, I've already done it. That's the problem. All of us here have already Googled what you're asking us to Google, and it's not there. But if you are so confident, and this is your positive claim that there's 100% certainty that I'm going to find this information, I want you to do it.
No, I'm the challenger. I know. I've already.
No, this is not about challenging. This is about you making a positive claim. You have made a positive claim that if you Google who has measured the surface of the Earth with 100% certainty, we will be getting an answer. I want to see the answer. I want to see the method. You do it.
No, you do it because I believe that. You are the one who doesn't believe.
I don't care if you believe it. I want you to prove your claim.
But I want you to prove your claim.
I already did.
You haven't. You're just a person who talks. I don't even know.
All right, no problem. Do you want measurements of the surface of the Earth? Do you want me to get you some survey data? The people that measure the surface of the Earth every day, do you want their measurements?
Well, scientific proof, not just, me and you, or I don't know if
this is not as okay. So the event for the day, we're talking about science and technology. Measuring things is not science. That would be mathematics. Okay, so this is not a scientific topic that you are currently discussing with me. This is about measurements. Okay. So we're not going to be trying to figure out the cause of an effect like we would do if we were using science, right? This is not science. This is geometry.
Well, isn't geometry part of the science? And also, I think that
That would be a composition fallacy. Even if we did use geometry within science, that is the parts of the parts do not make up the whole. So that's a composition fallacy. Science and geometry are two totally different things. In this case, we are dealing with geometry only.
I believe that a scientist, and this is true, can use geometry in his observations.
Yeah, I already covered that, bro. You're repeating yourself, and I don't care about what you believe. I want to see what you can prove.
Well, you can't prove anything of this, so you are talking like
Sure, I can. What do you want me to prove? How about this? I'll give you some proof. You ready?
Yeah.
And we'll see if you agree. Would you agree that water is level on its surface when it is at rest?
Water is what?
Level.
What's that? I don't know.
Okay, so level, if you haven't come across that word in English yet, it means straight or flat, having no part higher or lower than another. Like if you were going to build something, you would use a level, right?
Okay, so water is what at level at rest?
Yeah, so the surface of water, like, you know, the glass of water in your cup, is it flat, level, horizontal across its surface?
In my cup?
Yes.
Yeah.
Yeah, okay. What about in your bathtub? Is the water in your bathtub, is it flat and level across the surface?
It depends on the structure of the bathtub, right?
I'm talking about the surface, man. Are you telling me that somehow the surface of the water in your bathtub is not straight, flat, level, horizontal?
It depends on the incline, you know, but
No, it doesn't.
Well, how if it is a little bit, you know, it's not the same height or
the surface of the water.
Well, if
Hey, brother, real quick, brother. If you take a tray that you make food in and you fill it with water and you turn it diagonally, what happens to the water?
Goes down.
It runs out. So there's no such thing as sloped water, brother. Water's flat on the surface, homie.
Well, I'm sure if you zoom and you go to quantum level, you won't really have this observation. But yeah, me as a human, because I'm a human and I have an eye, I'm not like a robot. I'm sure I can see it as a flat.
Yeah, you can, because that's how you see it. It's how it's observed and measured. Water is horizontal, level, flat upon the surface. We don't need to talk about the quantum level. That's irrelevant.
How is it relevant?
Right, because we're talking about the surface of water over distances of tens, hundreds, thousands of miles.
Well,
it's not on the quantum level.
What are you like? How are you checking this surface? Are you checking with your eye, or are you checking with a microscope? How is it called?
We're checking with optics. The human eye. You asked a question. We're checking with optics. The human eye, telescopes, and then we measure and survey with surveying tools like lasers and theodolites. We survey the land with surveying tools. Why are you speaking through me?
I don't know where.
In the side chat, my friend, being as you decided to speak through me, you might as well read what I've posted with regards to water being level upon the surface. You noticed our citation from such places as physics.info. Now, please read those. I have many more. Sorry, says who, mate? You carry on.
No, you take over. I got to take care of something. Thank you.
No problem. So I've also posted some other citations in the side chat. I'll read them to you. Water will always form a flat surface unless it is acted upon by another force, such as wind. That comes from the National Air and Space Museum. Science in pre-K. Do you want me to read the other ones out to you? You understand, because we're not talking about on the quantum level. We're talking about the surface of water over distances.
I'm sure that if you zoom enough, the surface is not really flat.
If you zoom in enough, we're talking about the surface of the Earth, my friend. We're talking about where it should measure to have curvature because it's a planet, a sphere. We don't measure the curvature where it should be. When we measure the surface of the Earth, we measure the surface of the Earth, primarily water, to be horizontal upon the surface, which is contradictory to the Earth being a sphere. A sphere would have a curvilinear surface. We don't measure that. We measure it to be flat. Now, primarily over water, not on the quantum scale, not if we zoom in with a microscope, over distances that should show curvature.
Okay, don't know what
you notice. You notice this isn't scientific evidence. This is direct measure of a shape. This is geometry. Observation and measurement are required for geometry.
Okay, but have you tested a big enough object to
Yes.
measure?
Yes.
Like a big enough as
Yeah, so I'll give you an example. With the radius that we're told of the Earth of 3,950, we should have a rate of change of slope on the surface, that's curvature, a calculation of approximately 7.98 inches per mile squared. Let's keep the number simple, 8 inches per mile squared. That means over the first mile, there should be 8 inches of descent from point A's horizontal. Over 10 miles, there should be 66 feet of descent from point A's horizontal. 20 miles, 260 odd feet of curvature descent from point A's horizontal. Now we're measuring over those distances, 10, 20, 30, 40, 50 kilometers, where there should be curvature on the Earth according to the claim in the mathematics. But there isn't. When we measure with surveying tools, like I said, primarily with lasers or theodolite, or other light or observation equipment, we measure the surface of the Earth to be horizontal.
All right. And let me ask you, why do you think the rest of the people believe that it is round?
Because just like you got taught this. You didn't question it. We just got told it at school. We turned on the TV. So we all got taught this. The funny thing about being children is it accept the reality of which we are presented. And that's exactly what we did. We were presented with a globe and we didn't question it.
And okay, I agree. But then why?
I don't know, dude. My claim is as far as the surface of the Earth. I can't divinate the motives of individuals or groups that I've never had met.
But wouldn't that be like unreasonable? Like, why would they?
So unreasonable for me to not divine people's motives and intent if I haven't met them. I think that's perfectly reasonable.
I mean, there should be a reason, though. And
yeah, there probably is a reason. I just don't know what it is. I might be able to speculate, but I don't know with 100% certainty. I don't even know who they are. It's not you, right? It's not my school teacher, right?
Fair enough, but we do know some people. We do know some people in the past that posited the idea that the Earth was a globe before they could possibly have known it, and they were religious. They thought that God is perfect. God would create perfection. Therefore, the Earth must be perfect. Therefore, it must either be a ball, because a sphere is the perfect shape, or a testicle, because a testicle is, the embodiment of divine creation, or an egg, which is also like divine creation or life. So it had to be in the shape of a ball, either an egg, a sphere, or a testicle. Yeah, that's what they thought. So we know why they thought it. And there's other people that are in record saying why they thought it, right? So we know at least why they did. Kind of like a tradition, People start thinking about something. They start telling other people, hey, this is the reasons. And you're like, oh, those reasons sound pretty good. I'm going to agree with you. And then eventually enough people are like that till they say, hey, we're going to make an education system and force our kids to learn what we all agree on. And so then all our kids are just going to believe it. There you go. That's how it happened, brother.
Guys, I have a question for you who believe that the Earth is flat. How would you describe the sun movement?
Pardon? Can you say that again, please?
How would we
How would
describe
it's
the sun
described?
movement?
Well, it can be described depending on your perspective, right? So mathematically, it's described as an arced path, but there's no way to prove that it would be an actual arc.
From east to west. That's how I would describe the sun's path. Comes from the east in the morning and goes towards the west in the evening.
And what about the south and the north?
What about them?
Why you say it moves only in two directions?
Because that's how these things are kind of defined, right? East is defined as where the sun rises. West is defined as where it sets. You asked us how we describe the sun's motion, and it's as simple as that. Now you're asking about north and south. North and south are absolute directions, let's say. North, right? Now, east and west would be circles, I think, around those poles. So not absolute directions, just directions of travel.
Or are you asking about in? Oh,
no, you can go ahead. You're good. Don't worry.
Are you asking about the relative difference in the direction of the sun, whether you're in the north or the south?
Yeah, that's right.
Yeah, well, those are relative directions based on your location, but objectively, the sun goes from east to west.
I don't understand how that works on a flat Earth model, I guess.
Well, there really is no model, but it doesn't really matter what a model would say. Everybody observes the sun to go from east to west.
Well, I guess what I'm saying is it doesn't seem to be something that's possible if the Earth is a disk, right?
No one said that the Earth was a disk.
Well, you know what I mean, overall, generally flat and not a round sphere, you know? So
right, so you have a flat surface, and the sun goes from east to west on that surface.
Do you mean it spins around the flat surface? I don't understand what that means.
Nope, I didn't say that either.
Can you clarify? I'm misunderstanding.
The sun goes from east to west over our heads on the Earth.
Back
as observed. Nope, didn't say that.
Okay, I'm trying to make you give it if you could do an illustration for me. Maybe I'm not.
I'm giving you the observation that we all have. I'm not going to create for you my concept of what the Earth may look like and what the sun might be doing. What we do observe is that the sun goes from east to west for everybody.
Yeah. So I agree with that. Okay. What I'm saying is, if I have a round Earth perspective, obviously. And what I mean by goes from east to west is obviously the Earth spins around, and then we see the sun, quote unquote, travel to east to west, right? But what I'm saying is, I don't really understand how that would work on a flat model. That seems to be not possible to me.
Let's put it this way: it's not necessary to understand how that works. It's what we observe. How it works would be a different question completely, meaning we would have to have some kind of mechanism or an understanding of the system itself and how it operates, how it's powered, what these things are in the sky, like these lights, if they're physical, if they're holographic, all that stuff. We have no idea about any of these things. What we do observe is that the sun goes from east to west over a flat, stationary surface. That's what we can measure. That's what we can observe. The Earth is measurably flat, so the sun is going from east to west on a flat surface.
Sure. Okay. So maybe I'm not being clear, right? So what I'm saying is, presumably speaking, if you have two models, let's say you're trying to choose which one is most coherent, a flat model or a round model. And let's say, yeah, and let's say what you're trying to do is we're making some observation, right? Like the sun goes from east to west. I agree. Presumably speaking, we would agree, right, that to find out which one is more likely,
under this specific thing about the sun's movement, at least, you would see, okay, is it that that one of them is, like, for example, impossible, or you would have to make way more assumptions, right, in order to actually find it be consistent with the model that the sun actually moves from east to west in one.
I agree.
Right? Yeah. So that
I agree. So the easiest way to determine that is to measure the surface of the Earth to see if it's curving or if it's flat. That way we can eliminate one of these concepts. So we've measured the surface of the Earth. It is not curving. Therefore, the concept, or in the way that you described it as a model, that model would be incorrect.
Sure. I guess we can move on to another reason if you want, but what I'm talking about is not like whether or not the model would be consistent with some other fact, like the measurement of Earth. Right now, I'm just talking about like the sun's movement. Like, we're talking about which one of those facts are consistent with it. But if you want to move on to like,
well, in the concept, and I'm not even going to call it a concept. In the reality, the Earth is measurably flat, and the sun goes from east to west over the surface. That's what we can prove. So in that concept, if you want to call it that, that would be the one that is correct.
Okay, I guess if you want, we can move on to that. And I've just asked, like, how do we see, like, the Earth is horizontal? How do we measure that?
We measure across the surface of water because it is our greatest and easiest way to do. The one claim is that the gravity is pulling the water towards the center of the presupposed sphere, and so that water is essentially equidistant from a center point, and so it is as round and consistent as the surface as you're going to find on the Earth. Well, we measure across the surface as big a bodies as water as we can find with the most expensive lasers that we have, and it is measurably flat. It is parallel. The surface and the laser itself, the separation of the beam and the surface, there is no deviation, so they are parallel. The Earth is flat, measurably so.
Can you show me that?
Sure.
Paper or something?
Although I never have it at the ready, so if somebody has the 40-kilometer laser test,
yeah, I can grab that quickly.
Thank you.
Gotcha.
There's also a 100-page PDF document with all the data, measurements, specs, distances, all that stuff along with it if you want to read it.
You understand the principle, right, of the laser test and how the water underneath the laser would have to be curving at a specific rate if the Earth were a globe.
Well, it would just have to be curving on average at any rate, right?
Well, yeah, it would be at a rate which would be consistent with a globe that has a certain radius value of 3,959 miles.
Well, I mean, we're not talking about the radius. We're just talking about whether it's round or not right now. So I don't think that matters. We're just talking about whether it has a curve.
That's what we're testing, right? So we're told the exact size of it, so we can calculate exactly how much curvature there's going to be over a given distance.
Yeah. Okay. Hold on. What I'm saying is, presumably speaking, if there's any curve, let's say the curve is such that the Earth will be quote unquote double its size than purported, right? That would still be like a round Earth, right? So that's just what you're trying to talk about right now. I don't know the exact diameter of the Earth.
Right. So here's the test that Seisu wanted posted in the side chat.
What is this, a YouTube video?
Yeah, it's hosted on YouTube, right? It's you know YouTube's just a platform that people can post videos on, right?
Yeah, that is what YouTube is. Do you have like is this like in a peer-reviewed journal or something, or is it just a PDF?
Yeah, there's a 180-page PDF to accompany it with all of the technical details.
Well, so I guess what I would be looking for is like some sort of independent verification for multiple different sources that are experts in the field. I don't know if I would trust something.
Yeah. So these are experts in the field, right? These are literally field engineers. It's a whole team of field engineers. Okay, they did 5 different tests. We've also had PhDs in optics go out doing similar tests with different spectrum lasers. Okay, Dr. John D. So these have been done over and over and over again. Now you're dismissing it, right? Because what you're trying to do is appeal to authority and appeal to credentials. Okay, so you've got some faulty logic happening right now. So you haven't even looked at the test, and you're instantly dismissing it because you don't think the people that did it are qualified enough. Even though it's a team of field engineers using a $30,000 laser, you're just hand wave dismissing it, and that's intellectually dishonest and fallacious.
Okay, so in reality, I don't actually hold any of the beliefs that you just described. But what I would say is that my issue, I guess, is that I don't know any engineering at all. So generally, what I would look for to find out whether something like this would be true would be some sort of, number one, explainable, right, to me. It wouldn't just be like a whole bunch of numbers. And it would be usually be like independently verified, like in a decentralized manner. Rather than just
this is independently verified, and anyone can go and repeat this themselves. And not only is it a 180-page PDF document with all of the numbers, there's a 1 hour long high definition video showing the entire process done start to finish.
Can you show me the independent verification?
Yeah, you can watch the video. You haven't even looked at the test yet. There's an hour-long documentary showing the entire test done, unless you would be claiming that these people are lying and all of this is somehow CGI or incorrect.
No, that's not what I'm saying, right? What I'm saying is, if the independent verification happens in the source itself, then it wouldn't be independent, right? It would be by the people that made it.
He told you, brother. He told you. This is just one example of a. Listen, pay attention. This is one example of a group. All right, check it out, brother. This is one example of a group. They did 17 tests. This one PDF has 17 tests in it, done at different locations, okay? Other people have done other tests at other locations. Some people have done it at different lakes. Some people have done it over the land. Like he mentioned to you, there was a PhD specializing in optics. He heard about flat Earth. He decided to use his optics skills to test it. He went out and he cataloged what he did. He did a similar thing with lasers to do a laser transit measurement. So this has been repeated multiple times by multiple different people, even people who weren't flat earthers. So yes, it's been independently verified.
So what I'm not asking is the independent verification of the measurement itself. I'm sure other people have measured the Earth. What I'm asking is the independent verification of the PDF that was posted. That's what I'm asking.
What would that even mean?
Well, what it would mean, so generally, normally what we do is we take like a paper, we like make it whatever, and then you post it in a peer-reviewed journal, and then a whole bunch of people who are also experts in the field will respond to that. And they will be incentivized to
that's not independent verification, dude. That's
well, it would be independent because
they're different things.
Well, those are the same thing. Those peer review is an example.
No, they're not.
What do you
think?
think
Peer review doesn't verify that you did anything. It just reviews the process of what you did. Unless you duplicate the experiment, you're not verifying anything.
Yeah. So hold up. Peer review is an example of verification because what you can do is you can take data and see if it lines up with what would be expected in reality, right? So that would be an example of independent verification. There are other methods, I agree.
Yeah, so why does the laser hit the target?
So
every single time the laser, right? So the laser is placed 1.5 meters above the surface of the water. Okay, and then there's a target on the other side of the body of water that's also 1.5 meters above the surface. And every single test, the laser is hitting the target. Why? Why do you think the laser is hitting the target?
Sure. Okay. So I'll answer any question you have once you answer whether or not it's the case that this PDF, like you can show some sort of independent verification of this PDF here. I would like to see that.
Yeah. So it hasn't been peer reviewed by whoever you're thinking should peer review it, right? But that doesn't mean that the test wasn't done. That doesn't mean the test hasn't been done and it hasn't been reviewed by thousands of independent researchers.
Yeah,
well, hold on, DJ. Hold on, DJ. There's a problem here because duplication is a higher standard of verification than review. Okay, so he's actually asking for a lesser standard than's already been done. This has been duplicated. Yeah, it is, dude. 100%.
No, I'm not asking for that. Right. So what I'm not, just to be clear,
you asked for a verification, dude. That's not duplication of the actual process.
So I don't think you're
somebody just reviewing it and giving their opinion on it.
So I don't think you're correctly prescribing my beliefs right now. So what my beliefs would be that, look, I'm sure other people have done this test before, and I'm sure maybe some people have come up with flat and some people have not, right? Maybe one of those groups of people are lying. I don't know. Oh, Jesus Christ. This is like the sound that disables flat earthers.
How about a PhD specializing in optics that not only reviewed the process but duplicated the experiment, and not only duplicated it but upped it by using dual band lasers rather than just one frequency?
Show me a PhD that have reviewed this PDF. I want to see that. Yeah.
Yeah, he duplicated it. It doesn't even have to review it.
Well, I'm asking for so I just want to be super clear what I believe. I don't believe, I'm sure other people have duplicated the experiment. What I'm asking for specifically is whether or not people have reviewed this specific experiment. But presumably you could do another experiment, that's fine. And
the moment we're asking you to review it.
Well, I'm not an engineer. I don't know anything about this. I'm kind of
yeah, dude. I'll fast forward. Dude, I'll help you. Okay.
Thank you.
Okay, here's how it works. Anybody who has an open mind looks at it, reads it. Globers who scrutinize it, they come up with ideas to scrutinize. For example, they might say, "Oh well, the collimator burnt out on test 4, and therefore that test doesn't count," or they didn't level the laser, et cetera, et cetera. But the fact of the matter is the laser hit the target. Now, they may say, well, okay, the laser hit the target. They have to concede that. There's also a photograph of the laser at the longest range shot, which is 25 miles. So there's actually an image of the laser, right, the light of the laser coming into the camera, which means you can use a Gaussian profile because lasers distribute their light pattern Gaussian. And you can actually tell that the centroid of the beam is actually coming into the camera. So you know that the laser hit the target. Now, the standard excuse, just for your benefit, the only excuse, because keep in mind, this is going to be 90 meters off from a globe prediction, which is 2 orders of magnitude debunking the globe geometry by laser transit methodology, which is an effective measurement methodology. So the standard response is, well, light just bends around the Earth magically to always hit the targets whenever flat earthers do a test that disproves the globe. There you go. There's the review. That's what they all do. That's what they all say.
Wait, so you just reviewed the paper? That's crazy. Are you an independent?
No, I'm telling you. Listen, friend. I've been doing this for 10 years. I've heard thousands of people talk about this document, including flat earthers and globers alike. Some with credentials, okay. Some from like astronomers, some physicists, et cetera, et cetera. And they all have the same thing to say. So I'm just telling you what their review was. And that was their review. Okay, now you know.
Yeah, sure. I would like to. Okay, wait. Can you show me the review rather than like saying the review yourself or something? So I'll just recite specifically what I'm asking. Right? What I'm asking for is here's a PDF. Now I think anybody can write a PDF. Okay, it could be true or not true. I don't know because I'm stupid. I'm not a physicist or anything. So
okay, stop for a second. Okay, so if you're not credentialed in those fields, how could you possibly scrutinize somebody's review of this event?
Well, the way you would do it generally is you get a whole bunch of experts way smarter than you and me who can explain it to us, and we say,
I see. So the point is you're going to have to scrutinize what they say based on your own acumen. Okay, correct?
What? Wait, sorry.
You're either going to carte blanche accept what they say based on faith, or you're going to scrutinize what they say based on your own intelligence, right?
Oh, no, I don't hold that belief, no.
What? That's the only two options, dude. Look, if somebody tells you a proposition, A, you believe them based on you trusting them that they're correct, or B, you scrutinize their proposition and then you either accept it or reject it. Those are the only options on the table, bro. There's nothing else you could do.
Well, so the difference is I don't base it on faith. Right?
Well, calm down first.
Yeah, calm down.
Yeah, if absolutely. Yeah. Listen, if a physicist says such and so is true, and you just say, okay, because you're a physicist, I'll accept it. That's faith, brother.
That's not what I believe. No, I didn't say that.
Oh, okay, that's fine. So then the only other option is you have to scrutinize what they say. Correct?
Well, I could also do it based on some other metric than faith, for example.
Right, which would be scrutinizing what they say, correct?
Well, there could also be a preset measure that I have that measures the likelihood of whether or not it's true, the thing they're saying, right? And an example of that could be
a Ouija board.
Well, you could also set some standard that would increase the likelihood of correctness, right? So you'd say if multiple independent experts in the field looked at a topic and decided that this is actually seems to be consistent with reality, and they can explain that to me, of course. Like,
Right, which would be faith. Right, that would be faith. Faith in a greater number, but it'd still be faith.
Well, so maybe we have different definitions of faith. What I think take faith to be is some sort of like axiomatic, unjustified belief. But I don't know if you want to.
No. Faith is confidently trusting that something is true.
Oh, sure.
Okay?
Yeah,
Without direct knowledge of the truth of it. Okay.
Well, I don't know if you have direct knowledge of the truth of anything, but like, if what you mean by faith is just that after this process has happened, I would hold like a greater than 50% belief that it's true. Then then that is what I mean. If that's what you mean by faith, generally I don't use the word that way though.
Okay, so if let's say 7 physicists say that this laser test isn't correct because they didn't level the laser, okay, would you believe that?
Wait, what do you think? If what?
Okay, let's say 7 physicists scrutinize this test and they say they didn't put into the document how they leveled the laser, therefore this test is incorrect. Would that be true?
I would say if 7 say that consistently, independently, and in a decentralized manner, like without bias, then I would probably believe that. Yeah.
Right, but the problem is that's logically fallacious. That's logically fallacious. Just because they left it out of their document doesn't mean that they did or did not level the laser properly. So they would actually be logically incorrect. So you're basically just believing them, even though they're wrong.
When you say logically incorrect, do you mean that it like violates some law of logic or something?
Okay, they're making a conclusion. In the document, it doesn't say how or if they leveled the laser, therefore their conclusion is wrong. That's illogical.
Okay, when you say illogical, do you mean that some law of logic is being violated?
No, dude, you know there's logical propositions, right? Yes, they do form out of the laws of logic, but that doesn't matter, dude. You know logical arguments? You know, like there's like 400 logical fallacies, 200 formal fallacies, et cetera, you know all those? So if I said to you, you're a guy, therefore you must own a Toyota Camry, that would be illogical, correct?
You're a guy, therefore. Well, the reason it would be illogical is because it violates the law of logic, right?
Which is what law does it violate?
Well, that one. Well, you're a guy, so therefore it must be. Well, I would say it would be non-valid, so it would probably be the law of non-contradiction, right?
What? What? No, dude. Not at all.
What do you disagree with about that?
It's called non sequitur. The conclusion doesn't follow from the premise.
Yeah, and a non sequitur is a law of is a violation of the law of non-contradiction.
No, it is.
Second law.
No,
it's not.
Nope.
Maybe you're.
There's no contradiction. There's no contradiction that if you're a man, you own a Toyota Camry. That's just an if then.
But sorry, hold up. If the thing which if the argument is invalid, right? Then it means that it doesn't follow from its conclusions, right? So when you have a conclusion and it doesn't follow, it means you're claiming it's justified and also not justified at the same time, and that would be a violation of the law of non-contradiction, right?
Well, I mean, look, if you put it that way, you could stress it out maybe, but it doesn't matter because there is no inherent contradiction.
Sorry, if it's a logical fallacy, then it violates the law of logic. Right? That's just
no, dude, because you can make a conclusion that's poorly reasoned, but the conclusion is still correct.
Sure, it depends on whether you. Sorry. You can make a conclusion that's correct, but poorly reasoned. I agree with that. But then
right, or you can make a conclusion that's poorly reasoned and incorrect based on your presuppositional biases of your worldview. For example, as a peer reviewing somebody else's work, you could shove your worldview into your interpretation of what's going on and make conclusions based on assumptions rather than the facts.
I don't know what you're saying there, but like, look, the point is just.
Oh, no, stop, dude. If you don't know what I'm saying, this is very relevant. No, we're not, dude. It's very relevant because you said you want physicists or whoever, credentialed people to peer review this. But how do you know that their review is correct?
Okay, so The problem is I can't respond to multiple things at once. I don't know which one of those things do you want me to respond to.
It was only one thing on the table, dude. You think that having 7 dudes with credentials reviewing this thing is going to matter, but I'm asking you, how would you know their conclusion about the review is correct? How would you know it?
The problem is that you have already moved on from the thing you already said, and I haven't responded to that. Which one of those do you want to go by? The one we have now, or the one we did previous that you moved on?
No, I'm just trying to get to the point where if 7 dudes agree because they have credentials, it means they're correct, and you're going to believe them.
Okay, we'll address the one you moved on to. Okay, so I would say that if 7 people have credentials, there's a higher likelihood than not that they're probably going to have a good belief on it. That's number one. And number two, if 7 people are saying it, that's going to increase likelihood even more, of course. And if they're independent, decentralized, it means that they're probably not affected by some sort of bias. So those are going to be the justification for that. That's going to increase the likelihood more than not, like compared to not having 7 dudes. It's going to be my
so that's great and all. So how do you know that what they're saying is correct?
Well, I just gave you the reason why it would be more likely than not. Like all those.
Okay, but how do you know it's correct?
Sorry, when you say knowledge, do you mean like 100%? I don't know anything 100%. I'm just claiming
you can't even tell me how you know what they're saying is correct, let alone how you know anything. So why should I trust your opinion about anything?
Okay, maybe we use knowledge in a different way. What I'm claiming is just that it's more than likely to be true, and that's what I mean by this is how I know it. If you use know as a like, do I know 100%? I don't think that's true. I don't think I know that many things 100%.
Okay, so there's 3 billion Christians in the world. Are they correct?
Are there 3 billion?
All different walks. So yeah, there's 2.5 to 3 billion Christians, 2.5 to 3 billion Muslims and Hindus. Like it's all in whatever. Anyway, there's multiple billions from all countries, from all walks of life, from all demographics, completely disconnected from each other. Yet they all agree on one thing. Are they correct?
Yeah, so I would say things aren't correct just because a lot of people say so.
Oh, really? Wow. Now we're getting somewhere. So just because 7 dudes agree that this test doesn't disprove the globe doesn't mean they're correct. Good point. Right. I'm glad you made it there, brother.
Yeah, so there has to be other things true than just them being 7 people, right? There has to be.
Oh, there you go. So then their arguments of why it's correct or incorrect are actually what matter, not the fact that they agree.
Well, no. What would matter is, 1, there's 7 people. Well, you would say the majority of the people who reviewed it or something, right? That's number 1. Number 2, they're experts in the field, right? On the proposition of whether this thing is true or not. And number 3, you would say that they're independent and decentralized and unbiased, right? So those things.
Them being experts in the field are irrelevant unless they use their expertise in a proper argument to make their point. If they just make a point and they generally appeal to the ethos of their credentials, being an expert in the field, then their point gains no merit from that whatsoever. If their conclusion isn't logically connected to their expertise, then their point is irrelevant.
Yeah, I agree with that.
Right. So since you're not qualified to critique these guys, like you already admitted, how could you possibly know what they say is true or not?
Well, for the same reason I already stated, right? It's going to be more likely that they've used expertise.
Yep. So thank you. So what you had just agreed, whether you realize it or not, is you have no way of understanding. Even if we gave you a peer review of this event, you would have no way to understand what you're reading. You would just take it on faith that if 7 dudes with credentials said, no, this is bogus, you'd just be like, yep, I agree. Good point. Thanks for playing.
So I have a feeling we mean something different by the word faith. I don't know what you mean by faith.
You admitted that you don't have the acumen to critique their review and that you're going to take it on a more than likely basis that they're correct. And then you're going to put your faith into that conclusion.
Yeah, I'm going to believe it because of the surrounding factors of the.
Correct. That's called faith, brother. Faith.
Sure. If that's how you define faith, as in you believe in the more than likely conclusion, then I agree with that. Yeah. I mean,
no. See, dude. See, the more than likely. See, I don't agree with your metric of more than likely being based on 7 schmucks who have a particular worldview agreeing. So, for example, there's a bunch of retarded evolutionists who think that boobs on a woman evolved from butts on a monkey so that they could trick men into having sex with them face to face rather than from the butt. So, yeah, they're morons. Yeah. Oh, see, that's true. Oh, see. Oh, wow, dude. I got one. I got a person who actually believes that. Wow.
That's crazy. I can try to build biology paper if you want.
Yeah, dude. So the butts, what happened was the butts, they slowly moved to the hips, and then they slowly moved to the belly, and then they slowly crawled their way up to make boobies that men find attractive.
So okay, so you have a slight misconception. It actually crawled like the other way around. It crawled the back.
Out the back, it crawled around the back. So they had back boobs for a couple of millennia.
Yeah, you can actually see that on the tissue samples we get from like fossilized
fossilized. Dude. Hey, Jedi, fossilized monkey dino back boobs.
No, but, well, specifically, you're not getting it from like the you're not getting from like actual tissue. Usually, it's turned to stone or something.
Whatever, dude.
Okay, so
you're the kind of guy that when they put out an image of 5 pixels and they say it's a planet where diamonds are raining down, you believe it. That's the kind of guy you are. I bet. I posted a definition of a model. Admiral, why are you interrupting me? Anyway, we got here a model, a 3-dimensional representation of a person or thing or a proposed structure, typically on a smaller scale than the original. Okay, so it's a 3-dimensional representation of a structure, right? So if that's what a model is, then a globe would be a model of an Earth as a globe, would it not? So, and to say that there's no globe model, that wouldn't be accurate, would it?
Well, what's a modeling?
That's modeling their representation of what they think the structure is, just like the definition.
Then it's not a model. If they
No, it is a model.
It's if they think. You said a model is the representation of a structure, typically to smaller
structure or proposed. It doesn't have to be real.
Okay.
Just like you can model a car that doesn't exist, right? You make a model and then you say, hey, we want to make this car in real life. In fact, a lot of models for cars, they're just like styrofoam and then they cover it in clay. And then there's artists that sculpt the clay to make the form that they want the vehicle to be. It doesn't yet exist. They're mocking it up, but that's definitely a model. I'm just saying there's no reason to get hyper pedantic about saying, oh, globers don't have a model, especially if they present you a globe and they're trying to say the Earth is a globe. And then you say, well, what's the heliocentric model? Well, the heliocentric model may include the Earth being a globe, but that doesn't mean the Earth can't be a globe apart from it. It's kind of a pointless point to make. Because then if you're denying that objects that represent something else can be models, I mean, then you basically have to take almost everything that we model and throw it in the garbage and say, no, those aren't models anymore. Now we need a new word to make up for those things. How does that even make sense? For example, if they ask you for a flat Earth model and you say, well, I don't have one because I don't know where the sun is or all this stuff. Well, now you're not talking about the flat Earth anymore. You're talking about a cosmological model, which is different. A globe is just a model of a globe. It's not a model of where all the celestials are relative to its surface. So yeah, a globe on a table is most definitely fits the category of a definition of the term model. Now, there are different terms that the same word is used for that it doesn't fit. But if you want to use those and say that it's excluded from those, you have to parse that out. You can't just say it's not a model, carte blanche, end of story, because that would be false. Easily disproven by a simple look into a dictionary. Also, by the way, things you find just because you find a word defined in a dictionary doesn't mean that the definition that they put in the dictionary means that that's true, right? Which we are already agree. In some dictionaries, you'll find that level means curved around the Earth's surface water. Well, that's in the dictionary, that's defined. So does that mean you have to accept it? Of course not. Definitions don't create realities in themselves, right? We all agree on that, I would think. So the challenge of the day is if you had to model flat, how would you do it? Not flat Earth, not where flat Earth is in the cosmos relative to other objects, just flat itself. How would you model flat?
I would take something and make it horizontal.
Okay, but what if
something that's flat? Yeah,
I'd take something. Flat?
Mm-hmm. Like maybe flat-ish, but the flat part would really be orienting that horizontally, and I'd be like, that's a model of a flat surface.
Okay, but you're already using the known flat surface, but how would you get a known flat surface in the first place?
No, it's just like it could be a slab. It's not like flat, like 2D flat, but the bottom line is like, if you're saying model something flat, I'm just going to take something like a slab and place it horizontally.
Fair enough. Fair enough. How do you know the slab's flat? Because you're telling me it's flat, and I would agree with you. I would agree with you.
I didn't say that. I didn't say that. When I'm saying horizontal, that is also equally like I'm saying that's the part that I'm saying is flat. I'm not talking about the slab itself. You're saying model something that is flat. If you don't mean horizontally, then no, I'm not talking about doing that. I just thought you meant model something horizontally.
If I wanted you to model something horizontal, I would have said that. I just said flat in the first instance.
Well, flat and horizontal are the same, but I get you now. So, okay, I'm stepping out.
Yeah, but there's no reason to step out. It's a chore that everyone needs to know how to do. If they're going to say something's flat, then they need to know how to model flat. Right,
but
what determines that something's flat?
When I say something is flat, I'm typically saying what I just told you. So I wouldn't be doing.
Okay, let's say that's true. Let's say that's true. So there are many things in your life you encounter that are flat, that are not horizontal. And so clearly, when you use the term flat for describe any of those things, horizontal is excluded. So flat is something unique.
I'm not talking
modeled in itself. Okay, that's fine. You don't have to. I'm asking you to do it.
Well, you said I don't have to step out. You said I don't have to step out, but I am though. That's what I'm saying. I opened my mic to do one thing. You said that's not what you were talking about. I said, okay, fine then.
All right, fair enough.
I concede. That's all I was saying.
Fair enough. Does anyone else know how to model flat that's willing to participate?
Hello.
Hey, brother, who just chimed in. If I told you model me something flat, how would you do it? Okay, so I'm asking you. I want to know how you know something is flat, or can you model me something that is flat? That way we can understand what flat means. Could you do it for me? Okay, but you could point to something in your house that is flat, right? Right, so you know what something is that is flat, but how could you create something that is flat? So let's say you don't have anything flat. How would you make something flat? You want to make a flat surface, how would you do it?
For example, I will take a wood and I will cut it to be flat, I guess.
Okay, that's fair, but you're just using the term flat without telling me how you cut it to be flat. Like what about the cut is going to make it flat? Like what actions are you going to take? So when companies they're making products, right? And let's say they're making a granite countertop, or they're making a surface plate, or they're making a machine part that goes into an engine or something, and they want it to be flat. How in the world do they know how to make something flat?
They grind it that way using a very large surface grinder. And they do it so much that when they put a gauge on it, they don't get any deviation from one end to the other.
Okay, so they make a surface that has no deviation from one end to another. What type of deviation?
Pretty much. Oh, it's like in the millions, maybe 5 decimal, not even 4 decimal, 5 decimal places.
Well, that's the value of the deviation, not what kind of deviation.
That's what I thought you asked for. What is the deviation? Bumps.
Okay, bumps. And bumps would be perpendicular to the plane of the surface that they're trying to make, right?
Uh-huh.
Right, so you have a plane surface, but you have bumps on it, which are essentially verticals, you might say. If you lay the surface horizontal, then you'd have verticals. But you could also do it vertically and then say that the bumps are horizontal. But either way, they're perpendicular to the surface, right? So you're trying to get the overall plane of the surface to have the least amount of variations in the perpendicular angle to the surface, right?
Yeah.
Right, and that's the only way that you can actually describe something that's mechanically, physically flat, right?
That's how I do it.
Right, that's in the machining handbooks and all that stuff. That's how they define it. Right, so if you were going to model something flat, what you would have is you'd have a surface plane in which all the points on the plane are within a tolerance perpendicular to the plane that's very narrow relative to the overall surface area, right?
Yeah, you should be able to zero. You should be able to take your indicator anywhere on a plate, zero it, and move it around, and it shouldn't move. Should just stay right there. If it moves at all, you got a bad plate.
Right, especially when you've got different tolerance instruments. Like if your goal is to get it within a 10,000th of an inch, then if you have a bump readout, then you fail.
Yeah, 10,000ths. That's you can drive a truck through 10,000ths of an inch. It's 0.0001. That's 10,000ths, 1/10,000th of an inch, or are you saying 10,000ths like 0.01? There's one 10,000th of an inch, which is 1/10 of 1,000th, or there's 10,000ths of an inch, which is 10/1000ths of an inch.
I'm just saying. What did I say?
I don't know.
10,000ths of an inch.
Yeah. So.
So let's just say 10 out of 1,000. So that would mean you have 10 out of 1,000 parts of an inch.
Okay. Yep. So point.
Right. So if your meter. Yeah, so if your meter was unable to read anything more sensitive than that, and you put your meter across the entire surface and it read 0, no deviation, then you say, okay, I've successfully engineered this thing, right?
Yes. You can get gauges that only read in 10,000ths or even 1,000ths if you wanted to.
Right, but if you got an even more accurate gauge that read even smaller increments, then you put it back over the surface, all of a sudden you'd get deviations, wouldn't you?
Yep, and they would all average out to the same number eventually.
Right. So then we know that to get something flat, it doesn't have to be perfectly flat. It just has to be that definition where the variance is so much smaller than the extent of the plane, right? And they're all basically, once they're meaned out, they're essentially parallel between two parallel planes.
Yeah, they would be parallel. I mean, they would be parallel, not basically. Close as you can read with any kind of gauges.
Right. And if you had that item arranged horizontally, then they'd be parallel between two horizontal parallel planes, right?
Yeah.
Right. So if you had the whole surface of the Earth, which is covered in water, which is level, and the highest point to the lowest point of the whole surface is 13 miles against 197 million square miles of the known territory, and they're all between two horizontal parallel planes benchmarked by sea level and averaged out against sea level, you'd end up with a very, very flat surface, wouldn't you?
Yeah, it's pretty flat.
Even flatter than some panes of glass, by the way.
Actually, glass is pretty bumpy. I mean, you have to grind that if you want it to be okay. I'm not going to get into it, but anyway, just laying out glass kind of comes out bumpy. Getting it any better than that requires some work.
I was talking to Elder Bear one day, and I was saying, how do you know something's flat? He goes, a pane of glass, that's flat. So I looked up the tolerances on a pane of glass. Not necessarily every different ones because they all are different, but I looked at least one pane of glass. I said, okay, this pane of glass is definitely flat, right? He's like, yeah. Then I looked at the tolerance and said, oh, wow, this is actually a greater tolerance than the surface of the Earth would be. So the Earth would actually be flatter than this pane of glass, bro.
Yeah, glass is pretty wavy, even though you might not see it. You'd have to measure it.
All right, so when we say the surface of the Earth is flat and someone says, well, do you have a model of that? I'd be like, yeah, I do. All the points on the surface that are available to us are between two horizontal parallel planes with a variation of 13 miles over the 190 approximate million square miles of the surface, which means it's modeled mechanically flat. So yeah, I do have a flat Earth map.
If we took a Starrett surface plate and then called that however many millions of square miles you said, and made one side whatever, make it so the square, that's what it equals, right? So then you can put a little dot on the table, and that would be your mountain, your highest mountain.
Yeah, then take a little pinprick and just smack it on there for your lowest divot. There you go.
Oh, there's probably there might even be a hole in the table. You might get lucky and see a grain came out somewhere.
Yeah, so the practicable concept of flat three-dimensional reality is a model. In case you guys didn't know that, it is a model by definition. It can't be anything else because Platonic forms don't exist in reality. In case y'all didn't know who are listening,
so I'm going to use
don't exist.
I'm going to use the Starrett surface plate as my model for flat Earth from now on.
Yeah, but you should. Well, I'm not saying you have to buy one unless you have one, but if you could just put a little Photoshop dot on it and be like, "There's Everest."
I have something similar to a surface plate that's close enough for work. It's a big slab of what is it? Granite that's been ground. It's similar. It's like this thick stuff. I actually use it as a surface plate at home, and it came from another guy who used it as a surface plate also, so it's pretty flat. I mean, I've checked it. It doesn't deviate. So when you can get that close for shit I work on, I only need to be within 1,000th of an inch. That's way within tolerance. I can probably do that. I can probably scale that block. It's pretty big. I mean, it's like 36 by 24. And then put a piece of dust on it and say, there's your mountain.
Man, a 36 by 24 Starrett plate. What's that, like $3,000?
Oh, a real one? A plate from them? Yeah. That's got to be more than that. Maybe that. No, they got to be more than that. No, maybe that's about right.
No, the smallest size that they sell is in the $3,000 range. I know that.
Well, they make bench tops too. The little tiny 6-inch ones and 8-inch ones that aren't that expensive. But then mostly, I mean, I don't know. We have Starrett tables, so those are expensive.
Hey, when they I can finally talk. When they make mirrors, don't they use water like on a big huge table, and then they let the water settle, and then they make the mirrors that way? I was watching a video once because water is like the kind of like one of the best tools to use, if you'll say.
But they did it on Mercury. Water would just vaporize.
Well, they use water in whatever they use in it when they're making like to form the glass. They'll put on the table, then they'll put water to like establish the complete
liquid.
flatness that they need. Yeah, liquids. Yeah, I guess you could say that. Any liquid at that point then.
Like you said, if you put molten glass into water, dude, it's not going to end well for you.
No, I would definitely would be. You tell me before you do that too, because I want to be in the other. I want to be out in the parking lot. Actually,
It's a good way to make Rupert's drops.
yeah, you can make a
You
lot of
can't even
those.
put, dude. You can't even put undried metal into molten stuff. It'll explode because there's water on it.
Plate glasses may float it on like liquid heated lead or tin or something like that.
The principle is the same. That they're doing that because of the qualities of liquid, where it seeks a flat level surface. So yeah, the globe does have a model, and that model is that the surface is curved. And flat earthers have a model, and that model is that the surface is between two horizontal parallel planes. Those models can be tested, right? And so when you go out and test it, you don't really find that curvature that they said was there. And every time you find something supersedery, they just give you excuses, right? So they have an unfalsifiable model, which
We
makes
only
it
need to
not
measure one of
scientific.
those. We only need to measure the flatness of one of those parallel planes because they're parallel.
Right.
And you
the other one's just assumed.
And you can't make any surface of a sphere flat, no matter how
Well,
hard
that's
you want
fine.
to argue that.
Well, that is fine, but spheres don't exist.
True.
So
yeah.
if you say if the Earth was a globe, it must be a perfect sphere, and then argue against a perfect sphere, that wouldn't be very fair, would it? They have dimensions, right? They have dimensions and they have topography to deal with. So we already know the values. So you just argue against the actual real world values that they claim.
Right.
So, for example, in the real world, there's a certain topography for an area of land. You don't have to assume it's a perfect sphere surface because it's not. It's clearly got topography.
Right. Yesterday, it was so stupid. Yesterday, Mordwan was on McToon's channel, and he in his presentation, because they were talking about drones in Ukraine, and he was saying how the system they use is a flat plane, and then to do damage control, McToon's like, just for the audience to make clear, like a flat plane is still adhering to the curvature of the Earth, and I'm like, oh my god, dude, like how asinine is this dude, bro? Like it was comical.
So you mean my drone, when it flies in XYZ space, is actually curved?
Exactly. It was, and then
that's weird because I can't program it then.
And then he literally shows a little like an image from his manual, and it literally shows XYZ in on it. And I'm like, are these guys that dumb? They're literally showing it's an XYZ frame of reference, if you will. And I'm like, oh my god, these guys they're. I mean, that's the Glober in a nutshell, though. They just have to chant, but it's a globe. Trust me, bro. Even though we just showed you as an XYZ. Oh, and then another one. He says that satellite signals, they curve. The signals that they send, they curve. And then he shows a meme showing like all the satellite and the drone and the jets, how they're sending signals to the ground, all straight lines. And I'm like, the hypocrisy, bro. Like these guys are stupid, dude. In their own presentations, they debunked their own words. It was comical last night. I'm just laughing.
They follow after the philosophy of the great Greek Hippocrates.
There you go. Contradiction galore over there. He should name his channel Contradictions Galore. Yeah, they said a lot of dumb things last night. I just kept pointing them out. And to answer your question earlier, you're asking, I would model flat by I'd grab my level and be like, this is how we know something's flat, and then I would go there. But
Well, the plate on the bottom of your level should be flat and straight, right? But in actuality, it only needs to be straight on one axis, because if it's curved on the perpendicular axis to the plate that you put against the surface, it wouldn't matter. It would still read level. But if it's curved on the plate that's supposed to contact the surface, then it wouldn't read level, would it? Yeah, so friends, don't shy away from allowing the Globers to claim they have a model. Accept their model, that it's the model of a spheroid that has certain claims to its dimensions, that's their representation of what they think is reality. You have a model as well, which is flat, which is all points on the surface available to us are between two horizontal parallel planes benchmarked by sea level, right? And you can compare those two models to which is in reality, right? You don't need to talk about the sun, the moon, the stars. They're not relevant to what I just described. I mean, unless you want to talk about that separately, but the Earth being flat has nothing to do with the sun or the moon or the stars, right? We all agree on that, right? Oh, by the way, the Earth being a globe would have nothing to do with the sun and the moon and the stars either. The structures of the objects would be what they are, regardless of what the sun, moon, and stars are doing. But you know, a lot of the arguments on the globe side are for reverse engineering the shape of the ground from their interpretation of the objects that are not the ground. Whereas the flat Earth positioner should be, I'm determining the shape of the ground by how the ground is. So those are two different ways of looking at the information. Check this out. If I go out and I'm just standing wherever I'm at, let's say I'm on a grassy field, and I take out a compass, which is a drawing tool. You know, it's got a pencil on one side and it's got a stabby pointy on the other side, and it separates at the center so you can draw circles. So let's say I take that and I stick it in front of my eye and I point the pencil, let's say at the sun, and then I point the stabby metal end at the ground. So I now have an angle of separation between whatever point that the point of the metal thing is pointing at and whatever point the sun is pointed at with the pencil. So I can then take a protractor, put it against it, get an angle of separation. So now I have an angle. Okay? Does that mean the ground I'm standing on is flat? Anybody at all? The answer is no. That information alone would be impossible to know if the ground I'm standing on is flat. That information alone could not possibly tell me that. Any disagreements?
Which information?
Oh, man. Were you not listening? All right, real quick.
Just which information was it? Yeah, really quick.
Just an angle between my eye. Let's just say at my eye, I have a device that can point at the ground. So I'm going to point it at the ground until it intersects with the ground in front of me. And then I have the other point intersecting the sun. And then I take a protractor, put it on that device, get an angle. I now have an angle of separation between those two things. Can that angle of separation tell me whether the ground is flat?
Well, by you saying angle, so you'll see, you're from your eye up to that line there. No, that cannot.
Right, can't possibly do that, right?
Nope.
Not enough information.
That's correct. But if you put your angle from your eye down to your feet, then you've got a problem.
Well, let's say I put it at my feet. Well, wouldn't the ground be right in front of the thing?
Yeah, wherever you see that horizon should be right there.
Right. So that would only be a point, though. I'd only have the information of a single point. So I could be standing on a hill. That's a continuous curve, right?
I'm gonna have to measure it.
Right. So I'd need an additional piece of information.
Yeah, you're gonna need to know if you're flat between you and the other point out in front of you.
Right.
So what we do is we set a theodolite up with a guy with a stick with a red line on it. We say, there's your mark. Keep going. Oh, now the lines line up. Now right there, stay there. Don't move. And then don't move all day. This is a 12-hour day, and you're not allowed to have water either. Stand there.
Oh, while everyone else goes around and sights you. you just stand there and hold the stick.
Yep, you're the stick guy.
And then the next day, you introduce the new guy to the thing that stabs into the ground and holds the stick.
Yeah, because you're the senior on there when the new guy shows up. We do that to people all the time.
Well, it actually makes sense that you'd have to hold it, because what if you have to call the guy and say, "Hey, move over to the right 2 inches"? I mean, come on now, it's obvious. They got me in the army with that one, with the bags of exhaust. Take this bag around the exhaust. You got to take a garbage bag around the exhaust of the tanks and then tie it up and bring it to the maintenance to test.
That's how they're checking the cars.
Welcome.
Hello.
Yay, this one speaks. How's it going?
Pretty good. Thanks for asking. How are you?
I am fantastic.
So is everyone muted?
Most of the time they do. It's just if they all speak at once, it's just noise. You just can't understand a word. So they normally just mute and sit back, wait for someone nice to pop in to talk to.
Okay. Gotcha.
So since you're in here, what do you think? We're living on a ball, tilting, wobbling, spinning, 72% covered in water, flying through the vacuum of space? Or is it planar with topography?
I mean, honestly, I don't think the Earth is flat.
You don't think it's flat, so what do you think it is then?
I mean, it's a globe, so it rotates through the orbit.
You said that with confidence?
I mean, from my understanding, that's what it is. I mean, if it's flat, then it just wouldn't really make sense to me. Like my brain just can't grasp it.
What do you mean it wouldn't make sense? What part of it wouldn't make sense?
Well,
your car will magically stop working, or why wouldn't it make
no,
sense?
it's more like how do you say it? So like when it how would that work exactly? Like through the orbit, like you're supposed to. I mean, it would make more sense if it's a globe, so that when it rotates, some parts of the world, like the time zones, would make sense. The time zone differences would make sense. Like some parts of the world.
Time zones don't make sense. You know that there's like 19 time zones in the north, 24 in the center, and 32 in the south. Did you know that?
Mm-hmm.
They're not. It should be 24 everywhere, but it's not like that in reality.
Okay.
So I don't know
Interesting,
how
isn't it?
time zones make sense. actually.
Okay, so what's your theory?
Well, first of all, nobody's ever observed the Earth orbit anything or rotate. No one's ever seen that. From our viewpoint, we don't see, on Earth, we don't see the Earth orbit the sun. We don't see the planets orbit the sun. In fact, nobody's ever observed the orbit ever of anything. Ever.
Okay.
I mean, I've said this to lots of globe earthers. I said, okay, show me something orbiting something else. I want to see a full orbit. Never seen one. And I'll never get one. We see the planets like move against the background stars, and Mars and some other ones, they do like a little loop-de-loop thing in the sky, but we don't actually see them go around the sun. We don't see us go around the sun. We see the sun move across the sky. We see the stars move.
Okay, so if the Earth is flat, so the other planets are also flat?
The Earth isn't a planet. Earth isn't like those things. There's no reason to think that the Earth would be like that. Well, I mean, what would the reason be that you could come up with that you would think the Earth would be a planet from observation? You look in the sky, you see a planet, you go, wow, that's just like Earth. Why would you even think that?
Okay, so
I know
Earth is
the answer to
only
this question,
planet
by the
that's
way.
flat.
The answer to this question is there's something called the Copernican principle that was adopted a long time ago. It's a philosophical principle that says the Earth is not unique. And if the Earth is not unique, then it's just like everything else. And when I look in the sky, I go, Earth is just like that because it's just like everything else, right? But there's no basis for that. It's just philosophical. And a long time ago, people decided that that's the philosophical position they're going to take and built a whole construct off of that. Now, if they took the position that the Earth was unique, at worst, they'd be geocentrists, where everything was orbiting the Earth, which is what people used to believe, right? That the Earth was the center of everything. No, wrong channel, buddy. Okay. The point is like, when you said with confidence that the Earth is a globe, we've asked a lot of people, how do you know the Earth's a globe? And they can never say how they know. They always point to how they think other people know. We've talked to lots of people, scientists, PhDs in physics, astrophysics, cosmology, you name it, we've talked to them. Lots of different people over the years. And if I talk to them, they'll say that the people that you think have the answers, they'll say the same things you do. They think there's just somebody else out there with the answers. We can never find the people with the actual answers. Like, okay, who's ever seen an orbit? They'll never find somebody that can actually say that they've actually observed an orbit. A lot of it's like it's almost like a mathematical construct. It's a concept that's been built up over centuries, and it's complex and complicated. And I know to you it probably doesn't make sense because you think the universe has planets and stars and galaxies and black holes and all this other stuff in it. But the evidence for that is very weak. And to us, at least to me, it's just another story about the stars, the same way they told stories 1,000 years ago about the stars, and they all thought that they were right. And 1,000 years before that, they told stories about the stars, and all those people thought they were right. And nowadays, we're telling stories about the planets and stars, and we think we're right. But in 1,000 years, they're going to think we're wrong and that we were a bunch of idiots.
Okay, so if the
Every
Earth
generation
was,
thinks they're right.
if the Earth is flat, then where is the end of the Earth?
There's no end.
And
The
where does
Earth
it
isn't in
begin?
space. And put this way, think of the Earth as like the floor of the universe. Everything is above it. There's only the Earth. There's no outside the Earth. Like, you can't go outside the Earth. It doesn't make sense. It's like asking, hey, can we go outside the universe? That question doesn't make sense because anything outside the universe would also be part of the universe. So you can't actually go outside of it. So there's no outside the Earth. There's no outer space. There's no spaceships. There's no freaking people orbiting the Earth. All that stuff is just a TV show. And I know that's crazy, and you're thinking, this is fucking crazy. How could they fake all these TV shows? I mean, fuck, dude, they fake Santa. So lots of photos of Santa. They can't all be fake, right?
Mm-hmm.
Because someone can make the same argument for Santa Claus. There's thousands and millions of photographs of Santa. Santa's real because the photographs prove that Santa's real. Because there's so many of them, right? This globe Earth thing's in the same position. Because these pictures of the Earth, they show one thing, always. That the Earth is covered mostly in water, and that water curves into a ball. But when we go check in the real world, like the ocean, a lake, a pond, anywhere, the water doesn't curve and the water's flat. So if you have more than 50% water on the surface and that water doesn't curve, then the Earth has to be flat. It cannot be a ball.
Okay, so you're saying Earth is a limitless flat platform?
Not limitless. I mean, limitless, I don't even know what that is.
Like boundless?
I don't think it's inside of something
Since you
where
said
like
there's no end.
yeah, what I said was
Okay, so how do you explain
doesn't
the core
make
of the
sense.
Earth?
What I'm saying is Earth is not an object that you can hold in your hand. That's how you think of Earth, like it's a ball that if you were a giant you could hold in your hand. The Earth is not an extended object that you could hold in your hand. It's not an
Well,
object
nobody
at
really
all.
says nobody really says the Earth is an object that you can hold in your hand.
Well, if you were a giant, right, I got the whole world in his hands, right? Yeah, they do say it. It's the whole song about it.
Well, I mean, even if you're a giant, like you would still be smaller than the Earth.
I mean, a
But
giant, like bigger than
anyways,
Godzilla.
how would you explain the core of the Earth then if the Earth is
What
flat?
core?
So you're saying there's no core of the Earth?
What is the evidence that I have that there's a core other than a picture in a book? That's not of the core, which is just a drawing someone drew. Has anybody drilled to the core? What's the deepest hole ever drilled? Do you know? 7 miles. The core's supposed to be 3,959 miles away. So they got a long more way to drill to prove that a core exists. Told you the global idea is sophisticated. It's been built over years, hundreds of years of people just adding more and more things on it. So I'll tell you this. If I have a set of data, I can make that data fit to anything I want. I could say, well, I'm going to interpret my data with the Earth as a pyramid. And then I can make the data work in the framework of Earth as a pyramid. Or I can take this data and say Earth is a ball. And I can make that data within the framework of the Earth as a ball. And this actually happens all the time in science. I'll give you a specific example. There's a paper that's published about where they're measuring, they're called telluric currents, which is electricity in the ground. Now, if they assume that the Earth is the ball, they can make predictions about what the currents will be 300 kilometers away. But they can also make the same predictions if they assume that the Earth is flat. They can also make predictions of it being 300 miles away. So the framework, in that instance, it doesn't matter if the Earth is flat or a ball. You can make the data fit because you can change your assumptions about what's happening and make it fit. And they've been doing this for hundreds of years. And there's a lot of myths that go along with the globe Earth, such as eclipses. I always run down these. So eclipses, people think that they use a globe Earth to predict when eclipse happens, and that's how we know eclipses prove the globe. In fact, eclipses are first predicted by flat earthers in 2000 BC, and the first known exact eclipse prediction was done by Thales of Miletus, a Greek flat earther, in like 300 BC. So people think there's a lot of mythos behind the globe which just aren't true. Eclipses are predicted with flat Earth mathematics. Sunrises and sunset, flat Earth mathematics. They don't use the globe to predict when those things happen. So there's just a lot of myths about all this stuff. About what a globe enables us to do. Okay, I'll give you another one. GPS. GPS uses a globe. No, it doesn't. It uses something called Earth-centered, Earth-fixed coordinate system. I know this is probably like, holy shit. You can fact check me on everything I'm saying. You can type it into ChatGPT, type it into Google. I don't care what you type it into. What I'm saying is factually accurate.
No. I'm mainly silent because I'm also in the middle of work.
Oh, that's fine. I'm used to people just going silent for lots of reasons. But it's just, sometimes people don't believe us, or some people think we're mistaken, or maybe they think we're interpreting things wrong. No, this is all in mainstream. I mean, we're using mainstream information. The thing is, most people, just like I did for 50 years, Earth is a globe, and I never checked to see if what they said was actually true. People, at least in here, and on our main server, and in the politics server, and running the same channel, we checked. Because, okay, they said the Earth is a globe of 3,959 mile radius. Okay, there's these geometric consequences. Let's go check to see if this exists. We went out and checked. They don't exist. And we're not trying to convince you the Earth is flat. We're just sitting in your head telling you, hey, dude, we checked. The globe they says exists can't possibly exist because we measured it. And nobody else did. Like, one thing we used to ask people was, hey, who do you know from either now or in the past ever measured the curvature of the Earth? And the answer is always, I don't know, or nobody. Because nobody's ever done it except for flat earthers. There's no curvature to measure. And I'm not saying believe us. What we all say is, go check yourself. You don't have to believe a thing we say. This isn't a contest between us and NASA, where believe us over NASA. Don't believe us or NASA. Don't believe anything. Just go out and check. I checked. Checked multiple times. They say ships go over the horizon. Okay, let's go to the beach. Watch ship go over the horizon. Okay, I got this app, marinetraffic.com. Where's the boat? Okay, it's 6 miles away. Let's watch it for a while. 1 hour goes by, it's farther away. 2 hours go by, it's further away. 3 hours go by, it's further away. Hey, man, it's 30 miles away. How come I can still see it? It should be 400 feet under the horizon. But it's not. The Globe Earth says it is. The Globe Earth says I can't see that boat. But there it is. So that's the situation, at least on our side, that we're in. We've gone out, we checked, we tell people, hey, we checked, and we get a bunch of shit for it for checking. But I thought science was supposed to be testable, repeatable, verifiable. But then we get a bunch of shit for testing, repeating, and verifying, and they're like, well, no, we don't want to revisit that flat Earth shit. How would you guys? We want to believe the Earth's globe. Believe what you want. I'm not into the beliefs. We go out, science is supposed to be empirical. We go get the empirical evidence. And empirical evidence, the Earth is flat. It's pretty simple. It's not complicated. There's only one question that can answer the question. Does the surface of the Earth curve or not? If it curves, it's a ball. If it does not curve, it's not a ball. That's the only thing that can prove it one way or another. You can look at the sun, you can look at the moon, you can watch TV, you can do all sorts of other stuff. Most of the so-called evidence of a globe is ambiguous. It can be interpreted within a flat Earth as well. It's what we call not globe exclusive evidence. It could be interpreted as flat Earth evidence, or it could be interpreted as globe Earth evidence. Just depends on what you presuppose. But the only definitive way, like I said, curving or not curving, will decides it. And from what we've measured, it's not curving. I mean, we got 40-kilometer laser tests, 475-kilometer long distance observations, 10,000 mile freaking radio transmissions. I mean, 800-mile. It's called LoRa chirp to low power radio waves over the ocean. Even the freaking NATO had a microwave system across Europe that communicated over 800 miles, which should be, there's something like in 800 miles, there's about 40 miles of Earth curve that should be in the way between the radar stations. So that means there should be a 40-mile hump of ball between the two radar stations or the microwave stations. And there's not. It's just like, it's all over the place. I mean, they did 10,000-mile radio transmissions in 1918 during World War I. So there's no repeater towers. There's no satellites. There's nothing. How did they broadcast the United Kingdom to Australia in 1918 and talk to them over the radio? It's almost like North Pole, South Pole communication on a globe. It'd be like being in northern Canada and talking to, Amundsen Station at the South Pole. Well, that's not impossible on a globe. But we know all the stories too. We know all the globe stories. Everyone here grew up on it. It's all been like we all been brainwashed with it. We know it. We know it just as good as anybody else. So it's not, a lot of people, they're prejudiced and think that, oh, these flat earthers, they don't understand the globe idea, or they don't understand the heliocentric model. That's why they don't believe it. They just don't understand it. And if I just tell them about it and they understand it, then they'll obviously realize the Earth's the globe. No, we do understand it.
That's why we're flat earthers.
Exactly. We do understand it very well. And we're like, hold on, this globe idea don't frickin' hold water. Of course it don't hold water. It's just spinning fucking balls. Spinning balls don't hold water. I mean, if you want something flat, what do you use? What tool do you use? Use a fucking level. How's a level work? With spirits inside it. That's a liquid. Yeah, I mean, just wrap it up. People think the flat earth is a belief, but it's actually the globe earth that's the belief. We observe a flat earth every day. You go on a plane, go on a mountain, go anywhere you want to go, hot air balloon, altitude weather balloon, jump out at 128,000 feet like Felix Baumgartner. No matter where we go, normal people, the earth is flat. Now, there's a group of people that claim they're special and they went someplace none of us can go, and they saw the earth as a ball. Now, you can believe that, or you can trust your own lying eyes that the earth looks flat because it is flat. Because we always hear, well, a giant ball looks flat. Do you know what also looks flat? Something that's flat. The obvious. Things that are flat look flat.
Ladies and gentlemen, we got him.
I used to pull apart my shit just because I was curious how it worked.
Yeah. Dude, what you said was awesome, man. That was good. But he wasn't really hearing you. I hate when they do that. When they ask questions and they only half listen. It's annoying.
Yeah, I know. Because it's just too out there. Like they can't, for them. There's only certain in a setting within which we could discuss this. Right? There's no other setting that they can conceive of. I understand why it's really difficult to wrap your head around.
Well, I mean, we're going to always end up with the identity crisis. The identity, like, oh my God, I'm not going to be a flat earther. I can't be a flat earther. What do my friends think? What do my family think? So there's always that psychological wall where they're like, they can't really take what you're saying seriously and like internalize it because they're afraid. Because they come in here and like we sound normal. We make sense. Everything we're saying is rational, but the Earth can't be flat. No way. Why would they lie? It opens up such a huge can of worms of questions, right? That they can't like, oh my God, if that's true, then what else is true? You know what I mean? Some people don't want to go down that road psychologically. I mean, I don't blame them.
Yeah.
You can ruin your own life. Shit, man. I was just about to get a job at NASA. Josh got me in there. I became flat earther, damn it. Were you in here when Talon X was in here spurging out?
Yes.
Oh my God, he was going mental, man. I was on my phone, so I couldn't really post stuff because I was like getting ready to go to the gym. But, God damn, he lost his mind. I thought he was going to be all right too, because the last time he was in here, at least when I was in here and he was in here, he seemed like he's like, this is like one of the better.
It was like chill, right?
Yeah, he was like, this is one of the
Yeah.
better channels on the server. You guys let people talk. Well, guess that honeymoon's over.
Yeah, it's all back to normal now. Yeah. Business as usual.
Motherfucking Neil. Neil, what you doing, boy? Shout out, Neil.
Hi.
What's up, man? How you been?
I'm chilling. It's 2026,
Chilling.
easing into it.
I haven't even talked to you this year. What the hell?
I know, right? It's almost like I'm growing up. No, I'm joking.
Grow up so fast.
I'm just chilling, bro. How you been?
Cool. Yeah, I've been all right. I'm chilling too. We all chilling.
Yeah, man.
And now that Mark's not here, talking about spurging out, I had a bit of spurg out, and he was. I couldn't help it, man. He was like, I just lost my shit with him.
Who's this now?
'Cause this guy, he was just like a little kid going, but why?
Talon?
And then you answer that, and they're like, but why? And then again, why? Like, that's what he was being like. It was like, oh. I want to.
Are you talking about Talon?
No, this guy called Mark. What was he? Philosophy, something. Goes by Mark.
Oh, so was he's doing the sea lion troll where you just keep asking question after question after question?
Pretty much, yeah. And it didn't matter what you said, and it was all leading back to like, because you pretty much say, look, we're not making a size or dimension claim. We're just saying that the surface quality flat and geometrically has to have curve if it's a sphere, right? The surface of water is flat. Yeah, but you don't know the size, right? How far does it go? Where's it? Like, it's just like, what? I said, why would we even know that? Because you're claiming to know. And I was like, Jedi was like, no, we're not. We're not claiming to know those things, just this one particular thing, Like, he just wouldn't let it go, bro. Like, I just lost it with him.
Who was that, Mark?
Yes, Mark, yeah.
Oh, he's a pain. Normally you get the question, what's your epistemology of the flat earth?
Here's my epistemology. What you see is what you get. It's like a web browser. The web browser editors, they call it what you see, what you get editors. That's what I'm talking about. Whatever you type in the editor, that's the way it looks on the web page. I was trying to get that guy. I was trying to get him to argue against what you see is what you get. I wanted him to argue that like believing his own eyes was okay. I'm always trying to get to do that because I think it's hilarious when they have to take that absurd position. You can't believe your own eyes, you dumb flat earther. You have to evaluate all reality with a slide rule and a calculator.
Right, but wasn't he just trying to determine what the Earth is by looking at what the things in the sky look like?
Exactly. It's selective empiricism. Someone did that. I don't know if you were in here like the other night. What if you went up to space and saw the Earth as a ball? And so I told him, I'm like, well, that means if I came down here, I'd be able to measure the Earth curve. So, but that in and of itself, you see a flat Earth every day, and you don't believe it. But I'm supposed to go fly in a rocket and see the Earth as a ball, and then I believe it's a ball, but you see the flat Earth every day, and you don't think it's flat? That sounds like a double standard. He freaked out after that. Because, you know,
The other question-
they think that's their ace card.
I
Their
love
ace.
it. That's funny. The other question that's been breaking them lately, Indio, is when you say to them, outside of your mobile phone, computer, and media or television, where have you seen the curve? And they seem to go into robot malfunction mode.
Any astral projection answers? I was astral projecting. I took a bunch of that guy was trying to make Earths a go because of ayahuasca. Yeah, I asked that. I don't know if you were just in here, Matrix. I just asked that kid, like, does anybody know the boundaries of reality? He's like, yeah, some people take DMT, and there was a study about DMT, and they could see stuff. And they were just high.
Wow.
Yeah, it's a freaking. You know, I took hallucinogenics, and I thought they were deep at the time. But now I know I was just high. Okay? I was just fucking high. It wasn't deep. I was fucked up. That's all it was. It's not complicated. People try to read all sorts of shit into their trips. No, you're just high.
Sorry, son, you're off your head.
Yeah. You just freaking. You know, we even do it when we were a kid, right? We'd spin around in the circle to get dizzy.
Now, there's actually a comedian that stood up and said that when they ban all drugs, they are going to go out into their backyard around until they fall over.
Oh, we used to just hyperventilate. Yeah, that gives you a good buzz. Spin out, see shit.
We used to do. I mean, they freaking would expel you if they caught you in us in school doing this. But you bend over and hyperventilate for 30 seconds and stand up, and then someone put you up. You stand up with your back up against the wall, and someone pushes on your neck to cut off the blood supply. Dude, you go like instantly into a fucking dream, man.
Yeah, you're inducing a short-term coma.
Yeah. Yeah, but I just always found it weird. Like when you go to sleep, right? You have to like sleep for a couple hours to get into a dream state, but it's like you go instantly into a dream state. It's freaking really, really odd. We used to call it the name we call it China syndrome or something like that. I don't know where that name came from, but China syndrome was a movie about a 3 Mile Island, their plant meltdown. If you guys remember.
Came from China.
Was that Michael Douglas?
I think it was Jane Fonda, right? In could have been Michael Douglas. Yeah, you might be right.
I'm not sure. I'm just I remember something about that. Yeah.
Oh, you got it, Michael Douglas. And I was right, Jane Fonda. And who's the other guy?
Oh shit! There you
Jack Lemmon. Yeah, Jack Lemmon was the.
Jack Lemmon? He was in a serious role?
Yeah. He was actually pretty good in that. Dude, that's but the cast for that movie, that's the pinnacle of libtard. Dude, I'm thinking about this movie, right, and how people were back then. How liberals were and like what they stood for. And though they were like a bunch of hippie peaceniks, you know, during the Cold War, and that brought them a lot of animosity. It is admirable to fight for peace. But they're all sellouts now. All of them. You ask them, should we send more weapons to Ukraine? They'll be like, hell yeah, right? So they're all full of shit.
Right. Yeah, they should be stay out of it. It's not your fault.
Yeah,
Leave it alone.
yeah,
People are dying.
I mean, I remember the peace movement was about peace worldwide, right? No wars anywhere. That was the idea. Now it's to be like just peace with you know, over there. And if you don't, it's like peace or we'll kick your ass. You know what I mean? That's where we're at.
Hello.
Hello.
Hello, Flat Earth Tribe.
Tribe.
I
That
don't
sounds
know.
racist.
No. It's like a place where I belong. It's like a
Place where
tribe.
you belong. Yeah. We could be tribe, club, like holding
Yeah,
hands,
the
sing
Cool Kids
Kumbaya by a
Club.
campfire.
Well, yeah, holding hands is fun and it's good for your body, and you get oxytocin with human contact. So
Oh my God, you do astral projection?
I've tried before with limited results. Hold on one moment. What? Hold on, I'm not muted yet.
Oh, this is gonna be fun. Gonna be nice.
Okay, why did you ask about astral projection?
Oh, because I asked the guy a little while ago, 10 minutes ago.
Okay, I've
If
had
anybody
very
knew,
limited.
no, well, no, hold on, let me finish. I asked him if anybody knew what the boundaries of reality are, and then he went into some people did some ayahuasca studies
Oh
or
Lord.
something.
Yeah, I've done dimethyltryptamine and LSD and mushrooms, and dimethyltryptamine is definitely the most profound. But back to astral projection, do you believe in stuff like that, or?
That you can do it? Yeah, certainly.
I mean, I've had
I
a
don't
few
think you
weird
should,
experiences.
but I think you can.
No. Well, it's hard
Like
to do
summoning
it
a
for an
demon,
extended
right?
period of time because if you get up in your emotions or you get shocked by your experience, you'll snap right back to your body. One of the weirdest experiences I had was I was meditating by the water and I calmed my body and I started to see myself literally walking and wading through the water, but I got so shocked by what I was seeing that I snapped back to reality. And then another time I was laying in my bed trying to do it and my head came out of my body, nothing else, but I could see 360 in the room. And then another night I got out of my bed out of my body and went up to the window and looked through it. But then I guess I fell asleep because I have no other memories, so I don't know. So yeah. But I
Woke up
love
one
stuff
night and I
like
felt
that.
like I was floating above the bed, and then it felt like I actually sank back down into it, and I just laid there freaked out.
Yeah, have you ever tried
Boys and
falling
girls is
through the
why you
floor?
shouldn't do drugs.
Well, no, I wasn't doing this when I was on drugs. You can't do stuff like that when you're on drugs. You don't do stuff like that. Like you can't achieve things like that without being sober anyway.
When you did these events, did you find afterwards the next day that you were absolutely cooked and you'd run out of energy?
No, I didn't feel any different.
Interesting. But other people say that when they've done that, next day that they are spent, like as if just flat batteries type, worn out.
Well, the experience was so short, and I snapped back into my body so fast that I don't think I expended any energy at all.
There you go.
Yeah. Things are never as it seems, I suppose.
No, I think they're exactly as they seem. People
Yeah.
are just. I think the things like the metaphysical parts of reality, I think they're pretty obvious, and people ignore them and try to pretend they don't exist because you can't put them in a jar or put them in a test tube or weigh them on a scale. So, but everybody sees it every day. They experience it their entire lives. I think it's pretty obvious. Everybody's had, I'm not going to get into like the weird coincidences that people have, and I mean, you literally you have to actively ignore it to not see it, as far as I'm concerned.
Yeah. Yeah, astral
But that's just
projection
a
isn't.
part of. But that's a part of being alive. You know what I mean? That's just one part, because we also are physical, and it's that
Yeah.
the rub, right? The friction between those two things, which give life its its zest or whatever. I don't know how else to call it. Shit would be fucking boring if it was all physical, and it would be just as boring if we were just disembodied spirits.
Yeah, I like the idea of not being limited to my body. Like, I like to think that, for sure, that we're limited by our senses to an extent. That's what causes our sufferings too. And then because we're so attached to what's going on in this body, the physical reality, and we have such a ego and all of these things that make us think things are impossible too. And then
Well, I
I'll
mean, you
stop
shouldn't
there.
neglect your body, because there's a lot to be said with
Well, no, you shouldn't
honing
neglect
and
it.
training your body to do some particular thing just like extremely well. I mean,
Yeah.
like a sport, painting, art, all that stuff takes a supreme connection with your body. And like, I don't think I'm kind of like more holistic about the whole thing. I'm not like, well, it's this and not that. A lot of people are like, it's mystical or it's all physical, and no, it's all of it. And you can sit there, and the thing is to harness all of it together. You know what I mean? It's
Yeah, that makes sense.
mind, body, and soul, right?
Exactly. Like I feel like people don't focus on all three all the time. They're just like body, 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 or soul, 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 and not mixing it all together. So you would say that you believe in like the metaphysical. It's just a part of reality, that we've just given it the label of metaphysical as if it's some separate thing from the experience, but it's not, right?
Yeah, I mean, not everything can exist. It's easy to prove that not everything can exist in an empirical way that you could stick in a test tube. Like human
Yeah.
rights. Everybody believes in human rights. Where do they exist? Can I weigh them? Can I weigh them? So we have these concepts and ideas, and they certainly exist. The laws of logic exist. Certainly, the law of identity, the law of non-contradiction, the law of excluded middle. These logic exists. Where does that exist? Where does mathematics exist? I mean, these are like, these questions have been asked for 1,000 years, but they exist. The people that like But the people that are materialist atheists are like, all there is material matter, and that's it, and the laws of physics and energy, and that's all there is. There's nothing else. I don't think they actually believe that. I think they're just like rejecting. They're just afraid of things they can't understand or explain in that way, right? In the mechanistic, physical physics way. This happened because of this. Here's the equations and blah, blah, blah. I mean, what's the equation for serendipity? What's the equation for coincidence? What's the equation for all these human events that we have names for that happen to human beings all the time? There's no equations for them. There's no formulas. There's no laws of physics. There's none of those things, but they certainly happen.
Would you say that could be part of like the consciousness, maybe?
I'm sure an atheist would say, "Well, that didn't really happen that way. You just thought it."
Yeah.
I don't know. They try to come up with all sorts of things. You're
Well,
just
most
giving
people are
meaning to
dumb.
something that actually has no meaning. Yeah,
Yeah.
they'll say things like that. Like, okay, go with that. I mean, you can believe what you want, dude. Go with it's something that, doesn't have any meaning. I mean, if atheists really believed what they say they believe, there'd be no atheists because they'd, eat a shotgun, for lack of a better word. Why carry on if you're an atheist? There's no point.
Exactly. They're so cold and like nothing means nothing. Or damn it, I said that wrong.
Nothing, but can never mean anything, right? And their atoms, they think their atoms and molecules are going to freaking, when the sun blows up in 4.5 billion years, all traces of them are going to be gone, right? So it'll be like they never existed. So whatever sequence of events that we experience, they're just the mechanistic processes. Even me right now talking about this, according to an atheist, these are just the preordained deterministic chemical reactions determined at the Big Bang.
Yeah. That's
don't
what I
like
would say
that.
too.
'Cause then
I
it
agree
makes
with you there. I've never heard of it said that way, but I totally agree with you. We're just a result of the expanding universe, and it's not so well. But then some people will also argue, well, it's a miracle too.
Yeah,
that
there's gonna be one
we
free
even
miracle.
exist. Yeah.
I mean, and that's
would
what
you
we
say
battle
it
in here.
might not
I mean,
even? Huh?
that's what we battle in here. Basically the materialist atheists. I mean, of course, some people are, Christian or Muslim or whatever, and battle us. But it's really, they've adopted the materialist worldview where there is no spiritual world, there is no metaphysical world, that everything is just, like I said, like the mechanistic laws of physics, and that everything must fit within
A framework of
this is
explainability. Explainability.
So when someone says, do you have any evidence for God? Well, you ask them, well, what do you accept as evidence? And they'll instantly say, well, I need a photograph, or I need God to come over here and write something down, or they need empirical evidence. That's what they actually want. They want something they can stick in a jar or a test tube, or they want to be able to videotape God or have God write something down, and they want to witness it, or you know what I mean? That's the only thing they're going to accept as evidence. So now that you know that they only going to accept this empirical, this little box of evidence, these are the only things they're going to accept. You just excluded pretty much everything else, even though those things exist. Like I just said, like the laws of logic, they certainly exist, right? But you can't even prove that the laws of logic exist. The only reason we know the laws of logic exist is because to argue against them, you have to use logic. To argue the laws of logic don't exist, you have to use logic to make the argument in the first place. So it's like a performative, you're proving it by doing it, But I mean, that's not in a test tube. It's not in, you know. Yeah, it's a messed up position for atheists to be in, but they'll just not on it to death.
Why do they feel so empowered to try to get out in the world and want to debate just for the sake of debate? Like, that's what annoys me, really. It's like if you really believe this, why are you fighting for it so hard when
Are
it's
you?
nothing to fight? You know?
Yeah, why are you fighting for anything?
Yeah.
Like I
So they
said, you
believe
should
in
just be
atheism.
you should be finding a cliff to jump off of. Just doesn't even matter. Why suffer?
Yeah, because they're always going to be bitching and complaining anyway. Excuse my language.
Yeah, you got that right.
How many genocides are connected to atheism now?
Yeah, but what if somebody argued to you how many people died because of religion? You know?
It's not that many. That's a blown up
Really?
number
Yeah.
compared to secular reasons. Just think about all the abortions.
Yeah.
Just that alone is more people than died in any war. What is it? 70? I think it's the number for abortions is something like 75 billion.
Oh God! Don't tell me that. That's kind of scary.
I have to look up the number. It's large.
That's a shame. It's messed
Well,
up.
think about it this way too. Like in the Bible, it tells you, don't take the Lord's name in vain. Don't do something in God's name that's actually evil. So a lot of times they'll say, "Oh, look at these wars that were started." Yeah, people taking the Lord's name in vain. They do this horrible thing in the name of somebody who would disagree. People say, "Oh, what does that mean?" Oh, it means just don't say, like, "Oh my God" or whatever. No, that's not what that's about. The about is people doing things wrong, but think they're doing it right because they're doing it in the name of.
Oh, I get it.
So it's not on, Christianity when somebody says they're doing something because of Christianity. That's on them. They're just dropping excuses for why they're doing something wicked.
Oh, good thing.
The current annual number is 73 million, but there's no way to say for certain how many.
Well,
I'm talking about worldwide.
We'll do another arbitrary number of years and then see what that comes out to, because that's still a hella high number. Let's say go back to when abortion started becoming more accessible for people, and start from like a year when,
Well, in the U.S., it's 63 million since 1973.
So that's how many years?
Yeah, just in the U.S., but that's just the U.S. Abortion was legal in the Soviet Union for a long time, and it's speculated that was hundreds of millions of people.
Wow.
Yeah, man,
And
it's not good.
when did birth control become a thing?
Condoms were invented during the Civil War.
Well, yeah, good point.
They weren't great. They're better than burning your dick.
I think there was an early version the French invented out of sheep intestines.
Oh God!
Oh, they still got them as lamb skins.
I reckon
Yeah, for people who are allergic to latex, right?
And for people who want to actually feel what they're doing.
Ooh, I didn't know that was a thing.
Yeah, it transfers body heat, so it feels more realistic.
What's it called again? Because
I think that's where the term Frenchie come from, right? Frenchies?
It doesn't. Yeah, probably. They don't. They only prevent pregnancy. They don't prevent venereal disease.
Okay.
Or no, is that the other way around? I can't remember. I haven't used that shit in a long time.
I don't know where you thought of all that stuff, but you're pretty smart, dude.
Yeah, they don't work against STIs. So, yeah. Well, I mean, we got to keep our, we got to stay sharp in here, man. Like, because we could go over Earthers. Like, it's been years, and they're always trying to come up with something new to trip us up. But we're ready for them because we're way ahead of them.
Right. Chewing on this pizza real quick. Hold up.
Chow down.
A lot of us are just like life experienced and just have read and watched a lot of TV and stuff too. Like, you just pick up odd bits of trivia here and there, right? It's like you'd never think you'd want to talk about it again, but then it comes up in the future, right?
Yeah.
See, the fundamental premise of flat Earth is so simple. We were just talking about it. What you see is what you get. It looks flat because it is flat. If you think that's wrong and you think that it looks flat because it's a ball, okay. First of all, that's crazy. Second of all, prove it. But we're flat Earth is really in the superior position, just because we have what's called qualia of experience. We can go out and we can observe the Earth as being flat. They can't go out and observe the Earth as a ball. The only way they can observe the Earth as a ball is if they go to their couch or their computer desk and watch a screen. It's true. It's true. And Matrix was talking about that just a minute. He said they've been putting it to them, and it's tripping them up. It's tripping the going or a TV or their phone. Where have they ever seen the Earth as a ball? And it just lays them out.
A lot of them don't even care about the Earth being flat or a globe. What they really care about is somehow something else in their worldview, this sort of like cosmic atheist nihilism. That is what they're really defending. They just need the Earth to be a ball for that. Because without that, they have a hard time maintaining this sort of cosmic nihilistic worldview that I suck, that Bill Nye I suck speech. That's how they view
I mean,
themselves.
for their religion.
Oh yeah, even better. That this religious worldview that it's just everything's just chaos, just utter inconsequential chaos. And I'm like, well, sure, if that's true, why are you in here every day arguing with flat earthers? If it doesn't matter, if it's just utter chaos and you don't care and everything's just completely random, why are you here at all then? Why do you care so much? And you see that they don't really care. They care in. They're upset that somebody disagrees with them. That's what they're
care in.
Yeah.
They care. Jesus.
It's so true. Yeah. Yeah, that's got to go on a t-shirt, man.
Oh shoot. I was gonna post the.
But Crit, what you said, I've always thought about, like, when I think about like most of the people that really triggered Globers that really hate us, that like, but they really don't know their own model, and right, the ones that are obviously they're atheists, right? I think but the thing I think they're fighting against is the outer space thing. I think outer space to them is analogous to going to heaven, in that they've invested a lot into this atheism on the promise that there is a atheist heaven in space, right? Go up there with Elon Musk where everything's going to be perfect and jolly, right? We're going to go to Mars. We're going to go to another planet. That's like it's analogous to going to heaven.
Yeah, like everything gets solved. Like all the whole world's problems just vanish as soon as you get to outer space.
Exactly.
Hey, maybe that's true. Maybe they'd say, like, in some sort of Star Trek idea that once you leave Earth, you leave government and religion behind. But what they don't understand is, like, it's more likely going to be like Warhammer 40K, where you get some fundamental, bizarre religious, cult of humanity. The God Emperor and whatnot. Like that's really what's going to happen. Well, they think like aliens show up all of a sudden humanity's gonna be like, oh, look at there's aliens. That must be there's no God. What's really gonna happen is all the religious leaders are gonna be like, let's convert some aliens.
I think that, like, when you've rejected any deity, God, and the promise of the afterlife has to happen here, has to happen like in physical reality, your reward. Or why go on? And their reward is gonna go to space. It's gonna be so beautiful. I mean, you ever seen like the ISS stream on YouTube? In the comments?
Oh, yeah, the comments. I think a lot of those are
Beautiful,
bots. though.
amazing. Oh, it's just, I wish I could see. You know what I mean? Just the fawning. It's. Oh my god, I'm gagging in my mouth just thinking about it. It's
I
disgusting.
think a lot of that's bots though, because it's like the same comment over and over again. It's like, are these really not like honest reactions, or is this like just some sort of like looped like bot that just repeats different comments?
I know. I mean, it's the internet. There'll be trolls when they go like, "Look at that." I'd never go there.
Yeah, it'd be some sort of comment that would be. Yeah, it's like, especially too, because when it's like a black screen, sometimes you see like a completely black screen, and it'll be like, "Someday I'm going to be there and see that." Dude, they're showing like the camera's like facing into the void or something. Like your 24-hour live stream is showing a completely black screen. What are you talking about? Yeah, they got this like I used to joke around too. This romantic idea that they're gonna meet. A lot of them are just like sort of upper middle class white guys, but the sort of failure to launch. They don't really have any prospects for like a wife and children. They work some like menial middle management position, mostly from nepotism. But they fancy themselves as some kind of like an amazing thinker. Like they should be like running NASA or something like that. Like in their mind, they think this. So their next step is they're going to find green alien chick. That's what they're really thinking. That idea of like a Earth Girls Must Be Easy movie. And they're gonna be like the most like this alien chick is just gonna show all these other Earth girls just how stupid they were for not fawning over this like amazing specimen of humanity. So you tell them, "Oh, dude, there's no space, there's no orbit, there's no aliens," and then they freak out because that's the last thing that's keeping them from what you said earlier. What eating a shotgun. Like that dude, I can't remember whose name. It's like one of those streamers, and he would just get on this like video game. I just saw clips of it on these weird rants about how cool space is, and people are like, "Just shut up and play your game, dude. Like, stream your game. Like, let me laugh at monkey make noise while playing video game with purple hair or whatever." Because like in his mind, he's thinking he's the last starfighter. If you remember the movie, like all these video games are just training simulators. I used to make fun of Eggshells because Eggshells would come in here and stream like Kerbal Space Program. Yeah, I tell them that there's a secret level that if you crack that, NASA calls you up and brings you there. Like a black helicopter just lands in your front and yell on and say, "We need you."
Did they buy it or what?
No, he kept saying like, "That's silly. Like, why do you keep saying that?" And I'm like, "Well, do you know? Do you know for sure? Like, what if they did that? What if the whole shtick was because you just say that this program was developed by NASA engineers, this Kerbal Space Program, and they use it for training and stuff like that." I'm like, "Yeah. What if they're looking for that next the janitor movie, Good Will Hunting? He's a janitor who would just solve math problems on the chalkboard each night." They're looking for that really autistically retarded kid who can play video games but lacks any social skills to like navigate a college environment, or how to even apply for student aid, how to register for classes. He can wipe the floor with that towel and like, clean the floor, but like try to have him do like just interact with normal humanity. He can't. So what they did was how do we find and recruit these people? Let's put secret levels in video games.
Yeah, that kind of reminds me of Mercury Rising as well.
Oh yeah, that's another good example.
I was just thinking about that, man.
Yeah.
They did it in the public school system, though, man. It was called the AIM Gateway Program. You guys ever hear of it?
No, there's another one that NASA has too, but it's not called AIM. It's called I can't remember, like a 4F4 or something like that, or
4F? I thought that was like an agricultural.
oh no, let me find it with Google real quick.
Gateway Program. AIM. It was for gifted.
Oh, N3. It's called N3. A 5-year program that ended just recently. It was a focus on getting people who are neurodivergent scholarships that would be that would filter them into NASA.
And why would they do that?
Well, I mean, that's what they think, that somehow that they're the crack the code. Like, how did all these amazing rocket scientists from the 50s and 60s do it? Well, they must have been all autistic or something.
I thought it was a bunch of black women.
Oh, that were given, that their work was stolen. That documentary on Netflix, like this group of black women.
Didn't they make like a regular movie about it?
Yeah, I
a
think
bunch
so.
of black women actually did all the calculations or something.
Yeah. Yeah, and then like the bathroom was like only like white males or something, so she had like walk like 3 miles to go use the bathroom. Where it was like, because that was during the era of Jim Crow.
Yeah. Anyone that believes that story that someone walked 3 miles to go to the bathroom, that's bull. No one would do that.
Right, not when there's a tree or some bushes over there.
Exactly.
Yeah.
I'm a lady. I mean, this is back then, dude. Not even everybody had indoor plumbing. Like, you know what I mean?
Yeah. I mean, this is a deep South. Like, all this NASA shit happened in the deep, deep South. Dirty South. And they're talking about like, oh, look at these amazing people. What the fuck are you talking about? Right? Like,
yeah, there's a lot of space stuff in the South. You got the Huntsville place, you got the Cape Canaveral, you got Houston, Texas.
it's like if there's some way of getting rid of that sort of ego-driven crap. That crap where they think like somehow we are part of the space program. They'll tell you, we went to the moon, or we done all these things. If you could get them out of that mindset.
Well, I already asked them when they say that. I go, who is we? Like, you're not one of those guys. They don't even know you. They probably wouldn't even talk to you.
Yes, well, like, it's funny too. Like, they have a network. Like, call them up. Be like when they stopped refilling the rocket yesterday. Well, yeah, or 2 days ago, whatever. And they're like, oh yeah, Gunslinger was in here. I'm like, give him a call. Look over the data, look over the stuff. and figure it out. Give them a call. Tell them you know how. You really want Artemis 2 to happen. Tell them how to fix their fueling system.
Hey, can you? I have a question.
Yeah.
Can you please just tell us why the Earth is flat? Like, why do you think that?
Because how flat it is. What do you mean?
Yeah,
Okay, I'll just break it down for you really quickly. Most of the surface of the Earth is water, right? Is that correct?
Yeah, of course, yeah.
Okay. That water's flat, not curving. So if that water's flat and not curving, the Earth is flat and not a ball.
The gravity's holding it down.
Hold on. Even if your hypothesis was true, you'd have to measure that you'd have to go out and get the empirical data that says that is actually happening, right?
Have you ever heard of Isaac Newton and calculus?
Yeah. Did Isaac Newton measure the curvature of the Earth?
He measured gravity.
He didn't do any such thing. Okay.
I think this is a problem of education.
No, I have a science degree. That shtick ain't gonna work, bro.
It doesn't.
Dandelion here is a science teacher.
Okay, well,
you don't understand gravity, so want me to give you the breakdown of gravity and how Newton came up with it? Newton came up with gravity because the universal law of gravitation as a geometric law, because he noticed from Kepler's second law of planetary motion that the elliptical orbits, if there was a force that pointed to one of the foci ellipses, that force would fall off inversely proportional to the square of the distance. And because he noticed this geometrical relationship, this is where the inverse square law comes from. It doesn't come from experiment. It comes from the mind of Isaac Newton noticing a geometry. And he proved it with conic sections. And if you don't believe me, you can watch Richard Feynman, who's a Nobel Prize winner, give a talk. It's called Feynman's Lost Lecture. It's on YouTube, and you can listen to the whole damn thing.
Now,
so you're not the smartest person in the room, and you're not even close to it, okay?
What's the lunar eclipse?
Now, you skated past the problem of, you said, hey, gravity curves the water. Do you have any evidence that that's actually true and not theory? Because if you have a hypothesis that's true, because science is based upon empirical evidence, that means observation, data, measurement, those things. That's the foundation of science. If you don't have any of those, then you just have a hypothesis. So your hypothesis is gravity forms the Earth into a ball. Do you have any evidence of that?
That Earth is a ball.
No, that gravity forms Earth into a ball.
Yeah, do you have any evidence of
Gravity
that? Curving the water around the
Gravity
Earth.
doesn't. Okay. Gravity doesn't form the shape of the Earth. Okay.
Okay,
not
good. That's a good concession. Appreciate that.
But
So the Earth
how
is
about
flat,
this?
and we still have
Switch
gravity.
it up. Let's switch it up a little bit. What's the thing with lunar eclipse?
What
Explain
about
that.
them? What about them?
Show me a picture of a lunar eclipse. I want to see it. I want to know exactly what lunar
the
eclipse we're
Earth-
talking about.
It's when
No. I want a picture.
circle-
Send it to me.
Okay.
Google it and show me the picture.
Can you not Google it yourself?
No, I want you to Google it because I don't think you know what it is.
Hold on, sheepdog. So this is the. You just said because Earth is spherical, it casts a round shadow on the moon, right?
Well,
I got $20, Indio.
If the Earth is
He says
spherical, it'll. Well, yeah, I'm sure he thinks it's. Yeah,
I think
agree.
he's going to send us a picture of a lunar phase and not a lunar eclipse. That's what
Probably.
I think he's going to do.
Probably. Okay.
I mean,
First of
based
all,
on my
Send us a,
they don't.
he'll
Here's
send us a
something you
waning
probably.
present.
Yeah, well, listen. Let me just stay focused with this shit. First of all, what you don't know is that they don't use the globe model to predict when lunar eclipses even happen in the first place. They've been using something called the Saros cycle since 2000 BC, and in fact, the first known eclipse prediction is by a flat earther. Has nothing to do with the globe. Has nothing to do with the shape of the Earth. The supposed round shadow on the moon would be a problem for you, because if the moon's a sphere can't cast a round shadow on another sphere because it has a curved surface. And when a shadow is cast on a surface, it conforms to that surface. If a shadow is cast onto a set of stairs, that shadow is going to look jagged. So if a shadow is cast on a round surface, it's going to be distorted from the curvature of that surface. So there's no way the Earth, if it was a ball, could maintain its circular shape. Transiting the moon, it would actually form an S-curve when it crossed the meridian, which is the center line of the moon. Now, if you or anybody else had actually just taken two spheres and a light source and tested this, you would see that you can't create, there it is in the chat, you would see that you can't create a perfectly round shadow being cast on a sphere by another sphere. So eclipses actually falsify the globe. Well, at least they falsify the moon. That would prove a flat moon or something if the Earth was a globe.
Yeah. So how about the footage from space where it clearly shows Earth?
How do you know it's from space? How do you know where it's from?
It's NASA footage. I mean,
Yeah,
are you
so?
going to try to debunk that? You're going to say it's artificial
What's the
intelligence?
Yeah, wanna know how I'm going to debunk NASA's footage? Because I'm going to go to the ocean and measure that it's not curving.
Well,
let me ask you this. If NASA shows, if NASA shows a picture like the 1972 Blue Marble, and it shows a curving ocean, and it says that the Earth has a radius of 3,959 miles, and then I, as an individual, go to the ocean, and that curvature that they show in the image doesn't actually exist at the ocean, can the image possibly be real?
Well, I don't know if you would do it correctly. I mean, I don't know if you know what you're doing.
I don't know if you would do it correctly. What does that mean?
I mean, you can claim that you can do this, but I don't know if that's true.
That you can measure curvature from the surface of the Earth? You don't think it can be done?
I mean, I don't know. Maybe.
How much do you think the Earth curves?
Well, I don't know the math.
Do you think it's a little or a lot? Off the top of your head. Like if I was like if I was 10 so like 10 miles away, if I'm standing on the ocean. Number one, if I'm 6 feet tall standing in the ocean, how far do you think the horizon should be away? Just off your experience of what you've seen in your life, how far do you estimate the horizon was away from you?
Maybe like 20 football fields.
20 football fields? That would be.
What the fuck does that even mean?
Well, I mean, that would be
feet or 2,000 yards.
That's 2,000 yards.
6,000 feet.
I guess, yeah.
20 football fields.
That's very rough, though.
5,280 feet in a mile. Yeah, that would be about 3 miles. How much drop do you think there'd be? How much the curvature of the Earth do you think there would be in 10 miles?
Quite a bit.
In 10 miles. Well, it's supposed to be 66 feet. So that means from 10 miles away, you shouldn't see a 6-story building. From 30 miles away, it's 420 feet. So you shouldn't see a 42-story building. From like 250 miles, which we do have observations from, the drop is something like 4 miles.
Okay.
So there's supposed to be a lot of curvature. But the fact is, it's never been measured. No one's ever measured it.
You sure?
I'm 100% positive.
No.
In fact, we had Josh in here. Josh works for Amazon. He thinks he's providing internet to the world through satellite. And he says that when we try to bring it up that the surface of the Earth isn't curving, you know what he says? He says that you can't measure curvature from the surface of the Earth. He says it's immeasurable.
Well,
which the math says it is measurable. Easily measurable.
And he also says, I'm trying to figure out why it's not measurable. That doesn't make any sense. That's what he says.
Really? He said that? Okay. Oh, man, you should have been in here earlier, man, because I was beating him on the two-word theory.
Okay.
Yeah, I'm convinced, Nikki, that you don't even know what a lunar eclipse shadow looks like.
Well, it's the Earth's shadow covering the moon.
How do you know that?
Like that's what we've seen one.
Show me.
Yeah.
I want to see what the moon looks like.
The moon? Well, it's the gray ball in space.
Yeah, I want to see what the shadow looks like during the lunar eclipse that you're claiming.
Look, dude, I have to ask him. If nobody told you that the moon was a gray ball in space, would you have thought of that yourself?
What do you mean?
If nobody told you that.
I can just look in the sky, dude.
Yeah. No. You can just look in the sky and see the moon, but to reach the conclusion that that's a gray ball in space. How did you reach that conclusion, other than being told?
No one told me that. It's mainly
no one told you that.
Eyes.
So, like, when how old were you when you first saw the moon?
I don't know. Probably
5 or 6, maybe. Think 5 or 6?
Yeah. Maybe.
Did you think it was a gray ball in space when you had no idea what the concept of space is? Yeah, so it falls apart instantly. You had no idea what the concept of outer space even was. You just saw light in the sky.
What does it have to do with the moon? About being a gray ball?
Yeah, it doesn't look like a gray ball.
I mean, that's like the simplest way you can describe it. But I can go.
No, a circle. They actually call it in the scientific literature the disk of the moon.
Well, like a sphere is like a ball, right? So.
Yeah, a sphere is like a ball, but the moon, according to them, is so far away, you don't have any 3D information called parallax. So the moon just looks like it's a flat disk very far away. You don't see it from different angles. No, I don't think. I said looks like.
I mean,
looks like a flat disk. That's how it looks because it's so far away.
Yeah, but you could see different sides of the moon depending on the time.
Well, that's crazy because the globe says the moon is tidally locked so that the moon faces the Earth at all times. You can't see the sides of the moon.
But you see whatever is presented to you.
You only see the same face every night.
Yeah, the man on the moon, dude. The man in the moon, rather. See, that's an indication that the moon's not a sphere. So I will grant it to you. There are indications that the moon looks like a sphere, but there's also indications that it's not a sphere. So spheres have things like specular reflections. The moon doesn't have these. Spheres have what was I just mentioning? If it's a ball, it should be rotating, but it doesn't appear to be rotating. We don't see the other sides of the moon. We don't have any parallax, meaning we don't.
You can't see Earth rotating. I mean, it's like we move so fast.
It's not rotating.
Yes, it is, bro.
Okay, what's your evidence the Earth is rotating? Yeah, what's your evidence the Earth is rotating?
Well, basic science.
That's not an answer. That's not basic science. Is not evidence. I can't go into the lab and go basic science.
Look, okay, the average person like me learns that these basic things from a textbook, and then we don't actually go outside and try to measure it. So maybe I'm not like you, right? try to measure these things because I don't have to. That's a waste of time. I already know.
Why is it a waste of time?
What's your goal in proving the Earth is flat? Like, what are you going to?
It's already proven that the Earth is flat. I'm not trying to prove the Earth is flat. I'm trying to enlighten you to the fact that what you've been told in the textbook is actually not the case, and that we also read the same textbook and read the same claims, and then we're like, we're not like you. We went out into the real world and checked, and now we're telling you, hey, bro, we checked. That shit in the textbook is bullshit. And you're here defending the textbook against us, even though you have no idea what the evidence is for what's in the textbook. We do know what the evidence is, okay? And based upon the evidence that we've seen, which is a lot, because I've been doing this for almost a decade now, there's no evidence the Earth is a globe. It's only a bunch of cartoons on fucking TV. And I know that's hard to your mind to fathom, that it's just a bunch of bullshit. But the Earth, if you go check, you'll see, if you go try to measure the Earth and you check it against the dimensions they say it is, it cannot possibly be that. And you could just say, well, maybe it's just larger Earth. Maybe it's just larger Earth and it just looks flatter than it really is because it's just larger. Well, then the moon would be farther away and it would be larger and the sun would be larger and the sun would be farther away and all the planets would be larger. Like everything falls apart if the size of the Earth is not correct.
But how about when you go up in an airplane and then you can actually see the curvature?
No, you can't.
I've never seen it
I was
from
in
an
an airplane on Thursday. Literally on Thursday, I was in an airplane. Okay. There's no curvature there from an airplane.
That's the thing.
47 or 37,000 feet. Look, you can't see curve from an airplane. It's nowhere near high enough. How much, like, let me ask you this. The International Space Station, from the height they say it is, how much of the Earth as a percentage would it see? It's 250 miles up. Airplanes fly at 10 miles.
I mean, I'm already looking at images and I can see people taking pictures of the Earth's curvature, bro.
From where?
Google, and they're not fake.
From Google? Where's that? I've never been there. From where are they taking the pictures, dude?
From an airplane window.
From an airplane window.
Mm-hmm.
So the ISS would see 3% of the Earth. So you think 25 times lower, they're going to see curvature.
I mean, is that not curved? Like, that's just totally... I mean, look, let me send you this one. This is like... I don't know if you're going to say this is a fake image, but just look.
A fake image. Let's see it. Are you DMing it to me?
Oh, I mean, I guess I have to. Let's see. Download it real quick.
I'm sad for you because I know what you're gonna send me. I'm gonna have to cook you on it.
Okay, cook me. I mean, I don't know.
I don't want to, but listen. Even admitted in mainstream science, they say that even 128,000 feet, which no airplane can even fly at, is not high enough. That's mainstream says that.
And what are these pictures from?
Think about it for a second. 10 miles above a ball, 8,000 miles in diameter. Just think about it for a second.
What do you think about
8,000 miles in diameter? You're 1/800th above the surface.
What do you think about like Neil deGrasse Tyson trying to debunk?
He said from 128,000 feet that stuff is flat.
Where do you think we got that from?
I'm just saying in general because I've seen some of
Post
his
the
stuff.
plane image.
Well, I don't need to. I mean, if you're gonna try to disprove it, then Just go ahead, but I don't think it's
I
possible.
mean, the geometry disproves it. Okay, the geometry of the Earth disproves it. It's not. It would not be possible.
I would think a flat Earth person, a person that believes the Earth is round.
I don't believe, dude. You believe.
Thinks that like there's different geometry. So like a spherical Earth geometry does not match, obviously, the flat Earth geometry. And so
There is
like,
no
what would
spherical
you-
Earth.
Okay.
What are you talking about? There is
I
no
was-
spherical Earth, brother.
If I was an 8-year-old child and didn't know any better, how would you tell me the Earth is flat?
Say, go outside and look.
Look at what?
The Earth. Climb a mountain, climb a hill, find an airplane, go to the ocean.
And what are they going to look for, though?
You know, when I was
Whether
8 years old,
the Earth is curving or not. I mean, geez, man.
When I was 8 years
what are we
old-
talking about here?
my
Yeah,
teacher
well,
told me the Earth was a globe, and I looked at her and said, "But it doesn't look like it's curving." She said, "That's because it's too big and you're too small."
Yeah, don't forget, you gotta climb a tree.
The Earth is too big for you to notice a curvature if you're just standing on land.
So you know it's flat.
Yeah, just climb
Well,
a
you
tree,
said-
bro.
That's
Well,
just
why
not-
would you think? Hold on. Why would you think, even though you observe a flat Earth, it's actually not that?
From a human perspective.
Yeah,
on
you can
Earth-
rationalize why you're hallucinating a flat Earth. Yeah, we can rationalize. Maybe it's a giant freaking porcupine. The porcupine's big enough it looks flat. Yeah, that's great. You can imagine all sorts of things, situations where it would still look flat. But why are we doing mental contortions? Maybe it's flat because it just is flat. You know what's flat? Flat things.
Unlike Earth.
You're just chanting now. You're like, I'm sorry, but we also know the properties of water. We level things with water. Why? Because we want to make them flat. So I'll give you another example. I'll give you a perfect one. Okay. And I already know what your response is going to be. Earth too biggie. That's what you guys all say, but it's actually not too biggie. You know what the Bolivian salt flats are?
No.
Okay, the Bolivian salt flats are a salt flat, and every once in a while it rains and it fills up with 1 to 3 inches of water. And it forms a gigantic mirror across its surface. I mean, a gigantic mirror. A mirror, there it is in the chat. A mirror that's 30 miles freaking long. Now, you've been to the fun house, right? Or you've been to a store where they have a convex mirror in the corner?
Sure.
What does that do? It distorts the reflection, right? Now, if the Earth is a convex surface, like a ball, it would distort this reflection because there's something called the law of reflection. So the angle of incidence equals the angle of reflection. If a ray of light hits it at 45 degrees, it bounces off at 45 degrees. So if you have a flat surface that's reflecting things, the reflection will be perfectly symmetrical with the thing being reflected. If it's a curved surface, it will not be. Now, you could say the Earth too biggie, but in fact, it's actually not too biggie. And you would actually notice within 700 feet, according to the mathematics, the distortion of the reflection. And in fact, if you were at like 70 meters above the surface and you saw a sunset on the horizon here, you would not see the reflection of the sunset because there's actually no optical path for the sun to reflect off the water from which you would see it.
Okay.
So we know just from this reflecting surface that the Earth can't be a globe. Unless this is freaking a flat spot.
Yeah. I'm not going to disregard what you said, but I'm just going to ask a question.
Yeah,
What
go
if you went to space and then you actually saw Earth as a round globe?
Well, if that happened, that means when I'm done going to space and saw Earth as a ball, I could come back and measure curvature.
I'm just saying, like, would you be surprised?
Yeah, would I be surprised? I'd be surprised to get me into a fucking rocket in the first place. That would surprise me.
Well, yeah, of course.
The point is like you're asking, hey, if I see the Earth as a ball from out in space, would I accept that? No, I deny my own eyes. Listen, every day, what you're asking me to do is go to space and look at the Earth and see it as a ball and accept it. While every day you see the Earth as flat and you don't accept it.
Because it's not true.
Because every day of your life you've seen the Earth as flat and motionless and you don't accept it.
You know why?
Hey, Indio, can I ask
I want to tell you why. Let me come up with a convoluted excuse on why I'd go onto a rocket and see the Earth as a ball and not accept it. Would you accept that from me? Why am I supposed to accept that shit from you? You see how you have a double standard? Your bias is showing, dude, that you want me to do something that you won't do yourself.
I mean, I would if I could. You know?
Do what?
Go to space.
First of all, that in and of itself is a belief system. That the idea that you can even go to space, it's see the Earth in its entirety. That is a belief.
I mean,
a story told to you by other people that you have no way of verifying, that you have to just trust what they say, that you can go to magic place where things float around and I can look at the Earth in its entirety. That's a belief. But that missed the point. What I asked you is, what I said was, you observe the Earth is flat every day and you don't accept it. But you want me to go to space and observe the Earth from there and accept that. You don't accept what you're doing now. Why should I accept your hypothetical when you won't even accept reality?
I mean, you know, when we're spinning around so fast.
We're not spinning. There's no evidence we're spinning, bro.
We're moving at a constant speed. And gravity's
No, you're not.
pushing us
Spinning is
down.
an acceleration.
And so that's why you can't.
Spinning is an acceleration, brother. If you're on the surface of a ball, spinning, right, you are accelerating, because how else would you change direction?
I mean, is the Earth not accelerating? I mean,
The Earth's not moving at all. The Earth is motionless.
why does the Earth spin? Let's see.
Okay, listen,
Inherited
brother.
angular
Let me give you
What
the
made it
evidence.
spin to begin with?
Hold on. Let me give you the evidence that the Earth is motionless. The Michelson-Morley experiment detected no motion to the Earth. The Aries failure experiment detected no motion to the Earth. The Rebbe-Compound experiment detected no motion to the Earth. These are all experiments that were done that detected no motion to the Earth. This is why general relativity was invented, because they couldn't measure the motion of the Earth. Do you understand? General relativity was a patch for the fact they couldn't measure the motion of the Earth. They don't tell you this in the textbooks. See, there was a guy named George Biddle Airy. He tried to detect something called stellar aberration. So he looked to his telescope, and because a telescope has a different refractive index with water versus air, he looked at a star through air, and then he looked at it through water. And if the Earth was in motion, there's something called the Foucault effect. The Foucault effect, because they have a higher refractive medium, would have moved the star in the optic of the telescope if the Earth was in motion, because the Earth will be the star light will be deflected into the direction of the motion because of this effect. Now, they didn't observe it. The freaking same star was dead in the crosshair. So they're confused about this. So they tried to measure the motion of the Earth through the ether, Michelson-Morley, and they did it interferometer. And they got a very low result, a low enough result where they called it a null, where they measured no motion to the Earth. The Rebbe-Compound experiment dropped a freaking, I think they did a vertical version of the Michelson-Morley experiment, and also detected no motion. We're not saying there's no motion because we're just making it up. The experimental evidence says that there's no motion.
Did we lose him again?
Oh, he bounced.
He might come back. He was having connection problems. He
was a good rant, man.
I know, it was great. I heard you. Yeah, I mean that was Yeah, that was a great explanation of those. I haven't heard you talk about. If I have heard you talk about those, it's been a long time. So,
Let's
yeah,
save
that
that
was
for
some
Rex.
good.
Yes.
That was good.
But if you went to space and you saw the Earth move, would you believe it?
You know,
I love that. How you? Yeah.
I should have brought this up. He said, well, then I'll have two data points. I'll have a flat-looking Earth and a globe-looking Earth, and I'll be with my two Earth theory like Josh.
Well, that's a good point. 2 points. There only is 2 points. Because he basically said the only people who know the Earth's a globe are the people that have left the Earth and have seen it as a globe. And that's only 2 people that are alive, supposedly. Only 2. That's it.
And one of those people
would be,
lost the debate really badly.
Yeah, but isn't that Buzz and Neil, right? They're still alive. So probably within a decade, there'll be nobody alive that knows the Earth's a globe. Nobody.
No, they're sending up their
Better hurry up,
replacements
kids.
on the 8th or something,
yeah.
right?
Yeah, they gotta tag your it.
Well, I've been thinking about, like, I mean, I think you were in here or in one of the chats when we were talking about this, is like the people that came up with the moon hoax, they're all dying off. Like, how are they going to keep it going? No one has any motivation to keep the lie going. So I guess they must have had a plan to, like, as soon as, like, the last guy dies off, like, you know, I bet you that the last two, one of the last two dies off on the day they go back. And they make a big hullabaloo. That'll be something that'll, like, really drill the propaganda into people's brains.
But I gotta like
Stunning
take a sip.
coincidence.
Take a sip
The
of
last
whiskey.
Apollo astronaut died on the day we finally went back to the moon.
Yeah, and then they'll take a sip of whiskey on the moon and then drop one for the homie.
Oh yeah. In honor of astronaut so and so, we are gonna play one round of golf.
If Earth is flat, why won't the sea leak to space and evaporate fully?
Say that again.
If Earth is flat, why won't the seawater leak to space and evaporate fully in the vacuum?
Because outer space is fake and the air is
Okay, somebody's
contained,
laughing, I'm leaving.
it has to evacuate into a thing that doesn't exist. That's why.
No, it's just ironic. That's all. Oh, bro, don't be a.
Wait. You're
snowflake.
saying space doesn't exist?
Yeah, we don't think that the Earth is a disk in outer space. That's not what we're saying.
You don't
Yeah,
believe that
so if
there is
outer
vacuum
space-
outside the space in the space?
If outer space doesn't exist, there's no vacuum for all of the air and water to rush off into.
Well, yesterday when I asked about seawater, why doesn't seawater go outside the Earth and stuff? Somebody here who was a moderator told me, yeah, outer space is like a vacuum, and inside the vacuum, water evaporates immediately, and I don't know, stuff like this. So,
Yeah, that's the story, right?
but you're saying there's
The
no outer
story
space
is
right now.
that the sphere Earth is surrounded by a vacuum, right? But in reality, when you have water in a vacuum, it evaporates. Yeah, that makes sense. So
Yeah, okay, but
outer
why doesn't the
space
water
doesn't
evaporate?
exist because outer space is a vacuum. You have water on Earth, right? So there's no vacuum.
Yeah,
Because
but
in a
why
vacuum,
water on Earth? But why doesn't the water in the edges of the flat Earth leak and go like fall?
There's a misunderstanding.
It's fake. So there's no
Yeah,
disk in outer space. You're inside of
right.
a
There's a misunderstanding.
Yeah.
Clear it up for him.
Since outer space is fake, there's no disk in outer space, so there's no water falling off and leaking into outer space. It's a contained system. Water's contained, the gas is contained, there's no vacuum.
What are the stars that we see at night then?
They're lights, and I don't know what they're made of, and I don't know what they are. I don't know how high they are. I know that they're there because I look and see they're there.
Oh, I think that was too much for him.
I broke the script, and he doesn't know what else to say. Damn. Leave.
Yeah, I have a question too. So, like, if gravity is supposedly holding or creating the container, why can't it be performed on Earth, like on the surface? Why can't they reconstruct that experiment?
I don't know.
You'd think they could, right? So they could have like a significantly sized vacuum chamber and just insert the tiniest little bit of gas into it, right? And it should all just like settle at the bottom.
Yeah, like
and do what?
Gravity's stronger the closer you get to the Earth, right? That's where so it should be easier to create a container using gravity down on Earth than it would be closer to space.
Right. So I think that they'd say that like so the kinetic energy that the gas has, right, is they can't though, can they? So they're saying that the kinetic energy the gas has at the surface is greater than the gravitational influence. I will say.
Yeah, that's how you have evaporation, right?
Right.
Yeah.
Because a gas molecules moving at how fast is it? Like 500? Is it 500 meters a second or something like that?
Way more than
Gas
that, man.
particle?
Thousands.
More than that? Oh, thousands. Okay. Well, yeah, I'm way off. There you go. Yeah.
It depends. It depends. I mean, like if you cool down a gas and you see it clumping together like in a sink, like let's say you take frozen oxygen, plunk it in your sink, and you watch it sublimate or something, you're going to see it go from a solid state to a vapor, and it's going to bypass the liquid state altogether instantaneously. And as those molecules heat up, I mean, they're just going to go faster and faster and faster until they equilibrate with the environment. So when it leaves your sink, they're not going to be moving very fast, but if they're allowed to continue to heat up, they're just going to keep going and zooming. Like, you won't be able to see them.
Right. So I guess they're saying that so the gas's kinetic energy is very great, but as it ascends, it gains potential gravity energy. Right?
Yeah. I don't know what to call it. I'll go with that too, man. What do you call it when you pick up a rock from the ground? You lift it up high.
Yep. Potential energy.
Yeah. The rock isn't moving and you're holding it. You're holding it. And they could maybe like set it on a shelf and the shelf is now holding it. Mic check. Am I coming in? Was I just getting cut off there?
My shit made me jump out also. So I think it was Discord.
Okay, so I was saying, like, people ask how does an apple fall from a tree? I was going through the process of, well, somebody takes seed, the seed turns into a sprig, which turns into a tree, the tree grows, and then it bears fruit. The apple literally came out of the ground. and was lifted up. And then when the apple detaches from the stem, it falls back to the earth where it came from. So the cycle's complete. But people don't think of energy like this. They don't think of the transfer of energy in these terms at all. So, like, if you were to pick up a rock and you were to place it on a shelf, maybe on a ledge, and a guy a million years later came and saw the rock on there, knocked it off the ledge, and it fell to the ground, he would have no idea that that rock had all the potential energy built up from what was required from somebody a million years prior, expending heat and calories to pick up that rock off the ground and lift it up, increase its energy state, and stick it onto a shelf. People don't think of gravitation in these terms. And I'm old enough to remember when that's how it used to be taught in school, honestly. I mean, it's not saying that we know what it is. Nobody's attributing like space-time or mass attracting mass causes. It's really just an exchange of energy.
Yeah, like an elastic band, but without the elastic material.
Yeah.
Yeah, basically nothing moves, right? Nothing falls without some type of energy exchange, some type
That's
of
right.
it has to be forced out of its natural state of rest by some sort of energy exchange, essentially.
There's
That's all
still
it
like
is.
there's people still looking at it as a mystery and coming up with alternatives to what's been presented over the last couple of hundred years, right? Or few hundred years.
Yeah.
I mean, I just read an article the other day about it. They're considering it to be more of an entropic effect, right?
Love it.
Like there's just all these different ideas about it. They're still throwing it around, like like it's a ball to be played with, right?
Yeah. Yeah, I mean it's funny that they call it an entropic effect when currently when it's been described by people coming into our Discord as a negative entropic effect. It's reversing the entropy of gas molecules. Which is funny because gas molecules
It is
expand
ironic.
without work, right? It's like saying that picking up the rock and putting it on the shelf was done without work. Gas molecules expand from the source without exchanging energy with the environment.
Gosh.
Think about that for a minute. So it's not analogous. Like when the sun releases like UV light and it slams into a rock and the rock chirps off some kind of nitrogen molecule that then like flies up into the air. Is that the same thing as picking up a rock and putting it on a shelf? Well, the funny thing is gravity doesn't pull down on that nitrogen molecule. But it does pull down on the rock. The nitrogen molecule expands without expending any energy into its environment, without that exchange. But the rock that you pick up absolutely does. So it's weird, man. Like gas molecules are weird. Unbonded matter seems to obey a different set of principles than solid matter or bonded matter. I mean, they call it the different
Yeah.
states of matter, right? So the different states have different principles that apply. Go ahead, T-Dub.
Well, it's just I was listening to Richard Feynman speak, the other day, and though he's advocate for the idea of gravity, blah blah. Even though he'd probably tell you at the end of the day, hey, look, I got no idea what it is, right? But he was talking about the electromagnetic force. He's saying how intricately that is, inside everything, right? Like, and it's like dictating everything. He's like he really loved that force, and he's saying it dictates our reality. He was saying like everything's held together by it, everything or other things are repelled by it, right? Like he's during his little speech on it, on that, he wasn't discussing gravity. It was like gravity took a back seat, or wasn't even invited to the party. You know what I mean?
It's funny. That's true. He is like that, and a lot of engineers and scientists seem to have that same sentiment. I mean, I happen to know quite a few engineering graduates from Rensselaer Polytechnic, and one of them was telling me that anytime gravitation or gravity was brought up on any of his exams, you just ignored it. Ever really thought about it like that? He was an aerospace engineer, and imagine that. Imagine being an aerospace engineer. Imagine taking graduate level engineering exams and not considering gravity to the extent that people do here when they come in and talk to us.
Well, I guess in that field, you're really only concerned about the effect, in the environment that whatever you're building is going to be operating within. I guess you're not really concerned about overarching, cause, right? You just want your device to operate correctly and safely as possible.
Right.
And you really only need to be concerned about the effects. As long as you understand what's going to happen to your device within a specific environment, that's all you need to really account for, right?
Yeah, you could consider gravitation as an effect, as the phenomenon that's observed, and we don't know the actual cause. But what it does describe is a statistical distribution of density, which is not necessarily related to the atmosphere. Because you can't predict, you can't take the inverse square law, apply it to what the mass of Earth is supposed to be, and then predict how much the atmosphere thins out from the center of the Earth to the surface and the surface out to space. Because what we observe in this gradation, this thinning out of the air, does not comport to the inverse square law at all based off of the mass of the gases as it's currently understood. And the ad hoc rescue devices, well, it's a dynamic system, the Globers will say, and they sound like us, and be like, yeah, they're at different regions of the atmosphere, you have different effects happening, and at some point you get to the thermosphere where suddenly it gets hot again. It was warm at the surface, and then it got extremely cold, and then it started getting warmer again. So you have a real mess. You have this non-uniformity of everything stretching from the surface all the way up into whatever does not comport to the inverse square law at all. What I find funny too is when they say that, well, the gravitation of Earth allows you to accelerate tangential to a supposed curvature of the Earth. As long as you move in one direction fast enough from a specific height, and your speed your velocity according to that height, you're going to be falling forward. Your gravitational vector is no longer inward towards the center of the Earth. It's going to be tangential to the curvature of the Earth.
Yeah. Yeah, where's the satellites that are, that are orbiting against the rotation of the Earth?
Yeah. So what about all the gas molecules? They expand in all directions. They go this way and that way and all over. Let's say you have a source of gas production from the surface, as it's currently known. It's where gases are produced on the surface of Earth. Got a bunch that are going to be flying somewhat tangential to the surface of the Earth at thousands of meters per second. Are they going to be doing geodesic arcs? Well, then, the Glober would say, well, yeah, they will until they collide with other gas molecules. And here's what's really funny. I'm also old enough to remember being taught that gas molecules are so small that the chances of them bumping into another gas molecule is basically infinitesimal. Such as, you don't even have to consider it in most circumstances, except for, very specific cases, laboratory conditions, and things like that. But in nature, you're not going to expect it to happen. But nowadays, you read about gas molecules and it suddenly feels like it's a bumper car full of 10-year-olds just slamming their cars into each other on a track, every which way in that. And this is what prevents their own claim holding consistently of gas molecules no longer traveling in straight lines linearly, but taking geodesic paths. Before we don't have a chance to falsify that because it's going to collide into another gas molecule. So they make their own claim unfalsifiable by now saying the gas molecules are bumping into each other like 10-year-olds in a bumper car track. That, 30 years ago, they weren't saying that in school when I was young. They weren't saying that. They were saying that space is so far spread apart and the atoms, the molecules are so tiny, the gas molecules in the air never even know each other exists. Just passing by each other. So, it's funny to see the narratives change. You live long enough and you start to see these changes. When I was young, NASA images were always composites, artistic renditions, and everybody knew that NASA was a big art house. And somewhere around, I would say maybe the mid to late 90s to early 2000s, with the last of the space shuttles and the beginning of the ISS, things started to change. NASA stopped putting these captions underneath these images. I mean, I was a big NASA junkie growing up. We lived in a NASA household. I've got postcards from the Houston Space Flight Center from the 1980s. I got family members that used to work in astronomy, radio astronomy, satellites. So it's just really interesting, man. I was locked into this. I remember being young, dude. I remember when they said that the first image of Pluto was coming in. Maybe it had already come in by this point. I hadn't seen it yet, but regardless, it was brand new when I remember this happening. And I remember thinking to myself, I was already skeptical, NASA being a big, gigantic art house. My mom and dad would talk about this and we'd bicker back and forth. My dad used to think like I do, if you know what I mean. My mom was the one who was connected to NASA and in working capacity at one point. But remember thinking, wow, wouldn't it be funny if like somehow Pluto the dog like found its way on the planet's surface of Pluto when they show us the image? And then I looked at the image. It was like in like a Sky and Telescope magazine or something. And then I turned the page and there it freaking was. I'm like, you gotta be kidding. It's a silhouette of a freaking Pluto dog on Pluto. You gotta be kidding me. You know, I was in my teens or something. I remember looking at that and I mean, I was like, this is just stupid. I still believed in outer space. I still believed in the Big Bang. I still believed in satellites and astronauts and space shuttles and all that stuff, the moon landing. It was all near and dear to my heart. But I was like, what the heck is wrong with these NASA people, these artists? This is just not right. Like, you guys, NASA, you got to hire some more honest artists because this is terrible. It's so on the nose. And then fast forward on like 15 years when one of the blue marble images of Earth came out with the clouds that had SCX written in the clouds, just like what happened in Lion King, which I think came out a few years prior, the movie with the SCX with the leaves.
Right.
You know, I'm like, oh my gosh, this is so stupid. You guys, again and again, and my belief started to crack at that point. But
And it seems like a recurring trend. I mean, we like around holiday events, and we get images released from the space agencies, like Halloween. Oh, we just happened to find this skull-shaped galaxy. Like look at or nebula or whatever. Like, look at this quasar that's emitting light like a Christmas tree.
Wait,
Right,
didn't they
right.
say? Didn't they
Jack-o'-lantern of,
say
like, the
Uranus? Didn't they say Uranus stank or something like that? It had like smelled like gas, like farts or some shit like that. I remember reading about that.
yeah, that it smells like
Yeah.
Methane or something.
Yeah, they're literal
Smells like farts.
of
Yep.
Uranus that open up like sulfuric fart smells. Yeah, like oh gosh,
Yeah.
It's gotten worse over the years. I got to
It'd be
say,
like if
peak
they-
NASA was the 1980s and early 90s, and it just got worse.
Right. It'd be like if they turned around and said, like, scientists have just discovered that Saturn's rings actually contains a lot of gold, and ironically enough, embedded in it is a giant diamond.
Oh man.
If you ask the internet the question just right, you can get it to say that Jupiter, Saturn, Uranus, and Neptune rain diamonds.
And now, like, black holes are
they what?
hairy.
Oh, yeah, the hairy black holes.
It just keeps digging further into the barrel of degeneracy. It's unbelievable.
Well, didn't like Walt Disney and they had like Satanists like Jack Parsons, like didn't they have a what was the Nazi, the German, his name escapes me.
Von Braun.
Yeah. Didn't they have like didn't like Walt Disney have a lot to do with NASA, right? Or did I read that wrong?
Disney and Von Braun were best buddies.
And then you had like Jack Parsons, who was like a known occultist who was like known for doing like sex rituals and followed that Thelema.
Friends with what was his name? Friends with the
Aleister Crowley.
Crowley. Yeah, thank you.
Yeah, Crowley. Yeah.
Impregnate a woman. Like
on the blood moon.
Yeah. Oh, jeez, dude. It's so sick. I mean, that's why JPL's called Jet Propulsion and not Jack Parsons Laboratory, as it was originally named. They had to divest themselves a little bit from that. Yeah, but they still retain all their freaking weirdness.
Another thing I always found interesting was the fact that NASA, like, so when they do their countdown, they would do like the T minus, they like T minus 10, 9, and then like, if you add T to NASA, it would spell Satan. I always thought that was kind of weird. Maybe it's just coincidence.
Yeah. Yeah, they minus the T. Yeah.
Tsukuyomi in the chat seems to be interested. Asking questions about the sky and the luminaries in general. It's a mystery, man. I don't know if he's listening, if he can hear us talking, but if not on here on YouTube.
He wasn't in the BC. He just didn't open his microphone.
Okay. I mean, for everybody else, I mean, my personal take is the sky is so beyond our comprehension. You really have to scale it back. Like, you have to scale it back. No, the moon landings didn't happen, so we didn't go there. No, we don't have Voyager space probes going out beyond the solar system. That's not true either. Scale it back. Scale it back about 100 years. There's a starting point to scale it back further. We don't know anything about these things in the sky at night. The celestials, what their distances are, what their composition is, how they manifest, or anything like that. We don't know if the way they manifest is completely observer dependent or not. If there's a medium, an exotic medium up there that is responsible for its apparent observer dependent behavior, or if it's medium independent and has more to do with our perception, the interplay between the biology of our eyes and our brains.
We're in
We
a
don't
video
know
game,
if,
bro. We're in a
huh?
video game on some kid's computer in his basement. This is all in the Matrix.
Flat, if that's the case. You know, people say that they can use the stars to navigate by, but to what degree of accuracy and how do you validate it? Do the stars like Polaris really shift 69 miles per degree? Is that the same everywhere? Is it symmetrical? Is it asymmetrical? How do you account for the distance when you're in the middle of the Pacific? 2,000 miles from land in all directions. 4,000 miles from land in all directions. How do you even begin? Oh, you're going to use GPS? Well, that's circular logic. Go ahead. Someone open their mic. You know, we use the sun to account for time. Universal time, UT. You have what the sun does when it goes from one point in the sky and returns to that same exact point in the sky after about 365 days and some change. You've got clocks. you've got really precise atomic clocks, like your microwave. Your microwave clock keeps time to like the 10,000th decimal of a second or something ridiculous. And the sun seems to be less reliable, is more variable than your microwave clock. Every now and then you'll catch a glimpse of this. You'll see it in the news, like, oh my gosh, is Earth speeding up in its rotation? Is Earth speeding up in its revolution around the sun? What is going on? I'll make a big deal out of microseconds or nanoseconds, whatever. Maybe more variable than that.
It's okay. When their clock starts getting off, they start saying things like, well, the tsunami caused the Earth's rotation to go backwards a fraction of a second. Even though nobody knows.
They'll say that, but here's the thing. I think, and I may be wrong, somebody please correct me. I think they actually take their atomic clocks, which are, I would want to believe are super accurate, but there's some reasons to believe that they may not be, due to like electron orbital decay or whatever. Assuming that they are extremely accurate, I think they actually correct them for the sun. When there's a discrepancy between the atomic clock and the sun, they refer to nature as the true reference, and they adjust their atomic clock back to match the sun. I mean, for practical purposes, it would make sense to do, right? Because if you were to let the discrepancy ride out long enough, you can't correct the sun to the atomic clock. Eventually, you're going to have the clock like showing it's morning when it's midnight. So, yeah, they adjust their atomic clocks to the sun. I don't think I'm wrong about that. UTC versus UT1, I think is where it is, and this gets into the equation of time. How we keep track of time. Yeah. If the sun is variable and if the clocks are variable, then do we have any accurate accounting for time? When you start looking into relativity, reference frames are all observer-centric, relative. There's no absolute time either. There's no absolute frame of reference. There's no absolute frame of reference for you to conduct celestial navigation, which requires time. How do you do longitude without a clock? There's no absolute frame of reference, therefore, when looking at the stars without a clock and just recording their angles. Everybody sees a star in a consistent but unique position relative to them. Just like looking at the sun's reflection off the water at your feet.
Bro, this server, what?
Hey, look, it's a dude with a freaking like GTA 2.0.
Yeah, bro, I'm
Avatar.
CJ, bro, Carl Jensen.
Wow. Do these guys listen in and like to butt in right at the most opportune time? I don't know. Sure seems to be, though.
I'm Donald Trump, and I approve this message.
This guy basically joined the server last week. If you guys don't make judicious use of the notes section for users, I recommend doing it. Take 5 seconds, click on their profile, add a note, date the note, date it. You'll never know when you see it again. And you'll be glad that you did when you do.
Oh, I haven't been dating it, but I've been just putting in a really basic profile, like visitor, speaker, noise bomber, whatever, just little. But I don't always do it, but I've been trying to do it more regularly.
Yeah. I started doing it a couple years ago, and it took a long time, but it's starting to pay off. Okay, we got somebody in the chat, Surreal791. UTC is based on 0 degrees longitude, Greenwich, not the North Pole. Yeah, I'd imagine so, that it's based off of Greenwich, not the North Pole. I don't know why you would think I would think it'd be off the North Pole. Longitude is more or less a function of time. And it's not based off Greenwich, so Surreal791, it's based off of the time that the sun is at its zenith over Greenwich.
How do they decide what's the eastern and western hemispheres?
I would assume
it's east and west of Greenwich.
Yeah. And then plus the way they have made the 2 lines in the sky to identify the 4 quarters of the sky, where the line the stars pretty much make a straight line, and then wherever that is associated with Greenwich, that would be the east and west. So if Scorpio is over Greenwich, then east and west of Scorpio, respectively.
I remember watching something about, I didn't fully understand it, but apparently our tropics are misnamed, that they shouldn't be called that anymore or something. That's from a time in the past when those circles coincided with those constellations, but they no longer do or something. So Capricorn and Cancer's incorrect.
Oh yeah,
but we still call them that.
Bill Nye explained that in one of his videos back when we were kids. I remember that.
I like the idea that it's based off of maps that might be 12,000 years old. Because it's going to be when the sun rises in the east on the equinox, in whatever constellation it was at that particular. Was it based off the equinox? It'd be based off the solstice. Excuse me, duh. Like the sun rising in the solstice. 90 degrees, not 90, well, just off 90, this would be like whatever degrees that would be. 90 minus 23.4. So you're looking
if I remember it being described, it would be
the sun is in that
summer in Alema,
Cancer,
and the constellation that sits in that spot. That's the identifier. And so it's shifted over, I think it's a 2,000 year span.
Is it 2000? Okay, so maybe thousands of years ago, the sun used to rise on the solstice and be where the Tropic of Cancer would be at that particular point. And it's no longer the case.
I'll see if I can find the video.
And the same with the Capricorn. There's so much I got this great book, and you guys have probably heard of it too. The Maps of the Ancient Sea Kings by Charles Hapgood. If that name rings a bell, it's because he did all this research into old maps and found that Christopher Columbus took maps, which he got from the Sultan of the Ottoman Empire, who had just recently conquered the Byzantine Empire. So the Sultan got his map from the Byzantine, the Eastern Orthodox Christians. So he basically, Christopher Columbus was working off of Roman maps, Eastern Orthodox Christian maps that had mapped out Antarctica, parts of the coastline of Antarctica, as well as parts of Brazil. And it was validated by the U.S. Air Force, like, mapping agency. Some colonel, like, he wrote to Air Force or something, and Air Force wrote back. And they got all these letters in the back of the book, their correspondence, saying, yeah, it looks like it could be true. It has to be true. Some of these maps from deep ancient history are pretty mysterious. Maybe somebody went there at one point and surveyed it. So these traditions, I mean, they would use celestial navigation. So the Tropic of Cancer and Capricorn probably just kind of stuck from whatever age that was. Probably goes back to the Phoenicians, whoever they were. Somewhere in New Hampshire, there's like a serpent mound. There's like, they call it the Stonehenge of North America in the state of New Hampshire. They believe that it was a Phoenician settlement from like 3,000 years ago. Yeah, crazy stuff, guys. I almost think that North and South America might have been one of the biggest secrets that all the kings and the upper class, the aristocracy of ancient empires knew about, but never really talked about. Like maybe this was a place you could go to get away from your empire. Kind of like a Bohemian Grove.
You also have Jekyll Island being a Canaanite island.
Oh, I didn't hear about that. Yeah, the Canaanites are related to the Phoenicians. Right.
Yeah, and over the, I think it's the dining hall, or underneath the dining hall in the basement was an altar. So, where the signing of the Federal Reserves happened was over a Canaanite altar.
Now, all these Epstein files have come out, which I would love to talk about as much as it's off topic, though. The ancient demons of old never left. They're here. The mask just dropped.
The 13 bloodlines? They like the Illuminati bloodlines?
We're talking deeper history than that. Anyway.
What's your opinion on the Admiral Byrd and the Antarctica thing? Do you think he actually like found something, or was that just a false story to send people down rabbit holes or something?
I don't trust him because he falsified his expeditions to the North Pole that took place 20 years prior to all this. He lied based off of what I've researched. He lied about his sextant readings and his positioning. And the royal societies that backed him also backed his lies. And this has been completely destroyed, for his claims destroyed forensically. I've got a write-up about this and some sources in our home server presentation too. So yeah, I don't trust Admiral Byrd. I don't believe a single thing he says. I don't think anyone should. No, in his fake expedition to the North Pole could have been used as a leverage against him to be a propaganda tool for post-World War II accomplishments, advancing the notion that America's hegemonic power should not be challenged. Those Antarctic expeditions directly preceded the space program. We're part of the same psychological operations program headed by the president to cement American hegemony and power, this projection of prestige around the world. So, yeah. You know, it's not like I'm hand-wave dismissing these claims. It's no, I've got good reason to dismiss these claims. Not with a hand wave, it's more with a chainsaw and a mallet. See, I've got a minute here if I can pull up something about all this that I posted elsewhere. Let's see. And pull it up. Never mind. There's a chance I was conflating Byrd with Admiral Perry.
Yeah, I mean, Byrd was the one that supposedly went to Antarctica during Operation High Jump, and there was like rumors. I don't know if he had stuff in his diary said that there's like another world in like basically like a concave Earth, basically that like another civilization.
Do you know the history of that
lived under there.
diary, dude? That diary's a fabrication, like by his brother.
I believe that. Yeah, I can believe that for sure.
Yeah. So like, I just no.
Well, that's like when
Diary is so full
everything
of
like
crap.
Antarctica got like super like secret, right? I mean, that's when shortly after all the nations signed the agreement, right? Whatever the treaty is, shortly after that. So like basically that Antarctica is just like a no-go neutral zone for science and
Yep. Oh, okay. So yeah, I was right. It wasn't Perry. It was Byrd. Yeah, his North Pole. Most people don't know that he's credited with flying to the North Pole.
yeah, no, I didn't know that.
Yeah, let me pull this up. Yeah, and jeez, freaking lunatic. Right, do I have it? No. I don't have anything available right now that I posted. Yes, as I was saying before, so he claims to have like flown his airplane over the North Pole, and then he's got this diary, but some really smart chronologers, astronomers, Dennis Rollins from DIOI, for example, dug into his numbers and discovered forensically that Admiral Byrd and his helpers backed into the sextant readings that Admiral Byrd used to claim that he flew over the North Pole. He didn't actually take them, because if he did, he would have gotten different numbers, different angles, and different times. He messed up. And so if this happened in like the 1920s, like 1929 or something, right? And since he had the backing of the entire like Western world, at least North America, behind him, these prestigious royal societies, these American institutes, these organizations knowing full well of the fraud that existed, why would Admiral Byrd be selected then to go to Antarctica and make similar claims? If not there being leverage that could be used against him. We own you, Admiral Byrd. We helped you falsify your Northern Pole expeditions. We convinced the public that you really went there when you didn't. You're going to pretend to go to the South for us. We'll make you one of the most famous men in history, and all your relatives and, your friends, everybody's going to worship you as a hero. So we not only control you, we're not only going to beat you with a stick, but we'll feed you a carrot.
What do you think the motive was? Like, why they would want him to do that? Just to be a propaganda machine? Just
It's a perfect guy to do it. He was already a hero. I'm going to post some links to substantiate what I'm talking about here. Then I have to get going. Yeah, I'm doing that. I'm going to drop some links and I'm going to run. Actually, I have to help cook some dinner. So hang tight. Save these. Go look at them later. It's a damn chat. Here we go. Here they are. Right. Gotta get going. Wish I could stay.
Speaking about YouTube, hello guys over there. If you want to interact with us, you can. I'll read your chat.
Yeah, I'm a little bit scared, of getting owned.
Are you scared?
Yeah, in case I could get owned, I could talk some shit and somebody contradict me.
No.
Yeah. Oh, I thought you said getting old.
Yeah, just like getting contradicted with facts.
Don't talk. The best thing for you to do is just keep your mouth shut forever. That's the way I look at it.
Yeah, that's what I was thinking,
There's a saying, it's better to be thought a fool than to open your mouth and to prove it.
Like, maybe they will clip me, they will upload me to YouTube, and I look like a fool.
Yeah, well,
You're doing it right now.
Yeah, that's already happening in real time. That's right.
You mean PWN too, right?
PWM. What is it?
That's lead talk.
Why don't you just tell us how you know the Earth is a...
He doesn't know. He doesn't know what that means. Come on now.
Yeah. Not really.
Hey, Tommy.
Yeah.
Let me ask you.
Don't give away our secrets.
Can I ask him a couple of questions, guys?
Oh yeah.
All right, let me see this. Tommy, are you able to watch the chat?
Yes.
All right, I'm going to post one picture for you, and I want to ask you a couple of two questions about it.
Okay.
Let me scroll here. And this is kind of fun because we do this a lot, and people sometimes they can answer it, sometimes they don't. So if you don't worry about it, if you can't answer it, you haven't been owned. Okay.
I don't think I've ever seen this one. I'm curious. Is it better than Radwin's?
Yeah, it's about the same. All right, do you see the picture in the chat?
Okay, yeah, it's about the same.
Yes. An Earth's picture.
Yeah, it's a picture of Earth, right? It's at least the way they tell us. They say we live on this ball in space. Agree?
Yeah, pretty much.
Yeah, that's the story. Do you know all the blue stuff in that picture? Do you know what it is?
That's ocean.
Yeah, it's water.
Yeah.
Do you notice something funny about the water in the picture? Like peculiar, something weird.
Not really. No.
It curves around the ball. Right? That's a little bit
but
weird.
that's because it's like illustrative. It's not like a real photo, or it's at least like edited.
Well, they say it's they say this is what the Earth looks like, and it has curving water on it. That's what they say. NASA, for example, right? They send us pictures. They send us
Yeah, but
pictures
isn't
from
like
space.
all of that curved? Like not only the water, but the entire thing.
Yeah, everything is curved, but Earth has a lot of water on it, so most of it is water covering the surface, right? Do you happen to know the Earth's radius? That's my second question. Because you answered the first one correct. It was water. The
I
second
think
one is
if you in kilometers, I think it's like around 18 kilometers, maybe. Maybe it's less.
it's actually 6,300 something
Okay, yeah, a
kilometers.
lot less. Yeah.
Yeah, the radius, right? So and I'm in America, so I do it in miles. In miles, it's 3,959 miles.
See it, yeah.
Yeah, you can even see it there. Yeah, there's some text. So because we know the size, right? We can figure out with math how much water needs to curve over distance. You understand? You with me, right?
Yes, of course.
You can easily figure it out. So if you look in the diagram, if Earth has a radius of 3,959 miles, over 10 miles, it has to curve 66 foot. That's just math. It's in logic. You agree?
Yes, it's a fact.
Yeah. It's exactly. Yeah, it is. It is. So here's the thing. They do send us a lot of these pictures. They call them pictures, right? Or images from space. And they say, this is where you live. You live on this ball. This is the size. And water is curving on it. So I thought about this a few years ago. And I was like, okay, great. I mean, really? How can I confirm this myself? So I did the math and I went out to a lake, and you can do this as well. Anybody can. So you don't even have to believe me. But if you shoot the laser 30 centimeters over the water, over a 10-mile wide lake, it has to end up 66 foot in the air on the other side. If we live on a ball, you agree, right? If we live on a ball, yeah. The thing is, when you shoot that laser, it's going to end up 30 centimeters over the water on the other side as well. Because guess what? Water does not curve. So I can't confirm these pictures. That's kind of weird, right?
Well, but when you say they, what do you mean by they?
I mean, anyone who makes the claim, this is the mainstream claim that we live on a ball that's 3,950 miles. That's the radius. So water has to curve. 66 foot is like a 6-story high building, or 20 meters. Are you in the metric system, or do you like the imperial?
I use meters. I don't use.
Yeah, me too. I'm from Sweden actually, but I lived in the States for a long time, so I use both, right? But 16 kilometers has to curve 20 meters. That's like a 6-story high building. So you could take your friend right now, go to a lake that's 16 kilometers wide, have your friend stand on the other beach and get a good camera and see if you can see him from your side, right? And I mean, unless your friend is 20 meters tall, you should not be able to see him because there is curvature, between you, if you live on a ball.
Okay, so can you say it again?
Yeah, if you take your friend to a 16-kilometer wide lake and you get a zoom camera and you can zoom in and see him on the other side, well, either your friend is 20 meters tall or there is no curvature on that water. You
Yeah, that
understand?
makes sense.
Yeah, I mean, that's what it is. So it's so weird that they say that the Earth is a ball, because when we go out and actually test it, and we do laser tests. Here is I can paste the laser test in the chat if you want to look at it at your convenience, right? These guys took laser to a 21-mile wide lake out in Utah, and they shot laser over it from one side to the other, and it was 5 foot on one side and it ended up 5 foot on the other side. It
Yeah.
should have ended up almost 100 meters in the air, but it doesn't, because, well, water doesn't curve. So
Yeah, so
isn't that interesting?
yeah, I actually looked it up. Here it says that the Earth's curvature, like over 16 kilometers, it creates about 20 meters of drop relative
Yeah,
to a tangent.
I know. It's
Okay.
super weird. And we can't find that. We've done thousands of these tests. I pasted one in the chat, and there is like, I mean, if you talk to anyone here, we can paste hundreds of these, right? So just something to think about.
And why are they hiding it?
I don't know if they are hiding it. I just don't think that they're thinking about it. I mean, most people just believe what their teacher in third grade told them, right? I mean, when we were like 9, 10 years old, they put this globe in front of us and they said, hey, this is where you live. And when you look at YouTube or all the cartoons, they tell us we're in space, right? And we're on this big ball. And I mean, somebody just told them it's basically tradition at this point. Nobody looks into it. Nobody goes out and do these tests, except for a few people, like me, for example, and the other people in this channel.
Right. Yes, sir.
So yeah,
Yeah, but I mean, like, what about all the different, like, what do you call them? Like, you know, you have radars and like different stuff that are based on curvature, right? They are based on a round
well,
Earth.
that's interesting you should say that, because actually those things like radar, we can shoot radar signals 1,000 miles. I mean, we did these kind of tests. We shot radio waves in the 1800s, 10,000 miles, like from England to Australia. That would not work on a ball. It only works over a flat surface like the ocean, right? So,
Yeah, I want to say something about the radar thing real quick.
yeah, go ahead.
The Australians just built, well, I'd say just built, like within the last 30 years. It's called the Jindalee radar system, which is a quote unquote over the horizon radar. They said that they can, from Australia, pick up on radar airplanes in North Korea. This is what they say, according to which is supposed to be 4,600 kilometers. So, do with that information what you want.
And what about planes?
What about
Like, you know, planes, they when they travel, they fly, they don't do it like in a straight line, right? They use like a curved path.
Oh, do you want me to handle it? So I can only talk for like a couple of minutes because I gotta go. But they don't actually fly in a curved path. That's just projecting onto like a Mercator map. So the way planes actually fly in reality is there's these things called international or domestic flight corridors that all the planes fly in. So like all cross Atlantic traffic in the north flies in a corridor, all the stuff in the middle flies in another one, all the stuff in the south flies in another one. The same with the Pacific. They have flight corridors that airplanes fly in. They're not curved. They're not curved paths. The curved path is just because they're showing it on a particular type of map. But if you can show it, I could actually post it in the chat. Like I could post a map showing an airplane while they're in the cockpit. So it's the pilots in the cockpit looking at their flight chart that shows them traveling in a straight path. But the only reason it shows them traveling in a straight path is because it's a polar projection. So it's a different type of map, and different types of map will make the path look different depending on the type of map.
Okay, gotcha.
But I want to go back real quick to what you said. Like, why are they hiding it? It's not hidden. The Earth, like, you can't hide the flat Earth. It's not hidden. It can't be hidden. You're just giving an alternative version of reality, and you chose to believe it. It's not hidden at all.
Well, it's like it's pretty much hidden as much as like anything that.
No, they're just giving you false information. That's it. If the Earth looks flat and you don't feel it moving, how can they hide that?
But who are they? That's the question. Who are they?
That's my question. You said, how are they hiding it? It can't be hidden at all.
Okay, but
It's not
okay,
being
let's
hidden.
say
You're just
okay.
being given an alternate story. So, like, listen, Tommy, if you tell somebody, hey, Earth is a globe, are you lying?
Hold on. Let's say it's not hidden, okay? Let's assume that theory. It's not they're
Not
not
a
hiding
theory.
it. Okay,
If you go to
let's
the
assume.
ocean, it looks flat, right?
I'm not sure about it. Like
You're not sure if the ocean looks flat?
it looks flat, but I'm
Yeah,
not sure
okay,
it
but
is
that's
flat.
fine. Okay, so that's the point. It looks flat. So if the ocean looks flat, they're not hiding it.
Well, it looked like we can't base like reality on how
On the way it
something
looks?
looks at first glance. Like we have testing
Why
and a
not?
lot of like. Well, because there's a lot of things that we don't look at. Like
Jedi, you got to take over because I got a bolt or somebody else does.
I guess our sight is not like is not
Yeah, I'm around.
is not really something that we can use to derive like facts or science.
Really?
Not to its
That's funny.
fullest. Yeah, but I was just.
So do they do astronomy in Braille? So how do they do astronomy? Do they look at the stuff?
No, they obviously look at the stuff, but I'm trying
Yeah,
to say
so we can't trust our eyes, right?
looking at something is not like a definitive proof of something.
I never said it was. The point is it's not hidden. It's impossible to hide.
Okay, but let's not touch that. Let's go back to the other topic about they. Who are they?
I don't know.
Because okay, let's say
Like,
they.
for example,
okay, you said,
my friend, is it your teacher?
Okay, but
No, please answer the question I've asked you. When you say they, is it your teacher?
I don't think so.
No, even if they, this is what Injo said earlier, even if they believe something, they're just repeating what they believe. They're not necessarily deceiving you with the intent to deceive you, are they?
Sure. I mean, so I'm gonna say, I'm just gonna repeat what you said. You said that they are not hiding it. It's just like an alternate story, right?
Hi guys, how are you?
Okay, so who are they? Who are the people telling this?
We don't know.
People you don't know.
We don't know. It looks like a historical kind of argument if you want to look back in history as to, you know, when or how or who pushed the globe Earth and where that came from. Seems to be a theological background. It's a religious idea. But this goes back way into history, dude.
Why did you say theological?
Because it comes from places like the Catholic Church.
The round earth.
Yeah.
Isn't like the opposite?
Kind of, if you want to talk about the antagonism between science and religion. But we have to understand.
There was no
understand, like,
I know.
thanks,
Hold on,
Injo. There was no
Tommy. All
antagonism.
that, Hold on a second. Tommy, I just want to tell you, all that shit you heard about church versus science is a lie. It's a straight lie. I'm not even going to call it a deception. It's a lie. Okay? So if you look at Copernicus, who came up with the heliocentric model, the revolutions of the heavenly bodies, it was dedicated to the Pope. And it starts off to the Pope. It made it past the papal censor. Its forward are written by Catholic cardinals. Okay? Galileo, he wasn't prosecuted for his. He was prosecuted not for coming up with any type of heliocentric model. His actual prosecution, if you look at the trials, which are in the Vatican archives, was for forgery. He forged what's called an imprimatur, which is permission to print a certain book. You couldn't back then. You couldn't just have books printed, so you needed permission from the church to print a book. He forged one and gave it to the printer and had a book different than the one he said he was going to printed. That's what he was on trial for. Had nothing to do with the heliocentric model because the Catholic Church had already endorsed it.
Okay.
That whole story of science, I mean, Newton was like a crazy religious nut. A crazy religious
You're
nut,
saying
dude.
the Catholic Church had already enforced the heliocentric model.
They endorsed it, meaning they approved of it.
Yeah, I understand what it means, but I'm saying like, yeah, I get that part. They did not reject it outright. Sure.
They wanted a model to help them predict
Maybe they
when
were like-
Easter was going to be.
Sure.
You asked who they were. We're pointing out that, with all intents and purposes, again, this seems to be theological, where we have to go back into history to the inception of these ideas. And we can go back further. We can start talking about the Greeks and their idea of perfect plutonic solids. And if God was perfect, he would create the perfect shape. And from their idea, that perfect shape was a sphere. So they saw lots of spheres in the sky, so presume that the Earth was also a sphere, and this was their theological understanding. So it appears to be theological.
You can also bring it closer to history and just look at the motion picture industry. And I mean, if you look into the history of like motion pictures, which is directly, basically the bedrock of modern science, is the ability to take high-speed imagery, infrared imagery, ultraviolet imagery. You'll find that there's been a very large conspiracy to cover up the means of trick imagery in the past. I mean, what our parents were shown in the 1990s about when timelines and certain technologies came into existence is just patently false. And when I say patently false, I mean that literally. You can just go look at the patents online and see like, hey, infrared traveling mats were first invented, or at least first patented, in like 1931. The blue screen process was patented in 20. So, I mean, there's a lot of history that's been totally just muddled about what's actually going on. And it seems to be a theological thing, like 100%, where these people desire a very particular worldview, and like, you know, based on like the Copernican principle, right? And they'll do anything to sweep any evidence that goes against it under the carpet. And that's like an international conspiracy, right? Because like that's not just like the United States saying, oh, you know, blue screen wasn't in existence or whatever. That's like the Russians not coming out and calling out the Americans. That's the North Koreans not calling out the Americans. That's literally any country you can point at, and they'll be like, oh, look, the Americans their timeline is right. You know, we're all on board with that. Same with like 9/11. Not a single one of our enemies seems to even entertain the idea of saying it was fake, even though it would be great propaganda to disseminate towards the American public to cause mass distrust. None of our enemies are doing that. Enemies in finger quotes. Who are they? What? They are leading the world. That's who they are.
What's up, Lanolin? Good to see you, man.
Just popped in for the morning. I'm not here for a long time because I gotta take care of some stuff outside the computer. But I'm doing all right. Thank you for watching me.
Turning blue yet, DJ?
It's -18 at the moment, which is probably not too cold by Lanolin's standards. He's in Alaska, so. But yeah, it's pretty damn cold. Usually it's not too cold in the house, but tonight I can feel it. So it's going to be, I think it's going to get down to -25 or something tonight. Celsius.
That's cold. That's very cold.
Yeah, pretty cold.
So, who was the guy or person who asked a question about that? Are you still here? I can't remember your name, sir.
About what?
Yeah. You asked who they were. Do you understand the answers that have been given to you?
Yes, I do understand the
You got any
argument.
questions?
Yeah, I mean, there are a lot of questions, I guess.
Yes.
I mean, I can point to one specific guy. If you like want one specific guy, I can point you to a guy named Craig Barron, and it's like that guy. He knows he's lying to the American public en masse about the history of cinema. There's no way he doesn't know. I mean, literally, because he's talking about industrial journals and how he's read into them, and the history just shows it. It's like, dude, if you finger through any of these journals with any amount of insight in that industry, which he owns his own company called Matt World. I mean, he worked on The Empire Strikes Back episode 2, and it's like, just to know any of that technology, when you look through these industrial journals, it's like you can't miss it. Like, it's impossible to miss, and I mean it. Like, if you know anything about the field and how this tech works, it's like, oh shoot, yeah, you're just spewing lies, man. Why would he do that? I don't know, but I mean, you can point to some specific people. It's like, yep, they definitely know they're just spewing BS to spew BS. It's not even debatable.
Yeah, I got to say, while we have Lanolin here, I'm super impressed by his side view pictures. Super impressed. We need more of those. Everybody should try to get those kind of pics, even though I understand it's expensive.
Hey, I just want to tell everybody, you don't have to go out to a crazy frozen lake to do what we did. You just have to, all that's really necessary is to go to the lake, any lake particularly, and have your instruments, and just recognize that when you're doing them, it's important to know that one side of the lake is going to be different from the other side. So it depends on which direction you're shooting. Because when we, in our observations, it was very consistent. If we're shooting from station C, I mean, it wasn't every day, because there were days where there were inversions, like where the surface was significantly colder than the air, and that would cause light to bend down. But it was very consistent where we were shooting towards the warmer half of the lake, and that means the density gradient is lofted higher. And I mean, it's super simple to know that if it's a warmer area downrange, and you're shooting from a colder area, that the light on a globe would necessarily have to bend down into the ground, because their whole point is it's so based on temperature. It has nothing to do with humidity. We can just ignore humidity in the globe model. That's what they like to say. So if it's based on temperature alone, your light is never going to make it an extreme distance if it's shooting into a warmer area, because it's going to end up colliding with the ground every time. There is no like hug the curve mechanism that will stop it from actually finally reaching floor. If you're shooting into a cooler area, of course, that would the whole idea would be that it's going to rise up, it's going to bend up even in a globe model. So you basically just have to go to a lake, get your weather stations set up. They don't even have to be extremely accurate, because when you're accounting for humidity and the release over lakes or over ice lakes, there's so much humidity leaving the ground that if you can collect your wet term and your dry term, which if you can do some simple searches on Google or DuckDuckGo or whatever to try to help you sort out how to do that. I'm sure you might even be able to use AI to help you run calculations. A lot of them are really good at math. It's not really all that hard. It's like not out of the reach of people to do these anymore, and you don't have to get in danger. So, and then you can verify it if you have a theodolite, right? You'll be able to calculate like how much drop there is in the theodolite during upward refraction, and then you'll be able to see if during downward refraction, you'll be able to verify in the sights of your theodolite, oh look, at the surface that's above my theodolite crosshair this day. Then on another day, you can see too far, and it's like, well, it's below my theodolite crosshair on this day. So it's just we got to be accounting for surface temperature. We got to be accounting for the air characteristics. That's what the globe model doesn't do. So.
Oh yeah, that's what I'm always requesting from them. And they're making hyper-specific claims as well. They'll be saying, "Oh, this thing off in the distance, 3 miles away, is, it's ever so slightly lower than it should be. Therefore, that matches up with a globe." It's like, okay, well, have you taken all of the potential variables into consideration? They're like, "Oh yeah, we put it into a computer model, and that let us know what the refraction coefficient was." It's like, what? So you just reverse engineering it onto a globe model, or they'll just use standard refraction, and which is basically just guessing. So yeah,
100%, man. I mean, I think it's pretty interesting. If you see the movie, you'll see where we pointed out where in the in climatology maps where they have to bend the contours to the maps, which means you have to be accounting for the surface boundary being like a curved surface if there was one, right? So instead of using genuine measurements, instead they imposed a fictitious value. And specifically, it was a fictitious value of the relative humidity. So they didn't like impose a temperature value. No. They imposed a fake humidity value. And it's because of how much of an impact humidity has on the final outcome. Right. Yeah, no, nothing. Sorry, no, go ahead and do your stuff. So I'd like to point, I want to just take the moment, since I seem to have the soapbox to stand on for a second here. The biggest argument that has been posed for, I think, every year that I have ever been in any one of these lobbies, right, where people are trying to say, well, you need to measure this or you need to measure that, and you need to get like your these hyper-specific high-resolution measurements. Otherwise, it's all, just nonsense, right? One of their biggest claims is that humidity is not important. You don't even have to account for it because it has such a small change in the refractive index. And that would be true, right? What their claim is that it doesn't change the refractive index very much, but that's only true if the humidity is stationary and not moving, meaning like it's all the same temperature of the surrounding air. And I should get some headphones here or something. That's so. It's all the same temperature of the surrounding air. They're not going up or down. They're not carrying the temperature up or down. And that's what I have been told. Not the part about them not moving up or down, but that it has such a low impact on the environment, on the refractive index. And that's like just a bold-faced lie. I mean, in so much that like when they're taking into account the environment, they literally use fake values because they have to use fake values. Not because they want to use fake values, they have to use fake values. And yeah, if you start trying to do like real ray tracing, like density, it's really density tracing. It's not really ray tracing. You're like measuring the density gradient, and that helps you calculate the ray and where it will go. If you start really trying to do that, and you want to hit targets that are really far away, you're going to have to start taking into account the real world. And when you start doing that, the mathematics becomes a flat Earth. Like they start using flat Earth mathematics for it. So it's pretty disgusting, honestly. To me, it shows a gross misunderstanding from the people in here trying to tell us how much they know about optics But all of their assumptions about how humidity impacts the refractive index is all based upon it being stationary and unmoving, and without accounting for the release rate at the surface, and without taking into account the surface temperature, and the fact that because there's 62%, or at least we're told that there's 62% the molecular weight of air molecules of the standard weight, so they rise. Even when the surface is colder, they often rise. Unless there's immense disparity in the surface temperature, they can also condensate, but that's like a multi-day cycle, you know, like not a multi-day cycle, a multi-event during the day cycle. So.
Right. So a lot of the mainstream literature seems to say that the humidity like lowers the refractive index because the water vapor or whatever is less dense than the gas molecules.
Right. You have density dilution right at the surface. So you have higher pressure because you have, so this is like the idea of having like if you have ping pong balls, right? And let's say they're solid core ping pong balls. Like let's not take it, like think about the density of the ping pong ball, just size, volume, okay? You have like the volume of a ping pong ball, and then you have sand, okay? And if you have sand being injected from the bottom, it'll fill in all the gaps between the ping pong balls, right? Now, this is just a volume thought experiment. It has nothing to do with the density of sand or the density of the ping pong balls. The whole idea is that you're filling in all the gaps with humidity, because there's a capacity, you know, like humidity and air. When you add humidity to the air, it's actually filling the capacity. But what it's doing is it's diluting the total density of that air. Okay, so as you fill it, it dilutes it down. The pressure increases, but you're actually dropping overall density. A lot of it has to do with the thrust, because it's picking up those ping pong balls, like literally, like as it comes in from the bottom. It's like dumping a perfume on the ground. The perfume rises up. It displaces the air. It doesn't just mix. It literally will lift the air up because it has a positive thrust. I mean, if you go outside on a super humid day, you can actually smell the humidity in the air, you know, like a sweet smelling perfume, except it's not so sweet, but it's the same thing. And that lifts up your density. So it's a large part of it. The temperature change, that's also a large part of it, because if you have especially a warmer surface, and the vapors are being released from the surface, let's say it's 12 degrees warmer at the surface than it is in the air, those vapors are 12 degrees warmer when they left the surface, and they don't discharge all their heat all at once. So you actually have warmer vapors in the air, and so you have air that's warmer per molecular weight near the surface. Like the difference between 10 feet and 0 feet in terms of overall pressure and overall density is a very small difference between 0 and 10 feet. But
yeah, exactly. Yeah.
So the whole premise of these measurements is that it's such a small change that this buoyant force, and it's a measurable force, and that's why historically they measure it as a force, because it is a force, like measurably, and it's historically been done through vent dynamics. The whole idea of pressure vent dynamics, where there is an off-gas effect happening, and it's putting something which is more buoyant underneath something which is heavier. And the Archimedes principle is a very well-known, established part of science, where, you know, it's going to create an upward thrust, and that thrust is being enacted upon the thing that's above it. So, and that isn't just a liquid principle, that's also a gas mechanics principle. So, yeah, it's...
So what you're saying is it's going to be pretty rough for the globers to get a very specific globe measurement.
Right. Well, someone said earlier that they went with a theodolite, they measured it, and they said, oh, look, it's a little bit lower than it's supposed to be. It's like, for that to even happen on the globe, it means on that day, if it was a little bit lower than it was supposed to be, that's not a globe prediction. That's like a, what the heck is going on? Because in their model, for light to even move in a semi-straight line is borderline. I mean, it's like, we're talking about an impossibility, which is like unfathomable. I mean, it's a massive, unlikely scenario. And when I say unlikely, that's an understatement of the century. It's like immensely implausible to ever happen that light would ever travel in a truly straight line on a globe. In fact, it should almost always look like you should see further on a globe, just because light would be bending down in their model all the time based on the accepted environment that they choose to accept, which is a false environment. Realistically, on a globe with the true environment that we can measure and do measure, not just can, but we do measure, light bending up would be very common, and you would almost never be able to see to the true like if there was a geometric horizon, you would almost never be able to see to it during the day, especially over land, and quite often over water. You would like never even be able to see nearly as far as you would hope to see if it was all traveling in straight lines. Not even close. So,
Hey, Lanwin, can I ask you a follow-up question on that? Sorry, DJ. It's just it's pertinent.
Yeah, go ahead, man.
We have a gentleman who's come in here, I think, at least 4 times in the last maybe 3 weeks, who has argued for the globe based on I forget the official name for it, but it's this giant survey that was done in India, I don't know, a couple hundred years ago or whatever, whereby they've taken sections, right? They surveyed different sections, different triangles, in triangles, I should say, of various sizes, using a theodolite or whatever it's called there. I think they have a different term.
And they're assuming straight lines.
And sorry?
They're going to be assuming straight lines.
Right. Now, anyway, so the claim is based off of those measurements when they do a series of angle measurements and then kind of add them all up, forming triangles or whatever, and they get an angle, an internal angle sum of something greater than 180 degrees.
Right,
they attribute that excess to a mixture of both refractive effects, having bent the light, but they also include in that excess, or they allege a component of that excess being due to the curvature. And I've asked this guy incessantly, how is it that they can actually quantify the proportion of that excess being because of the light bending or because the ground is curving? Like, how do you determine how much is because of which one? You know what I mean? And what the guy had done basically is say that you go to a position, you go point A, and you're taking an angle measurement to point B. Well, you do that over, multiple times over the day or multiple days, right, in different seasons or whatever. And you
used an average. Yeah.
And you average out, right?
Right.
But even if you do that, you're still like that average is still has both these components in it, right? So it doesn't answer the question. You know what I mean?
No, it
so like, how do they justify this kind of like seemingly sloppy, method full of assumptions, basically?
Because they're assuming that the average refraction during the day is downward, and so the whole idea is we're on a downward refraction. And I mean this, in all instances, they're trying to say the average is going to be closest to what reality is. But during the day, especially in a place like India, where there's, truth be told, it's probably more based on temperature in India than it is on humidity. I just assume because it's so dry. But that doesn't mean there isn't humidic effects. It's just there is going to be a lot more temperature internal fluctuation, and humidity has less of a multiplying effect in terms of the smoothing of it. So you can get a lot more variance in your observations because heat's a little bit more finicky, but it still should be very consistent. I would say it just, there is more potential, I would say, in terms of extreme upward refraction. But I mean, you can just see that in the desert. If you look in the desert, you can see some really serious extreme upward refraction. It's just because the sand holds heat so frickin' well compared to the air, right? So the inversion is much higher. So what I'm saying they did, because I'm just 100% certain if that's what they did, if they averaged it, it's that they're getting the average of upward refraction through the day. So it doesn't matter how many times you go out there. What average upward refraction will cause your horizon to be closer than it really would be, right? It actually brings your horizon in, especially on a globe. Okay, so if you're on a flat plane and you have upward refraction, it doesn't matter how many freaking days you go out there, especially during days, right? Because days, it's going to be where the ground is usually going to be warmer than the air, like predictably so. And that's going to cause upward refraction across all your days. You'll actually have a shorter horizon. So if you have a flat plane and you're trying to average just during the daytime, you know, the distance to your horizon and somehow apply that to like physical geometry, there is no way to separate it. You would have to be taking surface temperature measurements like we did on Tustumena and air temperature measurements and your humidity and your barometric pressure. And you'd have to do the calculations for every single one of your observations, not just in one direction, in both directions. That's what's really important, is if you're shooting from one theodolite back towards the other theodolite, and you're making these triangles where you're looking back at each other, like refraction isn't a one-way mechanism. It's actually like if I'm looking at strictly upward refraction from one point of view, from one side of a lake, the other guy can be seeing what appears to be downward refraction. Because, like, for example,
that would assume, but wouldn't that assume the gradient is in one direction or another as opposed to up to down?
Well,
like a horizontal gradient versus a vertical gradient.
The idea is the vertical gradient changes. Okay, so like and I think of it more of like a diagonal. When I tell people the gradient, it's like you're actually like just changing on a diagonal, because the diagonals kind of assume that there is a horizontal change and a vertical change, and that's how I like to think about it. And it's because it depends on how far you are to the target. Think of it like ocean waves, okay, ripples, like in the on the surface, right? If you put different layers of different density water, right, in a tube or in a bathtub, right, they'll separate, and then you disturb it, and the waves, if they're different densities, right, you'll be able to see the surface of each layer. Okay, and where that surface is going to be the densest layer, because you have all the weight above it pushing down, but then you also have the thrust from the third element, the vapor, but also the surface temperature, which is also technically another element that you have to account for, excluding vapor, in your measurement. So if they're not doing that, then they're not doing anything. They're just using averages, and on average, light bends up very consistently. Like, it's a very consistent thing you can predict. Like, if you're especially over the ground, like over dry ground, it's like if it's daytime, the ground is probably warmer, especially if it's sunny, is almost always going to be warmer than the air. So you're going to have a lot of heat release from the ground, causing a lofted density gradient, because the heat is warming that air above it. That's a thrust. That's a literal thrust, where that warmth is trying to raise up a buoyant force, and it's lifting the cooler air up. And so there's a pinching effect above the surface, where that warm air is pushing up colder air, and then the colder air above it's trying to push down, and it's how much that is offset. That tells you where the top of your wave is. And where the top of your wave is in gas mechanics, when you have a surface like this, a surface boundary that has a temperature release, then that's where your densest point is.
So through all that you said, is there a condition above the medium? You're looking across the median of the Earth. Is there a condition where this effect can cause a curving ball to look flat? Is that what refraction do at what?
Yeah, so like I was saying, there is like if there was downward refraction consistently on a globe, right? If it was a consistent measurable environment, yeah, it would make things look pretty darn flat. Yeah, that would be a mechanism. The problem is you need the mechanism for it. That is the problem that the globe has always struggled. And when I say struggled, it's not just struggled. I mean, it has always failed to procure. It doesn't have a mechanism to actually cause as much downward refraction as would be necessary. I have from my own survey on Testamina some examples of downward refraction where you can see it, and it's on a plane. Downward refraction can let you see sometimes a little bit further, but it has to be very, very light. If it's not even really seeing further. It lets you see over things, I suppose is the right way to say it. But any refraction is like destructive per se. So like downward refraction is fairly destructive. Actually, it's incredibly destructive, but so is upward refraction. If you look at examples of upward refraction, it can make it really hard to see things off in the distance really fast. And downward refraction does the same thing. I have an observation where I only wrote out, the camera was at 3.5 feet above the surface. I'm on a snow machine and I'm riding away from the camera, and I only make it about 1.9 miles from the camera and I disappear. And there's upward refraction. I mean, not upward, downward refraction going on because we have snow machine tracks off in the distance, which are beyond my position, and they are like up at the height of my head. So we're seeing the ground on distance look like a bowl. Where it's like there's the snow machine tracks that are on the surface of the lake and they're at the same height as my head. And I'm just a little bit closer. And then I end up getting squashed like an Oompa Loompa, right? Like a Mario, whatever they call those things that you jump on as Mario, squishes down, and you can see my snow machine tracks all the way to the point until I disappear.
But what about a laser? What about a laser? Because you're talking about like light that's reflecting off a surface.
Yeah, so a laser. So if you put a laser on the other side of that, it's going to cave down. So it's similarly, right?
Why? Why would it?
Because it's coming from an area that's warmer. Like I was saying, I was consistently riding toward. Listen, no. Let me answer. Let me answer.
All right, go on.
Let me answer. We were consistently aiming towards a warmer environment with the camera, with the P1000 on our observations. So any light going towards the warmer area, right, could on a globe be bent down into the ground. Anything coming towards us from the warmer area, likewise, should also bend down towards the ground as well, even faster, because it's going from warm air to cool air, and the cooler being the surface. So
that's not the only thing that's going to dictate the light's path, though.
No, you're right. No, that's what we've been saying. That's what we've been saying. So when we're talking about downward refraction, the reason why you can see my snow machine tracks all the way up to 1.9 miles is because they're being the light that's coming off of them. Like if you were like looking at it straight from the side, right? That's a very shallow angle to be seeing. So it's actually light that's being projected up from the surface that's then being bent back down to where it looks like I'm looking at it as though I'm closer and above it. Okay. So a laser, it's going in a very horizontal direction if you're pointing horizontal, right? And you'll see the equivalent of whatever angle it left its position from. So it's kind of like these things on distance spread out in a cone. I mean, a laser spreads out in a cone too, but you're trying to restrict how much of a cone it's spreading out in. And again, I'm with you. You actually do have to account for other factors, not just the angle at which it leaves, but you also have to account for the humidity, the surface temperature, barometric pressure, the whole thing. They're all intercorrelated. So, like we have an example where we can prove, look, there's downward refraction, and it made it almost impossible. In fact, it was probably the shortest distance we ever recorded from the camera. I don't think there is a single observation where we could see less far than on that day of downward refraction. I'm pretty sure we could almost always see on upward refractive days almost 3 miles. I don't think there's a single day that we didn't actually make it 3 miles from the camera when there was extreme upward refraction. But on downward refraction days where like the surface actually is appearing above my head, I was only able, like I said, on that day particularly 1.9 miles. So I think downward refraction is significantly more destructive because it ruins your ability to see things at the ground level, especially. Like it creates a skip zone, a dead zone, kind of like in
So refraction
radio.
is also a phenomena that causes balls to never look like balls, because you never see a ball, but you're saying refraction can cause you not to see the ball. So you never see the ball because of
Only if,
refraction.
only if the environment was suited the way that they claim that it is, but it's not. That's the thing. That's why I brought up that in the literature and through history, they have to claim the environment is different than what it is. It would work if we had a like you would be able to see 30% of the time, not 30% of the time, on average, 30% further is what I meant to say. So you would be able to see, and this is what they claim, that on average you can see 30% further than you should if it was light traveling in straight lines on a globe. That would work if the environment was suited that way, meaning if humidity was hydrostatic, meaning it wasn't moving up, it wasn't moving down, it was homogenized like milk. Like it was perfectly blended and it wasn't changing elevation, it wasn't carrying heat up or down, then you could have a globe where you can see too far consistently. And that's what they do in almost every single refraction model. If you go to like Walter Bisland's calculator, his Earth curve calculator, basically if you pay really close attention to when you're moving his refraction slider in the globe model, you might recognize that all it seems to do is change how curved the ball appears to look in his model, right? It just seems to it just makes the globe look way bigger than it really is. It's basically just changing the size of the ball underneath you in that viewing program, right? And that's done particularly that way because it's pretty deceptive as to what's going on. That is the equivalent of just putting a millimeter thick lens in front of your eyes and saying all the refraction is happening 1 millimeter in front of your eyes. His model does not show any compounding refraction, meaning the light ray is just assuming to be going in whatever arc is perfectly necessary to match the size of that said globe. Okay, because that basically light in that model has to travel in incredibly beautifully curved arcs that are not they don't really compound all that much. That's the problem.
Yeah, so Lanolin, is it fair to say he didn't offer any ray tracing model, so therefore no environmental effects were actually modeled? It's more of just a spreadsheet calculation. Got it.
Yes, that's exactly what he did. He offered literally no through ray tracing or density, and I call it density gradient tracing. But yeah, he didn't do any of that. There is no wave that he's showing over the surface. It's just at whatever distance you're saying your target is at. He's in his model calculator. He's just assuming that the air is perfectly homogeneous, meaning it's basically a perfectly machined glass lens that you'd build in a factory to where you can always get the perfect trajectory, the entire arc of that spherical surface. So then you'll be able to see your target. It doesn't account for surface temperature. It doesn't account for any of that. It just assumes the air is in free space with a surface with no effects from the surface.
And one thing on that, what, if I may, or sorry, Yoder, go ahead. If you had a follow-up.
Yeah, I was gonna mention real quick. It would be necessary then for every arc of light to have a different grade of bend in order for the entire rounded surface to be lifted flat, because you'd have a different arc at one grade that's close to your eye, to your observer point, bending at one rate, and then you'd have another rate for what's much further down or around the far side of the curve on the surface.
Right. Yeah, you just hit the nail on the head.
Right. That sounds like a conspiracy theory.
Oh, it is. It is a conspiracy. It's absolutely nuts. Because again, if you're dealing with a surface which is like, let's say, colder than the air, there's no mechanism for them to go at different rates that are perfectly consistent at each layer. It's like, no, it's going to get dragged down towards what's supposed to be the colder air near the surface, right? And it's inevitably going to hit the surface. So like on our night on Testamina, we shot 18 miles from station A to station C, again, shooting from a colder area into a warmer area where the surface is becoming colder than the air, like at a point, like it really is. I mean, it actually ended up balancing out. It was 32 degrees in the air, 32 degrees on the water. So, I mean, it had almost perfectly balanced the temperature as to the surface and to the air. But the light started at a certain density gradient, meaning if we're shooting into that area that's warming up, again, the density is simply going to get closer and closer and closer to the ground, because that's how where the density, if density was always close to the surface, like they're claiming, like it's always right at the surface, it just means it's, again, going to get dragged down literally to the surface. And we could see it. In fact, I have a shot where it's literally going above my head and hitting the trees above my head, and it's like it would have never made it to my head, would have never made it to our location unless we were aiming quite a bit up. I mean, like quite a bit up to where we were basically going through several layers, which with the green laser we did. We had, we were free aiming that one, and I'm shooting back towards him, and it was being bent up so much as it left my position that it was able to change its angular direction, right? It's basically the degree at which it's leaving the surface, its slope had changed. And it had to pierce through several other layers, okay, before it was forcibly dragged back down. And that's why we got a 7-image Fata Morgana, was because it left the initial layer, okay, it intersected with the wave, which was coming closer to the surface, mind you. Like, it was actually, the density gradient was getting closer to the surface as you go towards station A. And our laser had been bent up so much that it passed through that layer, went through 7 other layers, and bent back down, and then followed the first layer, the densest layer. And it's amazing to see that. I mean, a 7-tier Mirage, man, I've never seen. I didn't even know it went that high. Nobody talks about 7-tier Mirages. I think the highest I've seen written in literature is a 5-image Mirage. That was pretty cool. Okay, I'm trying really hard, DJ, to get you that raw picture. I just keep getting distracted. So.
Oh yeah, no problem. No rush either. Awesome. Yeah, I posted some pictures of the Fata Morgana laser in the side chat. I've never seen anything like that either. It's pretty crazy.
And that's not even, that one's not even of the 7. That one's 1, 2, 3, 4. That's a 5 right there that we got.
So what are we looking at there? Like, are we looking at an actual change in direction of light, or just an apparent one where the conditions have made the laser appear to be where it's not, but it's actually just traveling in a straight line?
Right. So in the globe model, for that to happen, there has to be more refraction, meaning more change in angular direction. There's no, like, you got to keep in mind, even if you're just looking through a lens, right? What you asked would basically be saying, am I wearing a set of sunglasses that have a lensing effect right in front of my eyes that just caused the light to look warped? But in reality, it actually was going in a straight line. It's just the sunglasses right in front of my face causing the problem. And that's what I'm saying. It's like, nope, negative. Light is traveling through that sunglass, which is actually spread across the entire distance, and it is angularly changing its direction. And what we're seeing is the side of it, right, as it goes through those layers.
I'll see that you
Hey bro, Earth is a cube.
Just hold up, man.
So, what I was trying to say was we are seeing a displaced position than where it truly is because we're looking up through these layers, but we are seeing its interaction with each one of these layers. So you wouldn't be able to just point at any point in that refraction and be like, that's exactly where the laser is. No, that's just the total sum of refractions to our eyes reaching us, showing us that, hey, look at how warped that image is. I mean, it is warped. It is definitely being changed. It's definitely being bent. But yeah, you wouldn't be able to, like, you know, shoot a bullet at that light and actually have it intersect the light probably at pretty much any point you're looking at right there. It wouldn't be where you're aiming. So, sorry, go.
Right now, I guess it was a kind of stupid question because, like, yeah, it has to, like, if a light is passing,
it's not really.
It's something that's changing, like, it's capable of changing its direction, and it reaches an observer's eyes. I mean, the light has literally changed direction.
Right. That is the biggest qualm I have with Walter Bislin's whole presentation of how accurate his entire model is he's just lying to people. To be able to code what he did and to be able to to be able to do even what he did on his website means you recognize there's a lot of different variables involved, and he's ignoring the most important, which is the bending at any given point. Like, you actually have to have 2 points of data to be able to make a model like he's trying to show on his you have to have 2 localities. You can't just have one. I mean, you can, but it's only going to work in one direction. Like, you'll only be able to make small short distance predictions, maybe like 3 miles, and that's if you're in a very unchanging locality, like at a lake. Like, you would be able to do it like at a lake only because a lake has a very consistent locality design. The water is consistently a similar temperature throughout the entire lake, unless, you know, a warm spring is entering the lake at some place, but that's usually a small area. If it's just a closed body lake, it's a pretty consistent locality. You could make some predictions from just one locality, but to be able to, like, compute like what's going on with this fata, you'd have to do what we did. You'd have to have 2 points. I mean, it's just, otherwise you're just spitballing in the dark. I mean, you can model in the sense of you can just kind of guess and be like, well, I believe in this model and therefore this is what must be happening. And that's what they did with the Rainy Lake observations, is they just said, we're just going to assume that it's this model, and we'll put all of our measurements in a computer model and say we measured it. And they didn't. So they didn't really measure it.
Now they did the same thing with the so-called black swan, right? The oil rigs. I think there was an article posted on his website where he used his calculator to kind of, like, you know, justify their interpretation of, you know, that observation being, you know, just on a globe, but with mega refraction, and the kind of modeling of what would be, you know, the proper phenomena or the actual phenomena to render or to yield that sort of observation. He puts at the top, right, some sort of some diagram, temperature related diagram about it, but he, as you said, he omits the rest, right? He doesn't account for the humidity or the air pressure or whatnot, just temperature. And if you look at that graph that he posts, it's, you know, it's obviously kind of imputed, just inferred, but it's an absurd claim because the graph depicts the necessity of something about over at a certain point in the trajectory, or the entire trajectory, that there would have been, I guess, an on average temperature change of between 10 and 15 degrees Fahrenheit or Celsius throughout like a 10 meter or 15 meter altitude difference or something like that.
Yeah. So, and by the way, you said he accounted for the temperature. I can tell you right now, he only partially accounted for the temperature because they assume in these models there is one temperature lapse rate and there is two temperature lapse rates, and that's why that's why you have to account for humidity, is because humidity has its own temperature and its own lapse rate as it leaves the surface. Even if the surface is colder, it has a cooling effect. If it's warmer, it's got a warming effect. So
okay, sure. I guess what I meant by like accounting for temperature is, I mean, all he's doing is showing one variable out of the multitude of necessary variables, just temperature. Now, whether he's doing it one way or both ways or whatever, that's a secondary issue. So you know,
he's using
more
one
problems.
half, and he's even using one half of it. Is what I'm trying to say.
Oh, there
He's
you
saying
go.
I'm just going to use one
even
variable. Yeah.
It gets even worse than that. And just a second, Lanolin will find this kind of funny as well, because what he did, okay, he had like a preset on the Walter Bisling calculator where you can put in the black swan observation, and it's like, okay, if he manipulates the temperature gradients, if refractive index gradients a certain way, it's like, okay, now it works on a globe. But what he had to do, which we worked out later on, was he put in a layer of fog that made the fog, like, that hid the background water. Okay, and when we did the same thing and removed the fog, this is what was in the background. And we added some surface to it just as a joke. But he actually had to add some fog because obviously you never see a scene that looks anything like this. So for him to make it work on his ray tracing, reverse engineering model, he had to have it set up so it had this giant, what looks like a tidal wave in the background, and he dishonestly removed it by using fog.
Oh, forgot about the tidal wave. That was hilarious. Yeah, big wall of water like 80 feet high.
Yeah. This is a screenshot from his simulator or whatever you want to call it.
Yeah, it really is no joke. To see the distance that they're claiming we can see on a globe would make the globe look like a bowl. Straight up. Like, you wouldn't be saying it's going over any curvature ever. And it's just absurd because downward refraction is very destructive because, like what was mentioned earlier, somebody pointed out how it sounds like a conspiracy theory that at all the differing heights, the light has to move in an arc at a different rate, in a nice, perfectly curving rate at each height. And it's like that's the only way to get that tidal wave wall to look like that. And it's insane.
You're saying it's much more dynamic and unpredictable? Chaotic.
Yeah, it is so much more chaotic on a globe. Nobody, like we quite literally would never have grown up thinking there was a physical curve that you could see. No one would have ever thought that because we would see things day to day that are just so absurd all the time that we never see. That's what I'm saying. It would just be just blatantly in our face that we're not watching boats going over a curve. We're watching them get crushed by the optical phenomena that the globe would be causing. So, yeah.
So, what your side views, man? How's the laser visible from you?
So yeah, what we did was I have a 4-watt dual diode laser. So it's actually two diodes that are 2 watts, and they're joined in through a beam splitter. And, well, I guess you would call them in this case a combiner, but that's what it's doing. They're being combined, and it's going out through the front as a single beam. And so it's a pretty powerful green laser. It can blind you very, very easily. It's got a half angle milliradian of like divergence of like point. It's either 0.123. It's like 123. It's like something like that, or it's like I can't remember. I can't remember what decimal point it is. I think it's 0.12. I'd have to go type in my stuff again, and I don't have it written down next to me. But it's basically at 6 miles, it will have diverged like 4 feet, I think. So it's pretty accurate. It's not like military grade, but it's pretty darn accurate. And
because usually, like you see on your YouTube videos, and they're showing a laser, they have to like spray some aerosol there or something so that you can see it. Like And I was just wondering, like, that must
So
be some
in this
heavy
instance,
laser you use.
yeah, we used a pretty strong laser, and we also waited. We waited for a day where the vapor discharge from the ground was pretty high. So like in our side view laser, you can actually see the humidity dispersion zone, which is where when the humidity is under pressure, it's actually in a smaller form. It's actually a smaller water vapor because vapor changes size as it goes higher. That's how you end up with clouds, right? As the vapor actually begins to expand as it gets higher. When it's under more pressure, it's actually smaller. And so in our shot, you can actually see the lofted haze, and that's the area where the vapor actually starts to spread out, and there's so much of it that you can physically see it with your eyes. But it continues to rise, and we actually have pictures where you can see that the vapor actually continued to rise through the night. So we were waiting for that night. I mean, we ran out of food on that night. That was our last night there, and we were like, oh, amen, thank you, Jesus, that this happened, because we were concerned we wouldn't be able to see it from the side. Because we did some test shots, and yeah, we could see it, but we also had the exposure on the camera. I had my camera, I specially selected my camera because it had an incredibly high light sensitivity. It's a 3-stacked CMOS chip. So I had bought that camera specifically because of its extreme light sensitivity. Like I said, the lens was we bought strictly because it was the lowest distortion lens we could get our hands on. They do make a wider one than the 12 millimeter, but it actually has a worse distortion rating. The 10 millimeter has a higher distortion rating than the 12, so we went with the 12. Golly, sorry, I'm trying to collect my thoughts. There's so much to pull out from the drawers in my mind.
I'm wondering what the length is there, like in those images. How much laser are we seeing?
About 12 miles from left to right.
In the side shot? In the side
Yeah, in the side shot, yeah. About 12 miles. Whoa. It's a little more than 12 miles, but yeah.
Wow. Yep. Like, is that from distance from the beam, or the beam distance itself that we're seeing? Like, how long is that laser?
The beam distance itself. So if you're actually trying to say how many miles of beam am I seeing, it's about 12 miles. It's a little more, but I don't want to throw out like a hyper specific number. Okay, but the distance from the camera to the center of the laser and the center of the frame is about 3.5 miles, and then on each side of the frame, it's roughly about 6 miles to each side of the frame. When I say roughly, I mean it's like incredibly close. It's almost exactly 6 miles. It's a little bit more than 6 miles, but it's really close. So, yeah. Yeah, no, it's a pretty cool shot. So,
hey, what's up, Linolen? I was telling them in the side chat, they're saying like, hey, this is a lot of good information. I was like, dude, like, I'm saying you should see when you do your fake moon landing presentation. That is awesome, bro. Like when you go through all your filmography and like show all the magic of, film and movie magic. Like, I hope you can do that one day in here. Good to see you, by the way, in here.
Thanks, Apocryphon. Thanks, man.
Maybe one day you can go through that stuff with them, so you have a lot of good information on that.
Yeah, I definitely, I definitely could. I have to go to the funeral home with my wife today at 2:00.
Oh, sorry to hear that.
It's in
sorry to hear.
2 hours. It's okay. She's with Jesus now, so it's not my wife, but her mom. So.
Yeah, I know. Okay. Yeah, condolences. Well, next time, maybe next time, if you could come back and when you have time and go over your whole like presentation with them. I was telling them before, I was like, I was so disappointed like that in your documentary you didn't go deep into it. I was like, I was telling DJ, I'm like, bro, I was like, that's the only thing I wanted, more of that film was like your whole fake moon landing presentation. So
Sorry, it's just when you're going on 2 hours, it's like it's hard to get people to watch anything that's over 2 hours.
Yeah, maybe you got to do a part 2, or you go deeper into the film stuff, exposing the moon landing.
Ultra extended cut.
Right. I mean, for those who are craving the info, they're going to watch it. You know what I mean? Like, especially because you have such a informative, a lot of information. Like, people that do love information and knowledge, they're going to watch it. They're not short attention spans. For those who really do look for the truth and do want who do love knowledge, like I think they'll watch it.
I think you're 100% right. Just just got to get there. Get to that point.
All right, we've got Exo in the chat. Sounds keen and eager to prove that the Earth is a globe.
Ego.
What say you, Exo? You gonna mic up? Have a chat. Sounds like you've got the goods. You've got the proof that the Earth is indeed not what we observe and experience, that being flat and motionless, but rather a big spinning ball in outer space. Let's hear it. Come on, let's go.
Said he can't talk English. He can't speak English, but he could type it. It's probably a sock account. That's why they don't want to talk, because we'll recognize the voice.
Yeah. Is that you, Rob? Rob Utah?
Probably a sock account. For sure.
It's not a fresh account, so it's got to give him the benefit of the doubt. Anyway, he doesn't want to mic up. He doesn't want to mic up. Can't make him.
Yeah. Hey, Lanolan, I'm glad you brought up that how his calculator, he doesn't account for like the conditions that are variable, because you know how some of these like globetards, they're like, flat earthers don't believe in refraction. You know how they make that false statement, but then it's kind of like projection, because they truly believe in perfect refraction, where it's always going to line up perfectly to where they need it to be. But if you look into the math of even what they're saying, how you can see the oil rigs, like 20 Cups was talking about earlier, one thing that he doesn't have in his calculator was refraction when you slide it. I wish he did. At least I haven't seen it. I wish he would put what the value is, because for the oil rigs to see 10 miles at 1 foot, that's requiring a negative 150 K value. And that's asinine in so many levels and ways. But for Globers just to blindly believe, oh yeah, that's possible. That's totally normal. That you could have a K value, coefficient value, just be negative 150. That literally becomes like a concave. You're now in concave world at that point. If you're trying to say, oh yeah, everything just went up, at negative 150. So it's interesting that he doesn't have, like, when you slide the refraction ruler, it's interesting that he doesn't do the what that equates mathematically. Because I think if people can see it just going higher and higher and higher and higher, like they'll be like, whoa, like this is not even normal. That's not even reality. You know what I mean? Like that's not even. No one can get that.
Again, his model presents it as though it's just the globe under your feet getting bigger and bigger or smaller and smaller. That's it. That's all he does. That's his whole model, is just change the size of the shape beneath you. And in that way, you'll never see like his model. This is a guaranteed way to know that his model is wrong. Is you can go out with a theodolite and you can go to a day with downward refraction, like genuine downward refraction, and something which should be hidden, from an object. Like let's say you're looking like you have a 6-foot piece of plywood set up halfway downrange, and you're looking like, let's say, 3 miles, and your theodolite is at 6 feet, so you're looking just over the top of that piece of plywood, and then you have something that's only at 4 feet that should be hidden behind that plywood, and you'll be able to see it during a downward refraction day. Well, that means that the world in that instance is looking concave. Even on a globe, that would be a concave day. Well, guess what? None of his model, no matter how much you turn that refraction slider on his website, will you ever be able to see an object which should be hidden behind another object appear to be above it. It will only make his globe look more and more flat. It will never make it look like a bowl. I mean, it's just a straight lie. His whole model is just him knowingly deceiving as many people as he can with the appearance of authority of sophistication, which comes from sophistication.
Right. Yeah. Even if you were to have like yeah, and you're exactly right. Like in regards to all he's doing is just increasing the size, because when you increase the size, you then have a larger radius
with the appearance of authority. Sophistication, which comes from sophistication.
Is my thing messed up?
No, that's Ocean. I think Ocean was
You're exactly right. Like
hot micing.
Oh, he's he's like replaying the video or something. Okay, Ocean, you're hot micing. That was weird. I was gonna say that you're right. Like it just makes the Earth bigger, and that's how you're able to see it, quote unquote. Because if you do the math, like in order to see 10 miles from 1 foot observer, you can do that even like at an 8 coefficient, a refraction value of 8, which is also super high. Like that's not even normal.
Absurd. It's absurd.
Yeah, but that will give it a 66,000 mile radius. So technically, you can see 10 miles from 1 foot observer on a ball that has a 60. This is all just math, obviously. On a ball to see the surface 10 miles from one foot observer height. Technically, mathematically, you can do it if the radius is 66,000 miles. Then, lo and behold, it'll be equivalent to you being, 6 feet tall, seeing 3 miles on a radius of 3959. So like it's all it's all relative. But no glober believes they're on a 66,000 mile radius. What did they do? They just yanked the shit out of the coefficient, a refraction coefficient, in a negative value. Again, concave. They just bent it up and then said, "Well, there you go. Mathematically, it works." It's like, wow, dude. These guys, they're so dishonest.
Yeah.
I love how their math destroys their math.
Their math destroys their math, but they will never present their math as destroying their own math. So, like, it does. I mean, I get it. It can be funny, but in the other way, it's kind of not funny. But
yeah, you're right. It's really asshole-ish, right?
It really is. Yeah.
Well, they just say, well, nothing's perfect.
None of them really know what they're talking about. Like even the anti-flat earthers that come in here that have been in it for 8 years, 10 years, they still aren't able to still man their own position when it comes to Walter Bisland's calculator or the refractive index or atmospheric refraction itself, right? They can't even define it properly. They screw up the most basic things. It's very rare to get a glober that even knows what they're talking about when they say the word refraction. Most of them have just learned to just kind of say that word and they think it's a get out of jail free card.
I would say even the ones who claim to have a very strong knowledge on refraction don't know very much about refraction. They just know their best position and how to present it. Like they said, okay, this here is how I should try to combat the flat earthers from this vantage point. And so anytime we have a conversation, my whole goal is to never leave this frame, because in this frame I can make them look silly or I can make them look stupid if I just commit to this frame and I dodge all questions or I dodge all detours. because that's ultimately what it comes down to for me. Like when I talk to them, is I feel like I'm being guided, like they're trying to guide me into a particular question that they can jump on me on, because like I don't know everything, but and I don't know what it is they want me to say either. You know, like they're asking questions, but they're actually looking for, you know, they're looking for me to say something, and I don't know what it is. so yeah.
Yeah, they're waiting. They're waiting for that moment to where they can be like, "Ah, got you," and then they'll try to exploit. Like even if you misspeak, they'll try to exploit that, because what they're ultimately doing is, this is just a tactic that they have. They're just trying to find a way to discredit you. That's all they care about. They'll attack you personally once they find like a small little chink in the, you know, in the armor. They'll be like, they'll try to exploit that. Like, and it could have been just something like something simply you just misspoke, and then they'll pounce on that, because it's a tactic.
Yeah.
All those other Globers, like in the other servers, like you have like Shoebill, and you have the Surveyor guys like Shoebill and Omni, and all these guys that they think they know about. You know, there's even like some that actually are legit surveyors, but because they stand on that, you know, like podium as saying, "Oh yeah, I'm a surveyor," so then all those Globers in that server, like they like bow down to him pretty much, and they go, "Oh, he must know what he's talking about because he's a surveyor." But then but then that guy will turn around and admit, like, yeah, it's a calculated value. But then I don't know why, for some reason, the Globers don't hear him say that. Like, it's really weird. Like, sometimes a guy's honest. You know, some of those surveyors, they are honest, but then they'll go, "Oh yeah, but we just add it." I said, "Yeah, exactly. You change it." So, anyways, it's funny.
Oh, and they discredit all the guys that are on FE that do have surveying certifications as well. So it's like, "Oh, you're a flat Earth surveyor, so you don't count. You don't count, right?"
Yeah, it's crazy, those guys, man.
Yeah, after having conversations with, you know, some of these so-called surveyors, you know, a lot of them they're just kind of operators, like entry-level survey technicians or something like that. Maybe they did a 6-month course or something, you know, passed a few exams, and now they're, you know, on Discord saying that they know everything there is to know about measuring the globe, you know, and surveying. But quite often they'll make really stupid errors, right? Like Jay Reese is one that comes in sometimes, and you know, he was trying to tell me that mirages can't happen over small scales, over small areas. It's impossible. And then, you know, I'm showing him ones done over a small scale, like just over a couple of meters. He's like, "Okay, yeah, well, I concede about that, but it can't happen at mid scale. The distances we're doing over our surveys, it can't happen." And then we showed him some examples, and you know, and then they just try to change the topic, and they a lot of them really don't know what they're talking about when it comes to refraction, miraging, that kind of thing, especially miraging.
Yeah, I've tried to talk to people who tell me they'll straight up say like, "Oh, we're measuring, you know, we are doing surveys down to the millimeters, folks. You know, with GPS, we are accurate. We are accurate down to the millimeters." And it's like, there is a difference, by the way. And I try to tell them this: there is a difference between the precision readout of your instrument and the accuracy of your instrument. Okay, so when they're doing like their GPS measurements, the instruments will read out a precision value. It is a precision value. It's highly precise. Precise meaning reads down to a very low decimal point. But the accuracy of it is quite low. I'll actually just read an abstract from just if you want. It's just one sentence. It's like literally just like one sentence.
Yeah.
From the refractive index of air, new equations for the visible and near infrared. And this was by Philip E. Sidor, I think is actually how you say it, Sidor. And in case you're wondering, this guy came up with the density model for the globe with the assumption of 7/6R built into it. Like, this is like a very high up there optictician, if per se. And this is the very beginning of his abstract. It says, The precision of modern length interferometry and geodetic surveying far exceeds the accuracy, which is ultimately limited by the inadequacy of currently used equations for the refractive index of the atmosphere. Just right there. The precision of modern length interferometry and geodetic surveying far exceeds the accuracy. And I think that is like understatement of, that's another one of those, like right there in competition for understatement of the year. Like seriously, it's up there. So they'll say we are measuring these down to the millimeters, and it's like, yeah, you've got an instrument that will give you a readout to the millimeter, but your accuracy can be off by feet. And if you're going over a long enough area, it's very hard to see that. It's very hard to see that. And almost nobody is doing flat grade surveying at any distance where the difference in height is going to be any more than just a few inches, even on big projects. So, yeah. And no one's going to try to do one continual slope the entire direction. There'll be drainage considerations across certain areas in smaller subsections, because they know if we try to get this all in one long survey where everything sheds one direction, they won't be able to do it. That's why they never do it that way. That's why there's always drainage considerations midway through the project of like, this is where the drainage needs to be here, it needs to be over here. It never works. They're not using a planar model when they're doing it. They're assuming that, oh, this is in fact curving, and it's not.
Have we got that? Can you share that with us? Have we got that, DJ,
Sure.
on Pickled
Sure.
Minds?
Here's just
Nope.
you can't actually. You won't be able to.
I was about to. Go ahead.
Yeah. You won't be able to read the whole article unless you pay for it. But here it is. I'm putting it in the side chat of the 24/7 Flat Earth Discord. There you go.
Thank you.
Should I use folder for it? It might be.
I mean, that's from 1995. It's like if people in 1995 didn't know how to measure the ground, we're screwed. You know what I mean? The globe's screwed. If they're saying it's that inaccurate in 1995, that's terrible. That's just trash. I mean, that's unacceptable in the current mainstream idea of we can measure things down to the frickin' millimeter.
And what distance generally are we talking about that he's referring to when he's saying it's inaccurate over X distance?
You would never be able to do it. Then he's not referring to any particular distance in his statement, but what he is saying is usually geodetic surveying is done on bigger jobs, right? The idea of using the GPS, it's usually done on things that are going to be over a 1/10 of a mile, right? In distance, or shy of 1/10 of a mile. Let's say maybe a 12th. So that's usually when you stop using the theodolite and you start strictly just the theodolite, and you move on to a position system. So we're talking about most of the time they're saying they're doing this down to the millimeter. It's okay, so you treated the world basically like it was flat, and you're maybe off by an inch. Is anyone going to notice that you're off by an inch? Do you know how hard it is? Well, I'm not posing a question. That's rhetoric, and it's not really a good way to phrase a way of speaking. But it is incredibly difficult to determine if your grade is off by even a single inch across an entire area. I mean, that's very hard to do, because how are you going to measure that with a light? Well, the light is the problem, is that it doesn't go in a straight line. So, it's pretty difficult. I'd say the best way, honestly, to get an accurate measurement is to use a water level. But it's just me.
Right. So if we've got some of these like anti-flat earthers going out making hyper-specific claims using some old theodolite over, say, 50 miles or something like that, right? Peak to peak. That's probably not a very good idea, right?
Well,
Especially
the peak to peak thing is like they're not
Even
accounting.
100.
They're just trying to say, "Hey, look, we're getting above the refractivity of air," and it's like, actually, you're not. You would have to get out of the air because anywhere you are, dependent on the layer, you can have light bending up towards the density above you because there's different layers. Like the Fata Morgana shows this very clearly, that there's different layers going on. And
yeah, absolutely. It's also more common for there to be the warmer pockets of air down lower in the mountains and that kind of thing as well, rather than cooler air down lower and warm air above.
Well, and you got to keep in mind that also, it's really like they make these claims, but they never, when they do this theodolite measurement stuff, it's like, well, why don't you, get your surface measurements? And it's really hard for to do it on a mountain. I know this sounds weird, but to actually take a surface measurement from the mountain is really hard because usually a mountain is falling away from you in every direction. So you have this like kind of conal effect happening. You're not using just a flat surface anymore. Now you have to have like, okay, what is the surface temperature maybe at the bottom of the mountain and then also where you are on the mountain as well. So then you can work out how much is being lifted through this funnel in terms of like humidity rise. Like humidity is such a huge factor in this, and they're not taking any of the measurements I've seen from peak to peak. They're never taking it into account. They're never taking any of the environment into account. They just go up there and say, "Ha ha, we went higher than," and it's like, no, you didn't. You're still in air. You can breathe up there. You know that, right? You can breathe up there. So obviously, there's going to be refractive effects going on. It's kind of sad.
Oh, yeah. You can even just go to Google and type in mirage in mountains or mirage high altitude, and you can see crazy miraging effects, over mountain peaks and things like that.
Mm-hmm. Oh yeah, because ultimately it's more about the distance. A lot of the times it's about the distance you're looking, and not the overall refractivity of the air. Like on a flat plane, a lot of these mirages make a lot of sense because it's happening over such a long distance. Whereas on a globe, like you guys were saying with the oil rigs, which I'm just going to presume you did your due diligence in that. I mean, you have to have a lot of refraction, like happening all at once, like in a very short span of area. It's pretty silly. And it's not just a little silly, it's really silly. Oh my gosh, look at that. That's a Fata right there over a mountaintop. Interesting. What I find interesting about flat Earth is we're over here talking about measurements and the environment, and we're not just like saying but outer space, I mean, we can show things that don't work in the sky too, but we're like more concerned with what the Earth is.
Oh yeah, and
I really like that about
hard. Yeah, absolutely. They'll do whatever they can to try to get the conversation away from that as well, especially in this server. Try to take it back to the sky. Not sure if you've seen this one, Lanolin. This is my go-to one, really. A lot of people's go-to one when it comes to the Santa Barbara oil platforms. This one was done first thing in the morning. Extremely clear conditions, 8-foot observer height. Full video about it as well, but it's extremely clean.
And first thing in the morning, that's a really awesome time to do observations. And it's because you had all night for the air temperature to stabilize, right? And the surface temperature to stabilize. And you have no third element source heating, right? You don't have the sun adding another heating element to it from above. So you've got a lot more stable environment to work with. So I think that's pretty fascinating. To be fair, that could mean it could end up resulting in downward refraction, or it could end up resulting in slight upward refraction, depending on the air temp, but and the release rate at the time. But it's more than likely this is going to be upward refraction every time, because the air would have to be significantly warmer, like in a very serious way, than the water itself, for condensation to occur.
Yeah. Yeah, we do have another good observation that Indio 007 did. I'm not sure if I showed it to you, but he used infrared P900 or P1000, and he waited for a day where he found the water temperature and the air temperature to be completely identical, and he made the observation right where the buoy is that takes the readings. So he was able to track a boat on marine radar 10 miles out, just over 10 miles out. He had his camera at 15 foot. And so we had identical water and air temperature, or close enough. And we had a known distance. And yeah, you could see the whole boat. You could also see the whitewash because the boat was moving. So you could see the little waves at the bottom of the boat. Really cool observation.
Yeah, and I would guarantee that I can't guarantee it, but I would say with great certainty that if this isn't in like freezing conditions, your relative humidity probably isn't 100% right at the surface. So, and that is one of the major fictitious impositions they put into the data. Is they'll claim that the surface is experiencing an extreme amount of humidity right at the ground. It's called supersaturation, where the relative humidity right at the surface is at 100%. Even if just above the surface, it's like, and I mean like 5 inches above the surface, you'll have a hydrometer that says like 50% or whatever. They'll be like, oh no, right at the surface it's 100. And the reason why they do that is because if the capacity of air is full, okay, it can't accept water vapor as fast. So it's basically a way to dry out the world, to make the world really, 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 really dry, by making the area right above the surface incredibly wet, to where it can't actually let any water escape the surface, which is just patently false. We'd have no freaking clouds in the sky if that was the case. So, yeah, it's like, it sounds like you're in an environment, if the air temperature is almost identical to the air temp. In fact, if that is indeed the case and your relative humidity is below 100% at the surface, then yeah, you'd be seeing upward refraction.
Yep. I think we have
in that one direction.
Yep.
But you would need a second point to guarantee that.
It was like half a degree warmer water than the air temperature as well. So.
Well, even so, even if it was a half a degree colder, that's so close. That's so close that just the buoyant thrust itself is lifting the density gradient. That's the whole thing. That's why they have to impose hydrostatic environments or supersaturation. They can't actually let the vapors rise, because even if the vapors are a little bit colder, they're actually still lifting the air. Like, it's a literal thrust. It's a measurable thrust. More buoyancy underneath thing of higher density causes density lift. So it's a displacement upward. That's why they can't have it rise. They basically have to say, when I would say their primary point of contention is at the beginning of the Bible. It says, and then God created the dew. Like the dew came up from the ground, and it's like, oh no, we can't have something God created in our system. We have to make it go away. There's no dew. There's no water coming up from the ground.
Yeah, it's a great point. It's actually a point that I never really considered. So here's the observation I was just talking about, just a GIF of it in the side chat, along with the information from the buoy, which is basically at the exact same time that he did the observation as well, just before. So water temperature 45.9, air temperature 45. It has a bunch of information about the dew point and all sorts of things there as well.
Guys, what proof do you have that the sun and moon are just lights in the sky?
When you look up at the sun and the moon, you literally see lights in the sky, right? A light can be all sorts of different things. Okay, a light, it's not a specific thing, right? It's just a light. Like, right? You'd be like, what's the source of the light? Or something like that. That we don't know. But we see lights in the sky. A star, a sun. If you look up, you could see a street light. It's just a light. A firefly would be a light in the sky. They would all fall under that category of lights in the sky.
But what proof do you have that we haven't been to the moon before?
There's no proof that you can go in. All right, so there's no proof that space is a vacuum. Okay, and there's no proof that we have been to the moon. Right, so that's like me saying, what's your proof that there's not unicorns on Uranus?
But
right, how can you disprove that there's not unicorns on Neptune? Right, you don't have to disprove that.
So what happened in 1969?
Yeah, so NASA did a really shitty job at faking a bunch of footage to try to beat the Soviets in the space race, the so-called space race. Okay, and the footage looks so ridiculous, especially in 2026, that I don't know how anyone could actually buy into the footage. Right, we all can agree that footage can easily be faked, especially when you have an unlimited budget, essentially. Right, a billions of dollar budget.
But
so if I post some footage right now, right, no one in their right mind should be, saying that it's unfair to question whether this footage is real or not. Okay, have a look, Crypt. Have a look at this footage. Just a second. Right, look at this footage, right? How could anyone think that this is real footage when they're claiming this is real footage? It's like, come on.
Okay.
But imagine defending that.
No, but what about right now when China is like saying they want to go to the moon and to Mars and all that, and NASA hasn't been to the moon in I think it's been I don't know, they haven't been there since like the 1970s, and now China says it wants to go over there. Then NASA is building this new program called Artemis, right? So if no one can go to the moon, then why are they getting all riled up about China wanting to do it?
I don't think anyone's getting riled up about China wanting to do it. China already said that they've landed things on the dark side of the moon, right? I don't know if you've looked at that footage, but it looks even worse than NASA's footage, right? China aren't as good at faking things as other countries.
The space race never ended, Cryptic.
No, but if they're faking it, then why is NASA getting riled up and starting the Artemis program?
Because the space race never ended.
But you guys are saying the space race isn't real.
No, we're saying the space race was propaganda.
But why would they show propaganda when they're are they trying to find who can give better propaganda to the public? Is that what the space race is supposed to be? Because you're saying we can't go to the moon or to Mars, right? So why are they trying to start up the new programs? NASA started the Artemis program in response to China saying they want to go to Mars and landing on the dark side of the moon, right? So, like, why are they doing this? If
because they want to project power and capabilities that other countries can't claim. Do you know what propaganda is?
Yeah, I know what propaganda is, but if it's all
Okay.
propaganda,
You keep asking me questions, and the answer is propaganda.
if it's all propaganda, then why are people getting so riled up, like in government agencies, like if China?
That's what good propaganda does. Don't you get it? NASA even states that they do this for psychological reasons, going back to the beginning of the space race itself.
Then why is China following suit in this propaganda as well?
Because they want to project power and capabilities that other countries can't claim to project or have. Just like what NASA said that they did with the space program back when it was founded.
No, but they're projecting power against the United States, right? And if
Yeah, they
both
don't want
the
to be
United
seen as inferior. They don't want to be seen as inferior to the USA, right? India doesn't want to be seen as inferior, so that's why they did their terrible job faking their little moon buggy in 2024. Okay, these
But if
countries
it's-
wanted prestige, right? They want it's the space race.
But if it's all fake, won't they know that it's fake, and like there's no point in faking propaganda. You can project superiority in like other ways, by not faking things that don't even exist, right? In your, like, you guys are saying it doesn't exist, right? You can't go to the moon and all that. So if you can't go there, then why are they putting this as the focus point of propaganda when they can like put like something that people can actually do and use that as propaganda? And if all three of these nations, China, India, um, uh, America, all know that it's fake, why are they competing to see who can give out better propaganda? Like, if America has never been to the moon, and if China has tried to do this and knows that it can't do it as well, it should know that the moon landing was fake, right? So why don't they go out of their way to show that the moon landing is fake instead of actually trying to further build on this propaganda?
Oh, if I was China, I'd do the exact opposite. If I was China, I would fake it even better than the Americans, knowing full well that because I'm faking it, the Americans know I'm faking it, means the Americans know that I know the truth.
But they could just go out of their way to like disprove it and completely destroy America's
They
reputation.
do it for political expedience. Listen, Cryptic, there's immense power in holding this blackmail over your enemies.
Holding what?
Blackmail.
So that
Right. So now
blackmail.
China's in a position where they can now say, at some point, they can come out and show the world that America faked the moon landings, and their political capital is preserved. Why? Because they didn't enter the space race until recently, when the technology seems to be more capable of performing it.
Okay, all right. Say that's true. Why is there more and more capital flowing into like private space industry in not just America but in other countries as well? Like you have people setting up startups and all that.
Yeah, you really think it's private? There are like maybe 3 or 4 launch facilities in the United States. They're all controlled by the military.
How about outside the US? Yeah, there's one in New Zealand. There's some in Japan. How about them?
Yeah, many are joint owned by NASA and their host governments that are part of the propaganda. Listen, if all the countries have mutual blackmail against each other, then you've got world security. It's almost like mutually assured destruction with nukes, but in this case with fake space programs.
Like, aren't we speculating? Like, isn't this supposed to be like a place where you find proof and show people your proof and facts? But aren't we entering into the realm of speculation where we
Would you like to
think
see my
about it?
evidence? I've got NASA documents from its founding in 1958 demonstrating, proving that they were developed for psychological warfare. The space program is a psychological op.
Okay, I'd like to see that.
Okay. Bear with me while I fish it out.
Okay, sure. And previously, I heard you guys say that like they were also faking the supply and demand issue of oil, right? So in like a lot has happened since then. Like Trump attacked Venezuela and like they're trying to take oil from everywhere and stuff. So like, is this all part of like try to inflate oil prices? Because like if
No, bro.
oil
Look, if you heard someone in here giving their personal opinion on what they think about oil, and I think I do remember that conversation that you had with a specific person, right? That's off topic. That doesn't mean that every flat earther in here agrees with what they were saying, or that even the person that was saying what they say really knows what's going on with the oil.
Okay, all right, got it.
Yeah.
Okay, Cryptic, I posted the tip of the iceberg. Why don't you flip through those?
Okay, I'll look at it. I'm looking at it.
You need historical context. The OCP is an organization under the president, his cabinet. Operations Coordinating Board. OCB was founded to be a psychological warfare operation after World War II. The operation is to cement in the minds of everyone on Earth that America is forever and always the greatest victor. So a bunch of other programs spun out from that, but one of them was the space program. Let's use space. Let's use space as a PSYOP tool.
So right now, America has a lot of debt, right? And they have to like, and people have to keep holding the U.S. dollar for them to be able to print more money, right? So if is all of this, yeah, like including the NASA propaganda machine, a way for America to project superiority so that they will continue to like borrow as much as they want and continue to stay in power no matter what, because like they're superior and they have like this image of superiority. But if this propaganda is destroyed, then that image is also destroyed, and that will affect the livelihood of the American nation.
Yeah, I don't know, man. Maybe. You're too specific. Maybe. Who knows?
I went to NASA's like space center in Houston, and there was this like huge space shuttle at the front. Is that all like fake? Like they just built it for propaganda and all that?
I don't know how much of it is. Good propaganda has elements of truth. So I imagine some stuff is true.
So that thing can fly, it has flied, but just not to space.
Dude, I don't know. Why would I know that? It's very specific. I don't know how specific we can get with this. What we can work off of is what we know based off of what they admit. And I sent you documents, so get reading. Research OCB. Maybe we can get this train back on track now. No, we're not here to provide alternate narratives, alternate historical fiction. There's nothing that I want to provide you to give you a sense of belief in something else. What I do want to do is destroy your belief and slaughter those sacred cows of your ideals. And I prefer to do it with as many hostile witnesses as I can. That's taking your opponent's own word for it, for the purpose of destroying their own arguments.
And I remember you guys saying that like all the stuff that they say about satellites is also fake, and like not fake, but the technology is real, but it's using other stuff, like not like satellites in
Yeah,
space. And
we say that because they say that.
yeah, I saw that. I saw that. Yeah.
Yeah, so it's not like we came up with this on our own. It's not like we reached this conclusion. We're telling you what they say in their own words, with their own documents, their own research, their own scientists.
And is the CIA involved in like in spreading this global propaganda across like all education systems or whatever?
I don't know about that, but I can show you among the documents I sent you includes a letter from the CIA director nominating his right-hand man to lead up the new NASA space agency before they get a director of their own. Why would they need to do that? Well, we know today, as of September, that NASA has been classified as an intelligence operation, according to Trump's executive order, which is to say, in my opinion, that it's always been. So why would we trust them, especially when their own claims contradict each other for the past 70 to 80 years? Now we just know why they contradict themselves. Those documents aren't a conclusion of research, but the beginning of it. So I encourage anyone to take a look, save them, and start taking down leads. Read through them, find keywords, find key people, and do as much research as you can. These are public and openly available. There's nothing whistleblowing about any of this. The government has mastered the art of hiding within plain sight. It's called Operation Security, or OPSEC for short.
How come it's so hard to join NASA? Like I've known people who wanted to join NASA, and like it's really difficult. Like you need to know like you need to be like very highly educated and all that. So if it's all fake, like why do they go to such
So if
great
you think,
lengths?
hold on, you said they have to be highly educated. If somebody can show a clip of Don Pettit, then we're going to get a real example of how highly educated people are. This dude is an astronaut that can barely make words. He's so stupid. And you think they need to be highly educated?
But what if that guy's an outlier? Like like everyone in, okay, not everyone, but most of the astronauts have to have like highly specialized engineering or biology or STEM degrees from like really good universities, right? So even if like like they can't explain what the questions that you guys are asking, like the amount of information that they had to absorb to get into NASA is a lot, right? So why are they making them do all this?
Oh,
Why can't they
because
just
it sells the lie, dude. Like, if they just recorded garbage can technicians, nobody would believe them.
Yeah, true.
Yeah, they don't have that higher qualifications for the most part. I mean, the one of the main guy that speaks for NASA is called Don Pettit. Who he literally sounds semi-retarded when he talks, and saying semi-retarded is me being very polite. Okay, but his education, he just has a bachelor's in chemical engineering. That's it. You know,
And the
that he got
reason
in the 70s.
the reason why I'm asking like about astronauts is because I recently saw like this this mixed race astronaut from America, and she apparently went to like the home countries of where her parents came from, and like the entire like town was like celebrating her coming and like taking it as like a national point of pride that like she's an astronaut or whatever. So like like I didn't know like the propaganda could be spread like that.
That's how you do it. You
Yeah,
show
it's
people on TV clapping, and then everybody goes, "Look, they're clapping, so that must be real."
and NASA comes up with a new exoplanet every year. Like I constantly look at the NASA website for like the stuff they put out on interstellar space. I don't know how they're getting all this. Like they don't even know what's on Mars, if there's life on Mars, and they're somehow getting like exoplanet stuff like from out of the star system. Like uh, like unless they made it all up. So and speaking about Neil Armstrong, right? Like was he specifically trained to like the Neil Armstrong and Buzz Aldrin, were they like specifically trained to um like make sure this whole thing, this whole narrative would be kept alive?
No,
Because
go watch Capricorn 1, and you'll figure it out.
okay. I went to
They got duped into thinking they were going to go somewhere, and then they didn't go. So that's why when they come back and they on stage in their press conference, they look like somebody shot the dog in the woods while they were gone.
I went to like the NASA place, and like there was this exhibition where they'd show exactly what happened in the control center while the astronauts were landing on the moon. And they were like there was like this grandiose like exhibition, and they were showing everything the scientists and engineers were doing in the control center when the astronauts landed on the moon. Is that is that part of the propaganda as well?
What, showing people sitting at computer terminal screens? Yeah, that's propaganda.
The U.S. military budget, according to what I saw, is like 800. I think it's like $700 billion a year annually. So like, why does propaganda cost so much?
You got to run it. You got to buy television advertising and social media advertising. How are you going to pay for it?
Why are you confusing military budget with NASA budget? Those are two different budgets.
But doesn't the stuff that they pay military contractors also contribute to NASA? Because Lockheed and Northrop Grumman and all these military contractors are also contractors for NASA. So like the
Yeah, well,
amount that
difference. The military budget, they have to produce a product. The NASA budget, they do not have to produce a product.
but like
Most products
Lockheed,
that they have to produce is whatever it is that's necessary for the reification fallacy.
but Lockheed and Airbus are getting paid to like build a space station, a new space station
No,
apparently.
no, they're not. Where's it at? I want to go see it. I'm going to get
Oh yeah,
permission to go see it. I'm going to take a tour. I can get permission to go see that.
because
Can you
like,
give me the location? I want to see them building it. If you can, I'm going to go take pictures of it for everybody.
and the ISS, it's a real thing, right? You guys can't see the ISS is also fake.
Yeah, it's fake as a $3 bill.
Like it's not a place. Is it not a place up in the sky, even though it's not in space?
No, it's a place in a swimming pool and a place in a video studio with green screens and wires and stage hands and cameras and directors and the whole thing, craft services, the whole 9 yards. It's a regular video studio.
And what about all the speculation that the government is hiding aliens in like military bases in the U.S.? Like all that's
Yeah,
fake.
they do that so that you think that space is real and they can still go to space and save us by going to Mars and turning that into Earth instead of just staying on Earth and fixing Earth. They think you can go to a dust ball that's 300 degrees below zero at night or something like that, whatever it is, and then 200 degrees during the day. They think you can go there and turn that into Florida with beaches and beach umbrellas and little lawn chairs.
Also, when we test the surface of the Earth, it debunks all of their bullshit. Right. Clearly, they have mock-ups. Right. Look in the side chat. Clearly, they have mock-ups, perfect mock-ups of the ISS. They have a mock-up under the water of the ISS. They say they use these things for training and for interviews and things like that. But then we look through the footage and we see all sorts of CGI glitches and people getting caught in harnesses and all sorts of errors, right, that they missed over the years. And at the end of the day, you know, it's going to come down to whether you want to have faith in NASA or not, right? It's not up to us to convince you about that, right? We can show you all of the fakery. We can show you a lot of these things, right? But at the end of the day, it's going to come down to whether you want to trust NASA, because you can never validate any of this stuff.
But what about
right?
the people who died? Well, what about the people who died? Like, there's been astronauts that have died, like traveling in space, like real NASA astronauts, and there was even like a movie about it, like where they almost died. Like, all that's fake.
Yeah.
Yeah,
But
most of the people that were on the Challenger disaster are still alive, seemingly. Okay, they have the same name. They work at universities or in prestige jobs. Okay, they look identical. They talk identical. They even have the same name. Like, what's the chances that all of these people that were on the Challenger? Have a look at what Stark posted, right? You should check out these videos. Okay, I don't know if someone else has some comparison shots of the people that were on there and the people that live today that look identical and still have the same name. Or some have slightly changed names. Right, I'll post you a couple of examples if no one else is putting any in the chat.
Yeah, DJ. They said that those people who look identical, they are twins. That's what they said to us, which is quite funny.
What, a twin with the exact same first name and last name? That's weird.
One twin's an one twin's an astronaut. The other twin's the janitor at high school. That kind of stuff. That's cool.
Yeah, it's like, hey, my name's Sharon, and this is my twin sister, Sharon. Yeah, they named us both Sharon.
DJ, they are mocking us. That's why they're telling us they're twins and all that.
Well, they're not mocking us; they're mocking Cryptic.
Yeah, they're mocking the people who believe in the BS.
The two that claimed to be twins were the black dude and the Asian.
I think most people like who simply don't care about space, like about all this stuff, like they don't even care about space exploration, so they obviously don't even question like whether NASA faked it at all. But yeah, so like I don't
Yeah, they do care though. If you tell them that NASA faked it, then they'll get all emotional and butthurt and try to mock and ridicule you. But they don't actually, if they've never looked into it, they just blindly believe it. They say they don't care, but they'll come in here like crying about it. And there's these same people, they don't know anything about the globe either. Right? Like any question about the globe will stump them. Like, does it spin? How many times does it spin in one day? And they'll be like thinking and thinking and thinking, and they get it wrong 99% of the time. Like the most basic questions that we can think of, they don't know. It's just a belief handed down to them from their parents and then reinforced throughout their life. They never questioned it.
Oh yeah, I heard that in Australia you can see the sky much more clearly than you can see it in other parts of the world. Is that just like because of light pollution, or is it because of the position of Australia and like different part of
Some assholes hot micing. Just a second. Yeah, so it really depends where you go in Australia. You know, if you're near a city or something like that, or you're on the coast, you're not going to see crazy stars. I mean, if you go inland, then yeah, you can see a lot of stars. But the same, if you just go anywhere outside of light pollution, you'll see a lot of stars, no matter where you are on the Earth. It's not like more in Australia or something like that.
Oh, but how did they come up with the layout of the Earth? Like, why is Australia at the bottom and then Asia is on top of Australia? Like, how did they come up with that layout?
Celestial sphere, inverting the celestial sphere into a terrestrial sphere, basically. Real simplified way of putting it is when you're under Polaris, right, it would be 90 degrees above your head. And then as you move away, you can keep plotting out points and say, okay, when I'm standing at this point on the Earth, Polaris is at X amount of degrees in the sky. Okay, and then they move further away, and they're like, okay, when I'm at this place, Polaris is X amount of degrees up in the sky. Okay, and they plot that down. Okay, and then when they get to the equator, they're like, okay, now we can't see Polaris. Polaris is at 0 degrees. Okay, and then they've got basically they've sort of mapped out to the equator area. Okay, using the sky, and then they can just inverted that basically because you can't see Polaris anymore. That's the only fixed star that you can see in the north. Okay, then they inverted that, and then you've got the spherical coordinate system. Obviously, it's a lot more complicated than that, but that's just super simplified way of explaining it. I got to go on mute because I got some background noise.
Like, do you guys believe in some sort of like a religion or cult by any chance?
No, we're not the globe believers. That would be you.
that's in the cult.
He's trying
religion.
so hard for it to be not about geometry.
No,
You're
are you guys like?
You're
are
a
you guys, like,
heliocentrist. Void, you're a heliocentrist, aren't you?
No, I'm not a heliocentrist.
You're not a heliocentrist, so you don't believe the Earth goes around the sun.
No, that was like before Galileo and shit.
Wow, so you don't even know what you're talking about, because that's the mainstream belief. So you're a geocentric glober? You think the sun goes around the Earth?
No, the Earth goes around the sun.
Hey, so you're a heliocentrist.
Yeah, I'm a heliocentrist. Sorry to correct myself.
Beep, boop, boop. Blue screen.
And the
You're watching 24/7 Flat Earth Discord live.